Remark. The difficulty in grasping the notion of electricity stems, in the first place, from the fundamental determination of inertia, both physical and mechanical, ascribed to the individual body in this process. This is why electrical tension is attributed to another special matter to which the light belongs, which manifests itself in abstract separation from the concrete reality of the body, the latter remaining aloof in its independence. The difficulty is, in the second place, the general one of the notion as such, the difficulty of grasping light in its relationship as moment of a totality, and here, no longer in freedom as solar light, but as a moment of a particular body. In this it is implicitly present as the pure selfhood of the body and enters into existence as a product of the body's own inwardness. Primordial light, that of the sun, proceeds only from the notion as such. Here, however, we have a coming to be of light, but of differentiated light, from an existence which is the notion existing as a particular body. It is a familiar fact that the former distinction of vitreous and resinous electricity, in which the difference is defined in terms of specific, sensuous existence, has with the advance of empirical science been converted into the conceptual distinction of positive and negative electricity, a remarkable instance of the way in which empiricism, whose primary aim is to grasp and retain the universal in sensuous form, itself transforms its own sensuous stuff. There has been much talk recently of the polarization of light. It would have been more correct to reserve this expression for electricity than to apply it to the phenomena observed by Malus, in which transparent media, reflecting surfaces and their various mutual inclinations, and other extraneous circumstances, produce an external difference in the shining of light, but not a difference in light itself. The conditions for generating positive and negative electricity, a smoother or rougher surface, example a puff of air, etc., are evidence of the superficial character of the electrical process, and show how little the concrete, physical nature of body enters into it. Similarly, the faint coloration of the two electrical lights and the smell and taste of positive and negative electricity, indicate only an incipient bodily nature in the abstract self of the light in which the tension of the process is contained, a process which, though physical, is still not concrete. The negativity, viz. the removal of the tension between the opposed bodies, is mainly a shock. The self which has posited itself as self-identical out of its diremption, is still, as this totalization, confined within the external sphere of mechanics. The light of the spark discharged hardly begins to develop into heat, and the combustion which can arise from the so-called discharge is, according to Berthollet, rather a direct effect of shock than the result of light developing into the reality of fire. 223. Insofar as positive and negative electricities are kept apart from each other in different bodies, there comes into play, as in the case of magnetism, the specific function of the notion, 6.2, the positing of the opposed as identical and of the identical as opposed. This is, on the one hand, the mechanistic activity of spatial attraction and repulsion. Insofar as this can occur as a separate phenomenon, it establishes the connection between electricity and magnetism as such. On the other hand, it acts physically in the interesting phenomena of electrical transmission as such, or of conduction, and of distribution. Zusatz. This electrical relationship is activity, but an abstract activity, since it is not yet product. It is present only where the tension, the contradiction, is not yet resolved, so that each side contains its opposite and yet remains independent. Now this tension is no mere internal mechanical tension of the parts, but one that essentially must express itself. This expression must be different from the corporeality of the individual body, for this, in becoming different, remains what it is. At first, therefore, it is only the universal individuality of the body which is manifest, without the body's real corporeality entering into this process. This expression is therefore still only abstractly physical, i.e. the body shows its difference only by its general shining. Thus the body shows its physical soul as light, but whereas the solar light is immediate and free, this light is rather called forth by the power of another body. Light, then, is in this case the mode of existence of bodies opposed to each other, This tensed light has the urge to differentiate itself upon the other body. But the differentiated bodies appear as light only in their vanishing, simply because the difference is as yet not independent but only abstract. What appears here consequently is not such a flame as results from friction, where light is the triumphant climax in the consuming of body. Even the spark struck from a stone is a suspension of cohesion and a concentration of parts in a point. Here, however, ideality is manifest as preserving body. It is a gentle fire, the spark is cold, a mere light which as yet has no nutriment. For the specific materiality of the tensed body has not as yet entered into the process but is determined only in elemental fashion, in soul. But as differentiated, light is no longer pure but already colored, the negative spark has a tinge of red, the positive a bluish hue. And since light is ideality breaking forth from physical body, the other physical determinations of total individuality, odor, and taste, begin to be manifest, but in a quite ideal, immaterial way. Electricity smells. When close to one's nose it smells rather like cobwebs. One also notices a taste, but a bodiless one. The taste is in the sparks, one tastes more acid, the other more alkaline. 225. Lastly, in addition to taste, figures too appear. Positive electricity has a longish, radiating spark, the negative spark is more concentrated into a point. This is seen when both sparks are made to strike on colophonium powder. Reflection I9. Accustomed to thinking of the individual body as something dead, which has only external, mechanical contacts, or chemical relationships, with other bodies. The expression of tension which we have here is accordingly not ascribed to the body itself but to another body, of which the former is only the vehicle. This other body has been called electrical matter. This theory regards body as merely a sponge which lets such matter circulate within it. Since body remains what it is, merely taking in more or less of this matter, this would be no immanent activity of body but only a transmission. Electricity is further made responsible for everything in nature, and especially for meteorological phenomena. But the part electricity is supposed to have played in all this cannot be demonstrated. Since it is not matter, nor a propagation of things, it appears, like magnetism, to be on the whole rather superfluous. In both cases, activity appears to be very restricted in scope, for if magnetism is the peculiar property of iron to point north, electricity merely is the making of a nine-park. But this is met with everywhere, and that is all, or almost all, there is to it. Electricity thus appears as an occult agent, like the occult properties assumed by the scholastics. If it is present in thunderstorms, we do not see why it should be present elsewhere. But we must not think of such great natural phenomena as thunderstorms on the analogy of our chemical laboratories. For how can clouds rub against one another, being at least softer than a sponge? And since it lightens when it is already raining and when the whole sky is wrapped in a veil of moisture, all electrical tensions would necessarily be immediately neutralized, since the falling rain which connects the cloud with the earth is a perfect conductor. But even if electricity is present here, the end, that is, the necessary linkage and connection of electricity with physical nature has not been demonstrated. Electricity is, of course, the universal scapegoat. Everything is electrical, but such a statement is vague, and leaves the function of electricity unspecified. We, however, see in electricity body's own selfhood which, as a physical totality, preserves itself when in contact with another body. It is body's own upsurge of anger which we see, no one else is there but body itself, least of all any foreign matter. Its youthful courage lashes out, it raises itself on its hind legs, its physical nature rouses itself to struggle deparitely against the connection with another, and it does so as the abstract ideality of light. It is not only we who compare bodies, they themselves compare themselves, and in doing so preserve their physical nature. It is a beginning of organic being which likewise preserves itself against the means of nutrition. The essential point here is that what is active is body's own immanent physical refractoriness. It must be observed in this connection that what at first was an 824, 3876 I 226. Immediate determination is now a posited one. Shape, namely, as crystal, was immediately transparent, just as the celestial bodies, being self-subsistent, were immediately lights. Now individual body 19 not immediately luminous, is not itself a light, since as shape it is not an abstract ideality, on the contrary, as an explicated and developed unity, it includes the determination of the celestial bodies as a property in its individuality, immediately, therefore, it is only as the shining of an other in it, through it. In the crystal, it is true, form has brought the difference of material being for self back to unity, but this unity of form in its determinations is still not physical ideality, but only immanently determined mechanical totality. Light, on the other hand, is physical ideality. The crystal, therefore, not being self-luminous, is this ideality only in principle, since it manifests the latter only when reacting to an other. But what the crystal is in itself must now be posited, thus this ideality, posited in developed totality, is no longer merely a shining of body as visible, an alien incident light, but the simple totality of the shining of the self in the face of an other. That is to say, since the unity of form with itself is now posited, the crystal here constitutes itself a sun, the light which proceeds from it as a differentiated self, only one displays the crystal's totality in its peculiarity and in a simple, physical existence. How does electrical opposition arise? And how is it related to the physical properties of bodies? Electricity makes an appearance wherever two bodies come into contact, especially when they are rubbed. Electricity, therefore, does not merely attach to the electrical machine, but every pressure, every blow, produces electrical tension. Contact, however, is the condition for this. Electricity is not a specific, particular phenomenon which occurs only in amber, shellac, etc., it attaches, on the contrary, to every body in contact with another body. It is only a question of having a very fine electrometer to convince oneself of this. The angry self of body comes forth from every body when excited, they all exhibit this vitality towards one another. Now although positive electricity appears primarily in glass, and negative in resin, this is a very narrow distinction, simply because all bodies are electrical, metals also are 90, only they must be insulated. Negative electricity can also be produced in glass, for the kind of electricity produced depends on whether the glass plate is polished or rough, and this difference reveals different electricity, and so on. How he says, electricity divides the mineral kingdom into three great divisions which correspond to the general classes of minerals. Almost all stones and salts are made positively electric by friction, provided they have a certain degree of purity. Combustible substances such as resin, sulfur, also diamonds, are, on the other. One in the text is probably a misprint for and only asterisk should read now star. 227. Band, negatively electric. The metals are conductors / a neutral substance, therefore, has positive electricity, a differentiated substance belonging to fire, to negative, self-subsistent being, exhibits negative electricity, a substance without immanent difference, whose nature is completely uniform, is fluid and a conductor. Thus almost all liquids are conductors, oil alone is a bad conductor on account of its combustibility. In general, electricity has this general connection with the specific qualities of nature Naturkuutalitaten. It is at the same time so superficial that even the slightest modification of bodies is sufficient to produce an alteration in electricity. Wax and silk, example, are bad conductors, but if the former is melted and the other heated, they become good conductors, since heat makes them fluid. Ice is a good conductor, dry air and dry gases, on the other hand, are very bad conductors. Polished glass, when rubbed with woolen stuff, becomes positively electrical, negatively so when rubbed with a catskin. Silk rubbed with resin yields negative electricity, with polished glass, positive. If two quite similar gus tubes are rubbed together, one becomes negatively, the other positively, charged. Of two sticks of sealing wax, one likewise is positively, the other negatively, charged. A silk ribbon when stroked crosswise becomes negatively electrical, but if a similar ribbon is stroked lengthwise, its electricity is positive. If two persons are insulated, if not, their electricity goes to earth and they do not count as individuals, and one of them holds a catskin in his hand and rubs the clothes of the other with it, the first will be positively, the other negatively, charged. The difference is due to the action of one of the parties. If molten sulfur is poured into insulated metal vessels, the sulfur will acquire positive, the metal negative, electricity. Sometimes, however, the reverse also happens. A principal factor is the one adduced by it. When the surfaces of bodies are rubbed together, that surfaces seems to become positive whose particles are least separated and deviate Le6s from their natural position relatively to each other. That surface, conversely, whose particles are more scattered by the other's roughness, tends more strongly to become negatively charged. This tendency is increased if the surface actually expands. If an animal or vegetable substance, solid and dry, is rubbed against a rough metallic surface, it becomes negatively charged since its particles are more disarranged. But if, on the other hand, such a substance is rubbed on very smooth metal which only slightly modifies its surface, the effect being restricted to pressure and separation of isolated particles, the substance then either gives no sign of electricity or gives signs of positive electricity. If a catskin is rubbed on a polished or unpolished metallic surface, the hairs can only yield to the pressure without losing their relative position, they are therefore positively electrified. But if these same hair, in the form of a woven material, are rubbed against an unpolished metallic surface, they are not only compressed but separated from each other and pulled apart by the roughness of this surface. This makes them negatively electrical, save when the metallic surface has a certain degree of smoothness. Color, too, makes a difference. Black silk material, if new, when rubbed against a white silk ribbon acquires negative electricity, plainly, became the black coloring of the material's surface makes it rougher. If, however, the black material has been used and its color rubbed off, it acquires positive electricity if rubbed against a white ribbon. A white ribbon, rubbed against white woolen material, gives signs of negative electricity. Rubbed against black woolen material, it shows positive electricity. The difference, therefore, can be produced either by essential or by superficial qualities. Pohl says in his review of Geller's Physical Dictionary, published by Munk in 3 volumes, we must recognize that electrical opposition, hardly less than the opposition of colors, comes close to the chemical opposition of oxidation and deoxidation, except that the latter opposition is extremely mobile and is often quite independent of the state of the mass and its more solid, internal qualitative relationships. We must recognize, too, that where two substances are interacting reciprocally in apparently similar conditions, and where the most delicate, careful observation is unable to detect further modifications, it requires but little effort on the part of nature, in her active, playful urge towards manifestation, to cast the plus end of electrical opposition, now on one side and now on the opposite side, just as from the same seed of an individual plant, it sends forth the same species sometimes with a red, and sometimes with a blue, corolla. The commonest and at the same time most harmful consequence of the false supposition of causal relationships existing in isolation, a supposition imported without question into phenomenology, has reached an extreme in the case of electrical phenomena through the idea, everywhere rampant, of electricity as in a state of motion, as a current. In supposing that something which, in its true meaning, is only the first steriog of an incipient chemical process, is an isolated, independent fluid, something which persists throughout the flux of phenomena, one no longer thinks of following up the process as such in its further development, and of recognizing the determinations which belong to it in their natural context. Instead, that which constitutes the veritable inner movement and development of the process itself is now, in accordance with the said fixed idea, straightway placed under the empty schema of a merely external movement of the said fictitious electric fluid, and viewed as a current which, next to the manifestation in the original form of tension, is exclusively asserted to be a second species of activity of this fundamental electrical substrate. This standpoint denotes a complete divergence from a natural view of phenomena and has initiated a series of shallow and erroneous conclusions, the baneful influence of which has hitherto infected all theories of electricity and galvanism, both generally and in their particular observations, up to the most recent researches in galvanism and electrochemistry, which teem with all sorts of deceptions and absurdities. Even though before Oersted's discovery, the assumption that electricity was actively present where the most sensitive electrometer gave not the least sign of its presence, could not properly be held to have an empirical basis, it is quite unjustifiable to stick to this assumption now that, in addition to the absence of any response from the electrometer, we see the magnetic needle immediately indicate the presence there, not of the electricity so long assumed to be present, but of magnetism. Electricity is the infinite form which is immanently differentiated and is the unity of these differences, and thus the two bodies are inseparably bound together, like the north and south poles of a magnet. But in magnetism there is only a mechanical activity, an opposition therefore only in the activity of movement, there is nothing to see, smell, taste, or feel, that is, no light, color, odor, or taste. But in electricity, these variable differences are physical, for they are in the light. If they were a further particularization of the bodies, we should have the chemical process. Of course, so far as in electricity the element of difference is active and as such still remains active, this activity, too, can consist only in mechanical movement. It is an approach and a withdrawal, as in magnetism. This accounts for electrical rain, electrical chimes, etc. Negative electricity is attracted by positive, but repelled by negative. The different elements, in thus forming a unity, communicate themselves to each other, but as soon as they form a unity, they again flee from each other, and conversely. In magnetism, only one body is required, one which does not as yet possess physical determinateness but is only a substrate of this activity. In the electrical process, each of the two different bodies has a different determination, which is posited only by the other body, but as opposed to this, the rest of the body's individuality remains free and distinct. Both kinds of electricity therefore require for their existence an individual body of their own, or we may say that one electrical body has only one kind of electricity, but causes another body outside of it to be charged with the opposite kind, and where we have one kind of electricity, the other is at once also present. But the same body does not polarize itself inwardly, as is the case in magnetism. Electricity, therefore, although it has the same fundamental syllogistic determination as magnetism, has raised the opposition to an existence of its own. Spelling therefore called electricity ruptured magnetism. As a process it is more concrete than magnetism, but less concrete than chemical process. The tensed extremes still fail to make up an actual, total process, they are still independent, so that their process is only their abstract self. For physical difference does not constitute the entire nature of body, and for this reason electricity is only the abstract totality of the physical sphere. What, therefore, magnetism is in the sphere of shape, that electricity is in the sphere of physical totality. THEIG. When a body is electrically charged, its electricity can be communicated, especially to conductors, like metals, for example, though metal, when insulated, can equally well acquire its own electricity as self-differentiating, so, too, can glass, only it is not a conductor. But as communicated, the electricity of each body is of the same kind, such bodies then repel each other. Physicists further distinguish between electricity which is communicated and electricity distributively manifested. The latter is as follows: a body A is charged with positive electricity. A cylinder B, an insulated conductor, is placed close to it without touching it, with the result that the conductor, too, is electrified, but in such a way that die end turned towards body A is negatively charged, the opposite end positively charged, while the middle is neutral. Two different cases are to be noticed. When B is removed from the electrical sphere of A, its electricity vanishes, but if it is still near to A and its positive end is brought into contact with the third body C, then when B is removed from the sphere of A, it is still electrified but only negatively. The reason for this is that to fix electricity, two individual bodies are required, one for positive and the other for negative electricity. Now so long as body B has not been touched, it contains tension and difference within itself, like magnetism, though this does not constitute its individual determinateness, but, being brought into proximity with another body which is already self-determined, it has its determination only through another. In all this it remains, as a conductor, indifferent, but because it is also in the electrical sphere it can, as extended, display differing determinations. Although, therefore, it possesses both electricities, electricity still does not exist as attaching to body itself. It is not till the body has only one of the electricities, that electricity enters upon individual existence. This requires that the body should be opposed by another body. Now since through this contact the indifference of body B is removed, and the opposite electricity to that which it turns to body A passes into body C with which it is in contact, body B, on the other hand, becomes charged with the other electricity. Also, since the proximity of the bodies is already a binding of their opposition, the negative electricity of body B is stronger, the greater its distance from A, and its intensity diminishes the nearer it is brought to A. TWO glass plates rubbed against each other and insulated, show no trace of electricity when brought near each other, but when separated they do. This is not true of metal plates, even when insulated, since their electricity is also implicitly neutralized. If two spheres of the same size, and having similar electricity, are brought into contact, then the intensity at the point of contact equals O, and is stronger at the remote points of the spheres. If spheres of unequal size and similar electricity are used, then the electricity is likewise equals O at the point of contact, but when they are separated, there is negative electricity at the point of contact of the smaller sphere. If, however, the distance is increased, this determination 231 vanishes, and the whole of the smaller sphere is positively charged. Here, it is the inequality of the amount which posits this opposition. Hackey also remarks that tourmaline and many other crystals with asymmetrical forms, when placed in warm water or even over a fix, acquire electric poles at just those parts of their extremities which violate symmetry, whereas in the middle they are indifferent. As regards the effects of electricity, these are shown principally in the removal of the tension. If the electrified body is connected with water, the tension ceases. The amount of electricity a body can take up depends on its surface. A bottle can be electrified up to the point where it bursts, i.e. the glass can no longer resist the increased tension. The capital instance of the removal of tension is when the two electricities come into contact. Each is incomplete without the other, and they want to totalize themselves. They remain in a forced state if kept apart. The substanceless opposites have no enduring existence, they form a tension which is spontaneously self-resolving. As thus collapsing into their unity, they are the electric light which in appearing vanishes. But the essence of this light is the negativity of the indifferent existence of shape, and this negativity itself has existence. The light forgoes its way into the shape and, shattering its indifference, it is inner and outer form concentrated into unity. The form which has become like itself is the light which breaks forth from within and flows into the light outside, the being within self of gravity which, in destroying itself, and in its vanishing, just becomes powerless, simple light, i.e. is simply one with the outer light. It is thus that Plato grasps seeing as a fusion of inner and outer light. Through the connection established between the tensed bodies, one difference hurls itself into the other, the two electricities reciprocally completing each other. This product, however, is only a play, the loss of two abstract determinations, the interpenetration of these sparks. The main result is the destruction of the bodies brought into contact. Electricity shatters pieces of wood, kills animals, breaks panes of glass, heats and fuses metal wire, melts gold, etc. That the effects of electricity can just as well be produced by mechanical pressure is shown by the electric pistol. This is charged with 2 volumes of hydrogen and 1 of oxygen, which are transformed into water by the electric spark. The chemical side of the electrical process is the decomposition of water. As it is not the individuality of the body which enters into the tension, electrical action can only produce a physical result in the element of abstract neutrality, water. It has the power of decomposing water into hydrogen and oxygen, though we already know that these are not the ingredients of water but only the abstract forms in which water is manifested. For in the galvanic process, no bubbles are seen moving about in the glass tube, nor is there any change in an acid placed in the middle of the tube, though this would be inevitable if these gases did pass through the tube. 232. 325 The particularization of the individual body does not stop at an inert diversity of properties and their own, separate activities, from which in the process the abstract, pure selfhood of body, the light principle, first issues in the tension of opposed moments and then resolves the latter in their indifference. Since the particular properties are only the reality of this simple notion, the body of their soul, of light, and since the complex of the properties, the particular body, is not truly independent, the entire corporeality therefore enters into tension, into a process which is at the same time the becoming of the individual body. Shape, which at first only proceeded from the notion and therefore was posited only in principle, now issues from an existent process and presents itself as the posited outcome of an existence, the chemical process. Zusatz. We began with shape in its immediate form, and its necessity has been ascertained from the notion. But shape must in the end also display itself as existing, i.e. as the outcome of a process. Body, as immediate, presupposes the real chemical process. Parents are thus the immediate from which one begins, but as regards their existence they, too, are characterized as posited. Shape, in conformity with its notion, passes into this third stage, but this is rather the first from which what was previously the first proceeds. This is founded in the deeper logical advance. Particularization does not stop at the moment of difference as the tension of abstract selfhood. Body as particular is not independent, not self-subsistent, but a link in the chain and in relation to what is other. This is the omnipotence of the notion which we already saw in the electrical process. In this excitation of a body by an other, it is only the abstract selfhood of the bodies which comes into play and is manifest. But the process must become a real process of the bodily determinations, their whole corporeality entering into the process. The relativity of body must be manifest, and this manifestation is the alteration of body in the chemical process. See the Chemical process. 326. In individuality developed into a totality, the momenta themselves are determined as individual totalities, as whole particular bodies which, at the same time, are in relation only as different a 33 towards each other. This relation, as the identity of non-identical, independent bodies, is contradiction, and hence is essentially process, the function of which, in conformity with the notion, is the positing of the differentiated as identical, the removal of difference, and the differentiation of the identical, the enlivening and dissociation of it. Zusatz. To understand the general position and nature of the chemical process, we must look forwards and backwards. Chemical process is the third stage in the process of shape. The second was differentiated shape and its abstract process, electricity. We also had a process in shape before it achieved completeness and neutrality, namely, magnetism. If shape is the unity of notion and reality, then magnetism, as at first only abstract activity, is the notion of shape. The second stage, the particularization of shape within itself and against an other, is electricity. The third stage is the self-realizing unrest of the chemical process, as the veritable reality of the notion in this sphere. As in magnetism, there is one form which sunders itself into differences and exists as a unity, yet it does not stop there. In magnetism, the difference is manifest in one body. In electricity, each difference belongs to a separate body, each difference is self-subsistent, and the whole shape does not enter into this process. Chemical process is the totality of the life of inorganic individuality, for here we have whole, physically determined shapes. Bodies enter into the process not merely as having odor, taste, and color, but as being odorous matter, testing, and colored matter. Their relation is not one of movement but of alteration of the entire different matters, the vanishing of their distinctive characteristics. The abstract relation of the body which is its light, is not only abstractly, but essentially, this particular relation, the whole corporeality therefore enters this process, and the chemical process is consequently the real electrical process. Thus we have the whole shape, as in magnetism, though not one whole but distinct wholes. The two sides into which the form sunders itself are thus whole bodies, such as metals, acids, and alkalis. Their truth is that they enter into relation. The electrical moment in the process is that these sides separate themselves out to have their own independent existence. This did not happen in magnetism. The inseparable unity of magnetism likewise dominates the two sides. This identity of both bodies which makes them return once more to the magnetic relation is absent from the electrical process. The chemical process is thus the unity of magnetism and electricity, which are the abstract, formal sides of this totality and are for that reason not the same process. Every chemical process contains magnetism and electricity in principle. But they cannot appear in their distinctiveness in the, so to speak, saturated course of the process. They can do so only when the chemical process is itself an abstract manifestation. *3+ when it does not attain its full reality. This is so in the universal individuality of the earth. The fully realized chemical process is the universal process of the earth, but we must distinguish between the process of the individuality proper and the universal individuality. In the latter, which is self-maintaining, even the chemical process, though spontaneous, can only manifest itself in an abstractly universal way. The earth individuality is not a particular individuality which can resolve itself and achieve real self-neutralization with another. For as a universal individuality, earth endures and does not therefore enter into the chemical process which affects a whole shape, only in so far as its existence is not universal, i.e. in so far as it divides itself into particular bodies, does it enter into chemical process. The chemistry of earth, then, is what we have seen the meteorological process to be, the process of physical elements as universally determined matters which are not yet individual corporealities. Since the chemical process exists here thus abstractly, its abstract moments come to view here, too. It is on earth, consequently, which has alteration outside it, that magnetism makes its appearance, and likewise the electric tension of the thunderstorm. The electricity of earth, which includes lightning, the northern lights, etc., however, differs in kind from ordinary electricity and is not tied to the same conditions. Magnetism and electricity are merely born by the chemical process. It is through the universal process of earth that they themselves are first posited. The magnetism which determines a single magnetic needle is subject to alteration and depends on the inner process of earth and the meteorological process. Perry, on his expedition to the North Pole, found that there the magnetic needle became quite indefinite, e.g. in a thick fog its direction northwards was quite indifferent, the needle lost its activity and could be pushed in what direction one wished. Electrical phenomena such as the northern lights, etc., are considerably more variable. The northern lights have been seen near midday south of England, even south of Spain. They are, then, only moments of the total process, on which they depend. Electrical tension also arises in the chemical process, especially when this is galvanic, but it also carries magnetic tendencies with it. This dependence of magnetism on chemical process is a remarkable recent discovery. The general revolution of the earth, Its rotation about its axis, which is the east-west polarity, determines the south-north polarity, the direction of the stationary axis. Ørsted found that electrical and magnetic activities, insofar as they are related as spatial directions, are also opposites which cross one another. Electricity runs in an east to west direction, while magnetism runs from north to south, but this can also be reversed. Magnetism, however, is essentially mere spatial activity, whereas electricity has a more physical character. This discovery also shows the simultaneous togetherness of these moments in the chemical processes of the individual corporeality, and it does so by showing them to issue from the galvanic process as separate and distinct manifestations of electricity and chemical action. The difference of the philosophically systematic mode of treatment from the empirical is that it does not treat levels of concrete existences in nature as totalities, but as levels of characters, determinations. Thus, when we have first considered the Earth as a planet, its concrete nature has not been exhausted. A further determination of physical moments is, on the contrary, a further determination of Earth, so far as such determinations are proper to Earth as a universal individuality, for the finite relationships of individual bodies do not concern Earth. This is precisely the case with the relationships here. The hierarchy of these relationships and their interrelatedness is one thing, but the consideration of a concrete, individual body as such is another. The individual body unites all these determinations within itself and is like a bouquet in which they are bound together. To apply these observations to the present case, Earth as a self-subsistent individuality opposed to the Sun does in fact exhibit chemical process, but only as a process of elements. At the same time, the chemical process of Earth is to be grasped only as a past process, for these giant members, enjoying a separate and independent existence, remain at the stage of diremption, not passing over into neutrality. On the other hand, process as it comes to view in particular corporeal individualities brings about their reduction to neutral existences which can be taken apart again. This process is inferior to the universal process, are restricted to it, whereas the meteorological process is the great chemistry of nature. But on the other hand, it ranks higher, since it immediately precedes the vital process. For in the latter, no member can endure or exist as a part, but endures only in the subjective unity, and it is the subjective unity which is the actuality of the vital process. The process of the heavenly bodies is, on the other hand, still abstract since they remain in their independence. The individual chemical process therefore is deeper, since in it the truth of particular bodies becomes actual, namely, that they seek and attain their unity. This is the position of the chemical process in the whole. We must distinguish in it the process of the elements and the particular process, simply because particular bodies are not only particular but belong also to the universal elements. Consequently, when they are in process as particular bodies, the universal meteorological process must also be manifest in them, simply because it is the universal process. Aj1 chemical processes are bound up with the general process of the Earth. The galvanic process is also determined by the seasons and time of day. This is especially noticeable in the electrical and magnetic sides of the process, each in its own way. These activities have their periods. Apart from other variations, these periodic variations have been accurately observed and reduced to formulae. Something of the kind has also been observed in the chemical process, but not to the same extent, e.g. Ritter found that a solar eclipse produced variations. But this connection is more remote. It 23's. Is not the case that the elements as such enter into this process. There is, however, in every chemical process, a determination of the universal elements, for the particular formations are only subjectivized forms of the universal elements which still stand in relation to them. If, therefore, particular qualities are altered in the chemical process, this also involves a determining of the universal elements. Water is essentially a condition or a product, fire, similarly, is a cause or an effect. As in this way the notion of the chemical process is in general to be totality, we have to think of the notion as wholly immanent in its differences, i.e. in positing itself as the negative of itself, it remains quite at home with itself. Each side, therefore, is the whole. As one side of the process, the acid is, of course, not what the alkali is, and vice versa, both are thus one-sided. But the further point is that each side is also in itself the other, the totality of itself and the other. This is the thirst of the alkali for the acid, and conversely. The moment the bodies are activated, they seize hold of each other. If they can find nothing better, they enter into process with the air. That each is in itself the other, is demonstrated by each seeking the other. Each is therefore the contradiction of itself, but everything only has an impulse in so far as it is the self-contradiction. This first begins in the chemical process, for here, this contradiction of being in itself neutral, itself the whole, brings about the infinite urge. In life, this is further brought to view. The chemical process 19, thus an analogue of life, the inner restlessness Regsamkeit, of life, there before our eyes, may astonish us. If the chemical process could carry itself on spontaneously, it would be life. This explains our tendency to see life in terms of chemistry. 327 First of all, we must set aside the formal process, which is a combination of merely different, unopposed bodies. Such bodies do not require a third, or middle term, in which they could be virtually one. The determinateness of their existential relationship consists in their common nature or genus. Their combination or dissociation is immediate and the properties of the bodies are preserved. Such combinations of bodies chemically inactive towards each other are amalgams and other alloys of metals, mixtures of acids with each other, of alcohol, etc., with water, and so forth. Zusatz. Winter 1 has called this process sinsomati. This name is not *. He was a professor at Pest, and at the beginning of this century, had 37 found elsewhere and has accordingly been omitted from the third edition. These sinsomatis are combinations formed directly without any intermediary which would produce and itself undergo change. They are still, in consequence, not strictly chemical processes. Fire certainly is involved in metallic amalgams, but it is not an intermediary which itself enters the process. When various incomplete bodies are made to form a unity, we ask what it is in them that has been changed. We must reply, that which makes them these particular bodies. Now the first, original determinateness which renders them particular bodies is their specific gravity, and next their cohesion. The combination of such bodies belonging to the same class is, therefore, no mere mixture, since their specific difference suffers modification in their combination. But since these determinatenesses belonging to the general particularity of bodies lie beyond the sphere of real physical difference, their alteration is still not a characteristically chemical change, but the alteration of the substantial inwardness of the body which does not yet reach to external existence of specific difference as such. We must therefore distinguish this particular mode of alteration from the chemical process, for though it occurs in every chemical process, it must also have a special, free existence of its own. The mixture is not external, but a genuine combination. Thus, water and alcohol mixed together, completely permeate each other. True, the weight is the same as when they were separate, but the specific density differs from the quantitative unity of both since they now occupy a smaller space. Similarly, gold and silver melted together occupy a smaller space. That is why the goldsmith who was given gold and silver by Hiero to make a crown was suspected of fraudulently keeping part of it for himself, for Archimedes had calculated the weight of the whole mixture on the basis of the specific weight of the two bodies. But Archimedes may well have done the goldsmith an injustice. Not only do specific gravity and cohesion alter, but color also. In brass, which is an alloy of copper and tin, the red color of the copper turns to yellow. With mercury, which readily amalgamates with gold and silver but not with iron and cobalt, there is a specific ratio in which each roetal saturates itself with the other. For example, if too little silver has been taken, the unsaturated portion of the mercury runs off, or if there is too much silver, part of it does not enter into the change. Some combinations also have greater hardness and density than the metals taken singly. This is because difference represents a higher being within self, whereas the undifferentiated body is lighter. At the same time, amalgams are more fusible than the individual metals of which they are composed would argue, since, on the contrary, a body immanently differentiated is more open to chemical change and offers less resistance to it, just as the strongest natures are most obstinate in the face of violence, but freely. An urge towards deeper insight into chemistry. He claimed to have discovered a particular substance, Antonia, but his claim has not been substantiated. And unreservedly yield themselves to those of kindred spirit. D. Arquette's alloy, a mixture of 8 parts bismuth, 5 parts lead, and 3 parts tin, melts at a temperature below the boiling point of water, will in fact melt in a warm hand. There are also earths, not by themselves fusible, which become so in combination, a fact of some importance in metallurgy, where it facilitates operations in foundries. Here we also must include the refining of metals, since this rests on the diversity of melting point in combinations. Silver, example combined with copper, is refined with the aid of lead. The heat which melts the lead carries the silver off with it, but the gold remains combined with the copper if any is present. Aqua regia is a combination of hydrochloric and nitric acids. The separate ads do not dissolve gold, but only when thus combined. These synsomades, therefore, are alterations only of the inner, implicit difference. The chemical process proper, however, presupposes more determinate opposition. From this a still greater activity and a more specific product are born. 328. The real process is, however, also connected with chemical difference, the whole concrete totality of the body at the same time entering into it. The bodies which enter into the real process are mediated in a third body distinct from them. This third is to the two extremes their abstract, merely at first implicit, unity which the process brings into existence. It accordingly comprises only elements, these being distinguished as the element of combination, abstract neutrality as such water, and as the element of differentiation and dissociation air. As, in nature, the different moments of the notion acquire separate existence, so here too the dissociative and neutralizing sides of the process are each in themselves twofold, each, namely, has a concrete and an abstract side. Dissociation is, on the one hand, a splitting up of neutral corporeality into material constituents, and on the other, a differentiation of the abstract physical elements into the four yet more abstract chemical moments of nitrogen, oxygen, hydrogen, and carbon, which together constitute the totality of the notion, determined in accordance with its moments. We have accordingly as the chemical elements, 1. The abstraction of indifference, nitrogen, 2. The two elements of opposition, the element of self-subsistent difference, oxygen, the consuming element, and the element of 339. Indifference which belongs to the opposition, hydrogen, the combustible element, 3. The abstraction of their individual element, carbon. Combination similarly is, on the one hand, a neutrally two-ing of concrete corporealities, on the other, a neutralizing of these abstract chemical elements. The concrete and abstract sides of the process are, furthermore, as much united as distinct. It is from the differences of the physical elements, which are the mean of the extremes of the process, that the indifferent concrete corporalities are activated, i.e. their chemical difference acquires an existence which presses on to neutralization and passes over into it. Zusatz. The general nature of the chemical process is, as a totality, the double activity of dissociation and the reduction of the separated parts to unity, and since the shaped bodies which take part in the process must come into contact with each other as totalities, so that their essential determinateness is touch, which is not possible if they only attack each other by friction as mechanically indifferent bodies do in the superficial electrical process, they must meet in what is indifferent, which, as their indifference, is an abstract, physical element, water as the principle of affirmation, and air as the principle of fire, of being for self, of negation. The elements which form this middle term take part in the process and determine themselves to differences, equally, they again fuse together into the physical elements. Here, therefore, the element is either the active principle in which individual bodies first display their activity towards each other, or else it is manifest as passive determination, as a transformation into abstract forms. The extremes are, however, combined to form entire middle term, or if they are neutral bodies, e.g. salts, they act decomposed into extremes. The chemical process is therefore a syllogism, and not merely the beginning of the process but its entire course is syllogistic. For the process requires three terms, namely, two self-subsistent extremes, and one middle term in which their determinatenesses come into contact and they are differentiated, whereas in the merely formal chemical process only two terms were needed. Fully concentrated acid, which as such contains no water, when poured on metal either fails to dissolve it or else has only a weak action on it. If, on the other hand, it is diluted with water, it attacks the metal vigorously, simply because the process calls for three terms. It is the same with air. Tromsdorff says, even in dry air, lead soon loses its luster, but it does so even more quickly in moist air. Pure water does not act on lead if air cannot get to it. If therefore a piece of freshly melted lead which is still very lustrous is put into a glass which is filled up with freshly distilled water and then sealed, the lead remains quite unchanged. Lead, on the other hand, which lies under water in vessels open to the air, soon loses all its luster. The same is true of iron. Rust, consequently, is formed only when the air is moist. If the air is dry and warm, the iron is not affected. The four chemical elements are the abstractions of the physical elements, whereas these latter are real in themselves. For some time it was thought that all bases were composed of such simple substances, just as they are now supposed to be composed of metallic substances. Giton supposed lime to be composed of nitrogen, carbon, and hydrogen, talc, of lime and nitrogen, potassium, of lime and hydrogen, and sodium, of talc and hydrogen. In vegetable and animal organisms, Stephens again tried to find the opposition of carbon and nitrogen, and so on. Such abstractions, however, appear on their own as chemical differences in individual bodies only because process gives the universal physical elements, as a middle term, the character of existing differences, and thereby separates them into these abstractions. Water is thus differentiated into oxygen and hydrogen, just as it is not permissible to represent water as consisting of oxygen and hydrogen, a point to which we drew particular attention in connection with meteorology, so air, too, must not be thought of as consisting of oxygen and nitrogen, for these two are only the forms under which air is posited. These abstractions, then, are not integrated through one another, but in a third term, in the extremes, which have got rid of their abstraction and have completed themselves into the totality of the notion. As regards the chemical elements, they are called substances after their bases, regardless of their form. Yet with the exception of carbon, none of them can be kept on its own as a substance but exhibited only in the form of a gas. Yet they are, as such, material, ponderable existences, since, example metal, when oxidized by the addition of oxygen, also gains in weight, and white lead, for instance, i.e. lead in combination with the abstract chemical element of oxygen, weighs more than lead in its pure state. Lavoisier's theory is based upon this. The specific gravity of the metal is, however, reduced, it loses its indifferently solid character. These four elements constitute a totality in the following manner. Nitrogen is the dead residue, corresponding to mediety. It cannot be inhaled, nor does it bum, but it can be differentiated. Oxidized, the air of the atmosphere is an oxide of nitrogen. Hydrogen is the positive side of the determinateness in the opposition, the differentiated nitrogen gas. It is incapable of supporting animal life and animals are soon suffocate in it. Phosphorus does not catch fire in it and it extinguishes a light or any burning substance plunged into it, but it is itself combustible and can be made to bum as soon as the air of di-atmosphere or oxygen gas has access to it. The other side of the determinateness, the negative, the activating principle, is oxygen. It possesses a characteristic smell and taste and activates the former two elements. The fourth element in the totality is the defunct individuality, carbon ordinary coal, the chemical terrestrial element. In its transfigured form it is the diamond, which is held to be pure carbon and is, as rigid terrestrial shape, crystalline. Whereas carbon alone can exist independently, the other elements achieve separate existence only by force and so only exist momentarily. It is these chemical determinations which make up the forms out of which solid substances are in general integrated. Only nitrogen remains outside the process, but hydrogen, oxygen, and carbon are the differing moments which are beaten into physically individual bodies, whereby these lose their one-sidedness. 241. 329 The process is abstractly the identity of judgment and the unification of the terms distinguished by the judgment, and in its course, the process is a totality returning into itself. But its finitude consists in this, that the moments of the process also possess bodily independence, so that the totality contains the presupposition of immediate corporealities, which, however, are equally only the products of the process. Because of this immediacy, the bodies appear to exist outside of the process, and the process to come to them. For the same reason, too, the moments in the course of the process fall apart into immediate and distinct processes. The course of the process as a real totality becomes a circle of particular processes, each of which presupposes the other but is itself initiated from without and becomes extinct in its particular product, without from its own resources continuing itself and passing immanently into the process which forms the next moment of the totality. In one of these processes, the body appears as condition, and in another as product, and its specific chemical nature is determined by the particular process in which it occupies one or the other position. Only on the basis of these positions in the particular processes can a classification of bodies be founded. The two sides of the process are, the passage from the indifferent body, through its activation, to neutrality, and from this combination back to dissociation into indifferent bodies. Zusatz. The chemical process is still finite in comparison with the organic process, since the unity of the diremption and the diremption itself, which are absolutely inseparable in the vital process, this infinite activity still falls apart into two sides in the chemical process. That the differentiated sides can be brought together again is, for them, an external and indifferent affair. With the direraption, one process was finished, and a new one can now begin. The finitude of the chemical process consists further in the fact that although each one-sided chemical process is again also the totality, still it is so only in a formal way. Combustion, for example, i.e. the positing of a difference, oxidation, finishes as direraption, but with such a one-sided process. There is also produced a neutrality, water, too, is generated. And conversely, in the process which culminates in the neutral body, there is also differentiation, but only in an abstract manner. Gases, namely, are developed. The shapes, then, which appear in the process are in the first instance stable. The process consists in the positing of such distinct formations into a unity, or in forcing them out of their indifferent existence into difference, without the body being able to preserve itself. The implicit unity of the distinct sides is, it is true, the absolute condition, but since they still appear as distinct bodies, they are only in principle, or notionahui, one, and their unity has not yet come into existence. Acid and caustic potash are in principle identical. The acid is in itself alkali, and that is why it thirsts for the alkali, as caustic potash thirsts for acid. Each has the urge to integrate itself, i.e. each is in itself neutral, but it does not yet exist as neutral. The finitude of the chemical process here, therefore, is that the two sides of notion and existence do not yet correspond to each other, whereas in the living creature the identity of the differences also exists. True, in the chemical process, the differences sublate their one-sidedness, but this sublatin is only relative, a lapse into another one-sidedness. The metals become oxides, a substance changes to acid, neutral products which again are always one-sided. It follows from this, too, that the totality of the process breaks up into distinct processes. The process whose product is one-sided, is itself incomplete, is not the total process. The process is finished when one determinateness has been posited in the other, therefore this process is not itself the genuine totality, but only one moment of the whole, total process. In itself, each process is the totality of the process, but this totality breaks up into distinct processes and products. The idea of the chemical process in its entirety is thus a series of broken processes which represent the various stages and transitional points of that series. In the formal process of the synsomades with which we have already dealt, the difference is not yet a real one. In the actual process, the crucial point is the mode in which the activity exists. In galvanism it exists as a diversity of indifferent bodies. Here, too, the difference is not yet present as a reality, but the mere diversity is posited by the activity of the process as a real difference. Thus we have metals here whose differences are in contact, and because in this association they are active, i.e. are really different, we have process there. In the process of fire, the activity has independent existence apart from the body, for fire is this immanently negative, destructive being for self, the restless, really different element whose outcome is the positing of difference. This process is in the first instance elemental and abstract. Its outcome, which is to give fire a bodily existence, is the transition to the caustic alkalis, to active acids. The third stage now is the process of these active substances, whereas the first was the positing of the oxide, the second the positing of the acid. The differentiating activity now exists in bodily form. This production is the reduction to neutrality, the production of salts. Finally, we have the return of the neutral substance to its beginnings, to acid, to oxide, and to radical. The process starts with the indifferent body, then comes the positing of the differentiated bodies, then their opposition, and lastly, the neutral body as product. But since the neutral body is itself one-sided, it is in turn reduced to an indifferent one. The indifferent body is the presupposition of the chemical process, and this presupposition is the product of the process. In empirical treatment the forms of the substances are the main thing, but the starting point must be the particular forms of process, and so must be distinguished. It is only in this way that the empirically endless variety of substances can be grouped into a rational system, and that one can avoid that abstract universality which chaotically lumps everything together. Combination 3 degrees galvanism. The beginning of the process, and consequently of the first particular process, is made by metal. Metals are, in regard to form, immediate, in different corporealities in which distinct properties are as yet undeveloped and concentrated into the simple determination of specific gravity. Metals, the first kind of bodies, distinguished only inactively one from the other, initiate the process by imparting to each other their immanent determinateness and difference, through this compact unity of their nature. In doing so, they enter into a state of tension towards each other, for they are at the same time independent. The tension is thus still. 245. Electrical, but in the neutral, hence separable, medium of water, in combination with air, their difference can actualize itself. Through the neutrality of water, and hence of its real capacity for differentiation, the water may be pure, or salt, etc., may be added to make it capable of a more concrete action. A real activity develops between the metal in its state of tension and the water. With this, there is a transition from the electrical to the chemical process. Its production is oxidation generally, and deoxidation or hydrogenation of the metal, or at least the generation of hydrogen gas and likewise oxygen gas, that is, a positing in abstract, independent existence of the differences into which the neutral element has been sundered, just as, at the same time, their union with the base comes into existence in the oxide, the second kind of corporeality. Remark. On this exposition of the process, insofar as it is present in its first stage, there is no difficulty either in distinguishing between the electrical and chemical aspects of the process in general, and of the galvanic process in particular, or in grasping their connection. But physicists persist in seeing only electricity in the galvanic process, so that the difference between the extremes and middle term of the syllogism is grasped merely as a difference between dry and wet conductors, extremes and middle term being alike classed as conductors. It is not necessary here to take account of further modifications of the process, e.g. the extremes can be different fluids and the middle term a metal. In some cases, the form of electricity can be held to, and sometimes made to predominate, whereas sometimes the chemical action can be intensified, also whereas metals are so independent that they can be differentiated only by the help of water and other more concrete neutral substances or by substances such as acids or alkalis which are already in a state of chemical opposition. In order to pass over into oxides, the metalloids percent by contrast, so lack independence that their differentiation is set off simply by contact with the air, which converts them into earths, etc. These and many other particularities do not alter the basic phenomenon of the galvanic process, which we shall call by its first, well-deserved name, but on the contrary, tend to confuse our treatment of it. The fundamental affliction which has killed a clear and simple treatment of the process, once its simple chemical character had been shown up in the voltaic pile, has been the conception of wet conductors. This has resulted in the ignoring, the giving up, of the conception, of the simple, empirically evident fact that water, the middle term of the process, is originally and manifestly active. It is regarded not as an active, but as a passive conductor, with the consequence that electricity, too, is regarded as something complete in itself and as only flowing through water as it does through metals, for metals, too, are in this connection seen only as conductors percent and in comparison with water, as first-class conductors. However, the active relationship of water in the process, ranging from the simplest relation, i.e. between water and a single metal, to the complex relations arising from modified conditions, is to be found demonstrated empirically yet with all the force of intuition and with the notion of a living natural activity, in Pohl's work, The Process of the Galvanic Circuit. Perhaps this higher demand addressed to the instinct of reason, to grasp the course of the galvanic and the electrical process as such, conceived as a totality of natural activity, is responsible in part for the fact that the lesser demand, viz., simply to take notice of empirically demonstrated facts, has up till now met with scant compliance. An outstanding example of the ignoring of facts in this field is the idea of a decomposition of water into oxygen and hydrogen when the former appears at one pole of the battery in whose sphere of action the water is placed, and the latter at its opposite pole. In this idea, water is regarded as consisting of oxygen and hydrogen, and its decomposition is represented as happening as follows. From the pole where the oxygen is developed, the other constituent of water, hydrogen, is mysteriously transmitted across the medium, which still exists as water, to the opposite pole, and reciprocally, the oxygen is similarly transmitted from the pole where the hydrogen is developed to the opposite pole. Also, the two gases are represented as passing through each other in their *47 passage from one pole to the other. Not only does the inherent fallacy of this conception pass unnoticed, but it is also overlooked that in dividing the material substance of the two portions of water a division which is, however, so arranged that there is still a connection, but only by a metal conductor the production of oxygen gas at one pole and of hydrogen gas at the other, takes place in the same manner under conditions which render impossible this intrinsically groundless, mysterious passage of gases or molecules through each other to their respective sides. A similar ignoring of experience occurs in connection with the neutralization of an acid and an alkali when one is placed at an opposite pole to the other. Here, too, the neutralization of the alkali is represented as due to a portion of the acid being transferred to the alkali from the opposite pole, as conversely the neutralization of the acid is represented as due to the transfer of a portion of the alkali from the opposite side. Yet when a litmus solution is placed between them, No trace can be perceived in this visible medium of any action, and consequently not of the presence, of the acid which is supposedly passing through it. It is also in place here to mention that the treatment of water as a mere conductor of electricity with the experience of the weaker action of the pile with such a medium than with other, more concrete agents has produced the original conclusion that TLO pure qui transmet un électricité forte, telle que nous excitons parnos machines ordinaires, deviant presque pour les faibles forces de one appareil électromoteur. Only the obstinate adherents to a theory which can disregard such consequences can have the audacity to make water an insulator of electricity. But as regards the central feature of the theory, viz. the identification of electricity and chemical action, the difference between these two processes is so striking that the theory is almost forced to beat a retreat, but then soothes itself by admitting that this difference is inexplicable. Certainly it is. If an identification is presupposed, this very circumstance makes difference inexplicable. The superficiality and inadequacy of equating the chemical properties and relationships of bodies with positive and negative electricity should be at once plain, in comparison with chemical relationships, tied though these are to external conditions, e.g. temperature, and otherwise relative. Electrical phenomena are wholly transient, unstable, and liable to reverse by the slightest circumstance. Whereas, also, the bodies of one side of the chemical relation, e.g. acids, are exactly distinguished from each other by their quantitative and qualitative ratios of saturation by an alkali, in the case of the merely electrical opposition, even were this more stable, no such kind of distinction is possible. But even if the entire visible course of real material change in the chemical process is ignored and attention fixed only on the product, it is impossible to avoid expressing surprise at the striking difference between this product and that of the electrical process, after the previous identification of the two forms. I will confine myself to quoting the naive expression of this surprise in Berzelius's work, Essai sur la théorie de proportions chimiques etc. He says, 11 essative portant ici une question qui ne peut être résolue par aucun phénomène ie analogue que la décharge électrochimique ils restant dans cette combinaison avec une force, qui est supérieure que toutes celles qui peuvent produire une séparation mécanique. Les phénomènes électriques ordinaires ne nous tombent pas sur la cause de punion permanente de corps avec un SI grande force, APRNSKL état d'opposition électrique SD and root. The changes in specific gravity, cohesion, shape, color, etc., occurring in the chemical process and, in addition, in the acid, caustic, alkaline, and such like properties, are all set aside and submerged in the abstraction of electricity. Let philosophy no more be reproached with its ignoring of particularity and its empty generalities, when all the physical properties just mentioned can be disregarded in favor of positive and negative electricity. A former style of philosophy of nature potentialized, or rather dissipated and attenuated the system and process of animal reproduction to magnetism and the vascular system to electricity. Such schematism was not more superficial than this reduction of concrete, corporeal opposition to electricity. In the former case, such a summary method of dealing with concrete phenomena to the neglect, by abstraction, of their characteristic features, was rightly rejected. Why not also in the present instance? But there is a remaining point of difficulty in the difference between the concrete process and the abstract schema, viz. the strength of the combination of the substances formed into oxides, salts, etc., as a result of the chemical process. T9 strength, of course, offers a marked contrast to the result of the merely electrical discharge, which leaves the positively and negatively charged bodies in just the same state, and so separate and uncombined as they were before and during the process of being rubbed together, while the spark has disappeared. It is the spark which is really the result of the electrical process. It is with the spark, therefore, that the result of the chemical process should be compared in respect of the difficulty arising from the alleged likeness of the two processes. Should it not be possible to remove the difficulty by assuming the positive and negative electricity to be combined in the discharge spark with the same strength as, say, acid and alkali are combined in the salt? The spark, however, has disappeared, so that it can no longer be compared, but the main point I9 that a salt or oxide is manifestly a further resultant step than an electric spark. The light and heat generated in the chemical process are also improperly ascribed to such a spark. Berzelius says the following about the alleged difficulty: SCELF at d'une force particulière in here and auxiliary atoms, comme la polarisation d'électrique. I.e., is there not a difference between chemical and electrical action in bodies? Undoubtedly and obviously one OSCE on propriet 61 électrique qui n'est pas sensible dans les phénomènes ordinaires vie as above, in strictly electrical phenomena. This question also is to be answered with a simple affirmative, viz. That in electricity as such, chemical action I9 not present, and is for that reason not perceptible, and that it is only perceptible at the stage of chemical process. However, as regards the first possibility, that of a difference between the chemical and electrical determination of a body, Berzelius rejoins, la permanence de la combinaison ne devait pas stressumis à l'influence de l'électricité. That is, two properties of a body, because they are different, must not stand in any kind of relation to each other, the specific gravity. 249. Of a metal is not to be connected with its oxidation, nor its metallic luster or color with its oxidation, neutralization, etc. It is, on the contrary, the commonest experience that the properties of bodies are essentially subject to the influence of the action and change of other properties. It is the dry abstraction of understanding that insists on the complete separation and independence of properties which are different, even when they belong to the same body. As regards the other possibility, viz. That electricity has the power to break up strong chemical compounds, though this power cannot be perceived in ordinary electricity, Berzelius observes, l'établissement de la polarité électrique devrait être MNME la plus forte combinaison chimique, and adduces in support the special instance of a voltaic pile consisting of 8 or RO pairs of silver and zinc plates the size of a 5-franc piece, which pile, with the aid of mercury, is able to decompose potash, i.e. to preserve the radical of potash in an amalgam. The difficulty was caused by ordinary electricity not showing the power in question, as distinct from the action of a galvanic pile. Now for ordinary electricity there is substituted the action of such a pile, with the simple modification that it is called batterie électrique, whereas previously the name for it in the theory was appareil électromoteur. This turn of expression, however, is all too transparent and the proof too easily taken, since in order to resolve the difficulty which stood in the way of identifying electricity and chemistry, one again straightway presupposes that the galvanic pile is merely an electrical apparatus and its activity merely the production of electricity. Zusatz. Each single process starts from something seemingly immediate which, however, at another point in the run-round of the periphery, is in its turn a product. The beginning, properly speaking, is with a metal as a substance inwardly stable whose apparent difference from another metal results from comparison. Thus gold is indifferent to its difference from zinc, it is not immanently distinguished like the neutral substances or oxides, i.e. it cannot be decomposed into opposed sides. Metals are thus, in the first instance, only inertly diffident from one another, but they are also not only different for us, for if they come into contact with each other they distinguish themselves from each other. The continuity of metals is the condition that make it possible for their difference to become active, so that the difference of each can be posited in that of the other. But a third substance is required, capable of a 2si real differentiation in which the metals can integrate themselves. It is on this third substance that the difference of each metal feeds dire Naran hat. Metals are not brittle like resin or sulfur where the determination posited in them is restricted to one point. In metals, the determinativeness is communicated to the whole body, and the difference of each is open to the other, each making its difference felt in the other. The difference of metals, then, is revealed by their relationship in process, which relationship is, in general, the antithesis of their inherent preciousness, solidity, ductility, and fluidity, to their brittleness and their readiness to form oxides. The precious metals such as gold, silver, and platinum, are not oxidized when heated and exposed to air. Their process in an open fire is a burning without a burning up. They do not decompose into the extremes of base and acid, which would fix them as belonging to one of these sides. All that happens is a non-chemical change of shape from the solid to the molten state. This comes from their lack of difference. The notion of this solid, simple nature of metal seems to be represented in its purest form by gold. That is why gold does not rust and old gold coins are still untarnished. Lead and other metals are, on the contrary, attacked even by weak acids. The still more numerous metals known as metalloids are those which are hardly ever found in their pure state and are oxidized merely by exposure to the air. Gold, silver, and platinum, even when oxidized by acids, can be restored to their original state without adding any combustible substance such as coal. They return to their pure form merely by being brought to a red heat in the furnace. Mercury, it is true, can be vaporized by heat, and when shaken and pounded under exposure to the air, admittedly does change into an imperfect, grayish-black oxide, and by continuous heating into a more complete dark red oxide with a sharp, metallic taste. But as Tromsdorf observes, when mercury is shut up in dry air and left to stand, its surface does not suffer change and does not rust. Yet he had seen a phial of mercury which old Butner had kept goodness knows how many years * which had oxidized, and which had on top a thin layer of red mercuric oxide. However, this and all other oxides of mercury can be brought back to mercury in its pure form by making them red hot and without adding combustible substances. Schelling, therefore, regards these four, gold, silver, platinum, and mercury, as precious metals, because in them is posited the indifference of essence and form. On the contrary, those metals are not to be regarded as precious in which form is most separated out of indifference with the essence, and in which selfhood or individuality is the predominant feature, as in iron, nor are those metals precious in which the incompleteness of form vitiates the essence, making them impure and bad, like lead, etc. But this is not enough. It is not simply their high degree of continuity and solidity, but also their high specific gravity which makes metals precious. Platinum, it is true, has a greater density than gold, but it is a unity of several metallic moments. Osmium, iridium, and palladium. Stephens, even before Schelling, maintained that density stands in inverse ratio to cohesion, but this is true only of some precious metals as gold, for example, whose specific cohesion is less than that of the less precious, Lee's brittle metals. Now the greater the difference between metals, the more active they are, too. If we put gold into contact with silver, copper, or zinc, or silver into contact with zinc, and put a third substance between them, a drop of water, we at once have a process and one of considerable activity. This is a simple galvanic circuit. It was accidentally discovered that the circuit μ9T be closed. If it is not closed, there is no active difference and no action takes place. The process is usually represented in this way, that the bodies are merely there, and in their contact only press against each other as heavy matter. But we saw that even in electricity, bodies act on each other according to their physical determinateness. Here with the metals, it is similarly their diverse natures, their specific gravities, which are in contact. Since the simple galvanic circuit is no more than the connection of opposites by a third, a solvent, neutral substance in which the difference can enter into existence, metallity is not the only condition of this activity. Liquids, too, can have this form of the process, but it is always their simple, distinctive difference which is the active principle of the process, as it is with the metals. Charcoal, too, which Ritter looked on as a metal, can enter into the galvanic process. Charcoal is burnt up vegetable matter, and as such a residue in which determinateness is extinguished. Charcoal, too, has the same indifferent character. Even acids, on account of their fluidity, can produce the galvanic process. If soapy water and ordinary water are connected by a piece of tin, a galvanic current is produced. If the soapy water is touched with the tongue and the ordinary water with the hand, then with the closing of the circuit the organs of taste are affected, but if the circuit is alternately opened and closed, they are caffected when it is opened. Humboldt observed simple galvanic circuits produced by hot and cold to ink and moisture. Schweiger constructed similar piles from heated and cold copper dishes filled with dilute sulfuric acid. Such differences too, therefore, induce the action. When the body in which the effect I9 produced is as delicate as muscle tissue, the difference can be much slighter. Now the activity of the galvanic process has its origin in the immanent contradiction which arises from the effort of each particularity to posit itself in the other. But the activity itself consists in the positing of the inner, merely implicit unity of these inner differences. In the galvanic process, electricity is still predominant since what is posited as different are metals, i.e. they are indifferent, independent existences which hold to themselves even in being changed, the very thing which characterizes electricity. On the one side there must be a negative pole, and on the other a positive one, or in chemical terms, oxygen must be developed here and hydrogen there. These phenomena were associated in the 253 conception of electrochemistry. Some physicists went so far as to believe that electricity was tied to chemical action. Wollaston even said that electricity was only present where there was oxidation. It was properly objected to this that when catskin is rubbed on glass, electricity is produced without oxidation. The metal is neither dissolved nor decomposed by the chemical action, so that it proves to be a neutral substance in its own self, but the real difference exhibited by the metal in oxidation is a difference added to it, for the metal is combined with something else. The two metals are combined in the first instance without the existence of a middle term. This middle term is only nominally present in their contact. But the real middle term is what the difference has to bring into existence, this term which, in the logical syllogism, is the simple medius terminus, is a duality in nature itself. In this finite process, the mediating term, which is turned towards the two one-sided extremes, and from which these extremes are to integrate themselves, must be not merely a nominally distinct substance, but its difference must actually exist, that is to say, it is precisely the middle term which must have a break in its existence. Galvanic action also requires the air of the atmosphere or oxygen gas. If the galvanic pile is insulated from the atmospheric air it remains inactive. Tromsdorff adduces the following experiment by Davy: if the water between the plates is perfectly pure and the outside air is kept from the volume of water by a coating of resin, then no gas is released in the water, and no oxide formed, and the zinc in the pile is hardly affected. Biot urged against Davy that beneath an air pump a voltaic pile still produces gas, though more feebly. This, however, is because the air cannot be completely exhausted. The fact that the middle term is a duality explains why the activity is much intensified if, instead of sheets of cardboard or cloth, hydrochloric acid or sal ammoniac is put between the metals. Such a mixture is already in itself chemically complex. This activity is called galvanism because Galvani first discovered it. Volta, however, first understood it. Galvani at first made quite a different use of it. It was Volta who first freed the phenomena from organic associations and reduced the activity to its simple conditions, though he took it to be mere electricity. Galvani found that when the spinal nerves of a frog were exposed and connected with the leg muscles by different metals, convulsive movements occur which manifest the activity which is the contradiction of these differences. Aldini showed that one metal was sufficient to produce the effect, namely, pure mercury, and that often a wet hempen cord was sufficient to effect this active connection between the nerve and the muscle. He ran such a cord, 250 feet long, round his house with successful results. Someone else found that in large, vigorous frogs, the mere contact of the leg with its nerve would produce jerks without T6 armature. According to Humboldt, where two like metals are used, the metallic stimulus can be evoked simply by breathing on one of them. If two parts of one and the Same nerve are covered by two different metals and connected by a good conductor, this too will produce convulsive movements. This was the first form. It was called animal electricity because it was thought to be restricted to organisms. Volta used metals instead of muscles and nerves, and he thus made up galvanic batteries out of a whole number of such pairs of plates. Each pair has the opposite determinate anisa of the following pair, but the activity of these pairs is summed up, so that at one end there is all the negative, at the other end all the positive activity, the middle being the point of indifference. Volta also distinguished between wet conductors and dry conductors as if nothing but electricity were present here. But the difference between water and metal is something quite different, and neither of them plays the part of a mere conductor. It is easy to separate electrical from the chemical activity. The greater the surface area of the plates, say 8 square inches, the more brilliant is the electric spark produced. The size of the surface appears to have but little influence on the other phenomena. On the other hand, with only 3 pairs, sparks are produced. If, in a battery constructed of 40 pairs of this size made of zinc and copper, the silver pole and zinc pole are connected by an iron wire, at the moment of contact a rose of fire appears, 3 to 3 inches in diameter, some of the rays being quite if inches long, in some places linked together and having little stars at their tips. The communicating wires are so firmly welded by the spark, that a considerable force is required to separate them. In oxygen, gold and silver behave as they do in atmospheric air. Iron wires catch fire and bum away, and lead and tin bum very vigorously and with vivid colors. Now if chemical action here is reduced, it becomes distinct from combustion, for with electricity, too, vigorous combustion occurred but as a melting by heat, not as a decomposition of water. Conversely, the chemical action is increased and the electrical action diminished, if the plates are smaller but more are used, 1000 pairs, for example. However, the two activities are also combined, so that water is decomposed by a powerful electric discharge. For Bayet says, pour decomposer lo, on ss diabord servi de violence dec args tranamises and traverse ce liquide, et qui producient de explosions accompanies de en cells. Mais Wollaston est parvenu and perdur lera 6 mi effect, d'une manière infiniment plus marquée, plus sure et plus facile, and conducent le courant électrique dans l'opar de fils tresses, turoins and points eggs, etc. Ritter, of the Munich Academy, has constructed dry batteries where electrical activity is insulated now, since it has been observed that with water alone chemical action is not strong in a battery which, with a different construction, could produce strong chemical action and high electrical tension. Chemists have concluded that water here acted as an electrical insulator which prevents the transmission of electricity, for since without this obstacle there would be a strong chemical action, and the action here is weak, the inference is that. 54. 55 The transmission of electricity which gives rise to the chemical action is prevented by the water. But nothing more absurd could be imagined, since water is the most powerful conductor, more powerful than metal, and this absurdity comes from attributing chemical action solely to electricity and from thinking merely in terms of conductors. Galvanic action is manifest both as taste and light. If, for example, a strip of tinfoil is placed under the tip of the tongue and on the lower lip, so that it projects from it, and if the upper surface of the tongue and the tinfoil are touched with silver, then the moment the metals touch, a pronounced alkaline taste is experienced like that of sulfate of iron. If I hold in my wet hand a tin saucer filled with lye and touch the liquid with the tip of my tongue, I get an acid taste on that part of my tongue which has touched the alkaline liquid. If, on the contrary, I place a tin, or better still a zinc, dish on a silver foot and fill it with clean water, stick the tip of my tongue in the water, it has no taste, but if at the same time the silver foot is held in a thoroughly moist hand, a weak acid taste is at once felt on the tongue. If a bar of zinc is put in one's mouth between the upper jaw and left cheek, and a bar of silver between the lower right jaw and the right cheek, so that the bits of metal stick out of the mouth, and their ends are brought together, then one has in the dark the sensation of light when the metals make contact. Here the identity is subjectively present in sensation, without the production of an external spark, though this does of course happen with powerful batteries. Now the product of the galvanic action is, in general, that which is in itself or has only notional existence, the identity of the particular differences which in metals are also bound up with their indifferent self-subsistence attains to an existence, as does also the difference of one metal in the other, and the indifferent is therefore posited as different. The process still cannot go on to the production of a neutral substance, for there are still no existent differences. Now since these differences are not yet bodies themselves but only abstract determinatenesses, the question arises, in what forms should they come into existence here? The abstract existence of these differences is elemental in nature, and we see it manifested as aeriform, gaseous substances. Here, then, we have to speak of abstract chemical elements. Thus, because water is the mediating neutral term between the metals, in which these differences can come into contact, it follows that each metal takes its existent difference from water, and determines water, on the one hand, towards oxidation, and on the other, towards hydrogenization. But since the character of water generally is to be neutral, the activating, differentiating principle does not exist in water but in air. The air does, indeed, seem to be neutral, but it is the stealthily destructive activity. The metals, therefore, must take from the air the activity which they display, and that is why the differences appear in gaseous form der Luftigkeit. In this process, oxygen is the activating, differentiating principle. The more specific result of the galvanic process is the oxide, a metal posited with a real difference. The first real difference we have, the indifferent body, becomes a totality, although stdll not a complete totality. But though the product is at once also dual, oxidation and hydrogenization, the outcome is not two differentiate bodies. On one side we have oxidation, e.g. zinc is oxidized. The other side, the gold, silver, etc., holds out in its solidity against its opposite, retains its pure form, or if it has been oxidized, it is deoxidized, restored to its pure form. Since the activation of zinc cannot be the positing of a one-sided difference, and can, on the other side, perhaps not be deoxidized, the other side of the opposition appears only under the other form of water, namely, as hydrogen. It can also happen that instead of oxidized metals, hydrogenized metals are produced, a fact established by Ritter. But the specific difference as opposition is alkali and acid, something different from that abstract differentiation. But even with such a real differentiation, the opposition is mainly brought about by the oxygen. The metal oxides which result from the galvanic process also belong the earths, silica, calcite, barytes, sodium, potassium, for the earths have in general a metallic base. It has been possible to demonstrate the metallic nature of these bases, although many have only slight indications of a metallic base. Now, though this metallic nature cannot always be preserved in its independence, as happens with the metalloids, it is exhibited in amalgams with mercury, and only metallic substances can form amalgams with mercury. In the metalloids, therefore, metallity is only a moment, they rapidly become oxidized again, wolfram, example, being obtained in its pure state only with difficulty. A specially noteworthy feature of ammoniac is that, on the one hand, it can be demonstrated that its base is nitrogen, its other constituent being hydrogen *, but also that it has a metallic base, ammonia. Here the metallity is carried to the stage where it is also manifested as a chemically abstract substance, as a gas. The process terminates in the product of oxidation. The opposition to this first, abstract, general negation is the free negativity, self-subsistent negativity, in contrast to negativity paralysed in the indifference of the metal. Though opposition is necessary in principle or in conformity with the notion, but its existence, as fire, is brought about contingently. 33*. The process of fire, the activity which, in the previous process, was only implicit in the differentiated determinateness of the metals brought into relation, when posited as an independent existence, is fire, whereby what is in itself combustible. The German text has *Sauerstoff / 257. Kind of corporeality is kindled into flamme, whereby also, in general, those bodies in which difference is still indifferent and inert, are energized into the chemical opposition of acid and alkali, not so much to a peculiar kind of real corporeality, for they cannot exist independently, as merely to a peculiar posited being of the corporeal moments of the third form. Zusatz. With the cessation of the galvanic process in the production of the metallic oxide, of earth, the course of the chemical process is interrupted. For chemical processes do not hang together, otherwise we should have life, the circular return of a process. If, now, the product is to be carried further, activity must come in from outside, just as the metals, too, were brought together by an external activity. It is only the notion, the inner necessity, which therefore carries the process forward. It is only in principle that the process is carried onward into a circular totality. Since the new form we introduce has its genesis only in us, comes to be only in principle or in itself, we must take the bodies entering into the process as they naturally are. It is not the same existing product that would receive further treatment, as it were only by other reagents, as in itself determinate. The object of the process must rather be taken up as something original, not something which has come into existence. That it has come into existence is a characteristic it possesses as a simple, inner, notional determinateness. One side of the process is fire as dame, in which the unity of the difference which resulted from the galvanic process, exists for itself, namely in the form of free, restless activity, of self-destruction. The other side, the combustible substance, is the object of fire, of the same nature as fire, but in the form of a physically existent body. The product of the process, then, is that on the one band fire exists as a physical quality, or conversely, that in the material substance there is posited what already constitutes its natural determinateness, namely, fire. As the first process was the process of what is heavy, so here we have the process of what is light, in which fire assumes the bodily form of an acid. The physical body, as the possibility of being consumed and activated, is not a mere lifeless reduction to passive indifference, but itself bums. Now because the material thus activated is inwardly a sheer opposition and so self-contradictory, it stands in need of its other, and only is in real connection with its other. The combustible substance thus has two different forms, since this being for self of the negative, in determining itself as different, posits itself in its own differentiation. One form is the ordinary combustible substance, sulfur, phosphorus, etc., the other form is a neutral substance. It is not the nature of either, but only a mode of existence, to persist tranquilly, whereas in the galvanic process, the metal's indifference constitutes its very nature. A more remarkable feature of 824-8375K. These substances is their mere shining without burning, the phosphor's sense shown by a number of minerals, when they are scratched or scraped or even exposed to sunlight, they remain phosphorescent for quite a time. It is the same sort of transient light phenomenon as electricity but without dualism. The range of primary combustible substances is limited, it embraces sulfur, bitumen, and naphtha. It is the brittle body without a firm indifferent base, which does not receive difference from outside by combining with an actively different body, but which develops the negativity immanent in itself as its own self. The body's indifference has passed into a chemical difference. The combustibility of sulfur is no longer the superficial possibility which remains possible in the process itself, such an indifference is actually abolished. The combustible substance bums, fire is its actuality, it does not merely burn, but bums up, it ceases to be indifferent, has become an acid. Indeed, Winterl has maintained that sulfur is as such an acid, and in fact it is, since it neutralizes saline and earthy bases and the metals, even without making use of the water base required by the rest of the acids. The second form of combustible substance is the formally neutral body, and the existence of this, too, is only a form not constitutive of its nature. If it were, it might survive the process. The formally neutral bodies are lime, barytes, potash, in a word the earths, which are nothing but oxides, i.e. they have a metal for their base, a discovery brought to light by the galvanic battery, whereby alkalis are deoxidized. The alkalis, too, are metal oxides, animal, vegetable, or mineral. The other side to the base, e.g. in lime, is the carbonic acid we produce by heating charcoal, a chemical abstraction, and not an individual, physical body. Lime is thus neutralized, but it is no real neutral body, such neutrality being effected only in an elemental, general way. Barytes, strontium, are not regarded as salts since they are not neutralized by a real acid, but by this same chemical abstraction which appears as carbonic acid. These are the two combustibles constituting the other side of the process. The substances in conflict with each other in the process of fire come together only externally. This is conditioned through the finitude of the chemical process. They are mediated with each other by elements, i.e. air and water. To produce the acid of sulfur, wet partitions and air are used. The whole process thus has the form of a syllogism with a broken middle term and two extremes. The more particular forms of the syllogism concern the modes of the activity, and that to which the middle term is determined by the extremes in order to integrate themselves from it. To deal with this more closely would involve going into refinements of detail which would make us digress too far. Every chemical process would have to be set forth as a series of syllogisms, where what was at first an extreme, becomes a middle term, and the middle term gets posited as an extreme. What in general happens is that the combustible substance, sulfur, phosphorus, or some formally 259 neutral substance, is activated in the process. It is thus that earths are made caustic by fire, whereas in their previous state, as salts, they were mild. Metals, too, can be so activated by burning that they do not become oxides but are driven straight on to become acids. The oxide of arsenic is itself arsenious acid. Alkali if activated is corrosive, caustic, acid, too, attacks and destroys bodies. Since sulfur contain no indifferent base, water here becomes the basic bond so that the acid can, even though only for a moment, exist independently. But when an alkali becomes caustic, the water which, as water of crystallization was the bond of neutralization, loses its formally neutral shape under the action of fire. Such an alkali already has on its own account an indifferent metallic base. 332. Neutralization, water process body thus differentiated is in a state of sheer opposition to its other. This is its quality, so that it essentially is, only in its connection with its other. It is only by violence, consequently, that its corporeality has an independent, separate existence. In its one-sidedness it is, in its own self, the process of positing itself as identical with the negative of itself, even if this process is only with the air, in which acid and caustic alkali lose their strength, i.e. are reduced to formal neutrality. The product is the concrete neutral body, a salt, which is the fourth kind of body and in the form of a real body. Zusatz. A metal is only implicitly different from its other, the other is contained in the notion of the metal, but only in its notion. Since, however, each side now exists as an opposite, this one-sidedness is no longer merely implicit but posited. The individualized body, therefore, is the urge to overcome its one-sidedness and to posit the totality which, in its notion, it already is. Both sides are physical realities, sulfuric or some other acid but not carbonic acid, and oxides, earths, alkalis. These opposites thus activated, do not need the presence of a third substance in order to become active. Each has in its own self the restless urge to sublate itself, to integrate itself with its opposite and neutralize itself, but they are not capable of independent existence since they are incompatible with themselves. Acids get hot, catch fire, when water is poured on them. Concentrated acids give off fumes, absorb water from the air. Concentrated sulfuric acid, for example, increases its volume in this way, occupies more space, but becomes weaker. Acids kept in airtight vessels attack the latter. Caustic alkalis similarly lose their causticity. It is then said that they absorb carbonic acid from the air, but this is hypothetical. The truth rather is that they first form carbonic acid from the air in order to neutralize themselves. What activates both sides is a chemical abstraction, the chemical element of oxygen as the differentiated abstraction. The bases are the indifferent subsistence, the bond. The activation of both acids and alkalis is therefore an oxygenation. But the difference of acid and alkali is something relative, as already appears in the opposition of positive and negative. Thus in arithmetic, the negative is to be taken partly as negative in its own self and partly as merely the negative of another, so that it does not matter which is negative and which positive. The case is similar in electricity with its two opposite directions, where the movement to and fro brings one back to the same standpoint, and so on. Acid, therefore, is certainly in its own self what is negative, but the relativity of the relationship also makes its appearance. What from one side is an acid, is from another side an alkali. Sulfuret of potash, for example, is called an acid although it is hydrogenated sulfur. Here, then, an acid is a hydrogenization. Admittedly, this is not so in every case, and is here due to the combustibility of sulfur. Through oxidation, however, sulfur becomes sulfuric acid, which shows that it is capable of both forms. The same is true of a number of earths which fall into two groups: lime, barytes, strontium are alkaline and metallic oxides. In the case of silica, clay, and talc, this may be conjectured, partly by analogy and partly from traces of galvanic process in the amalgam. Stephens, however, opposes talc and silica to the alkaline series. According to Schuster, alum also reacts to alkalis, i.e. is acid. On the other hand, its reaction to sulfuric acid 19 that it takes up the position of base, clay in solution in alkalis is precipitated by acids and therefore behaves as an acid. The double nature of alum is confirmed by Berthollet Stat K. Chemic, Part 2, p. 302 L. Alumina on disposition presquiggle KSE combiner avec les acids et avec les alkalis, p. 308, L. Acide nitrique aussi la propre pound t pound de cristalliser avec relumen, il est probable que ces pound galement parle moyen d'une base alkaline. Silica, says Schuster, is an acid, though a weak one, for it neutralizes the bases and then combines with potassium and sodium to form glass, and so on. Berthollet remarks, though, that they merely have a stronger tendency to combine with alkalis than with acids. Here, too, air and water act as the middle terms, for anhydrous, completely concentrated AD has a much weaker action than dilute acid, especially if air is excluded, for then action can cease altogether. The general, abstract result is that acid combines with an alkali which has not been brought to the activated stage, to form a neutral substance as such, which is, however, not an abstract indifference but a unity of two existent substances. They sublate their opposition, their contradiction, since they cannot endure it. 261. And in thus sublating their one-sidedness, they posit what they are in their notion, both the one and the other. It is said that an acid does not act directly on a metal, but first turns it into an oxide, into one of the sides of the existing opposition, and then neutralizes itself with this oxide which, though differentiated, is not activated to the point of being caustic. It is the salt which, as product of this neutralization, first is the chemical totality, the center, but it is still not as yet the infinite totality of life, but a totality come to rest and circumscribed by other totalities. 333 The process in its totality. These neutral bodies, returning into mutual relation, form the chemical process in its complete reality, for the sides of the process are such real bodies. Their mediation requires water, the abstract medium of neutrality. But the sides, being neutral on their own account, are not differentiated as against each other. Here we have the particularization of general neutrality, and with it also the particularization of the differences of the chemically active bodies in their mutual opposition. This is the so-called elective affinity, the formation of other particular neutralities through the breakup of those already present. Remark. The most important step towards simplification of the details of elective affinity is the law discovered by Richter and Gitten-Morveau, which states that neutral compounds suffer no alteration in regard to their state of saturation when they are mixed in solution, and the acids exchange bases with each other. It is on the basis of this law that the quantitative scale of acids and alkalis has been constructed, according to which each particular acid is saturated by a specific quantity of each alkali, so that if the alkalis are arranged in a series according to the amounts with which they saturate the same quantity of a particular acid, then for every other acid, the alkalis retain among themselves the same ratio for the saturation of this acid, as for the first one. All that varies is the quantitative unit of the acids combining with this constant series. In the same way, the acids bear a constant ratio to each other, relative to the various alkalis. Elective affinity itself is, however, only an abstract relation of acid to base. The chemical body in general, and especially the neutral body, is at once a concrete physical body having a definite specific gravity, cohesion, temperature, etc. These strictly physical properties and their alterations in the process enter into relation with the chemical moments of the process, and thereby impede, obstruct, or facilitate, and so modify the chemical action. Berthollet, in his famous work Statique Chimique, while fully recognizing the serial law of elective affinity, has brought together and investigated the circumstances which produce alterations in the results of chemical action, results which are often one-sidedly attributed only to elective affinity. He says, the superficiality which these explanations have introduced into the science is especially regarded as progress. Zusatz. The immediate self-integration of the opposites, the alkali and the acid, into a neutral substance, is not a process. The salt is a process-less result, like the adherence of a magnet to the north and south poles, or the spark in an electric discharge. If the process is to be carried further, then the salts, being indifferent and not in need, must be brought together again in an external manner. The activity is not in them but is brought forth again only by contingent circumstances. Substances which are indifferent to each other can come into contact only in a third substance, which here again is water. It is here especially that formation and crystallization have their seat. The process, in general, is this: one neutrality is sublated, but another one is brought forth in its place. The neutrality is therefore here engaged in conflict with itself, for the neutral ity which is product is mediated by the negation of neutrality. We have, therefore, particular neutralities of acids and bases in mutual conflict. The affinity of an acid for a base is negated, and the negation of this affinity is itself the relation of an acid to a base, or is itself an affinity. This affinity I9 equally the affinity of the acid of the second salt for the base of the first, as it is also the affinity of the base of the second salt for the acid of the first. These affinities, as negating the first affinities, are called elective affinities, which means no more than that here, as in magnetism and electricity, opposites acid and alkali posit themselves as identical. The way in which this process exists, appears, acts, is the same. One acid expels another from a base, as the north pole of a magnet repels the north pole, but each remains linked with the same south pole. Here, however, the comparison of the acids with each other takes place in a third. Each particular acid has its opposite which is more its base than another. The determination does not result merely from the general nature of opposites, since the chemical process is the sphere of kinds. 263. Which are qualitatively active against each other. The main thing, therefore, is the strength of the affinity, but no affinity is one-sided. The degree of my kinship with another is the degree of his kinship to me. The acids and bases of two salts break up their combination and form fresh salts, The acid of the second salt combining more readily with the base of the first and expelling its acid, while this acid has the same relationship to the base of the second salt. In other words, an acid abandons its base when offered another base to which it has a greater affinity. The result is another neutral reality. The outcome, therefore, is of the same kind as the beginning formal return of the neutral substance to itself. The law of elective affinities discovered by Richter, to which we referred in our remark, remained unknown till the English and French talked of Richter and made use of his work and so made it important. The same thing will happen with Goethe's theory of color. It will not succeed in Germany till a Frenchman or an Englishman takes it up or else expounds the same theory himself and gains acceptance for it. It is no use complaining of this, it is always that way with us Germans, unless indeed some trashy theory like Gall's phrenology is propounded. Now this principle of stoichiometry of Richter's, expounded by him with a wealth of erudite reflections, can be most easily pictured by the following comparison. If I buy various goods with gold coins, then for a certain quantity of the first article, for example, I require 1 gold coin, for the same quantity of the second article, 2 gold coins, and so on. Now if I buy with silver coins, I need more of these, namely, 5 silver coins instead of 1 gold coin, $11 instead of 2, and so on. The values of the goods preserve the same ratio with one another. An article having twice the value of another always keeps that relative value, no matter in what coinage it is measured. And the different kinds of coins likewise stand in a specific ratio, according to their relative values they therefore cover the cost of a certain portion of each article. If, therefore, the gold coin is $5 as much as 1 silver coin, and 1 silver coin covers the cost of 3 parts of a particular article, then the gold coin covers the cost of 5 3 parts. Berzelius adopted the same point of view in connection with the degrees of oxidation and sought to reduce them to a general law, for in this process, one substance uses up more oxygen than another. For example, to saturate 100 parts of tin as protoxide, 13 to 6 parts of oxygen are required, as white deuter oxide, 24 parts, as yellow hyperoxide, 27 4 parts. Dalton first investigated this question, but he wrapped up his conclusions in the worst sort of atomistic metaphysics. He laid down that the first elements or the simple, first quantity, was an atom, and he went on to talk of the weight and weight ratios of these atoms. They were supposedly spherical and in part surrounded by a more or less dense atmosphere of caloric, and he then taught us how to determine the relative weights and diameters of these atoms and their number in compound bodies. Berzelius again, and Schweiger in particular, concoct a hodgepodge of electrochemical relationships. But the formal moments of magnetism and electricity cannot appear in this real process, or if they do so appear, then only in a limited way. Only if the process is not completely real, are these abstract forms specially prominent. Thus Davy was the first to show that two substances which have a chemically opposite action are electrically opposite. If sulfur is melted in a vessel, an electrical tension is produced between them, since this is not a real chemical process. It is for the same reason that electricity is most obviously present in the galvanic process, for which reason, too, it also disappears when the process assumes a more chemical nature. Magnetism, however, can appear only in the chemical process, when difference must present itself spatially. This again occurs principally in the galvanic form, which is precisely not the absolute activity of the chemical process. 2. Dissociation. 334. The dissociation of the neutral body is the beginning of its reversion to particular chemical bodies, back to their indifference through a series of processes which are, on the one hand, peculiar. Each such dissociation is, on the other hand, itself inseparably linked with a combination, and similarly, the processes classified as processes of combination also directly contain the other moment, that of dissociation. To determine the peculiar place occupied by each particular form of the process and also which the specific product, it is necessary to consider the concrete agents and concrete products involved. Abstract processes where the agents are abstract, certainly contain in themselves the totality of the process, but they do not exhibit its moments explicitly. Remark. In empirical chemistry, interest mainly centers in the particularity of the substances and products grouped together according to superficial, abstract determinations in such fashion that no order is brought into their particularity. In this grouping, metals, oxygen, hydrogen, etc., metalloids, sulfur, and phosphorus, are placed side by side as simple chemical bodies and on the same level. The great physical diversity of these bodies is such that it straightway arouses opposition to 9 grouping. No less varied, too, is their chemical origin, the process from which these bodies result. But in equally chaotic fashion, the more abstract processes are put on the same level as those that have more reality. If scientific form is to be introduced into the sphere, each product must be defined according to the stage of the concrete, fully developed process from which it essentially results and from which it has its peculiar significance. For this purpose it is equally essential to distinguish between the stages of abstraction or reality of the process. Animal and vegetable substances, moreover, belong to a quite different order. Their nature, far from being understood from the chemical process, is rather destroyed in it. What we grasp therefrom is only the way of their death. But these substances should principally serve to counteract the metaphysics prevalent both in chemistry and physics, the thoughts, namely, or rather muddled conceptions, of the immutability of substances in all circumstances, and the categories of the composition of bodies and their constitution out of such substances. It is readily granted that chemical substances in combination lose the properties they show in separation, and yet men imagine that they are the same things without these properties that they are with them, and that their possession of such properties is no consequence of their being products of process. The affirmative determination of the still indifferent body, the metal, is physically such that its properties appear in it as immediate. In the case of further determined bodies, however, their behavior in process cannot be thus presupposed. Their primary, essential determination springs solely from their place in the chemical process. A further matter is the empirical, quite special particularity of reaction shown by bodies to all other particular bodies. A knowledge of this involves going through the same litany of reactions to every reagent. What is most striking in this respect is to see the 4 chemical elements, placed, as substances, on the same level with gold, silver, etc., sulfur, etc., as if they had the same kind of independent existence as gold, sulfur, etc., or as if oxygen had an existence like that of carbon. Their place in process indicates 65. A 6-6. Their subordinate, abstract character which distinguishes them in kind from metals and salts, and shows that they certainly do not belong together with such concrete bodies, this place has been dealt with in full in 328. The abstract middle term which is internally broken in two, to which, therefore, 2 elements belong, water and air being abandoned as a middle term, becomes the source from which the original, at first merely implicit, difference between the real syllogistic extremes acquires existence. This moment of difference, thus developed into an existence of us, constitutes the chemical element as a completely abstract moment. These substances, far from being primary, substantial foundations, as the term element at first suggests, are rather difference in its most extreme forms. Here, as in general, the chemical process is to be taken in its complete totality. The isolation of particular parts, of formal and abstract processes, leads to the abstract conception of the chemical process as being in general merely the action of one substance on another, with the result that such numerous other phenomena as occur, abstract neutralization and abstract dissociation, which occur in every process, seem almost secondary or accidental consequences, or at least as only externally connected with the process, and are not treated as essential moments in the relationship of the whole. A full exposition of the chemical process in its totality would, however, require it, as a real syllogism, to be explicated also as a triad of closely interlinked syllogisms, syllogisms which are not merely a simple connection of their termini but which, as active processes, are negations of their specific forms, and they would have to exhibit the interrelationship of combination and dissociation knit together in a single process. Zusatz. Whereas the first process led to combination, the processes of the neutral bodies against each other are, at the same time, their diremptions, or decompositions, and the separations of the abstract bodies from which we started. In this way, the pure metal with which we began, taking it as immediately given, is now a result produced from the total body towards which we were advancing. What is here decomposed, the concrete middle term, is a real neutral substance, whereas in galvanism the formal middle term which was decomposed was water, and in the process of fire, air. The forms and stages of this reduction vary, particularly the process of fire and also that of the salt. For example, if the salt is brought to a red heat, the weak acid is made strong again. In the same way, lime gives off carbonic acid, since at this temperature lime is supposed to have a greater affinity with caloric than with carbonic acid. It is in this way that metals are finally reduced, when, for example, sulfur, which as acid combined with a base, is driven off and the metal assumes a pure form. Few metals are found pure in nature, most of them are only separated off by chemical action. This is the complete cycle of the chemical process. Before we can determine to which stage of the process individual bodies belong, we must establish the definite order in which the stages of the chemical process succeed one another, otherwise we shall be dealing with a multitude of substances which, taken on their own, remain an unsystematized hodgepodge. The individualized bodies acquire their specific character in the process as follows. Individualized and differentiated air yields the different kinds of gases, air itself being the totality of the four: nitrogen, the abstractly indifferent gas; oxygen and hydrogen, the opposed forms of air, the former kindling and activating in opposition, the latter positive and indifferent in it; carbonic acid gas, the earthy moment, because it appears partly as earthy and partly as gas. One of the moments of the opposition is the cycle of fire, the individual, realized fire, and its opposite, the combustible substance. It, too, forms a totality, the basis, the intrinsically combustible substance which is, in itself, fiery. This is neither the indifferent substance to be posited only in a determination as difference, nor the positive which is only to be limited by difference, but it is negativity in itself, time which is inwardly realized but still sleeps, time, the quiescent existence of the sleeping time being only form, so that this negativity is its quality, not a mere form of its being, but its very being. As this form: sulfur as the earthy basis, hydrogen as the aeriform basis, naphtha, the vegetable and animal oils, and 90 the acids, namely, sulfuric acid, the acid of the combustible earthy substance; nitric acid with its various forms; hydrochloric acid, the earthy acids, the abstract, earthy; carbonic acid, the concrete; arsenious acid, etc., the vegetable and animal acids; formic acid, in opposition to acids, the oxides and alkalis generally. 267. The other moment of the opposition is realized zeoater, the neutrally ties of acids and oxides, salts, earths, stones. It is here, strictly speaking, that total body comes to view. The various gases are air 9, the cycle of fire has not yet reached the stability of the totality, sulfur is suspended in it as a basis over the other earthy bodies. The earths are white, simply brittle, the individual body as such, possessing neither the continuity of metal and its passage through process, nor combustibility. There are four main earths. These earthy, neutral substances are differentiated into a double series: those whose neutrality has its base only in the abstractness of water and which exist as neutral products of both acids and alkalis. This transition is formed by silica, clay, and talc. Silica is, as it were, the earthy metal, the pure case of brittleness which, through the abstraction of its singularity Einzelnheit, combines specially with potassium to form glass, and a metal represents the process of melting in color and solidity. So does silica represent it in singularity, Silica is the colorless substance in which metal light A has died away into pure form and whose inwardness is absolute discreteness. As silica is the immediate, simple, unexplicated notion, so clay is the earth earth with a difference, the possibility of combustibility. As pure clay, it absorbs oxygen from the air, but generally in its combination with sulfuric acid, it is an earthy fire, poercerumdu. It be to fire that it owes its hardness and crystallization. Water plays a less significant part than external cohesion. Talc or bitter earth is the subject of salt, to this the bitterness of sea water is due. It is an intermediate taste which has become the principle of fire and is precisely the return of the neutral substance to that principle. Finally, we have the antithesis to this, the genuinely real neutral or calcareous substances, the alkaline, differentiated substances which decompose their earthy principle afresh and only need the physical element to constitute a process, the extinguished process which reinstates itself. Lime is the principle of fire which is generated by the physical body in its own self. The earthy element, all of whose determinations other than gravity now fall outside of it, and in whose case gravity is identical with light, covers the metals. Gravity is the being within self in indeterminate externality, so this being within self in light has reality. Thus metals do possess color, but on the other hand their luster is this indeterminate, self-propagating pure light which destroys color. The different states of metal, first continuity and solidity, and then readiness to enter into process, brittleness, punctiformity, capacity for oxidation, all these are passed through by the metal within itself. Thus some metals are found in a pure state, ISS, others occur only in the form of oxide 9 or mixed with earths, hardly ever in a pure state, and when they do, they are powdery, like arsenic for example. Antimony and similar metals are so brittle and hard that they are easily pulverized. Finally, metal occurs as scoria, vitrified, and has the mere form of sameness of texture as in the case of sulfur. 335 The chemical process is, in fact, in general terms, life, for the individual body in its immediacy is not only produced by the process but also destroyed by it, so that the notion no longer remains at the ninth stage of inner necessity but is made manifest. But on account of the immediacy of the corporealities entering into chemical process, the notion is everywhere infected with division. As a result, its moments appear as external conditions, and what is dissociated falls apart into mutually indifferent products. The fire and activation Begeisterung are extinguished in the neutral body and not spontaneously rekindled in it. The beginning and end of the process are separate and distinct. This constitutes its finitude which keeps it far from life and distinguishes it therefrom. 269. Remark. Certain chemical phenomena have led chemistry to apply the determination of teleology in explaining them. An example is the fact that an oxide is reduced in the chemical process to a lower degree of oxidation than that at which it can combine with the acid acting on it, while a part of it is more strongly oxidized. There is here a rudimentary self-determination of the notion from its own resources in its realization, which is thus not determined solely by conditions which are already outwardly to hand. Zusatz. True, an appearance of vitality is there, but it is destroyed in the product. If the products of the chemical process spontaneously renewed their activity, they would be life. To this extent, then, life is a chemical process made perpetual. The determinateness of the species of a chemical body is identical with its substantial nature. We are accordingly here still in the realm of fixed species. In the organic realm, on the other hand, the determinateness of the species is not identical with the substantial nature of an individual. On the contrary, the individual is, in keeping with its determinateness, finite, but just as much infinite. In the chemical process, the notion exhibits its moments discontinuously. The whole of the chemical process contains, on the one side, fixed determinateness in the mode of indifference, and on the other side, the urge to be internally opposed to self, an opposition in which indifference falls away. But quiescent being and this urge are distinct sides. The totality is posited only in itself or in principle. the unity in which both determinations are at once present does not come to existence. This unity, as existent, is the determination of life, and towards this nature strives. Life is present in principle in the chemical process, but inner necessity is not yet existent unity. The nature of the chemical process is, however, to posit as negated these immediate presuppositions, the basis of its externality and finitude, to alter at a later stage of the process the properties of bodies which appeared as results of an earlier stage, and to reduce those conditions to the rank of products. What is thus posited in general in the chemical process is the relativity of the immediate substances and properties. Body as an indifferent existence is thereby posited as a mere moment of the individuality, and the notion is posited in the reality which corresponds to it, this concrete unity with self, self-produced into unity from the particularizing of the different corporealities, a unity which is the activity of negating this its one-sided form of reference to self, of sundering and particularizing itself into the moments of the notion and equally of bringing them back into that unity, is the organism. The infinite process which spontaneously kindles and sustains itself. Zusatz. We have now to make the transition from inorganic to organic nature, from the prose to the poetry of nature. In the chemical process, bodies alter not merely superficially but on all sides. 9, every property is effaced: cohesion, color, luster, opacity, resonance, transparency. Even specific gravity, which seem the deepest and simplest determination, does not survive. It is precisely in the chemical process that the relativity of the apparently indifferent determinations of the individuality which I9 the essence in this flux of accidents comes to light. Body reveals the transiency of its existence, and its relativity is its being. If we are to describe what a body is, the whole cycle of its alterations must be stated, for the true individuality of body does not exist in a single state but is exhausted and displayed only in the cycle of states. The totality of shape does not survive, just because it is only a particular totality. The individual body thus receives its due, i.e., because at 19 finite, it does not endure. Thus there are metals which, as oxides or neutralized by acids, run through the whole gamut of colors. They can also form transparent, neutral salts, salts generally being the death of color. Brittleness, solidity, smell, and taste equally disappear. It is this ideality of the particular that is here displayed. Bodies pass through the whole cycle of such possible determinations. Copper, example in its pure form as a metal is red in color, but copper sulfate gives a blue crystal. Copper hydrate as a precipitate is ultramarine, and a muriate of copper is white. Other oxides of copper are green, dark gray, reddish brown, etc. Azurite has still another color, and so on. The reaction varies according to the agent, and the chemical body is only the sum of its reactions. That is to say, the totality of the reactions exists only as a sum, not as an infinite rudimentu self. In all reactions in which the body combines with others, in synsomates, in oxidation, and in neutrality, it preserves its specific nature, but only implicitly, not existently. Iron always remains in itself iron, but only in itself, not in the manner of its existence. But it is in the preservation of existence, not of being in itself, that we are interested, more precisely, that what is in itself should exist or that what exists should be in itself. The cycle of particular reactions constitutes the universal particularity of a body, but this exists only implicitly or in itself, and is not a universal existence. Only in the process of fire is activity imminent, an instant of spontaneous life, whose activity, however, hastens to its death. But because the immediate shape in which particular determinations are present here is destroyed, we here have a transition in which the implicit universal of the determinateness also comes into existence, and this is the self-preservation of the organism. It acts, and reacts against, the most diverse powers. In each reaction it is differently determined, but equally also remains a single unity with itself. This implicit determinateness of a kind now also exists. It enters into relationship with another, but also breaks off this involvement, and is not neutralized in it, it preserves itself, on the contrary, in the process which, nonetheless, is determined by it and its other. The infinite form as the sole seal, of individuality is still materialized in shape, and so reduced to a unity which is not an infinitely free form within itself, but is in its existence a quiescently enduring being. This quiescence, however, is contrary to the infinite form, for this is unrest, movement, activity, only as such does it manifest what it is in and for itself. The persistence of the moments of the infinite form in shape, each of which moments can have an independent material existence, is of course also the entering into existence of the infinite form, but here the unity of the form does not yet have the truth which it is. But now, since the chemical process precisely represents the dialectic through which all the particular properties of bodies are brought to destruction, what alone endures is the self-subsistent infinite form, the pure immaterial individuality which is for itself, and for which material existence is alterable through and through. The chemical process 19, the highest to which inorganic nature can reach, in it she destroys herself and demonstrates her truth to be the infinite form alone. The chemical process is thus, through the dissolution of shape, the transition into the higher sphere of the organism where the infinite form makes itself, as infinite form, real, i.e. the infinite form is the notion which here attains 27*. To its reality. This transition is the raising of existence to universality. Here, therefore, nature has risen to the existence of the notion is no longer merely immanent, is no longer submerged in nature's mutual externality of being. It is a free fire as purged of matter, and as materialized in existence. The moments of what exists are themselves raised to this ideality, have only this being of ideality, and do not fall back into the restricted forms of existence. We thus have objective time, an imperishable fire, the fire of Elepha. Heraclitus, 2, declared the soul to be fire, and the dry souls to be the best. 27*. Section 3, Organics. 337 The real totality of body as the infinite process in which individuality determines itself to particularity or finitude, and equally negates this and returns into itself, re-establishing itself at the end of the process as its beginning, is thus an elevation into the first ideality of nature, but an ideality which is fulfilled, and as self-related negative unity, has essentially developed the nature of self and become subjective. This accomplished, the idea has entered into existence, at first an immediate existence, life. This is, firstly, as shape, the universal image of life, the geological organism; secondly, as particular, formal subjectivity, the vegetable organism; thirdly, as individual, concrete subjectivity, the animal organism. The idea has truth and actuality only in so far as it is determined as subjective, life, as only the immediate idea, is therefore external to itself, is non-life, only the corpse of the life process, the organism as totality of inanimately existing, mechanical and physical nature. Distinguished from this stage is the beginning of subjective vitality, the living organism in the vegetable kingdom, the individual, but, as external to itself, still falling apart into its members which are themselves individuals. It is first in the animal organism that the differences of shape are so developed as to exist essentially only as its members, thereby constituting its subject. Vitality, as natural, falls apart into the indeterminate plurality of living things which, however, are in themselves subjective organisms, and it is only in the idea that they are one life, one organic system of life. Zusatz. Let us look back for a moment at the preceding exposition. In the first section we saw matter, the abstract Asundimess, as space, matter, as the abstract being for self of Asundimess and as offering. 274 Organics resistance, is completely separated into units Vollkommen and Varianzelt, atomistic through and through. This atomistic matter, because of its sameness, is still completely indeterminate, but it is absolutely atomistic only for understanding, not for reason. ISS, Next we had particular masses determined over against one another, and lastly gravity, which constitutes the fundamental determination in which all particularity was sublated and ideal ideal. This ideality of gravity which, in the second section, was transformed into light and then into shape, is now restored. The matter there individualized contains, the free determinations as we saw them in the elements and their process. It then unfolds itself to become the realm of appearance Erscheinung, i.e. it develops into the opposition of self-subsistence and reflection into there, as specific gravity and cohesion, till in individual shape, it develops into totality. But since the particular body is just this, to sublate the different modes of its existence, this ideality is now a result in unclouded unity and self-sameness, like light, but at the same time as proceeding from the totality of particularizations which are compressed and taken back into the first indifference. Individuality is now within itself heavy and light like Litig, the triumphant individuality, the unity which, as process in all particularities, brings forth and preserves itself, and this is the subject matter of the third section. The living body is always on the point of passing over into the chemical process. Oxygen, hydrogen, salt, are always about to appear, but are always again sublated, and only at death or in disease is the chemical process able to prevail. The living creature is always exposed to danger, always bears within itself an other, but can endure this contradiction which the inorganic cannot. But life is also the resolving of this contradiction, and it is in this that the speculative consists. It is only for understanding that the contradiction is unresolved. Life, therefore, can be grasped only speculatively, for it is precisely in life that the speculative has an existence. The perpetual action of life is thus absolute idealism. It becomes an other which, however, is always sublated. If life were a realist, it would have respect for the outer world, but it always inhibits the reality of the other and transforms it into its own self. Thus it is in life that what is the true first exists. It is superior to the stars and the sun, which last is, indeed, an individual but not a subject. As unity of the notion and outwardly turned existence in which the notion preserves itself, life is idea, and in this sense spioisa, too, termed life the adequate notion, an expression which is of course still quite abstract. Life is the union of opposites generally, not merely of the opposition of notion and reality. Wherever inner and outer, cause and effect, and means, subjectivity and objectivity, etc., are one and the same, there is life. The true determination of life is that the reality in the unity of notion and reality, no longer exists in an immediate manner, no longer exists independently as a plurality of properties existing outside one another, but that the notion is absolute ideality of their indifferent subsistence. Since the ideality we encountered in the chemical process is here posited, individuality is thus posited in its freedom. The subjective, infinite form is now also in its objectivity. This was not yet so in shape, because in this, the determinations of the infinite form still have a fixed determinate being as matters. The abstract notion of the organism, on the contrary, is that the existence of the particularities conforms to the unity of the notion, since they are posited as transient moments of one subject, whereas in the system of the heavenly bodies, all the particular moments of the notion are freely existent, independent bodies, which have not yet returned into the unity of the notion. The solar system was the first organism, but it was only implicitly organic, not yet an organismus existens. These giant members are independent shapes, and the ideality of their independence is merely their motion. They form only a mechanical organism. But the living creature possesses these giant members of nature in one body, in which everything particular is posited as appearance. Thus in life, light completely masters gravity. The living creature, therefore, is individuality which has subdued within itself the further particularizations of gravity, and is active within itself. It is only as self-sublating reality that the self-preservation of the notion is posited. The individuality of the chemical body can fall victim to an alien power, but life has its other within itself. is in its own self a single rounded totality, or it is its own end. The first part of the philosophy of nature was mechanics, the second part, in its conclusion, was the chemical process, and this third part is teleology. Life is means, but not for an other but for this notion, it perpetually brings forth its infinite form. Kant already had defined the living creature as an end for itself. Alteration occurs only for the purpose of the notion, is only an alteration of the otherness of the notion, and it is in this negation of the negative, in T9 absolute negativity alone, that the notion can remain at home with itself. The organism is already in itself what it is actually, it is the movement of its becoming. But that which is result is also that from which it has resulted. Beginning and end are the same. This, which was hitherto only our knowing, has now entered into existence. Since life, as idea, is the movement of itself whereby it first constitutes itself subject, it converts itself into its other, into its own obverse / it gives itself the form of object in order to return into itself and to be the accomplished return into self. Thus it is only in the third part that we have life as such, since its principal determination is subjectivity. The earlier stages are only imperfect steps in that direction. And consequently we have the three kingdoms, the living mineral kingdom, the vegetable kingdom, and the ordinal kingdom. Life, which presupposes itself as the other of itself, is, firstly, geological nature, and as such it is only the ground, the basis of life. True, it ought to be life, individuality, subjectivity, but it is not veritable subjectivity, it does not bring back its different members. 275. Into unity. In the sphere of life, the moments of individuality and of the return into self or subjectivity must indeed be present, but as immediate, these sides are estranged from each other, i.e. they fall outside of each other. On one side stands individuality, on the other, the process of it. Individuality does not yet exist as active, idealizing life, has not yet determined itself to individuality, but is a frozen life, over against the process of life. It, too, contains activity, but partly only as a potentiality, partly as outside itself. The process of subjectivity is divorced from the universal subject itself, for we have not as yet an individual which is, in principle, already self-active. Immediate life is therefore life which is estranged from itself, and thus it is the non-organic nature of subjective life. For all externality is non-organic, as, example for the individual, the sciences are his non-organic nature, in so far as he is not yet familiar with them, but they are stirring in him and are his implicit rationality which he has only to make his own. The earth is a whole, the system of life, but, as crystal, it is like a skeleton, which can be regarded as dead because its members seem still to subsist formally on their own, while its process falls outside it. The second part is the stage of reflection, an incipient, truer vitality, in which the individual is intrinsically its own activity, the life process, but only as subject of reflection. This formal subjectivity is not as yet the subjectivity that is identical with objectivity, with the articulated system of its members. This subjectivity is still abstract because it issues only from that estrangement, it is the brittle, Iunctiphone, merely individual subjectivity. True, the subject particularizes itself, preserves itself as subjectivity in its connection with its other, articulates itself into members which it pervades, but what makes it only a formal subject is that it does not truly preserve itself in this connection but is still drawn out of itself. The plant is still not veritable subjectivity because the subject, in distinguishing itself from itself and making itself into its own object, cannot trust itself to the truly articulated differences, but it is the return out of these differences which first constitutes true self-preservation. The plant therefore does not advance beyond a formal distinguishing of itself from itself, and it can remain only in formal communion with itself. It unfolds its parts, but since these its members are essentially the whole subject, there is no further differentiation of the plant. Leaves, root, stem, are themselves only individuals. Since the real differences which the plant produces in order to preserve itself are completely similar to itself, it does not develop true members. Each plant is therefore only an infinite number of subjects, and the togetherness whereby it appears as one subject is only superficial. The plant is thus impotent to hold its members in its power, for these, a non-self-subsistent, escape from it, and the innocence of the plant is the same impotence of self-relation to inorganic being in which the plant's members become, at the same time, other individuals. This second kingdom is the water kingdom, the kingdom of neutrality. *77 The third kingdom is the fire kingdom, individual subjectivity as vitality in its completeness, the unity of the plant and the differences. This subjectivity is shape, like the first system of forms, but at the same time the members are not parts, as they still are in the plant. Animal life preserves itself in its otherness, but the latter is an actual difference, and at the same time, the system of these its members is posited as ideal ideal. Only then is the living organism subject, soul seal, an ethereal being, the essential process of articulation and expansion, but in such a manner that though this shaping is immediately posited in time, the difference is eternally retracted. Fire releases itself into members, there is a perpetual passage into a product, and this is perpetually brought back to the unity of subjectivity, for the self-subsistence is immediately consumed. Animal life is therefore, is not self-subsistent but exists only as bound up with the whole. Feeling, the finding of self in self, is the highest achievement and occurs here for the first time, it I9 to remain one with self in determinateness to be freely at home with oneself. The plant do 9 not find itself within itself because its members are self-subsistent individuals over against it. The explicated notion of life is animal nature, here for the first time we have vitality in its true form. These three forms constitute life. 338 The first organism, just because it is at first determined as immediate organism or as only implicitly organism, does not exist as a living creature, for as subject and process, life is essentially a se/terrains of Europe, North and South America, and Northern Asia. As regards animal life, shellfish, snails, and zoophytes come first in respect of quantity in Europe wherever there are flats formations, consequently in countless localities in this continent, similarly in Asia, Anatolia, Syria, Siberia, Bengal, China, etc., in Egypt, Senegal, in the foothills at the Cape of Good Hope, and in America. They are found not only at great depths, in the first flats formations covering the primitive rocks, but also at the greatest heights, e.g. on Mount Perdu, the highest part of the Pyrenees, 10,968 feet high, on the Jungfrau, the highest peak of the Limestone Alps, 13,872 feet high, and on the Andes in South America, which are 12,000 to 13,242 feet above sea level. Such remains are not scattered throughout the whole mass of the mountain but occur only in individual strata, often in the greatest order, as if in families, and as well preserved as if they had peacefully settled there. In the very oldest stratified formations lying directly on the primitive rocks there are, on the whole, very few fossils of sea animals, and those only of certain species, but in the later deposits their number and variety increase and sometimes, though very rarely, fossil fish, too, are found. Fossil plants, on the other hand, occur only in the more recent strata, and the bones of amphibians, mammals, and birds, only in the most recent strata. Most remarkable, in fact, are the bones of quadrupeds, elephants, tigers, lions, bears, in species now extinct. All these huge animals lie not far below the surface, under sand, marl, or loam, in Germany, Hungary, Poland, Russia, especially in Asiatic Russia where there is a considerable trade in the tusks they dig up. Humboldt found mammoth bones in the Valley of Mexico and in the valleys of Quito and Peru, always at heights of 7,086 to 8,934 feet above sea level, and in the River Plate he found the skeleton of a huge animal 12 feet long and 6 feet high. but not only these remains of the organic world, but the geognostic structure of the earth, too, and generally the whole formation of the alluvial terrains, bear the stamp of violent upheaval and external formation. In mountain chains there are entire formations which themselves form solid mountains and mountain ranges, composed entirely of boulders and debris all stuck together in a conglomerate. The Nagelfluhe in Switzerland is a species of rock consisting of smooth pebbles cemented together again by sandstone and limestone. The stratifications of the Nagelfluhe deposit are very regular. One layer, example, consists of big stones almost all of which are 6 inches thick, the next layer of smaller stones and the third layer of still smaller ones. This is now followed by another layer of larger stones. The constituents are the most varied assortment of debris, granites, gneisses, porphyries, amygdaloids, serpentines, siliceous schists, hamstones, flints, saline and compact limestones, argillaceous and ferruginous stones, and alpine sandstones. In one Nagelfluhe there is more of one species, and in another more of another species. One such Nagelfluhe forms a mountain chain with a breadth of 1 to 3 leagues. It rises to a height of 3,000 to 6,000 feet above sea level, which therefore is above the tree line in Switzerland. With the exception of the Alps and the Pyrenees, they are higher than all the other mountains in France and England, and even the highest peak of the giant mountains in Silesia is only 4,949, and the Brocken only 3,528 feet high. Lastly, all primitive rock masses, granite mountains, and rocks, bear in themselves the terrible traces of frightful poundings and upheavals. They are intersect lengthwise and crosswise by innumerable valleys and ravines superposed one on top of the other by stages, and so on. All of this which belongs to the sphere of history must be accepted as fact. It does not pertain to philosophy. If, now, this is to be explained, we must understand the way in which this must be treated and considered. Formerly, history applied to the earth, but now it has come to a halt. A life which, inwardly fermenting, had time within its own self, the earth spirit which has not yet reached the stage of opposition, the movement and dreaming of one asleep, until it awakes and receives its consciousness in man, and so confronts itself as a stabilized formation. As for the empirical side of this past state, it is considered that the main interest for geognosy lies in the determination of time, in knowing which stratum of rocks is the oldest, etc. To explain the geological organism usually means to make the order in which these different formations succeeded one another the chief business, but this kind of explanation is only external. It is said that first the granitic primitive rocks, the deepest strata, came into being one after the other in time, then, regenerated, dissolved granite which was precipitated again. The upper strata, e.g. the Fletz formations, are supposed to have been deposited later in time, and the solution is supposed to have run into the fissures, and so on. This mere happening which involves only a difference of time, this temporal succession of the strata, does not explain anything at all, or rather it completely ignores the necessity of the process, the comprehension of it. The solvent effects of water or fire are wholly separate factors which do not express organic fermentation, any more than when we understand it as the process of oxidation and deoxidation, or quite superficially reduce it to the opposition of the carbon and nitrogen series. The whole style of explanation is nothing more than a transformation of spatial juxtaposition into temporal succession, as if, seeing a house with a ground floor, first and second floors and a roof, I now reflect with profound wisdom, and conclude that therefore the ground floor was built first, and after that the first floor, and so on. Why is the limestone later? Because here limestone overlays sandstone. This is a facile insight. This transformation has really no rational interest. The process has no other content than the product. It is an indifferent curiosity which wants to see also in the form of succession what exists as a juxtaposition. One can have interesting thoughts about the long intervals between such revolutions, about the profounder revolutions caused by alterations of the Earth's axis, and also those caused by the sea. They are, however, hypotheses in the historical field, and this point of view of a mere succession in time has no philosophical significance whatever. But in this sequence there does lie a deeper meaning. The meaning and spirit of the process is the inner coherence, the necessary connection of these formations, and nothing is added to this by dissecession in time. The general law of the sequence of formations can be recognized without any reference to the historical aspect, that is the essential point. This is the rational element which alone has interest for the notion, to recognize in the sequence the characteristics of the notion. It is Werner's great merit to have drawn attention to the sequence and to have looked at it, on the whole, from the correct point of view. The inner coherence exists in the present as a juxtaposition, and it must depend on the constitution, on the content, of these formations themselves. On one side, therefore, the history of the earth is an empirical matter, and on the other, a reasoning from empirical data. The point of interest is not to determine how things were millions of years ago, the interest is confined to what 19 there before us, to the system of distinct formations. It is a very complex empirical science. Everything in this corpse cannot be explained, for contingency plays its part in it, any more than it is the concern of philosophy to acquaint itself with the rational system of legislation in its obscure rudimentary state, or to get to know in what chronological order and in what external circumstances such a system has come into existence. The production of the living thing is represented in general as an evolution out of chaos, where plant and animal life, organic and inorganic, were in a single unity. Or it was imagined that there was a general form of life and that this split up into the many species of plants and animals, into the races of mankind. But we must not assume a sensuous process of differentiation appearing in time, nor the existence in time of a universal man. To postulate such a monster is to give rein to empty imagination. The natural, living thing is not mingled, is not a medley of all different forms as in arabesques. There is essentially understanding in nature. Nature's formations are determinate, bounded, and enter as such into existence. So that even if the earth was once in a state where it had no living things but only the chemical process, and so on, yet the moment the lightning of life strikes into matter, at once there is present a determinate, complete creature, as Minerva fully armed springs forth from the head of Jupiter. The Mosaic story of creation is still the best in its quite naive statement that on this day plants came into being, on another day the animals, and on another day man. Man has not developed himself out of the animal, nor the animal out of the plant, each is at a single stroke what it is. In this individual, evolutionary changes do occur, at birth it is not yet complete, but is already the real possibility of all it is to become. The living thing is the point, this particular soul, subjectivity, infinite form, and thus immediately determined in and for itself. Already in the crystal, as a point, the entire shape is at once present, the totality of the form, the crystal's capacity for growth is only a quantitative alteration. Still more is this the case in the living thing. 3. The particular formations of the earth are the subject matter of physical geography. The self of the earth, as diversity of formation, is a quiescent exposition and self-subsistence of all its parts. It is the solid structure of the earth which does not yet possess its life as soul, but as universal life. It is the inorganic earth which, in animate shape, sets forth its members like a rigid body. Its separation into water and land, into continents and islands, and the shaping and crystallization of these into valleys and mountains, all this belongs to its purely mechanical formation. With regard to this, one may well say that in one place the earth is more contracted, and in another more spread out, but this does not tell us anything. The concentration in the north results in the products, plants, and animals, sharing a common nature. At the extremities, animal life is particularized and individualized into various genera and species which are peculiar to each continent. This appears at first to be accidental, but the activity of the notion is to grasp as necessarily determined what to sense consciousness appears as contingent. Contingency certainly has its place, too, but only in unessentials. The northwest to southeast direction of countries and mountain ranges can also be traced back to magnetic axes, but magnetism is, in general, as a linear direction, a wholly formal moment, the force of which is already suppressed even in the globe and still more in the subject. A rational comprehension of the configuration as a whole, would have to consider the fixed land formations in comparison with the ocean currents rather than with the oceans, i.e. with the expression of the free movement of the earth in its own self. In general, the effort to develop a shape definitely opposed to the sphere tends to produce a pyramidal form, constructing a base in the former, a breadth which tapers off to a point on the other side. This is why the land falls away to the south. But the restless, rotatory movement of the ocean currents hollows out this shape everywhere in a west to east direction, as it were pushes and presses the solid land mass towards the east and distends the shape on the eastern side like a bent bow, so that to the west it is rounded and bellies out. But in general the land is split into two parts, the old and the new worlds. The former is shaped like a horseshoe, the latter elongated from north to south, and this is new, not merely through the accident of being discovered later, i.e. of a later entry into the general system of peoples, but everything in it is new. Humanity there lacks those great weapons of civilizations against one another, the horse and iron. No part of the old world has been conquered by the new, but the new is only a booty for Europe. Its fauna is feebler, but its flora is on a vast scale. In the old world, the mountain ranges run, on the whole, from west to east or else from southwest to northeast. By contrast, in America, the counter aspect of the old world, they run from south to north, but the rivers, especially in South America, flow to the east. Altogether the New World presents an undeveloped duality, a northern and a southern part, like the poles of the magnet, but the Old World exhibits the perfect diremption into three parts, one of which, Africa, the compact metal, the lunar principle, is rigid through heat, a land where man's inner life is dull and torpid, the inarticulate spirit which has not awakened into consciousness. The second part is Asia, characterized by bacchanalian extravagance and cometary eccentricity, the center of unrestrained spontaneous production, formlessly generative and unable to become master of its center. But the third part, Europe, forms the consciousness, the rational part, of the earth, the balance of rivers and valleys and mountains whose center is Germany. The division of the world into continents is therefore not contingent, not a convenience, on the contrary, the differences are essential. The physical organization of the earth, as immediate, does not begin with the simple, enveloped form of the germ, but with a beginning which has fallen apart into a duality, into the concrete granitic principle and the calcareous principle. The former is the core of mountains in which the triad of moments is displayed in an already developed state, while the latter is the difference which has been reduced to neutrality. The development of the moments of the first principle into specific formations goes through a series of stages in which the further forms are partly transitional, the granitic principle remaining the basis, only more unlike and unformed within itself, partly a development of its moments into a more determinate difference and into more abstract mineral forms such as metals and fossil objects generally, until the development loses itself in mechanical stratifications and alluvial terrains, lacking any imminent formative process. Side by side with this proceeds the development of the other, the neutral principle, partly into weaker transformations and partly, in combination with the granitic principle, into formations ranging from concrescent forms down to merely external mixtures. Zusatz. Werner's mineralogy distinguished between rock species and lodes or veins. Geology treats of the former and orictocuasi of the latter. These names are no longer used in textbooks of mineralogy, it is only miners who retain the distinction. The rocks comprise the concrete mass and geology studies the further formation of a fundamental form of rock species and its modifications, in which the rocks remain concrete formations. From this develops the other, more abstract side, the veins which, too, form themselves into mountains, so that generally the two sides cannot be exactly separated. Such abstract formations are crystals, ores, metals, where the moment of difference has developed. They have made themselves into neutral substances capable of forming concrete shapes, for it is precisely in such abstract forms that shape becomes free. The types of vein are seams in the mountains consisting of a specific medley of rocks and earths. They have a definite grain or inclination, i.e. they make an angle with the horizon. Now these rock strata are cut by the veins at various angles, and it is these veins which are important in mining. Werner thought of these veins as fissures filled up with a different mineral from that of which the mountain was composed. The physical formation of the earth is so constituted that its surface erupts into organic centers, into points of totality, which unite within themselves the whole and then let it fall apart, displaying it in individual products. This contraction, in unfolding outwards, passes over into a scattering abroad of the moments. These centers are a kind of cores which, in their shells and husks, represent the whole and which pass through these to blend with the general soil as their element. The core and root of these formations is not a simple self but the developed totality of the formation which contains within itself the already separated moments, the existence of the organic unity as it is able to exist in this universal individuality. This core is gravity, which is so blended, so hard, so solid, that the individual parts are not easily separated out of it in their pure form. Everywhere there is an incipient crystallization. In the whole, granite is the innermost, the mean, the basis, and it is to its traits in two directions that the other formations first attach themselves. It has three constituents although it is itself primary, but these three constitute a single, quite hard mass. Granite, as we know, is composed of silica, quartz, absolute earth, the rigid, punctiform principle, mica, the surface which has developed to the stage of opposition, the punctiform principle which has unfolded itself, the moment of combustibility which contains the germ of every abstract form, and lastly felspar, the adumbrated but still undeveloped neutrality and crystallization of lime in the siliceous earths, for 2 to 3% of lime is found in it. This is the simple, earthy triad which now develops in accordance with its different sides, and more specifically, in the two directions of the process. On the one hand, this whole is to contain the differences as its form and is to remain the whole, only with a variously modified content, and on the other, the differences are to permeate the substance and become simple abstract isolates. The former is the formation as it appears at this point, and the latter is difference, but a difference which has lost all chemical significance and is just the formation of simple physical bodies. More precisely, we have the external forming of the primitive rock, the extirpation of the existent moments of the totality and the separation of them in their purity as abstract isolates flets formation. This is followed by decay into an indifferent existence alluvial terrain. 1. In primitive rock, as throughout all the further formations, we find the antithesis of the siliceous, and the argillaceous and its cognate forms, and the calcareous. The antithesis to granite is primitive limestone, so that the siliceous and the calcareous series form an essential antithesis. Stephens in his earlier writings has drawn attention to this, and it is one of his best inspirations among the otherwise crude and immature observations of Biss' undisciplined imagination. In primitive rock, the different character of these sides is well marked and a determining factor. The calcareous side is the total neutrality, and its modifications concern more the outer formation than the inwardly self-specifying diversity. In siliceous formations, on the contrary, where granite form the basis, a more definite difference is present. The granite rocks which form the beginning have the greatest. 287. Kali, misprint for Kalk. 288 Organics height. The other rocks acts supported on the granite in such a way that the rocks of greatest height are always the undermost stratum, the others in turn resting on them. The next rock formations are modifications of granite, further developments of one side of it, where now one and now the other side predominates. The granitic rocks are surrounded by beds of gneiss, syenite, mica schist, and so on, which are nothing but a light modified cations of granite. One species of rock, says Ebel, passes by gradual modification of its composition into the rock species of another slab of rock. In this way, compact granite passes over into veined granite and gneiss, and the hardest gneiss passes over through varying combinations of its constituents into the softest mica schist, which itself passes over into argillaceous schist *, and so on. The latter species are quite contiguous so that the passage of one into the other is readily seen. In the study of geology, then, we must first direct our attention to the general mass of rocks and the notion of the moments, rather than thoughtlessly enumerate the different kinds, straightway converting a small difference into a fresh genus or species. What is most important is to follow the transitions from one layer to another. Nature keeps to this order only in a general way, and numerous variations occur although the basic features of the order persist. But while nature juxtaposes the species as parts indifferently, she indicates the necessity by the transition of the different species into one another, but the difference in kind comes to view not only by a mere lessening of difference but by a differentiation in accordance with the notion. Nature marks these transitions as a mingling of the qualitative and the quantitative, or shows that the one species differs from the other in kind. In the one rock there are nascent formations of the other rock in the form of globules, clusters, centers, partly mingled with the ferrat rock, partly also externally separated off in it. Heim, with a truly philosophical view of the matter, has very clearly exhibited this transition, the breaking forth of one rock in another. Syenite is the rival of granite. Instead of mica it contains only hornblende, which is more argillaceous than mica but resembles it. From mica syenite the next stage is a definite loss of depth. Quartz disappears from view and clay becomes predominant, until thin sheets and clay entirely predominate in argillaceous schist, in schistous formation generally, which is the next change of form. Here the peculiar nature of quartz, felspar, mica, and hornblende formations is dissipated and lost. Further down, formlessness remains predominant, the transformation of granite progressing from this point onwards. There are a number of other formations still belonging to the stage, but they are degenerate forms of granite. Mica schist is transformed into porphyry, which consists mainly of clay and also of another mineral, throughout which grains of felspar and quartz are dispersed. Old porphyry still belongs to the primitive rocks. Schist assumes different forms, becomes harder, more like quartz in siliceous schist, and more sandy in greywacke schist and greywacke, so that the day is no longer predominant. Greywacke, e.g. in the Harz Mountains, is an inferior reproduction of granite, looks like sandstone, and is a mixture of quartz, argillaceous schist, and felspar. This is truer still of greenstone, which consists of hornblende, felspar, and quartz, the first named being the principal constituent. Joined onto these are the entire further ascending series of trap rocks, but here everything is more mixed. That is the limit of these absolute rocks. So the development, starting from granite, proceeds, as we have said, to the stage where its particular constituents are no longer visible. The triad forms the basis, but these moments become separated and one or the other emerges. Basalt is the central point where the elements completely permeate one another again. It contains 40 parts of silica, 16 of clay, 9 of potash, 2 of talc, 2 of natron, and the rest is manganese oxide and water. Its alleged volcanic origin has this much truth in it, that it belongs to the igneous principle, but it owes its origin as little to fire 83 to water. An internal deformation is found in it, and still more in amygdaloid, olivine, augite, etc., which are abstract formations completely particularized in themselves. From this point onwards we meet with only a formal mixture or formal decomposition of these elements. The further details must be classified in accordance with this principle. One line of development is only a modification of granite where traces of the triple basis are still always present, in gneiss, mica schist, porphyry, right down to greenstone, greywacke, basalt, amygdaloid, and even ordinary sand. The other line is the splitting up of the concrete mass into abstract forms. Here, especially, we find the antithesis of the siliceous and the calcareous series, in mountain ranges, within these in the formerly so-called gangs. So far, we have described mainly the siliceous formations, but on the other side, the whole passes over into the talc form of saline earth, the igneous principle which has unfolded itself to the point of bitterness, and which appears sporadically here and there. Over against this igneous form, then, is the calcareous as such, the neutral substance which, however, permeated by metallite, contains qualitative unity and consequently is wholly permeated by organic development. The primitive limestone is already associated with granite and is just as compact as granitic rock. Thus the primitive rocks are surrounded by limestone formations. This primitive limestone is fine-grained, crystalline. Primitive limestone, the opposite of granite, meets up with a more unfolded limestone in transitional limestone. Formations also occur where granite and limestone are piled in a confused mass, thus primitive limestone, example permeates mica. Von Romer in his geognostic essays says, primitive limestone accompanies schistous rocks with which it mixes, alternating with them in thin layers, in beds, in huge deposits, and sometimes forming chunks of rock in which the schist is almost completely suppressed. These principal formations pass over into so-called flats formation and alluvial rock, where these moments, separated out almost as pure earths, represent the completely resolved totality, layers of sandstone, beds of clay and loam, coal seams, peat beds, bituminous schists, beds of rock salt, finally, limestone strata mixed in with the last named, gypsum and marl. As the granitic principle becomes more of an indeterminate mixture, the separate parts of what is differentiated now appear in greater abstract isolation, and this is an obliteration of differences as in trap and greywacke which belong to the transitional and bet species. But in the process in which granite and its cognate forms gathers itself up into abstract isolation, the more it loses its compactness, its firmly knit totality, and battens out, the more, on the other hand, do the self-separating ores and their accompanying crystals unfold themselves, and these are found disseminated throughout entire rock masses and strata and especially in seams and beds formations. The interior is opened up and reveals abstractly distinct formations. These seams are the outward formations of particular elements from the rock species which are more concrete, and in attaining to a freer outward formation they yield these manifold crystalline products and pure forms. In granite they do not occur at all or only rarely, only tin occurs. It is only when the primary rock has unfolded further to the stage of secondary limestone that metal appears. These abstract isolations can appear only in rocks which are themselves more abstract or are mixed. Cavities open up where rock crystal formations have reached their characteristic shape and have detached themselves from their inner connection with the rock. The lodes are regarded as nests and containers of these minerals. In a purely mechanical manner these lodes traverse the rock mass. Drying out is supposed to have caused a fissure, a crevice in the rock into which the metallic solution bowed. This is the theory specially favored by the Neptunians and it provides a very plausible explanation of the subsequent closing up of such rock wounds. But it is a thoughtless conjecture. The relationship is not mechanical but is, in truth, physical, one in which the parts of the totality simplify themselves and sublate their developed determinate being, and for this very reason now expel it in abstracted form. The lodes mostly run counter to the direction of the rock they form, as it were, fault planes, not merely in spatial form but in a physical sense. According to Treber's observations, the lodes follow the gentler slopes. These lodes must not be regarded as contingently connected with the rock species, for though contingency necessarily also plays a great part here, yet we must not fail to recognize the essential connection between them. Miners have varied experiences in this regard. One of the most important aspects of this connection concerns the range of metals and other minerals found in association. Gold, example, is always found with quartz, either alone or with copper and lead, with silver and zinc, and so on, not with mercury, tin, cobalt, molybdenum, wolfram. Silver is freer in its associations. Gazelle-Eiger is found much oftener with other metals, most commonly with galena and accompanied by zinc ore. Mercury is found with quartz, calcareous spar, iron, and therefore with sparate iron ore. 2. Copper is rarely found with mercury. The various kinds of mercury are usually found together and all of them mainly in clayey soils. Copper with its various ores is accompanied by few minerals. Tin is not found with silver, lead, cobalt, calcareous spar, gypsum, etc. There are metals which occur in all rock formations, such as iron, for example, others such as molybdenum, titanium, tantalum, wolfram, uranium, tin, are more confined to the primitive rocks. Molybdenum and wolfram, for instance, disappear with the primitive formations. Gold occurs most frequently near the equator. Other noteworthy relationships which hint at a higher connection are the lodes which contain sometimes precious and sometimes base metals. The cobalt formations at Regelsdorf and Saalfeld in the Thuringian forest only become rich in this mineral when the lodes are set in the primordial 1 sandstone formations. At Andreaberg in the Harz the rock is schist and greywacke, and the lodes contain base metal when set in beds of siliceous schist. In Klauste this happens when the lodes run through fissures in clay or loam, and in the Freiburg area, when they run through porphyry. Metals occur, too, at specific depths. Horn silver, white antimony ore, occur only in the upper strata. In the Tyrol, a bed of sparate iron ore, clayey ironstone, and brown spar appears where copper pyrites peters out. At Lagardet in Dauphine, gold nuggets lie near the surface and especially where the ground is traversed by rifts containing iron ochre. The veins differ according to the thickness of the rifts. At Sayenattkirchen, iron glance is always found where the lode narrows, and where it widens limonite, black magnetite, and sparate iron ore are found. Topazes occur in a greasy mica which has been modified into ithomarge, and in a friable lithomarge which is sometimes pure and sometimes mixed with a good deal of iron ochre. This lithomarge also owes its formation to mica and is accompanied by quartz and china clay. Both on the topazes and euclays, very clear imprints can be seen of very fine scales of lithomarge which could be sufficient evidence of the simultaneous formation of these minerals. It is the same with the emeralds found around Salzburg. In gneiss, the mica separates itself and forms huge 8 cams up to several feet in thickness. Emeralds are rarely found in gneiss but always in mica, never in a compact cluster but scattered unevenly through the mica. The emeralds, too, have imprints of scales of the mica surrounding them. /2 1 Lat Legend. 2 Spix and Martius, Travels, Vof. I. p. 332. O. Organics 3. The LaBT moment. The transition from flats formations to alluvial terrain is a mixture and abstract stratification of clay, sand, lime, marl, the completely formless minerals. Such are the general outlines of the advance founded on the determinations of the notion. The primitive rock develops itself to the point where it loses its mineral state and joins onto a vegetable state. Argillaceous earth and coal formations become transformed unmistakably into peat, where mineral and vegetable are no longer distinguishable, for peat has a vegetable origin and yet all the same still belongs to the mineral kingdom. On the other side, it is the limestone formations which, in their ultimate formations, tend towards the osseous nature of the animal. The limestone is in the first instance granular, marble, mineral through and through, but in its further forms it belongs partly to flats formation and partly to alluvial terrain, and passes over into forms of which it cannot be said whether they are mineral or animal. They are not yet shells which could be regarded as the remains of an extinct animal world, although, of course, that is one explanation of the petrified animal forms which are found in abundance in limestone pits. But, on the other hand, there are limestone formations which are not the remains, but only the beginnings, of animal form in which the limestone terminates. This is, therefore, an intermediate stage between limestone and petrifaction proper, but a stage which must be regarded only as a further development of the nature of mollusca, of what is purely mineral, for such forms have not yet attained to the fullness of animal life. The opposition of the siliceous and calcareous series hints, in this way, at a superior organic difference, since their boundaries are linked on the one hand with the vegetable kingdom, and on the other, with the animal kingdom. This side, too, has been clearly brought out by Stephens, but he has gone too far in treating these formations as originating from a vegetable and animal process of the earth, and as if the former were the carbon series and the latter the nitrogen series. As regards the rudimentary organic forms in the geological organism, these belong principally to clay schists and limestone stratifications, partly as scattered animal and plant forms, but mainly in entire huge masses organically shaped through and through. They are also found in coal measures in which the tree form is very often distinctly recognizable, so that if the breccias are included in the reckoning, there is present as much organically shaped matter as pure mineral. It is easy enough to postulate here the earlier existence of an organic world which was submerged by water. But then where did this world come from? It has arisen out of the earth, but not historically. It perpetually proceeds from the earth and has its substance in it. These organic forms, especially where they occur singly and do not constitute the entire rock mass, are present where beds pass over into one another. The boundary where the moments, which processless nature lets fall apart, are posited in a unity, is preeminently the site of organic forms, of petrifactions, and of those products which are neither animal nor plant forms, but which 293. Transcend the crystalline forms and are playful essays in organic formation. It is especially in schistous and calcareous formations that the inorganic unfolds itself. For the former, in partly transforming its earthy nature into the sulfurous principle, but partly retaining in itself metallity, sublates its fixed subjectivity. Its punctiform nature, opened up by bitumen and containing differentiation generally, receives in rotaliety the continuity of an absolute subject and predicate, is infinite, and fluctuates between the organic and inorganic. Similarly, the calcareous formation as the neutral substance, has in its sides the moment of reality they persist, and simple metalliety, through the simplicity of its continuity, manifests itself as the qualitative unity which cancels the indifference of the sides, a unity which contains the sides of the neutral substance, and a neutral substance which has unity. The calcareous formation thus represents the transition to organic being, on the one side, arresting the leap into dead neutrality, and on the other side, into lifeless and unitary abstraction. These organic forms are not to be thought of as having once actually lived and then died, on the contrary, they are stillborn. To suppose otherwise is like supposing that bone fibers were once veins or nerves, and subsequently hardened. It is organoplastic nature which generates the organic in the element of immediate being and therefore as a dead shape, crystallized through and through, like the artist who represents human and other forms in stone or on a flat canvas. He does not kill people, dry them out and pour stony material into them, or press them into stone. What he does is to produce in accordance with his idea and by means of tools, forms which represent life but are not themselves living. Nature, however, does this directly, without needing such mediation. That is, the notion is not present as something conceived or imagined, while the thing stands over against the thinker and is fashioned by him. The notion has not the form of consciousness but is immediately in the element of being, not detached from it. The notion has the material for its work, where the moments of the organic are present in their totality. The question is not of a universal life of nature being everywhere alive, but of the essence of life. This essence is to be comprehended, to be exhibited in the moments of its actuality or totality, and these moments are to be demonstrated. This crystal of life, the inanimate organism of the earth which has its notion in the sidereal connection outside it, but possesses its own peculiar process as a presupposed past, is the immediate subject of the meteorological process, through which, this subject, as in itself the totality of life, no longer becomes merely an individual shape but is fructified into vitality land and especially sea, as thus the real possibility of life, perpetually erupt at every point into punctiform, transient forms of life, lichens, infusoria, and in the sea countless hosts of phosphorescent points of life. but it is just because gene ratio equivoia has the subjective organism outside it that it is restricted to this punctiform organituation, does not develop internally into a specifically articulated organism, or reproduce itself ex ovo. Zusatz. Whereas the geological organism of the Earth was at first a product in the formative process of its shape, now, as the underlying productive individuality, it overcomes its rigidity and unfolds into subjective vitality which, however, it excludes from itself and delivers over to other individuals. In other words, because the geological organism is only implicitly in sich vitality, the truly living organism is an other than the geological organism itself. But since this is in itself the negativity of itself, is the sublating of its immediacy, it posits the inwardness of itself but as a being which is the other of it, that is, the earth is fertile simply as the ground and basis of individual vitality upon it. But the earth is vitality only in an indeterminate mode. True, this vitality erupts at all points, but only feebly. This universal life of the earth has living parts which are the elements, i.e. are its universal, its inorganic nature. But as the earth is also a particular body over against its satellite and the sun and comets, it is the perpetual generation, i.e. the conservation, of this system of differences, is the absolutely universal chemical process. Since, however, the giant members of this diremption are free, independent individuals, sheer connection exists purely as the free process of motion, while the comets themselves are a fresh, perpetual generation of this process. The reality of this process, then, the destruction of seemingly independent forms and the consequent emergence of real individual unity, this is first reached in the individual chemical process, which for this very reason is profounder and more fundamental than the universal process. But because the universal process of the elements is that of material substances, the individual process cannot be without it. The free, independent members of the universal process, sun, comet, and moon, are now, in their truth, the elements, air as atmosphere, water as the sea, but fire as a terrestrial element contained in the fructified, dissolved earth and separated off as a fructifying sun. The life of the earth is the process of atmosphere and sea in which it generates these elements, each of which is an independent life for itself while all of them constitute only this process. Here the chemical process has lost its absolute meaning and is present only as moment, it is reflected into self-subsistence, subdued by the subject in which it is held fast and powerless. Each element, through eta substance, is itself related as a free subject to the other, and the formation of the organic earth contains the modes of existence of its organic life. 1. Its first determinate life is now the atmosphere. But the meteorological process is not the life process of the earth, although the earth is vivified by it, for this vivification is only the real possibility of subjectivity emerging on the earth as a living being. As pure motion, as ideal substance, the atmosphere does contain the life of the celestial motion, but at the same time, it materializes this motion in its element. The atmosphere is the earth in its state of dissolution, of pure tension, the relation of gravity and heat. It runs through the period of the year as well as of the month odd day, and expresses it as variations of heat and gravity. This periodical fluctuation in turn splits into two, where the axial rotation preponderates, the diurnal period has the ascendancy, and therefore at the equator there is a daily variation, a daily rise and fall of the barometer level, but this fluctuation is not seasonal. It is otherwise in the temperate zone where the daily rise and fall is not so noticeable and the variations are all linked more with the phases of the moon. The gravity is interior gravity, elasticity as pressure, but essentially alteration of specific gravity, a movement, an undulation, of the atmosphere which goes together with an alteration of temperature, but so that this alteration has the opposed meaning, viz. of being ordinary temperature and light temperature, the former, heat given out and the latter freely added to the atmosphere by light. The latter is, in general, clearness and pure elasticity of the air, high barometer level, while the former belongs to the formative process and is present when the elasticity of the air passes over into rain or snow. It is in the air that these abstract moments return into themselves. Just as the celestial morion materializes itself in the air, so on the other side sea and earth invade the air and volatilize themselves into it, a processless, immediate transition. The air individualizes both within itself, partly into the universal atmospheric process in which it displays its greatest independence, resolving water and earth into odors and also discharging itself and passing over into water, partly in transforming itself into meteors as transitory comets into earths which it generates, i.e. aerolites, partly into noxious airs, miasmas, harmful to animal life, and partly into honeydews and mildews animal and vegetable airs. 2. But the neutral earth, the sea, is equally the movement of ebb and flow, a composite movement resulting from the changing positions of sun and moon and from the shape of the earth. Just as the air, as universal element, takes its tension from the earth, so, too, it is from the earth that the sea takes its neutrality. The earth, relatively to the air, evaporates. As sea, but relatively to the sea, the earth is the crystal which discharges its superfluous water, into springs which collect to form rivers. But this is, as fresh water, only abstract neutrality, whereas the sea is the physical neutrality into which the crystal of the earth goes over. We must not, therefore, explain the origin of inexhaustible springs by mechanically and quite superficially attributing them to percolation, any more than we must use a similar kind of explanation, on the other side, to account for volcanoes and hot springs. On the contrary, just as springs are the lungs and secretory glands for the earth's process of evaporation, so are volcanoes the earth's liver, in that they represent the earth's spontaneous generation of heat within itself. Everywhere we see tracks, especially sandstone beds, which are always giving off moisture. I regard mountains, therefore, not as gatherers of rainwater which penetrates into them, on the contrary, the genuine springs which generate rivers like the Ganges, Rhone, and Rhine have an interior life, a striving and a stirring, like naiads. The earth discharges its abstractly fresh water which, in these outpourings, hastens to its concrete life, to the sea. The sea itself is this higher vitality than the air, it is the subject of bitmess and neutrality and dissolution, a living process which is always on the point of breaking forth into life but again perpetually falls back into water because this contains all the moments of that process, the point of the subject, neutrality, and the dissolution of this subject into neutrality. Fruitful as is the solid earth, the sea is no less so and in a still higher degree. The general mode of vivification displayed by land and sea is gene ratio equivoca, whereas in the sphere of vitality proper, the existence of an individual presupposes another of the same kind. It was assumed that omne vivum ex ovo, and then when the origin of certain animalcules could not be accounted for, recourse was had to invention. But there are organisms which originate immediately and do not procreate further, infusoria agglomerate and give rise to another shape, so that they serve only as a transitional stage. This universal vitality is an organic life which inwardly stimulates itself, acts as a stimulus on its own self. The sea, which is something other than fresh and salt water, which contains not merely common salt but also sulfate of magnesia, is concrete salinity as an organic being which reveals itself at all points as procreative, just as water generally always has the tendency to pass away and to transform itself, for it is only the pressure of the atmosphere which preserves it in the form of water. The sea has this characteristically putrid smell, a life which, as it were, is always putrefying. Sailors speak of the blossoming of the sea in summer. In July, August, and September, the sea becomes polluted, turbid, slimy, and to the west in the Atlantic, this occurs a month earlier than in the Baltic. The sea is filled with vegetable life in the form of innumerable points, threads and surfaces. There is a tendency to break forth into vegetable life. When this 296 tendency is intensified, Vast tracts of sea break out into phosphorescent light, a superficial life which gathers itself into a simple unity, but equally into a unity which is also completely reflected into self. For this luminosity is often present in fish and other creatures which already belong to the sphere of living subjectivity. But the whole surface of the sea, too, is partly an infinite shining, partly an immeasurable, immense sea of light which consists purely of points of life lacking any further organization. If such water is taken from the sea, the vitality dies away immediately and there remains a gelatinous slime, the beginning of vegetable life, with which the sea is filled from its surface to its depths. Already in every fermentation, animalcules reveal their presence. Lastly, the sea develops further to determinate shapes, to infusoria and mollusca which are transparent and have a longer life but which are still quite rudimentary organisms. For instance, de Chamisso made the fine discovery of a salpa which was so fertile that its numerous progeny, like the free petals of a plant clustered round its stem, were arranged in tiers one on top of the other, forming a garland or circle where many have a single life, like the polyps, and then come together again in a single individual. Since this inferior animal world, which includes a host of luminous species, only gets as far as a momentarily existing slime, the subjectivity of animal life can make that life here merely a luminosity, the external show of self-identity. This animal world cannot hold its light within it as an inner self, but the light breaks forth only as a transient physical light, and the millions of rudimentary lives rapidly drift away to be dissolved again in the watery element. In this way, the sea reveals a host of stars, densely crowded together in Milky Ways which are as good as the stars in the sky, for these are only abstract points of light, but the former come from organic forms. In the sky, light is in its first, undeveloped crudity, but here it bursts forth from animal life as an animal product, like the phosphorescence of decaying wood, a flicker of life and an emergence of soul. It has been rumored round the town that I have compared the stars to a rash on an organism where the skin erupts into a countless mass of red spots, or to an ant heap in which, too, there is understanding and necessity. In fact, I do rate what is concrete higher than what is abstract, and an animality that develops into no more than a slime, higher than the starry host. And even without counting fish, the marine world contains polyps, corals, lithophytes, zoophytes, etc. Each drop of water is a living globe of infusoria, etc. The sea contains within it the principle of life in a more imminent manner than does the land, in so far as its fluid nature does not allow the punctualization of this principle into a living being which could break free from the sea and inwardly maintain itself over against it. The neutrality of the sea wrests this incipient subjectivity back into its indifferent womb, and thus makes the vital force which the subjectivity has taken for itself melt away again into the universal. The most ancient teaching, it is true, made all living creatures come forth from the sea, but this very coming forth from the sea is a breaking away from it, and the living being exists only as tearing itself away from the sea and maintaining its own independence in face of the neutrality. The sea, therefore, in its fluidity remains at the stage of elemental life, and when subjective life is cast back, drawn back, into the sea again, it feels, even with a more developed organization, the presence of this undeveloped torpidity. 3. The land, as the giant corpse of the life which was formerly immanent in it but which has now fled, is this individual concretion which has wrested itself free from neutrality, the solid crystal of the lunar element, while the sea is the cometary element. Since, however, in the subjective living being these two moments interpenetrate, the slime becomes the casing of light which remains interior. Earth, like water, displays infinite, universal fecundity, but whereas the sea brings forth mainly animal life, the earth tends rather to bring forth vegetable life. The sea is more animal because neutrality is an interior propagation, earth is primarily vegetative as holding to a punctifero development. Everywhere the earth covers itself with green vegetation, indeterminate formations which can equally be classed with animal life. Individual vegetation must, of course, be generated from seeds of the same species, but universal vegetation is not so individual. Such are lichen, moss, into which every stone breaks forth. Wherever earth, air, and moisture are present, there we find plant life. Wherever something weathers away, at once a vegetable form, mold, or mildew makes its appearance, fungi, too, spring up everywhere. This vegetation, as not yet shaped by individuality, consists of inorganic organic forms like lichens and fungi which one does not rightly know how to classify, peculiar, tough substances coming near to animal life. Rudolphi says, in lichens we can find nothing which we might assume characteristic of plant structure, they definitely do not possess true parenchyma, tubes, or vascularity, and all writers are agreed on this. I have nowhere found any proof that the so-called reproductive organs are really such, and it is perhaps more likely that they are germination buds by which the lichens propagate themselves in a way similar to that of a number of true plants, so that this proves nothing. In a number of them their pigments, their gummy and resinous constituents, the sugary mucilage and tannin, point to a vegetable nature. Fungi are entirely different in structure from plants. I have examined a good many and find that their substance is of a kind that could rightly be called animal. In the softer fungi there is a fibrous, mucous tissue which closely resembles that of animals but which is completely different from the rigid cellular structure of plants. In Boleta pseudotapcorus there is a lanuginous tissue which is definitely not vegetable in nature but which forms a clear transition from the soft to the ligneous fungi, and which might be compared to the stem of the gorgonias. If1 considers the animal composition of fungi and 299. Its behavior in galvanization, says von Humboldt, pages 171-80, we shall more readily discard the opinion that fungi belong to the vegetable world and are true plants. Above all, their mode of origin is confirmation of this, for when animal or vegetable matter putrefies or decomposes, this very putrefaction gives rise to fresh forms. Clavaria amylians, for example, originates only on dead maggots. This infinite host of shapes does not get to the point of a germ or a seed, which exists only where subjectivity is attained. Fungi do not, so to speak, grow but suddenly shoot forth as crystals do. We must not think of such vegetation as coming from seeds, any more than we must think of seeds or spores as the origin of the host of imperfect animal forms, infusoria, intestinal worms, swine gargets, etc. This universal vitality is found not only in sea and on land, but also in independent, living subjectivity. The definition of what a plant or an animal is, I9 based on statements about cell tissue, seeds, eggs, growth, and so on. But an exact definition cannot be established and there is none, for fungi, lichens, and the like belong, in general, to the vegetable kingdom, although the specific determinateness is lacking, because nature in its manifestations does not hold fast to the notion. Its wealth of forms is an absence of definiteness and the play of contingency. The notion is not to be based on them, rather it is they which are to be measured by the notion. Such indefinite intermediate beings, which are neither fish not flesh, are moments of a total form, but isolated moments. This division between the universal, self-external organism and the merely punctiform, transient subjectivity just dealt with, is in virtue of the implicit identity of their notion, overcome in the existence of this identity. In the vivified organism, this is the subjectivity which differentiates itself into members and which excludes from itself, an objectivity confronting it, the merely implicit organism, physical nature in its universal and individual forms. But at the same time, it has in these natural powers the condition of its existence, the stimulus, and also the material of its process. Zusatz. What is lacking in this display of organic being, or immediate organic being as such, is that the notion here I9 still immediate, is only as internal and in the element of indifference, but that its moments are physical realities which are not reflected into themselves, do not form a one confronting that indifference. But the universal, the end, expands into these moments and returns into itself. Their indifference is the one-sided moment which gathers itself together into negativity and is an individual. The substance divides itself not only into different sides but into absolute opposites, such that each of them is the totality, is a being reflected into itself, indifferent to the other, a one by its very nature and not only by its own nature, since the division is into sides whose very reality is this oneness, this negativity, i.e. whose existence is the process contained in it. Life, therefore, is essentially this perfectly fluid pervasion of all its parts, i.e. of parts indifferent to the whole. They are not chemical abstractions but have a substantial, whole life of their own, a life of the parts which, inwardly restless, resolves itself and brings forth only the whole. The whole is the universal substance, the ground as well as the resultant totality, and it is this totality as an actuality. It is the one which contains bound within itself the parts in their freedom, it sunders itself into them, endows them with its universal life and as their negative, holds them within itself as the power over them. This is posited in the form of an independent circulation in and through the parts, but this movement is at the same time the sublation of their particularity and the becoming of the universal. This is the universal circle of movement in the individual actual, a circle which, more accurately, is the totality of three circles, the unity of universality and actuality, the two circles of their opposition and the circle of their reflection into self. First, the organic being is the actual which sustains itself and in its own self runs through its process, it is its own universal, and this sunders itself into its parts which sublate themselves in their production of the whole. The genus here stands on the side of the organic being. The conclusion is that the genus is directly united with its non-organic nature, the organic being sunders itself therefore into two universal extremes, the non-organic nature and the genus, of which it is the middle term, and with each of which it is still immediately one, being itself genus and non-organic nature. Thus the individual still has its non-organic nature within it, and feeds on itself in that it consumes itself as its own inorganicity. But in so doing, it develops members within itself, i.e. it sunders its universality into its differences, the course of the process within the individual itself as a diremption which does not exclude the differences, and as a relation of the organic being to itself. The universal has to actualize itself in its own self, and it is precisely through this movement in which it becomes for itself that it gives itself its self-feeling. The organic being is turned against itself as this immediate universal, as this organic genus. This is its process of individualization, it opposes itself to itself internally, as later it will oppose the external world, but as yet, the other is still held in check by the notion. However, in so far as the individual is already presupposed, it unites here the genus which is its universality with the particularized universal. This latter is one of the extremes, that which, taken up into the absolute genus becomes absolute particularity and singularity. This is the particular delivering, the becoming, of the moment of individuality. 301. Which enters the process as already in being. Nothing comes out of the process but what is already there. It is the process of the digestion of itself and the development of the moments as members, the shaping of them, the members are no less generated than consumed, and in this general unrest, what abides as simple is the soul. In this process, the individual succeeds through the genus in breaking loose from the latter, it is the process in the genus which makes the genus into a one which is charged with negativity, and so is opposed to the genus as to the universal. Secondly, the universal is a real existence and the organic one is the power over this negative of itself, this external being, and consumes it so that it exists only as sublated. The organic being is immediately unity of individuality and universality, organic genus, it is an exclusive one and excludes the universal from itself, the genus as abandoned by the power of negativity, by life, in other words, the organic posits for itself its non-organic nature. The genus is the absolute universal which posits the abstract universal as its opposite, but in doing both, it has also liberated the moment of singularity which is the negative relationship to this non-organic nature. Whereas previously the individual was the middle term and the sides the universal extremes, now it is the genus which is the middle term. Here, therefore, it is through the genus that the organic being is mediated with its non-organic nature. The former is the power over the latter, because it is the absolute universal. This is the process of nutrition. The non-organic nature is the universality as the non-actual genus, which is subject partly to individuality as such, to the earth, and partly to the singularity which frees itself from it. This universality is mere passivity. But in its actuality, as it is in its own self, the universality is the sundierance of organic nature and its non-organic nature, the former being the form of individuality and the latter the form of universality. Both are abstractions, the substance is the same in both forms into which it has differentiated itself. The determinity 9s remains a universality, is one with the element and principle, for the organic being, there is nothing which it is not itself. The reflection into self of the organic being means that its non-organic world is no longer in itself, this exists only as sublated and the organism is the positing and sustaining of it. But to take this activity alone, would be equally one-sided. The truth is rather that the earth makes the sun and its elements, as it make 9 everything organic, because it is this universal organic being, but it is equally in itself both of these sides. This positedness of the non-organic is its sublatedness, it is not in itself. The organic being is self-subsistent, but the non-organic as an in itself for the organic being is, in the first instance, the indifferent existence of both, but it then passes over into an existence which is attention, into the form of being for self appropriate to the organic being. ISS, that immediate being of the organism as genus is equally the outcome of sheer mediation through the non-organic world, it exists only through this otherness, this antithesis to itself as abstract universality, it is the genus which has been released from the individuality. But because that abstract universality is in its own self also life, it makes the transition through its own self to organic being in the Geruratio e Curvica. In general, the existence of organic being is the act of the whole earth, in which it individualizes and contracts itself, the reflection into self of the universal. But equally it becomes a stabilized reflectedness into self, and the higher plants and animals are this established reflectedness into self, which does not shoot up out of the earth like fungi, like unindividualized jelly or lichens which are only organic life in general überhaupt, with but a meager internal organization. But the abstract universality in its real existence only reaches as far as a general reflection and begins here its immediate becoming. This life which is a reflectedness into self is now established as an independent existence passing through its own cyclic process, and it has its own existence which remains opposed to that other reality and holds fast to its negative nature, denies its origin, and displays its own becoming. Thirdly, this actual being thus brought forth is the genus, the power over the individual and the process of that power, it sublates this individual, brings forth another which is the actuality of the genus, but just for that reason is also a tearing itself apart from the non-organic nature to which the genus relapses. The organic being which is thus mediated through the non-organic nature with the genus is the sex relation. The conclusion is the connection of the two sides which are the whole organic being, or the diremption of this whole into opposed, self-subsistent sexes, the sublation of the individual and the resultant being of the genus, but of the genus as an individual actual being which initiates the cycle again. The result is, therefore, that the individual has separated itself off from the genus. This self-subsistent individual is therefore related to a being to which, as genus, it is indifferent. The genus has sundered itself into self-subsistent beings, each of which as this whole is object to itself, but outside of itself. In the first process we have being for self, in the second, the representation and knowledge of an other, in the third, the unity of both, of the other and itself. It is the true actualization of the notion, the complete self-subsistence of both, in which each also knows itself in the other as its own self. It is the relation which has become purely ideal, so that each is ideal to itself, is in itself a universal. The pure non-objectivity is set up in the self as such. The organic being begins with singularity and rises to the genus. But just as immediately this course is the reverse, the simple genus descends to singularity, For the consummation of individuals in the genus resulting from their sublation, is no less the becoming of the immediate singularity of the child. The other to the universal life of the earth is thus the truly 3** organic form of life which continues itself in its genus. This is, in the first instance, the vegetable world, the first stage of being for self, of reflection into self, but only immediate, formal being for self, not yet the genuine infinity. The plant discharges its moments from itself as free members and is only the subjective point of life. Plant life therefore begins where the vital principle gathers itself into a point, and this point sustains and produces itself, repels itself, and produces new points. THEPLANTNATURE 343. The subjectivity in virtue of which organic being exists as a singular, unfolds itself into an objective organism in the shape of a body articulated into parts which are separate and distinct. In the plant, which is only the first, immediate stage of subjective vitality, the objective organism and its subjectivity are still immediately identical. Consequently, the process whereby the plant differentiates itself into distinct parts and sustains itself, is one in which it comes forth from itself and falls apart into a number of individuals, the whole plant being rather the basis bodin, for these individuals than a subjective unity of members. The part bud, branch, and so on, is also the whole plant. A further consequence is that the difference of the organic parts is only a superficial metamorphosis, and one part can easily assume the function of the other. Zusatz. Whereas the geological organism is the mere system of shape devoid of ideality, with the subjectivity of plant life ideality now enters in. But as the ideality present in all its members, life is essentially a living being, and this is merely excited by the outer world. Here, therefore, the causal relation falls away, and generally in the sphere of life, all the categories of the understanding cease to be valid. If, however, these categories are still to be employed, then their nature must be transformed, and then it can be said that life is its own cause. The proposition can be advanced that everything lives in nature. This is sublime and is supposed to be speculative. But the notion of life, i.e. life in itself, which of course is found everywhere, is one thing. Real life, the subjectivity of the living organism, in which each part exists as vivified, is another. Thus the geological organism is alive, not in its separate parts but only as a whole. It is only potentially alive, not in present existence. But the living organism, too, differentiates itself into a subjective and a dead being. On the one hand, in its woody structure, in its bones, it makes itself the presupposition of its frame in the individual, as is the case in the geological organism as a whole. But on the other hand, the living organism is the shape which is inhabited by the substantial form. This is determinative not only in respect of the spatial relationships of the separate parts, but is equally the unrest of the process in which the form determines the physical properties out of itself, so that, from that process, it may produce shape. The plant, as the first self-subsistent subject that SDLL has its origin in immediacy, is, however, the feeble, infantile life that has not yet developed within itself the moment of difference. Like every living organism, the nature of a plant is particularized, but whereas in the animal the particularity is at the same time a particularity in contrast with which the subjectivity as soul is also a universal, in the plant the particularity is quite immediately identical with the plant's vitality in general. It does not exist as a state distinct from the plant's inner life. On the contrary, the quality of the plant completely pervades its general vegetative nature, instead of being distinct from it as in the animal. In the plant, therefore, the members are particular only in relation to each other, not to the whole. The members themselves are in turn wholes, as in the dead organism where in sedimentary strata they are also external to each other. Although then the plant posits itself as the other of itself in order perpetually to idealize this contradiction, this differentiation is only formal. What it posits as the other is not a veritable other but the same individual as the subject. F. In plant life, therefore, growth is predominantly an increase of the plant itself, as an alteration of form, whereas animal growth is only an alteration of size but at the same time remains one shape, because the totality of the members is taken up into the subjectivity. The growth of the plant is an assimilation into itself of the other, but as a self-multiplication, this assimilation is also a going forth from itself. It is not a coming to self as an individual, but a multiplication of the individuality, so that the one individuality is only the superficial unity of the many. The individuals remain a separated plurality, indifferent to each other, which do not proceed from their substance as from a common essence. Schultz therefore says, the growth of plants is a perpetual addition of new parts which did not exist previously. Bound up with the homogeneity of the parts of the plant, therefore, is their falling asunder, because they are not related to each other as inner, qualitative differences. In other words, the organism F. Goethe, Zoomorphology, Volume I, pages X11, the more imperfect a creature is, the more do the parts resemble each other, and the more are they like the whole. The more perfect the creature is, the more dissimilar its parts become. In the first case, the whole is more or less like the parts, in the second, the whole is dissimilar to the parts. The more the parts resemble each other, the less they are subordinated to each other. Subordination of the parts betokens a more perfect creature. Has not at the same time acquired a system of viscera. It is a production of itself in externality, but all the same, a growth altogether from within outwards, not a sort of external accretion as in crystallization. 3.5. 344 The process of formation and of reproduction of the singular individual in this way coincides with the process of the genus and is a perennial production of new individuals. Because the self-like universality, the subjective one of the individuality, does not separate itself from the real particularization but is only submerged in it, so that the plant is not yet a self-subsistent subjectivity over against its implicit organism, therefore it can neither freely determine its place, i.e. move from the spot, nor is it for itself, in face of the physical particularization and individualization of its implicit organism. Consequently its nutrition is not an interrupted process but a continuous flow, and it relates itself not to individualized inorganic nature but to the universal elements. Still less is it capable of animal heat and feeling, for it is not the process in which its members, which are rather mere parts, and are themselves individuals, are brought back into a negative, simple unity. Zusatz. Everything organic is an immanent differentiation which preserves the manifoldness in the unity. Animal life, however, as the truth of the organic sphere, advances to a higher specific difference, such that the difference which is pervaded by the substantial form is only one side, and the other side is constituted by the substantial form on its own. Over against this submergence in the difference, the animal consequently has sensation. But the plant has not developed to this difference within itself, to the stage, that is, where the self-like point of unity and the organic crystal would already be the two sides of its life. Accordingly the vital principle, which in the animal is soul, is in the plant still submerged in the process of the mutually external parts. In the animal, on the contrary, the one vital principle is doubly present, as indwelling and vivifying, as a self-like unity which exists as simple. It is true that both moments, and their relation, must also be present in the plant, but one part of this difference falls outside of its existence, whereas in the animal there is present the absolute return of the living organism as self-feeling. The existent plant, on the other hand, is only one bodily organism, in which the pure self-like unity with self is not yet present as a reality but only in the notion, because it has not yet become objective. In the plant, therefore, the body with its members is not yet the objectivity of the soul seal, the plant is not yet objective to itself. Therefore for the plant, the unity is something external, just as the process of the organism of tile earth falls outside of it, and this outer, physical self of the plant is light towards which it strives, in the same way that man seeks man. The plant has an essential, infinite relationship with light, but at first it is a quest for this itself, like heavy matter. This simple principle of selfhood, einfach Selbsticht, which is outside of the plant is the supreme power over it. Schelling therefore says that, if the plant had consciousness, it would worship light as its god. The process of self-preservation is to attain the self, to satisfy oneself, to come to self-feeling, but because the self is outside of the plant, the latter's striving after the self is rather a being drawn out of itself, so that its return into itself is a perpetual forthgoing, and conversely. Thus the plant preserves itself by multiplying itself. The externality of the subjective, self-like unity of the plant is objective in its relation to light, in the same way that light appears externally in the jelly-like forms of marine life and also in the colors of birds in the tropics, so that here, even in the animal world, the power of light is visible. Man fashions the self in more interior fashion, although in southern latitudes he, too, does not reach the stage where his self, his freedom, is objectively guaranteed. It is from light that plants first get their sap, and in general, a vigorous individualization. Without light they can, indeed, grow bigger, but they remain without taste, color, and smell. They therefore turn to the light. Potato plants sprouting in a cellar creep from distances of several yards across the floor to the side where light enters through a hole in the wall, and they climb up the wall as if they knew the way, in order to reach the opening where they can enjoy the light. Sunflowers and a host of other flowers follow the motion of the sun in the sky and turn towards it. In the evening, if one enters a meadow full of flowers from its east side, only a few flowers, or perhaps none, will be seen, because they are all turned towards the sun, but looked at from the west they all make a splendid show. In the early morning, too, when one enters the meadow from the east, no flowers are seen, not until the sun shines on them do they turn towards the east. Some, says Wildenau Grundrister Krauterkunde, edited by Link, do not open out to the sun until noon, like Portulaca oleracea, Drosera aurokundifolia, some only at night, like the magnificent torch thistle Cactus grandiflorus, which only blooms for a few hours. Now because, as we have said, the subjective one of the plant is fused with its very quality and particularization, and consequently the negative selfhood of the plant is not yet self-related, therefore this self, too, does not yet exist as a purely non-sensual being, the name of which is simply soul seal, but is still sensuous, no longer, it is true, as a materia plurality, yet still as a sensuous unity of material. 306. Parts. Now the sensuous element which remains for the unity is space. Since the plant thus cannot entirely destroy the element of sense, it is not yet pure techne within itself. For this reason, the plant is in a specific place which it cannot get rid of, although it unfolds itself within it. The animal, however, as process, opposes itself to its place, gets rid of it, even though it does posit it afresh. Similarly, the ego wills to move itself, the point, that is to say, it wills to change its place, i.e. its sensuous, immediate existence as point, or the ego wills to distinguish itself as ideality of the one, from itself as a sensuous one. In the heavenly motions, the bodies of the one system have indeed a free motion, but it is not a contingent motion, their place is not determined by them as particulars, but by the time of the system which is rooted by law in the sun. Similarly, in magnetism, the opposed qualities are the determining factors. But in the subjectively living being which is its own time, there is negation of place, a negation posited in an absolutely indifferent manner, or as an inner indifference. The plant, however, is not yet this mastery over the indifferent, mutually external existence of parts in space, and its space is consequently still an abstract space. The movement of pistils and anthers towards each other, the oscillatory movements of conferva, etc., these are to be understood only as a simple growth without any contingent determination of place. The movement of plants is determined by light, heat, and air. Trevoranus J** points this out, example in Hedysarum gyrats, at the end of each stem of this plant there is a larger leaf, elliptical and lanceolate in shape, and on each side of this and attached to the same main stem are two smaller petiolate stipules. The movements of the main stems and leaves are different from those of the stipules. The movement of the main stems and larger leaves consists in an erection in the light and in a drooping down in the dark. It occurs in the joints which join the leaf with the stem and the latter with the branch. Even the reflection of sunlight from a wall 20 yards away produced a distinct erection of the leaves, and also the screening of sunlight by an opaque body or by a passing cloud resulted in their drooping again. At high noon, and by focusing sunlight through a burning glass 8, Hufeland observed a trembling movement of the main leaves and of the whole plant. Moonlight and artificial light had no influence on this movement. The second movement, which is made only by the small folioles, consists in the alternate erection and drooping of each pair of these leaves which face each other on the same branch. The movement ceases only with the death of the plant. There are no external causes immediately producing this effect, but it is most marked at the time of fertilization. Treviranus, however, attributes to the zoospores of the conferva an arbitrary movement even after they have become detached from these plants. Some of the movements. 307. T. Biologie oder Philosophie der lebenden Natur, Vol. V, pages 202-3. Of the conferva are said to be oscillatory. Their separate threads bent their free ends in a series of jerks from right to left and from left to right. Often they twisted in such a way that their free ends seemed to describe a circle. But movement of this kind is still not a voluntary movement. The relationship of the plant to the outer world could be an interrupted relationship only if the plant existed as something subjective, only if, as a self, it had a relation to itself. The reason, therefore, why the intraception of the plant is not interrupted is simply that its nature is not to be a veritable subjectivity, but its individuality always falls apart into its particularity, and so does not hold on to itself as an infinite being for self. It is only when the self exists qua self that it is exclusive in its relationship to the outer world and, precisely as such, is the soul of this relationship as reference to self, since in this self-reference the self forms both sides of the relation. This latter is a circle within the soul which holds itself aloof from its non-organic nature. But as the plant is not such a self, it lacks the inwardness which would be free from the relationship to the outer world. Thus air and water are perpetually acting on the plant. It does not take sips of water. True, the action of light is interrupted or weakened externally at night and in winter, but this is not a difference of the plant itself, but is external to it. It is possible, therefore, gradually to change the plant's activities by putting it at night into a lighted room, and in a darkened room during the day. De Kendall in this way changed the period of sleep of mimosas and several other plants after only a few nights by leaving lamps alight. The rest of the plant's behavior depends on the seasons and the climate. Plants from northern latitudes, which sleep through the winter, gradually change this habit in southern latitudes. Similarly, the plant does not yet enter into relationship with what is individual, also because its relationship is not that of self to self. Its other, therefore, is not individual, but what is elementally inorganic. A number of experiments have been carried out on heat in plants and the subject has aroused much controversy. Hermstadt in particular has devoted much attention to it. It has indeed been claimed that in plants a slightly higher specific heat has been detected than in their environment, but that does not settle the matter. Heat is a conflict of altered cohesion, but plants lack this alteration of cohesion in themselves. They are devoid of this internal inflammatory process, this interior fire which constitutes animal life. True, a thermometer placed in a hole bored through a tree revealed a significant difference between the outside and inside temperatures, e.g. of 50 Reaumur and +2 degrees, of I0 degree and +I degree, etc. This, however, is because wood is a bad conductor of heat, and also the trunk gets its heat from the earth. Besides, says Treviranus, there are more than 4,600 experiments of Fontana which show that the heat of plants depends entirely on the temperature of the medium in which they are situated. Treviranus continues. There are some species of plants which, in certain circumstances, can in feet generate heat and cold, and thus withstand the influence of the outside temperature. Several investigators have observed on the surface of the spadix of Arum maculatum and other varieties, at the time when it begins to break out of its spathe, a heat which increased over a period of 4 to 5 hours, and which diminished over a similar period. The maximum temperature exceeded that of the air outside, in the case of Arum maculatum by 150160 F and of Arum cordifolium by 60°-70° F. The ice plant develops cold, undoubtedly from its saltpetery content. But in the former instance, the heat probably no more serves to protect the plant from cold at the time of fertilization, than in the second instance, the cold serves to protect the plant from heat. The plant is therefore none the less devoid of this internal process, for in its movement outwards it only gets benumbed and rigid. The animal, on the other hand, is this fluid magnet whose differentiated parts pass over into one another and so develop heat, the principle of which resides precisely only in the blood. That the plant has no feeling is again a consequence of the fusion of the subjective one with the quality, the plant's own particularization. The being within self is not yet self-subsistent in face of the outer world as a nervous system, as it is in the animal. Only that which possesses sensation can tolerate itself as other, can, with the hardiness of individuality, assimilate it and venture into conflict with other individualities. The plant is the immediate, organic individuality in which the genus has the preponderance, and the reflection is not individual. The individual does not as such return into itself but is an other and therefore has no self-feeling. The sensitivity of certain plants does not come under this head, and is only a mechanical elasticity, like the action of light in connection with the sleep of plants. On this point Treviranus says, there has been a tendency to regard the sensitivity to external, purely local stimuli and the movements of reaction to them, as sensation, and, of course, the resemblance of this to the contraction of animal muscle fibers is unmistakable, but this can also take place without sensation. Pollination mechanisms in particular display ouch sensitivity. The pollen is scattered from the anthers when the stamens are touched, the pistils and stamens move in response to mechanical stimuli, and the filaments, especially, move towards the pistils when they are touched. But the externality of the cause of this sensitivity is demonstrated particularly by the observations of Medicus cited by Treviranus, that a number of plants in colder latitudes. F. Link, Grundlehrender Anatomie und Physiologie der Pflanzen p. 229, remarks on this that the flower has a very offensive smell. In my opinion, the sole cause of the generation of beet is the release and decomposition in the air of the oil or carbonate hydrogen which produces the stench. Show no sensitivity in the afternoon when the weather is hot and dry, but in the morning after a heavy dew, and during the whole of the day with a gentle rain, they are very sensitive. Plants in warmer climates display their sensitivity only when the sky is bright. And all plants are most sensitive when the pollen ripens and the pistil is covered with a lustrous oil. With regard to the sensitivity of the leaves, the most notable plants are some of the mimosa species and other plants which, like these, belong to the family of legumes. Dionaea muscipula has a large number of leaves arranged in a circle round the stalk, and the leaves of Oxalis sensitiva consist of 12 pairs of oval-shaped leaflets. When they are touched they fold up their leaves. The leaves of Avercoa carambola are pinnate and droop when their stalk is touched. The anatomical observations of Rudolphi and Link demonstrate this fact. Rudolphi says, these plants have an articulation of the leafstalk and of the partial leaf stalks peculiar to them. At the base, the leaves are contracted, while in other pinnate leaves the base is widened or at least is not thinner. The stalk, which is thick above the joint, in these plants becomes much thicker than in the other parts, and this makes the contracted joint still more visible. Moreover, this thickening consists only of cell tissue which usually soon lignifies. When saxifrage, lupins, etc., are cut, all the parts very soon close up as when the plants are asleep, and they do not reopen. A fresh mimosa will droop at the slightest touch, and, if it is quickly lifted up again while it is sick or exhausted, it can be stimulated for a long time in vain, and a long time, too, can elapse before it lifts up the drooping parts. Desfontaine, as Merble relates, carried a mimosa with him on a journey. At the first movement of the carriage it closed all its leaves, but subsequently they opened again imperceptibly, and did not close again on the journey, almost as if they had got used to the swaying of the carriage. 1 Inc says, in the wind, the leaves close, but open up again in spite of the wind, and finally become so used to it that the wind ceases to have any effect on them. And in the Nachtrage zu den Grundlagen, the sensitivity is confined to the area of shock. A leaflet can be subjected to very violent action without die leaves nearby being affected by it. Each stimulus seems to be confined to, and to affect, only the place where it is produced. Here, then, we have nothing more than the simple phenomenon of contraction and expansion, which occurs more rapidly and suddenly than in the change in plant activity mentioned above, where the action was slower. 310. 345 But the plant, a non-organic, also essentially articulates itself sich-glidered, into a variety of structures, 9 abstract cells, fibers, and 3*1 the like, and some more concrete, which, however, remain in their original homogeneity. The shape of the plant, as not liberated out of individuality into subjectivity, is still closely related to geometrical forms and crystalline regularity, and the products of its process are even more closely related to chemical products. Remark. Goethe's Metamorphose der Pflanzen marks the beginning of a rational conception of the nature of plant life, in that it has forced attention away from a concern with mere details to a recognition of the unity of life. The identity of the organs is predominant in the category of metamorphosis, but the other and necessary side to this substantial unity is the specific difference and characteristic function of the members through which the life process is posited. The physiology of the plant necessarily appears more obscure than that of the animal body because it is simpler, assimilation passes through fewer intermediary processes, and alteration occurs as immediate infection. As in every natural and spiritual life process, the main point in both assimilation and secretion is the substantial alteration, i.e. the immediate transformation of an external or particular material as such into another. The attempt to follow up the mediation as a series either of chemical or mechanical gradations meets a point where it breaks down and becomes impossible. This point is everywhere present in the process and pervades it, and it is the ignorance of, or rather the failure to recognize, this simple identification as well as the simple diremption, which makes a physiology of the organism impossible. Interesting information on the physiology of the plant is given in the work of my colleague Professor C.H. Schultz, a work which I am the more bound to mention here, as some of the special features of the life process of the plant referred to in the following paragraphs have been taken from it. Zusatz. The objectification of the plant is wholly formal, is not a veritable objectivity. Not only does the plant outwardize itself simply as such, but itself is preserved as an individual only by a perennial positing of a fresh individual. The type of the whole plant is simply this: there is a point, a germ, a grain, a node, or whatever you may call it. This point puts out threads, develops into a line, and this linear movement outward stops again, develops a fresh grain, a fresh node. By this process of self-repulsion these nodes continue to be formed, for inside a thread the plant splits up into a number of germs which, in turn, are whole plants. Thus members are produced, each of which is the whole. It is at first a matter of indifference whether these nodulations keep within a single individual or whether they split up into several individuals. This reproduction is thus not mediated by opposition, is not a coming together resulting from it, although the plant can also rise to this. The veritable separation of the sides of the opposition in the sex relation belongs, however, to the sphere of animal force, and it is only a superficial form of this which is found in the plant, about which we shall speak later. The simplest and quite immediate example of this plant type is found in the conferva, which are nothing else but green threads devoid of any further developed structure, the first rudiments of aquatic vegetation. Treviranus thus describes them: the conferva in fountains and spring water propagate themselves by an oval bud into which the tip of the delicate thread of which this plant consists, swells up. After a while, this bud separates from the thread, establishes itself in the nearest spot, and soon puts out a tip which prolongs itself into a complete thread. The propagation of all the species classed by Roth under the genus Ceramium takes place in a similar simple manner. On the surface of their stem or their branches there are formed at certain periods, but mostly in the spring, back-form bodies which usually contain one or two smaller grains. When these bodies are fully ripe they either fall off or open and release their seed. In the conferva proper, in Hydrodictyon R.T. in Rivularia and many Tremella, the reproductive organs are found in the substance of the plant, and they are of two kinds. They consist either of small grains arranged regularly side by side in rows, which are already present in the plant from its first formation, or of larger, ovular bodies of the same diameter as the inner tube of the conferva, which appear only at a certain period in the life of these phytozoa. In some conferva, the former are arranged in a zigzag or in a spiral, in others, in star-shaped figures, right-angled parallelograms, etc., or they are arranged side by side in TB shape of branches which form a whorl round a common stem. They flow away and are the beginnings of fresh conferva. Very different from these smaller grains is a larger variety of round bodies which are formed in some articulated conferva, and propagate only at a certain period in their life. At this time, the smaller, original grains leave Michelet's ? 3 their normal position and unite to form larger oval or spherical bodies. With the formation of these, the conferva loses its green color, and all that is left is a transparent, colorless skin which contains in each of its articulations a brownish fruit. When at last this membrane has disintegrated, these fruits fall to the ground, where they rest until the following spring, when a conferva of the same species develops from each of them in a manner which seems to bear more resemblance to an animal coming out of its shell than to the germination of a grain of seed *I. And the same work Treviranus credits the conferva with copulative procreation. In the higher plants, especially in shrubs, the immediate growth occurs as a simultaneous division into twigs and branches. In the plant we distinguish roots, stem, branches, and leaves. But there is no more familiar fact than that each branch and twig is a complete plant which has its root in the plant as in the soil. If it is broken off from the plant and put as a slip into the ground, it puts out roots and is a complete plant. This also happens when branches are accidentally severed from the plant. Treviranus says, the propagation of plants by division never occurs spontaneously but always artificially or by chance. The ability to propagate itself in this way is possessed to a remarkable degree by Tillandsia usneoides, a parasitic plant of the Bromeliaceae. If any part of this plant is torn off by the wind and caught up in the branches of a tree, it at once takes root and grows just as well as if it had sprung from seed. Strawberries and a number of other plants, as we know, put out runners, i.e. creeping stalks which grow out of the root. These filaments or leaf stalks form nodes. If these points touch the earth they, in turn, put out roots and produce new, complete plants. Wildenau states, the mangrove tree bends down its branches perpendicularly to the ground and turns them into trunks, so that in tropical latitudes in Asia, Africa, and America a single tree will cover the moist banks of rivers or lakes for a mile or more with a forest consisting of numerous trunks which meet at the top like close-clipped foliage. The branches grow from buds. From each bud, quotes Wildenau from Aubert du Petit Thouars, vessels are prolonged and go down through the plant, so that the wood is strictly a product of the root fibers of all the buds, and the woody plant is an aggregate of a number of growths. Wildenau then continues, if a grafted tree is opened up at the side of the graft, fibers from the graft will, of course, be found running for a short distance into the main stem, as both Link and myself have observed. He speaks at length about this process of grafting. We know that a bud from a shrub or a tree when grafted onto another trunk develops on it and is to be regarded as a separate plant. Its nature does not change at all, but it continues to grow as if it were in the earth. Agricola and Baim were even more fortunate in T9 kind of propagation. They set the bud straight in the earth and 3*4 organics raised perfect plants from them. A noteworthy feature of T9 kind of artificial propagation is that where the branches or I9 are made into fresh plants by layering, grafting, inoculation, or any other way, the plant from which they were taken propagates itself not only and 9 a species but also as a variety. The seed only propagates the species, which can bring forth by various methods from the same 9 EED, a variety. Consequently the Borstorff apple must always remain the same when grafted and inoculated, but from the 9 EED quite different varieties will be obtained. Such buds retain their individuality to 9 Euca degree when they form a branch of another tree that from a single tree one can grow, example a dozen varieties of pears. Bulbs, too, are such seed buds and similarly divide themselves. Treviranus says, bulbs are peculiar to the monocotyledons. They grow sometimes on the upper part of the root and sometimes in the angle between the stem and the leaf stalk as in Lilium bulbiferum and Fritillaria regia, and sometimes in the flowers, as in several species of Allium. Those plants whose roots bear bulbs usually produce infertile seeds, but these become fertile if the young bulbs are destroyed as they appear. In Fritillaria regia each leaf, even when detached from the stem, is capable of producing bulbs. A leaf of this plant cut off close to the bulb in autumn, lightly pressed in blotting paper and kept in a warm place, puts out fresh bulbs at the lowest extremity where it was joined onto the root, and the development of these bulbs proceeds pari passu with the gradual dying off of the leaf. In some plants whose bulbs are produced in the axils of the leaves or on the stems, the bulb 9 spontaneously detach themselves from the parent stem and, separated from it, put out roots and leaves. Such plants especially deserve to be called viviparous. In Lilium bulbiferum, Poa bulbosa and several species of album, this phenomenon occurs without artificial aid. In Titapa gemeriana, Euchrodes punctata, and a number of other succulent monocotyledons, it can be produced artificially if the flowers are removed from these plants before fertilization occurs and the stalk with the leaves on it is put in a shady place. W. Ildenau actually remarks, Pathos entomyra can even be propagated from leaves, to which Link adds, this property is particularly remarkable in Bryopchilton calicinum *. A leaf placed horizontally on the ground puts out threads and rootlets all round its edge. Link says, thus we have examples of rooting buds which grew from the leaf stalk, Mundirola wa9 the first to propagate trees artificially from leaves. It is possible for a bud to grow from any part which contains only spiral vessels and cellular tissue. In short, any part of the plant can exist immediately as a complete individual. T9 can never be the case in animal aid with the exception of the polyps and other quite undeveloped 9 species of animals. Strictly speaking, then, a plant is an aggregate of a group of individuals which form a single individual, but one whose parts are completely self-subsistent. This self-subsistence of the parts is the impotence of the plant. The animal, on the contrary, has viscera, members which are not self-subsistent, which can exist only and solely in unity with the whole. If the viscera are injured, then the life of the individual is destroyed. Of course, the animal organism, too, can be deprived of organs, but organs of this kind are the only ones possessed by the plant. Accordingly, Goethe with his great insight into nature has defined the growth of plants as a metamorphosis of one and the same formation. His work, The Metamorphosis of Plants, which appeared in 1790, has been treated with indifference by botanists who did not know what to make of it just because it contained the exposition of a whole *. The going forth of the plant from itself into several individuals is at the same time a total structure, an organic totality which, in its completeness, has root, stem, branches, leaves, blossom, fruit, and of course also posits a difference in the plant which we shall develop in the sequel. But what Goethe aims to do is to show how all these different parts of the plant are a simple, self-contained basic life, and all the forms remain only outer transformations of one and the same identical fundamental nature, not only in the idea but also in their existence, so that each member can quite easily pass over into the other, a spiritual, transient adumbration of forms which does not attain to qualitative, fundamental difference, but is only an idea metamorphosis in the material. Aspect of the plant. The parts exist as intrinsically the 9 and Gathef grasps the difference between them merely as an expansion or contraction. It is well known, for example, that trees have been planted upside down, the roots up in the air and the branches and twigs in the ground, with the result that the former put out leaves, buds, blossoms, etc., and the latter have become roots. Double flowers, e.g. in roses, are nothing else but flowers in which extra nourishment has changed the stamens, anthers, and in the wild rose the pistil too, into petals, either entirely or still leaving traces of their original form. Many of these petals retain the nature of the stamen, so that on one side they are petal and on the other side stamen, for the stamens are simply nothing else but contracted leaves. Tulips which are called monstrosities have petals which hover between petals and sepals. The petals themselves are nothing but leaves of the plant, only refined. The pistil, too, is only a contracted leaf, also the pollen which in the R09E bush is a yellow powder, has the leaf nature. The same is true of the capsule and the fruit, and sometimes on the back of the fruit leaves can still be seen. The leaf nature can also be recognized in the stone of the fruit. The thorn of wild plants becomes a leaf in the cultivated PLDHT. In poor soils apple, pear, and lemon trees have thorns, but cultivation turns these into leaves*. In this way, the whole growth of the plant shows the same uniformity and simple development, and this unity of form is the leaf. One form can thus readily pass over into the other. Even the seed bears within itself the characteristic of the leaf, with its cotyledons or seed leaves, which are just leaves composed of cruder material and not elaborate. The next stage in the development is the stalk, which puts out leaves which are often pinnate and so approximate to flowers. When this prolongation goes on for some time, the stalk leaves develop nodes, and from the nodes grow leaves which, lower down on the stalk, are simple, and then notched, separating and dividing themselves. In the former, those lower on the stalk, the periphery, the edge, is not yet developed. 2 Goethe, in this picture which he gives of an annual plant, continues therefore, however, the further development of the plant stretches continuously from node to node through the leaf. From this point onwards, the leaves appear indented, deeply notched, or composed of several leaflets. In the latter instance, we are presented with complete little branches. The date palm provides a striking example of such an excessive and extreme diversification of the simplest leaf shape. In a sequence of several leaves, the midrib is carried forward, the fan-like simple leaf is tom and divided, and there is developed an extremely complex leaf vying with a branch. The leaves are now more finely elaborated than the cotyledons, for they draw their sap from the stem which already possesses an organization. In this connection, I make the following observation which has an important bearing on the difference of species, namely that this course of leaf development, which can be seen in one species, is also the principal determinant in the different species themselves, so that the leaves of all the species together exhibit the complete development of a leaf, as can be seen, for example, in a series of pelargoniums in which the leaves, in the first instance very diverse, pass one into the other through a series of transitions. It is well known that botanists find the specific difference of plants mostly in the formation of the leaves. Consider the leaves of Sorbus hybrida. Some of these leaves are still almost completely anastomosed, and it is only the somewhat deeper notches of the indented edge between the lateral veins which hint that nature here is striving towards a more marked separation. In other leaves these indentations, mainly at the base and the lower half of the leaf, become deeper, and it is unmistakably evident that each lateral vein is meant to become the midrib of a separate leaflet. In other leaves the lowest lateral veins are already clearly detached to form separate leaflets. In the following lateral veins the deepest indentations have already achieved this, and we recognize that here, too, a freer impulse towards ramification would have overcome anastomosis. Now this is achieved in other leaves where, from below asterisk upwards, 2, 3, or 4 pairs of lateral veins are detached, and the original midrib by a speedier growth pushes the leaflets apart. Thus the leaf is now half pinnate and half still anastomosed. According to whether the tree is younger or older, and to its condition, and even according to the kind of year, we see a predominance sometimes of the process of ramification and sometimes of anastomosis, and I possess leaves which are almost entirely pinnate. Now if we turn to Sorbus aucuparia, it becomes evident that this species is only a continuation of the evolutionary history of Sorbus hybrida, and that these two species are distinguished only by the fact that Sorbus hybrida strives to develop a more compact tissue, and Sorbus aucuparia strives to achieve more freedom to germinate. Pages 38 to 40, Goethe then passes from the leaves to the calyx. The transition to the flowering phase occurs sometimes more rapidly, sometimes more slowly. In the latter case, we usually observe that the stalk leaves begin to draw in again from their periphery and in particular to lose their various peripheral divisions, while on the other hand, a varying measure of expansion is shown in the lower parts of these leaves where they are joined to the stalk. At the same time, we see that even where the interval from node to node is not markedly increased, nevertheless the stalk assumes a much finer and slenderer shape than it had before. It has therefore been remarked that excess of nourishment hinders inflorescence of the plant. Often we see this transformation occur rapidly, and in this case the stem, above the bud of the last formed leaf, suddenly shoots upwards, becoming longer and slenderer and gathering at its apex a number of leaves round a center, the calyx. Its leaves are the same organs as the stalk leaves, but now gathered round a common center. Further, in many flowers we see unaltered stalk leaves directly beneath the corolla drawn together in a kind of calyx. Since they still completely retain their leaf form, we need only appeal here to ocular evidence and to botanical terminology which designates them floral leaves. Where the stalk leaves gradually draw close together, they become transformed, and gently insinuate themselves, as it were, into the calyx. These leaves become still less recognizable when, as often happens, they are united and their sides have grown together. The leaves thus pushed and crowded together present us with the bell-shaped or so-called monophyllous calyces which are more or less incised from the top inwards. The way therefore in which nature forms the calyx is to join together round a single center a number of leaves, and then a number of nodes which she would otherwise have produced one after the other, and at some distance from one another, in the calyx. Therefore, nature produces no new organ. On the contrary, the calyx is merely a point round which are gathered in a circle what previously were distributed throughout the whole stalk. The flower itself is only a duplication of the calyx, for the petals and sepals are very similar to each other. Here, too, in the transition of the calyx to the corolla, Goethe does not find any pronounced antithesis, although the color of the calyx usually stays green and similar to the color of the stem leaves, yet it often changes in one or the other of its parts, at the apices, the edges, the back, or even on its inner side, while the outer side still remains green, and all the time we find this change of coloring associated with the refinement of the form. In this way, ambigynous calyces arise which can equally correctly be regarded as corollas. Now the corolla again is produced by an expansion. The petals are usually larger than the sepals, and it can be observed that the organs which were in a state of contraction in the calyx, are now expanded again as petals in a higher degree of refinement. Their finer texture, their color, their smell, would quite disguise their origin from us if we could not see nature at work in a number of unusual instances. Thus, example inside the calyx of a pink, there is sometimes to be found a second calyx which in part is completely green, and looks like an incipient monophyllous incised calyx, and in part, is jagged and remodeled at its points and edges into actual rudimentary petals, spread out and colored and of a delicate texture. In several plants the leaves appear more or less colored even long before inflorescence, others are completely colored at the approach of inflorescence. Sometimes, too, on the tulip stem appears an almost completely developed and colored petal, and even more remarkable is the case when such a leaf is half green, with its green half belonging to the stem and remaining firmly attached to it, while its colored half is carried up with the corolla, and the leaf is torn into two pieces. It is a very likely conjecture that the color and smell of the petals derive from the presence of the male fertilizing substance in them. Probably it is present in them in a form not yet sufficiently isolated, but only mixed and diluted with other juices. And the beautiful appearance of the colors leads us to think that the substance with which the leaves are filled, although possessing a high degree of purity, does not yet possess it in the highest degree, in which it appears white and colorless. Fructification is the supreme development of light in the plant, and here, too, Goethe points out the close affinity of the petals with the organs of pollination. This transition is often a normal occurrence, e.g. in canna. A true petal, slightly modified, contracts in its upper margin and an anther appears in which the rest of the petal takes the place of a filament. In flowers which are often double, we can observe this transition in all its stages. There are several varieties of roses in which, inside the perfectly formed and colored petals, other petals can be seen which are contracted, sometimes in the center and sometimes at the aid. This contraction is caused by a small callosity which appears as a more or less complete anther. In some double poppies, fully formed anthers. Which is just what happens in the monstnages referred to on p. 315. 3 greater than 9 are borne on slightly modified petals of strongly double corollas. The organs designated nectaries * are gradual transitions between the petals and the stamens. Some of the petals carry little grooves or glands which secrete a honey-like sap which has not yet been perfected into a fertilizing fluid. At this point there is a complete absence of all the factors which caused expansion of the stem leaves, sepals, and petals, and a feeble, extremely simple filament develops. Those very vessels which would otherwise have grown longer and broader, and again sought each other out, are now present in an extremely contracted condition. Thus the pollen acts all the more powerfully outwards, on the pistil, which Goethe also traces back to the same type. In many cases the pistil almost resembles a stamen without anthers. In the light of the close affinity of the female part with the male, which this examination has made clearly evident, we see no objection to calling fertilization an immaterial Geistige, anastomosis, and we believe that we have, for a moment at least, brought closer together the concepts of growth and generation. We often find that the pistil has grown together out of several separate pistils. The pistil of the iris with its stigma, presents to our eyes the complete form of a petal. The umbelliform stigma of Saracema does not, indeed, reveal itself so strikingly as compounded of several leaves, but its green color does not belie the idea. A physiologist says of the anthers, in the formation of the anthers, the edges of the sepals curled inwards, so that at first a hollow cylinder was formed, at the top of which there was a tuft of fine hairs. These dropped off later as the anthers became more perfect and fuller. A similar transformation appeared in the style where one sepal, often several, curled inwards at the edge to form an arcuarentur. From this there developed first a simple cavity and later the ovary. The tuft of hairs seated at the top of the cavity did not wither as did those on the anthers but, on the contrary, grew into a perfect stigma. The fruit and the capsule can similarly be shown to be transformations of the leaf. We are speaking specifically of those seed vessels which nature forms to enclose the so-called covered seeds. In pinks the seed capsules are often changed back into calyx-like leaves. Indeed, there are pinks in which the seed vessel has changed into a genuine and perfected calyx. In these instances, the apical notches of the calyx bear delicate remains of the styles and stigmas, and, in place of seeds, a more or less perfect corolla is developed from the interior of this second calyx. Furthermore, in regular and constantly recurrent forms, nature herself has revealed to us, in very diverse ways, the fertility that is latent in a leaf. Thus a leaf of a lime tree modified, but still completely recognizable, will produce from its midrib a little stalk, and on it a perfect flower and fruit. The direct fertility of leaves is presented to us even more forcefully and, as it were, monstrously, in ferns, which develop and scatter. Thf. Autenrieth, De Durum Sexuali etc., pages 29 to 30. 320 Organics. Countless seeds capable of growth. In the seed vessels, we cannot fail to recognize the leaf shape. Thus the legume, for example, is a simple, folded leaf, the siliquas consist of several leaves superposed and fused. Nature obscures the similarity to the leaf most effectually when she forms soft and sappy or woody and tough seed containers. The relationship of the seed capsules to the preceding parts shows itself also in the stigma which, in many instances, is sessile and inseparably bound up with the seed vessel. We have already indicated the relationship of the stigma to the leaf form. It can be observed in various instances that the seed transforms leaves into its immediate integuments. In many winged seeds, of the maple, for example, we can detect traces of leaf forms which are imperfectly fitted to the seed. To avoid losing hold of the thread which we have once grasped, we have throughout considered the plant only as an annual, we have observed only the transformation of the leaves associated with the nodes and have derived all forms from them. But to give this essay the necessary completeness, we must now also speak of the buds. The bud needs no cotyledons, etc. Later, we shall come to speak of the impulses and processes of perennial plants. These are the main concepts of the Goethean metamorphosis of plants. Goethe has ingeniously represented the unity of the plant as a spiritual conductor Geistheitsleiter. But metamorphosis is only one side which does not exhaust the whole. We must also pay attention to the difference of the organs, with which difference the vital process proper first makes its appearance. We must therefore distinguish two things in the plant, this unity of its entire nature, the indifference to a change of form of its members and organs, the diversity of its development, the course of the vital process itself, an organization which is an elaboration up to the stage of sexual differentiation, even though this is only an indifferent and superfluous affair. The vital process of the plant is an independent process of the plant in each part, branches, twigs, leaf, each possesses an entire independent process, because each is also the whole individual. The plant's vital process is thus complete in each part, because the plant is particularized through and through without the process having already differentiated itself into a number of different processes. Consequently, the process of the plant as an immanent differentiation, appears both in its beginning and in its end product only as a development of shape. In this respect the plant stands midway between the crystal of the mineral sphere and the free, animal shape, for the animal organism has the oval, elliptical form, and the crystal the straight line form of the understanding. The shape of the plant is simple. The understanding is still dominant in the straight line of the stem, and altogether in the plant the straight line is still very preponderant. In the interior of the plant are cells, in part like those in a honeycomb, and in part elongated, and then fibers which, it is true, do intertwine in spirals but then spontaneously resume their linear form without developing inwardly into a rounded shape. In the leaf, surface predominates, the various forms of leaves, both of the plant and of the flower, are still very regular, and a mechanical uniformity is noticeable in their definite indentations and taperings. The leaves are dentate, jagged, pointed, lanceolate, scudiform, heart-shaped, but yet their regularity is no longer an abstract one. One side of the leaf is not the same as the other, one half is more contracted, the other more expanded and rounded. Finally, in the fruit the spherical shape is dominant, but the roundness is commensurable, not yet the higher form of the roundness of the animal structure. Numerical determinations, also characteristic of the understanding, still play a dominant part in plants, e.g. the number 3 or 6, in bulbs it is the latter. In the calyx of flowers the numbers 6, 3, and 4 are dominant, although the number 5 also occurs, in such a way, too, that if the flower has 5 filaments and anthers, there are also 5 or 10 petals, and the calyx then also has 5 or 10 sepals. Link says, strictly, only 5 leaves seem to constitute the complete whorl. If there are 6 or more, 2 or more whorls will certainly be noticed, one inside the other. 4 leaves in a whorl leave a gap for a fifth, 3 indicate a less perfect form, and 2 or even only 1, likewise leave gaps for 2 or a third. Like its shape, the plant's juices, too, stand midway between chemical and animal matter. The process itself, too, still hovers between the chemical and animal spheres. Plant products are add substances which, though no longer wholly chemical but already more indifferent, have not yet the indifference of animal matter. These products cannot be accounted for simply by oxygenation and hydrogenation, and this applies even more in the sphere of animal life, example in connection with respiration. Water which has become organic, pervaded by life and individualized, escapes from the domain of chemistry. The bond is spiritual. 34s The process which is vitality, although a unity, must no less explicate itself as a triad of processes. Zuzadit. In the process of the plant, which splits up into three syllogisms, the first, as already stated, is the universal process, the process of the vegetable organism within itself, the relation of the individual to itself in which the individual destroys itself, converts itself into its non-organic nature, and through the self-destruction comes forth into existence the process of formation. Secondly, the organism has its other, not within it, but outside of it, as a self-subsistent other. It is not itself its non-organic nature, but it finds this already confronting it as object, an object which it seems to encounter only contingently. That is the specialized process towards an external nature. The third is the process of the genus, the union of the first two, the process of the individuals with themselves as genus, the production and the preservation of the genus, the destruction of the individuals for the preservation of the genus as production of another individual. The non-organic nature is here the individual itself. Its nature, on the other hand, is its genus, but this too is also an other, its objective nature. In the plant, these processes are not so distinguished as they are in the animal, but coincide, and this precisely is the source of the difficulty in expounding the nature of the vegetable organism. The inner process of the plant's relation to itself is, in keeping with the simple nature of the vegetable organism itself, immediately a relation to an outer world, and an externalization. On the one side it is the substantial process, the immediate transformation, partly of the absorbed nutriment into the specific nature of the plant species, and partly of the internally transformed fluid into organs gebilde. On the other 9ide, as SEI mediation, the process begins with the simultaneous outward diremption into root and leaf, and the inner, abstract diremption of the general cellular tissue into woody fiber and vital vessels, the former likewise being related to the outer world, and the latter containing the plant's internal circulation. The preservation of the plant in this self-mediating process is growth as production of fresh formations, diremption into abstract self-reference, into the hardening of the wood and the other parts, and into the bark. The unification of self-preservation is not a union of the individual with itself but the production of a fresh plant individual, the bud. Zusatz. In the process of formation we begin with the germ of the organism, the immediate form of the latter. But this is only a posited immediacy, i.e. the germ is also a product. This determination, however, appears only in the third process. The process of formation ought to be only an interior process of the plant, as a production of the plant from within itself, but because in the plant world the plant produces itself by coming out of itself, what it produces is an other, the bud. This too, is directly involved with the process outwards. The first process, therefore, cannot be grasped without the second and third. The process of formation in its developed form, which would be the visceral process of the individual with itself, is lacking in the plant, just because it has no viscera, but only members with a relationship to the outer world. However, an essential side of the organic process generally is that it destroys, infects, and assimilates what comes to it from outside. Water, in being absorbed, is at once affected by the vital force of the organism, so that it is at once posited as a fluid pervaded by organic life. Does this take place immediately, or is there a sequence of transformations? The main thing in the plant is that this transformation takes place without mediation. But in more highly organized plants this process can also be traced as passing through many intermediate stages, as it does in the animal organism. Yet here, too, the direct transformation into lymph occurs without the intermediation of the organs. In plants, especially in the lower forms, there is no mediation through opposed sides, no coming together out of opposition, but nutrition is a transformation devoid of any process. Consequently, the inner physiological construction of the plant is also quite simple. Link and Rudolphi have shown that it consists only of simple cells and spiral vessels and tubes. The germ is the unexplicated being which is the entire notion, the nature of the plant which, however, is not yet idea because it is still without reality. In the grain of seed the plant appears as a simple, immediate unity of the self and the genus. Thus the seed, on account of the immediacy of its individuality, is an indifferent thing, it falls into the earth, which is for it the universal power. A good soil means simply that it is this unlocked, organic power or possibility, just as a good bead means no more than a possibility. The seed, as essentially power, through its being in the earth surmounts its existence as earth and actualizes itself. But this is not the opposition of an indifferent outer existence, like the opposition to its non-organic nature. On the contrary, putting the seed in the earth means that the seed is power. This hiding of the seed in the earth is therefore a mystical, magical act which signifies that in it there are secret forces which are still slumbering, that, in truth, the seed is something quite other than what it is as it lies there, just as the infant is not only this helpless human shape which gives no indication of reason, but is in itself the power of reason, something quite other than this creature which cannot speak or perform any rational action, and baptism is precisely this solemn recognition of fellowship in the realm of spirits. The magician who endows this seed, which I crush in my hand, with quite another significance, he for whom a rusty lamp is a mighty spirit, this magician is the notion of nature, the seed is the power which conjures the earth to serve it with its power. The development of the germ is at first mere growth, mere increase, it is already in itself the whole plant, the whole tree, etc., in miniature. The parts are already fully formed, receive only an enlargement, a formal repetition, a hardening, and so on. For what is to become? 3*3. Already is, or the becoming is this merely superficial movement. But it is no less also a qualitative articulation and shaping, and therefore an essential process. The germination of the seed first takes place through the agency of moisture. In perfect plants, the future stem can be distinctly seen in the future plant or embryo, and it forms the conical part which is usually called the radicle / the pointed part is lower down, and from this grows the future root. It is only rarely that the upper part is very elongated, this elongation is usually called a stalk. Sometimes, too, on this part there is an indication of a plumule. From the sides of the embryo there often grow the two seed lobes or cotyledons which later develop and represent the seed leaves. It is incorrect to regard the radicle as the future, actual root, it is only the stem growing downwards. If we carefully examine the larger plant seeds, e.g. of wheat, pumpkin, or beans, during germination, we shall see how from the seed the true roots emerge, much thinner and more delicate one. If the pointed part is turned up, it germinates, but grows in an arc and turns its tip downwards. The germ consists of the radicle and the plumule. From the former grows the root and from the latter the part of the plant above ground. If the seed is put in the ground upside down so that the radicle is turned towards the surface, it will never grow upwards. It grows longer, but into the ground and turns the seed over in order to come into its proper position. Asterisk on this subject, Willdenow has made the following discovery: the water chestnut has no radicle. These nuts put out a long plumule which grows in a perpendicular direction towards the surface of the water and puts out at wide intervals along its sides capillaceous, branching leaves. Some of these leaves bend over and take firm root in the ground. This shows that some seeds can dispense with a radicle, but a fertile seed without plumule and cotyledons is quite unthinkable. No one has ever yet presumed to deny the existence of a plumule in any seed whatever. It is noteworthy that in bulbiferous plants, the radicle is changed into the bulb, in some which have a middle stem *, the radicle is chaked into the stem, e.g. in cyclamens. Lastly, In some plants the radicle disappears soon after the seed has sprouted and the true root develops. The side 1 2 3 this direction of the one seed in two directions, towards the earth as the ground, the concrete universal, the universal individual, and towards the pure abstract ideal being, towards light, this can be called polarization. Between leaf and root, the first direction, is the stem, for fungi and the like do not come under this head. The stem, however, is not altogether essential, the leaf can grow directly from the root, and many plants are restricted to these two principal moments. This is the great difference between the monocotyledons and the dicotyledons. The first class includes bulbous plants, grasses, palms, the Hexandria and Tyandria of Linnaeus, who had not yet drawn attention to this difference and who ranged all plants in a single row. The question, namely, is whether the leaflet put out by the seed is double or single. In the monocotyledons, the root and leaf, which constitute the first antithesis, represent the primary, compact nature of the plant, a nature which does not advance to the opposition in which another, the stem, appears between root or bulb and leaf. True, palms have a stem, but this is formed solely by the attachment of the leaves to one another at their base. This can be seen quite easily from the outside. Palms have no branches except at the top of the trunk, and there are only twigs to support the blossom. It seems as if the excessive size of the leaves has absorbed the branches. This is precisely the case too with ferns. Even in our indigenous grasses and many bulbous plants, one rarely sees branches other than those bearing flowers. The antithesis of cells and woody fibers is possessed by them only interiorly in their substance, but they have no medullary rays. The leaf veins are not curved, or only slightly so, and in grasses they grow in straight lines. The monocotyledons not only lack a proper stem, they also do not produce a completed, flat leaf. They are always this enveloped bud which, though it opens, never completely develops. Consequently, they never produce fertile seed, their root and entire stem is pith. The stem is a continuation of the root, has neither buds nor branches, but continues to put out fresh roots which die off and axe bound together by woody fibers. The overwhelming power of light prevents the emulation of the plant into wood. The leaf does not die off but puts out new leaves. But just as in the palm the leaves seem to be trunk and branches, so also, conversely, there are varieties of stem where the stem remains one with the leaf, as, example in the cactus, where stem grows out of stem, the joints which are commonly regarded as leaves are parts of the stem. The leaves of this plant are subulate, fleshy tips which are often surrounded at their base with small prickles. They fall off directly after the development of the part *, and the place they occupied is indicated by a scar or a tuft of prickles. These plants remain fleshy leaf which withstands light, and, instead of wood, they produce only prickles. The general texture of the plant is formed by cellular tissue which, as in the animal organism, consists of small cells. It is the universal animal and vegetable product, the fibrous constituent moment. Each cell is separate from the others and has no community with them. In the bast, the cells assume an oval, pointed oval, or elongated form. The vesicles and elongated cells are differentiated in the basis itself of the plant. The regular cellular tissue is the parenchyma, the loose, spongy cellular tissue which consists of broad cells. It is very easily recognized and it occurs especially in the bark and pith of the trunk. The bast, the fibrous, tight, cellular tissue proper, is found principally in the stamens, in the pistil support and similar parts. It has very long, narrow, but still clearly distinguishable cells. It is only in the inner bark, in the wood, in the nerves of the leaves, that it is very difficult to recognize the structure of the bast or fibrous tissue. It consists of extremely slender and narrow cells which assume an elongated, pointed oval form. Irregular cellular tissue occurs in those plant species in which only a pericarp and the rest of the supporting body are distinguished externally. The lichens have either a crust-like or leaf-like thallus. The crust consists entirely of round vesicles or cells of widely varying sizes, irregularly heaped together. The algae are quite different from lichens. If the thallus is cut through its thickest part, there will be found very distinct but, as it were, jelly-like threads tangled in all directions. The basis of some algae is a membrane, often slimy, often jelly-like, but never soluble in water. The tissue of fungi consists of fibers which are readily recognized as cells. Between this fibrous tissue, grains lie scattered everywhere just as they are in lichens where they can be taken for gemmi. This concerned the outer form of the cellular tissue. Now how does this cellular tissue develop and alter? It is apparent that new cellular tissue is formed between the old cells. The grains in the cells might be the starch of the plant, whereas the first diremption was directly related to the process outwards, the root being in reciprocal relation with the earth and the leaf with air and light. The second, more intimate diremption is the plant's own separation of itself into woody fibers or active spiral vessels and into other vessels which Professor Schultz has called vital vessels. His well-founded experiments are in keeping with his philosophical grounding of the subject, even though one might disagree with him about the details of the latter. This separation of the plant in its inner structure, the production of spiral vessels, etc., this, too, is an immediate production, generally a mere multiplication. The medullary cells multiply, and with them also the spiral vessels, the woody fibers, etc. Link makes this particularly clear. The spiral vessels are bands which are rolled spirally to form a tube. The spiral vessels are transformed into stairways, the cunine of the spiral vessels growing together in pairs. The stairways cannot be uncoiled. Through the accretion of neighboring parts the spiral vessels become taut or compressed. This produces the wavy curves of the cross bands and the apparent splitting of the cross lines when two coils have been pushed one over the other. Perhaps, too, there are actual split B. The vessels which have such bands or points are the stippled vessels, which I hold to be similar in kind to the stairways. At Hist, there remain only the cross lines, and coils of the spiral vessels which have grown quite close to each other exhibit only dots instead of line 9, indentations and cross lines. The ring vessels arise from the rapid growth of the adjacent parts, the coils of the spiral vessels being torn apart and left standing singly. It is no wonder that in the rapidly growing roots and other parts where such spiral vessels in quantity must fulfill their functions, there are also to be found more old, modified vessels than in those parts where growth proceeds at a gentler pace. The spiral vessels are disseminated in almost every part of the plant and form its skeleton. The reticulated bunches of spiral vessels present in the leaves, after they have been freed from all the intervening cellular tissue, are actually called the leaf skeleton. It is only in the anthers and the pollen that one have never found spiral vessels. They are everywhere accompanied by bast, and the bundles of vessels mixed up with bast we call wood. The cellular tissue which surrounds the wood is called bark, and that which is completely surrounded by wood, pith. In many plants all these vessels are missing. They have never been found in plants with anomalous cellular tissue, in lichens, algae, and fungi. The genuine plants with regular cellular tissue either possess spiral vessels or do not. To the latter belong mosses and liverworts and a few aquatic plants like O'Hara. How the spiral vessels originate I do not know. Spreng says that since they are present in the form of cellular tissue, they must surely have developed from it. This does not seem to me to follow. My belief I9 that they are developed between the cells of the bast from the sap discharged there. Anyhow, the spiral vessels do grow, and new ones grow between them. Apart from these vessels which can be given the general name of spiral vessels, I have not observed any vessels in plants. But where are the vital vessels to be found? From what Link says in the Nachtrage, it could be inferred that the spiral vessels develop from the linear-shaped woody fibers. Find Ray 9 Elf compelled to accept again an old opinion, namely that in plants there exist simple, long fibers whether they are solid or hollow cannot easily be seen. The simple fiber without a trace of branches, by no means extends throughout the whole plant. Where branches enter the stem, it can be seen distinctly that their fibers adhere to those of the stem and form, as it were, a wedge in the stem. Even in the same stem and branches they do not seem to advance uninterruptedly. The fiber vessels always lie in bundles which are heaped together in the oldest stems together with the bast in the form of rings. Usually they surround a bundle of spiral vessels, although in some plants there are. F. Link, Grundlehren, pages 46-9, 51-8, 64-5. 1 Ibid, pages 65-8. Also simple fiber vessels without any trace of spiral vessels. These vessels lie in straight lines and are almost parallel in these bundles. In tree trunks and in roots they tend to diverge and are, as it were, interlaced. They are found in most plants and are general in the phanerogams. In many lichens and algae there can be seen only threads coiled together, and in fungi these can often be clearly seen. Yet there are fungi, lichens, and algae in which not a trace of them can be found but only vesicles and cells. Thus we see the original antithesis of grain or node and simple length in the antithesis of utricle and fiber, while the spiral vessels strive to attain to roundness. Oken expounds this transition of cellular tissue into spiral vessels on the lines of the principles outlined above, but he decks it out with the formalism of the philosophy of nature of his time as follows: the spiral vessels are the light system in the plant. I am well aware how much this doctrine conflicts with what has been accepted up till now, but I have collected all the facts, weighed opinions, and experiments, and can confidently state that they all corroborate this result of construction by philosophy of nature. This construction, however, is merely an assertion. If they are the light system, then their function in the plant is spiritual or the function of simple polarization. The empirical arises from the opposition between light and the cellular tissue, or from the opposition of the sun to the planet. A light ray travels through the utricle or the germ. The utricles or cells or the points of slime gradually arrange themselves side by side along this polar line. In the conflict between the sphere and the line introduced into it by light, the globules of slime, although placing themselves side by side in a line, get continually dragged down into the circle of chemism by the planetary process of the cellular tissue, and it is from this conflict that the spiral form arises. The part played by the sun's revolution, whereby at any moment another part of the plant is lit up and another is left in shadow, so that the parts become in turn stem and root, this is a topic I do not pretend to have done more than briefly touch on. The other side to this is finally the process itself, the activity in the first determination, universal life. This is the formal process of merely immediate transformation, this infection as the infinite power of life. The living creature is a being, stable and determined in and for itself. Anything from outside acting chemically on it is immediately transformed by this contact. The living creature, therefore, directly overcomes the presumptuous chemical action and in being brought into contact with another, preserves itself. It poisons, converts this other in an immediate manner, just as spirit, in envisaging something, transforms it and makes it into its own, for it is its picture. In the plant, this process is again to be grasped in its two aspects, as the action of the woody fibers, which is F. Oken, Lehrbuch der Naturphilosophie. Absorption, and ISS, as the action whereby the sap in the vital vessels acquires the vegetable nature. Absorption and the circulation of the sap with its vegetable organic nature are the essential moments of the notion, even though there might be variations in particular instances. Now the leaf is the principal seat of the action of the vital sap, but it absorbs, just as well as the root and the bark, since it already stands in a reciprocal relation with the air, for in the plant, each member does not have such a special function as is the case in the animal. One of the most important functions of leaves, as Link says, is to prepare the sap for other parts. The foliage is the pure process, and so, according to Linnaeus, the leaves can be called the lungs of the plant. About the functions of the vessels and the cellular tissue generally, Link remarks, uninjured roots do not absorb colored liquids, nor can these penetrate the colored cuticle oberot. The nutritive sap therefore at first passes through imperceptible openings in the cuticle and fills the cells at the tip of the roots before it is absorbed by the vessels. The saps pass through the various vessels, especially through the ducts in the cellular tissue which are not enclosed by any special skin, exude through the spiral vessels, etc. There is air in the spiral vessels and all the associated vessels. The sap which is in the fiber vessels exudes from them into the cells, spreads in all directions. The fiber vessels everywhere accompany the air vessels Lichtgefäß. The pores on the cuticle still seem to me to have the function of excretory glands. For oils, resin, and acids are secretions and waste products of plants. 1 Spix and Martius, 2, in their travels to Brazil speak of the gum produced between the bark and the wood of the tree Hymenia curbaril L, which over there is called jatoba or jata'i. By far the greatest part of the resin appears under the tap roots of the tree when the earth is cleared away from them, and this, as a rule, can only be done after the tree has been felled. Under old trees, pale yellow round cakes, weighing 6 to 8 pounds, are sometimes found, which have been gradually formed by the oozing of the liquid resin. This formation of resinous masses between the roots seems to throw some light on the origin of amber, which had been accumulated in this way before it was taken from the sea. Insects, too, especially ants, are found in bits of jata'i resin as they are in amber. Now if the spiral vessels carry out the first function, namely, to absorb moisture just as it is, the second function is the elaboration of the sap into an organic form. This elaboration, in keeping with the nature of the plant, takes place in an immediate manner. The plant has no stomach, etc., as the animal has. This sap circulates through the entire plant. This quivering of vitality within itself belongs to the plant because it is alive restless time. That is the blood circulation in plants. As early as 1774, the Abbé Cordouin had observed a kind of circulation of the sap in the Conferva Charolin. Amici I observed it afresh in I8R8 and with the aid of the microscope made the following discoveries: in every part of this plant, not only in the finest green threads of the stem and branches, but equally in the most delicate root fibers, there can be seen a regular circulation of the sap. There is an uninterrupted circulation of white, transparent globules varying in size, in a constant, regular flow, the velocity gradually increasing from the center to the lateral partitions. They circulate in two currents flowing alternately in opposite directions, one up and the other down, and through the two halves of a simple, cylindrical canal or vessel without any partition. This canal runs lengthwise through the plant fiber, but is interrupted at intervals by nodes, and is closed by a partition which bounds the circulation. Often, too, the circulation is spiral. Thus the circulation goes through the entire plant and in all its fibers from one node to another, and in each such bounded section is a separate process, independent of the others. In the root fibers, only one such simple circulation occurs, for only one such central vessel can be seen, but in the green filaments of the plant the vessel is multiple, for the large central vessel is surrounded by several small similar vessels, each of which is separated from it by a partition. If such a vessel is loosely tied underneath, or bent at a sharp angle, the circulation is interrupted as if by a natural node, and then continues to circulate above and below the ligature or bend, through the whole section as before. If the vessel is restored to its former state, the original circulation is also restored. If we make a cross-section of such a vessel, its sap does not immediately and entirely flow away, but only the sap from one of the two halves, that sap namely which is flowing towards the section, while the other sap continues its circulatory course. 1 Professor Schultz has observed this flow in some developed plants, e.g. in Ckeutmrum majus, which has a yellow sap, and also in Euphorbia. The description which Schultz gives of this is simply the activity of the notion. What has been intuitively apprehended in thought is represented outwardly. The flow is a movement from the center to the partitions, and from the partitions to the center again, and, together with this horizontal flow, there is the flow upwards and downwards. The process in relation to the partitions is such that these, too, are not fixed, but everything is produced from them. The flow is perceptible through the tendency to form a globule which is always dissolved again. If the plant is cut in two, and the sap is allowed to run into water, then globules are like blood corpuscles of animals. This flow is so slight that it cannot be perceived in every species. In the plants investigated by Professor Schultz, the flow was not through a single tube as in the chara, but there are two vessels for the ascending and descending movements. Research would be necessary to find out whether the circulation is interrupted or not in trees which have been grafted. Now it is through the circulation which traverses the entire plant that the many individuals which form a plant are combined into a single individual. Schultz now describes this double process as follows. First, the wood sap is the still imperfectly assimilated food of the plant which will not be more highly organized and carried over into the circulatory system until later. The wood is the system for assimilating air and water. This assimilation is a vital activity. The wood, which consists of cellular tissues and spiral vessels, absorbs water through the woody fibers of the roots, and above ground absorbs air. The papillae, clearly visible at the tips of many roots, have the function of absorbing the nutritive sap, and then the spiral vessels receive it from them in order to carry it further. Capillaries and their law of capillary action are not adequate explanations in connection with plants. The plant wants water, is thirsty and so absorbs it. The other point is the quite original and very important discovery by Schultz, the movement of a sap which is now assimilated, although it cannot be demonstrated in every plant because the movement is difficult to observe. The wood sap still has only a slight taste, is only slightly sweet, and is not yet elaborated into the peculiar character of the plant which has a particular smell, taste, etc. Schultz now says of this vital sap, the circulation in plants which goes on during the whole of winter is the movement of a fully organized sap, a movement which takes place in a closed system in every external part of the plant, in the root, stem, flowers, leaves and fruits. Similarly, all these parts have their assimilative function which, however, is always in polar opposition to the circulation, and in which the movement of the wood sap is quite different from the movement in the circulatory system. Also, the passage of wood sap into vital sap takes place only in the extremities of the external parts of the plant, and particularly in those parts where leaves are present, in the leaves themselves and also in the flowers and the parts of the fruit. On the other hand, wood sap does not pass directly from any bundle of wood fibers into the vital vessels. The passage of wood sap into the bark is by way of the leaves. That is why the bark, which has no direct connection with buds or leaves, does. On this subject, Link cites the following experiment. Meyer isolated portions of bark by cutting. Link, Grunge-Urin, p. 76. 33 *. Away strips of bark round them, and he noticed that those portions on which there were a bud, etc., survived, but those which had none soon withered. I have repeated these experiments on apricot trees and confirmed them. A piece of bark without buds and leaves, isolated in this way, soon withered and dried up, nor did it exude any gum. Another piece, isolated, with 3 off buds and leaves, dried up more slowly, and also exuded no gum. A third piece, with 3 undamaged buds and leaves, did not dry up, remained green all over, and from its lower portion exuded gum. On a piece of detached bark, a layer of parenchyma is first formed, a fresh pith, as it were. This was followed by a layer of bast with individual spiral vessels and stairways, and all was covered by the new bark from the parenchyma, which therefore is produced first and also forms the basis of the young stem and the embryo. There was formed in some measure a new pith, new wood, and new bark. Thirdly, the plant's vital sap becomes a product. With the breaking out of the leaf, the bark is easily separated from the wood in every part of the plant, and this is a result of a delicate, soft substance found between them, i.e. cambium, which only comes into being with the leaf. The vital sap, on the other hand, is not between the bark and wood but in the bark. This third sap is the neutral substance. The cambium does not move and has a periodic existence in the plant. Cambium is the residuum of the entire individual life. It is not a fluid like the other plant juices, but the delicate embryonic shape of the whole, already formed plant totality, the unexplicate totality, like a woodless plant. Now the cambium is formed from Tb vital sap of the bark by the circulation, and from this also comes the wood and the layer of bark. The cellular tissue, too, is developed from the undifferentiated cambium. As, therefore, in the vascular system of the circulation, we have the antithesis of vital vessels and vital sap, in the assimilative system the antithesis of spiral vessels and wood sap, so in the cellular tissue there appears the antithesis of the cell and its fluid content. With the lengthening of the roots and branches, the new embryonic formations are deposited on their tips, those which come from the homogeneous substance going upwards, and those from the cambium going to the side, although there is no essential difference between them. In ferns, grasses, and palms one node forms on top of another. In bulbous plants the nodes are formed side by side, and from one side of them grow the roots, and on the other side the buds. In the higher plants, this external nodulation is no longer so evident, but instead there is seen the formation of wood and bark at the tips of the nodes. Now, summarizing TB foregoing, we have to distinguish the following three moments in the interior formative process of the plant: the diremption into root and leaf, as itself a relation outwards, is the interior nutritive process, the wood sap, the relation to its interior, the pure, immanent process, is the vital sap, the general product is the cambium of the botanists, the dead secretion into etheric oils and salts, the internal diremption of the plant into wood and cortical substance. Then secondly, we have the formation of nodes as a generic multiplication of the plant, and lastly, the bud, which hints at the process of sexual difference. 2. The sap, which has been endowed with a vegetable nature, and its product, the division of what was previously undifferentiated into bark and wood, can be compared to the diremption of the individual which takes place in the universal life process of the earth, namely, into the vital activity as such, which lies in the past and outside it, and into the system of organic formations as the material substrate and residue of the process. The plant, like the animal, perpetually destroys itself, in that it sets up an opposition between itself and being. In the plant it is the formation of wood, and in the animal it is the skeletal system. The latter is the subporter of the animal organism, but, as abstract, immobile being, is the excrete, calcareous moment. The plant, too, posits within itself its inorganic basis, its skeleton. The unreleased power, the pure self, which simply, on account of its immediate unitary nature, sinks back into the inorganic sphere, is the woody fiber. Looked at chemically it is carbon, the abstract subject which, in the root, remains in the earth as pure wood without bark and pith. Wood is combustibility as potentiality of fire without itself being heat, for this reason it often develops a sulfurous nature. In some roots fully formed sulfur is produced in the root, surface and line are so crumpled and effaced, so knotted, that the former dimension is suppressed, and is a solid continuity, which is on the point of being wholly inorganic and without any distinction of shape. Oken considers the woody fibers to be nerve threads. The spiral vessels are for the plant what nerves are for the animal, but the woody fibers are not nerves but bones. The plant only gets as far as the simplification as abstract reference to self. This reflection into self is a dead substance because it is only abstract universality. The process of wood formation in its further details is very simple. Link describes it in his Grundlehren as follows: T and the monocotyledons, the inner structure of the stem differs considerably from that in the dicotyledons. In the former, the woody rings which separate the pith from the bark are absent, the woody bundles are dispersed in the cellular tissue in larger quantities towards the bark, and in smaller quantities towards the center. In the dicotyledons, all the woody bundles are disposed in a circle, although, since nature nowhere draws precise boundaries, such scattered bundles are found in Cucurbitaceae and a few other plants. Usually bast accompanies the cellular tissue, but there are some cases where bundles of very narrow, elongated cellular tissue or bast occur in the stem fairly remote from the vascular bundles. Thus some Labiati have such bundles of bast in the forecomers of the stem, and many umbelliferae in the projecting edges. Now the growth of the stem and the formation of layers of wood in the monocotyledons takes place in a simple, ordinary manner. Not only do the parts become longer and wider, but new parts appear between the old cells between cells, vessels between vessels. The cross-section of an older stem resembles that of a younger stem in every part. In the arborescent grasses the parts harden in an extraordinary way. In many grasses, remarks Wildenau, silica has been found, in bamboo cane, etc., it also forms an ingredient of plant fiber, e.g. in hemp and flax. It also seems to be present in the wood of Alnus glutinosa and Beachella alba, for when this wood is turned on the lathe it often emits sparks. Link continues, things are quite different in the dicotyledons. In the first year, the woody bundles form a circle, separated from each other, and surrounded by parenchyma. At this earliest age, they contain only bast and a bundle of spiral vessels inside. It is mainly the bast which adnass and inserts itself between the parenchyma *, thus giving rise to alternate layers of fibers and parenchyma. Woody bundles spread laterally, compress the parenchyma and finally form a closed ring which envelopes the pith. Now the bast of this woody bundle is alternately dense and loose. It is probable, therefore, that new bast has inserted itself between the old. Inside the woody ring, and against the pith, there are still individual woody bundles disposed in a circle. The medullary rays originate in the alternate layers of bast as well as in the compressed parenchyma *. They are, therefore, prolongations of the pith, and they grow outwards towards the bark, are found between the elongated fibers, and are not present in the monocotyledons. It is the woody ring which first separates the pith from the bark. Later the woody bundles spread inwards, the woody ring grows wider. Rows of scalariform tissues are seen radiating towards the pith. On the inner side of the ring round the pith there is a circle of separated bundles of spiral vessels. But the medullary cells have become, not smaller, but larger, although the amount of pith in relation to the thickness of the stem has diminished. The amount of pith has therefore decreased, the outer part being diminished and compressed laterally into rays, but this reduction is not the result of the pith being compressed into a smaller space at the center. Consequently the first bundles of spiral vessels are not pushed inwards by the adnate wood, on the contrary, fresh bundles are continually being formed in the pith, and those already existing have spread themselves laterally and compressed the parenchyma. The scalariform tissues were formed from the spiral vessels, and as the spiral vessels are, in the first instance, slightly separated from each other, so now the scalariform vessels too, lie in rows running inwards. It is evident from all this that the woody 335 layer is formed by scattered bundles of spiral vessels and bast meeting and joining together at the sides, and also by the constant growth, in a circle on the inside, of fresh bundles of spiral vessels, which likewise join together at the sides. In each of the following years a fresh layer of wood is inserted between the bark and the wood. As in the first year, layers grow onto the woody bundles, thus enlarging them, and so it is extremely probable that in successive years a similar fresh layer of wood attaches itself round the wood. Similarly fresh layers of parenchyma are deposited in the outer bark, and freer layers of bast in the inner bark. But the precise, uninterrupted passage of one layer into the other shows that the new growth also takes place in the interstices of the vessels and of the cellular tissue of the older layer, in the pith, too, until it is completely filled out. Everywhere fresh parts are interpolated, but only on the outside in amounts large enough to make the increase easily perceptible. In the growth itself, there is no difference between the layers, everywhere the wood grows uniformly and uninterruptedly, and there is no difference whatever except in the denseness or looseness of the layers. The older layers, however, do not retain their thickness, but get continually thinner, and finally so thin that they can hardly be distinguished and counted any longer. There takes place, therefore, a genuine contraction which narrows the bast cells. In the interior of the wood, growth finally ceases when all the pith is exhausted. Right. From May to June, I examined almost daily branches of the previous year, and for a long time found no trace of a second-year ring. Then suddenly it appeared, and when it did it was already a respectable size. It seems to me, therefore, that the annual ring was made by a sudden contraction of the wood, this contraction must occur about or after St. John's Day, and has no connection with the annual growth of wood. If what takes place is only the accretion of a fresh ring round the outermost layer, then one could not fail to notice the annual ring of the previous year in the spring and autumn or ft. Therefore even the development of the annual ring in the plant is always a fresh production, not, as in the animal, a simple conservation. 3. With this production is also bound up the taking back of the individuality into itself, and this is the production of the bud. It is a fresh plant on the old one, or, at any rate, the simple return of the old plant into the tendency to become a new one. Each bud unfolds a stem with leaves, and at the base of each petiole is a fresh bud. That is the way in which growth in general takes place. The development from bud to bud would, however, continue unchecked, were it not that each bud, as soon as it has produced blossom, die after the blossom and fruit have completed their development. The opening of the flower and of the fruit which follows it constitutes the insurmountable barrier to the growth of the branches. The blossom is thus an annual plant. Point 2. With this, the process of the plant is closed, the plant preserves itself by the reproduction of itself, which is at the same time the production of another plant. The process is thus mediated by the moments indicated. It is still the formal process with regard to production, as a simple bursting forth of what was enveloped in the initial main impulse of the plant. 2. The process of formation is directly connected with the second process, the self-specifying process of the plant outwards. The seed germinates only when stimulated from outside, and, in the process of formation, the diremption into root and leaf is itself a diremption into the direction of earth and water and that of light and air, into the absorption of water and its assimilation through the intermediation of leaf and bark and of light and air. The return into self in which assimilation terminates, does not have for result the self as inner, subjective universality over against externality, does not result in self-feeling. Rather is the plant drawn out of itself by light, by itself which is external to it, and climbs towards it, ramifying into a plurality of individuals. Inwardly, the plant draws from light its specific energy and vigor, the immaterial quality of scent and of flavor, the splendor and depth of color, and the compactness and robustness of shape. Zusatz. The coincidence of the process outwards with the first process, being such that the process of root and leaf in their vital existence exists only as a process outwards, the only distinction between the two processes is partly that this outward turned side must become more definitely marked, but also and principally that the return to self as the becoming of the self-feeling, the satisfaction of the self from the overcoming of inorganic nature has here the peculiar form of being also a development outwards. The self present in the shape enters into the process outwards in order, through this self-mediation, to come to itself, to bring the self before the self. But the self does not authenticate itself. In the plant, this self-satisfaction does not become a union with self, but a fashioning of itself into a light plant. This takes the place. Wildenau, Grundriss Kräuterkunde, pages 402-3. 9. Goethe, Zoomorphology, p. 54. 337. Of the senses. In its existence, in its shape, the self is reflected into itself. This means here, that its existence, its shape, is, in all its parts, a complete individual, is itself something that simply is, but, in its existence, it is not itself a universal individual, in which it would be the unity of itself and of the universal, but the other individual to which it stands in relation is only a part of the whole, and is itself a plant. The self does not become object of the self, of its own self. On the contrary, the second self with which the plant, in conformity with its notion, must enter into relation, is outside of it. Though self does not become for the plant, but the plant becomes a self to itself only in light, its lighting up, its becoming light, does not mean that the plant itself becomes light, but that it is only in light that it is produced. Consequently the self-like character of light as an objective presence does not develop into vision, the sense of sight remains merely light, color, in the plant, not the light which has been reborn in the midnight of sleep, in the darkness of the pure ego, not this spiritualized light as existent negativity. This closed circle of the outward turned process is annual, even though in other respects the plant, as a tree, is perennial, and the same is true, not only of the opening of the flower bud, but also of all the parts and organs which are involved in the rest of the process, the roots and leaves. The leaves fall in northern climates, says W.I. Yudenau, in the autumn, but in others they live several years. But whereas W.I. Yudenau attributes the shedding of leaves to the stoppage of sap, Link postulates an opposite cause. The shedding of leaves seems to be preceded rather by a superabundance of sap than by a lack of it. This shedding was furthered by complete wringing of the bark, which prevented the return flow of the sap in the bark. It now seems to me that the primary cause of leaf shedding is a weakening of the bark, partly by the growth of the trunk and partly by cold. The roots too die off and fresh ones grow, the plant root is constantly changing. Fibers and hairs are perpetually dying and being replaced by others. The quantity of fibers and hairs which grow out of the root are enticed out by moisture, and they spread in all directions, and in this way the root is drawn away into moist surroundings. The roots also exude moisture, and this probably accounts for the sand clinging to them. The older roots, it seems, soon become useless, perhaps because of the excessive dislocation of the spiral vessels, and so they manure and corrupt the soil. The main root seldom lasts more than a few years, it dies after it has put out branches and stems with new roots. In trees, the trunk grows into the earth and finally takes the place of the root. For it is not only the root which tends to grow downwards, this tendency is by no means absent in the stem, too. A few days after germination it can be found to have penetrated already well into the ground. External nature with which the plant stands in relationship is not nature as individualized, but the elements. The plant enters into relation with light, air, water. While the process of the plant involved with the elements of air and water is general, the relation with light is displayed particularly in the opening of the flower bud, but this, as production of a fresh shape, also belongs to the first process, and, as indicating sexual difference, to the third process too, thus demonstrating how the different processes of the plant interpenetrate and are only superficially distinct. It is in light that all the plant's energies develop, and it acquires scent and color. It is light that endows the plant with these qualities, and also holds it upright. In light, the leaves grow green, but there are also green parts of the plant which lie completely hidden from the light, e.g. the inner bark. Young leaves raised in the dark are white, but when they are larger and stronger they take on a greenish color in the same darkness. But flowers become more beautifully colored in the light, and there is an increase of aromatic oils and resins. In the dark, color, scent and vigor all diminish. In hothouses, plants throw out long shoots. These, however, are feeble, without color and scent, so long as they are deprived of light. The bark and leaf, which are the self of the process, are still unsapatated, and for that very reason are green. With the neutrality of water, this synthesis of blue and yellow is broken up and split into blue and yellow, the yellow later turning to red. Horticulture consists in MFLTRMG. Flowers grow in all these colors and their combinations. In this relation of the plant to itself which is outside of it, the plant does not behave chemically, but appropriates the self and possesses it inwardly, as is the case in vision. In light, and in the relationship with it, the plant is for itself, and the plant constitutes itself an independent being in face of this absolute power of light over it, in face of light's very own identity. Just as a human being in his relationship to the state, which is his ethical, substantial nature, his essence and the absolute power over him, becomes in this very identity independent and for himself, a mature and substantial being, so too does the plant in its relation with light give itself its particularity, its specific and robust quality. These aromatic plants grow especially in southern latitudes. One of the Spice Islands spreads its scent many miles out to sea and has a magnificent display of flowers. 2. The specifying of air within the plant in the air process is manifested by the plant giving out the air again as a specific gas, for, in appropriating the elemental matter, it differentiates it. This process comes closest to being chemical. Plants exhale, they convert air into water, and, conversely, water into air. This process is a breathing in and a breathing out. During the day, the plant breathes out oxygen, and at night, carbon dioxide. This process is obscure because of the sealed reticence of the plant. If intussusception is understood as a taking up of parts already formed, only the heterogeneous element being separated from them, this amounts to saying that the plant draws in carbon dioxide from the air, and leaves the rest, the oxygen, etc., outside. This supposedly philosophical way of looking at the matter is based on experiments in which plants under water and exposed to light give off oxygen, as if this were not just as much a process with the water, as if plants do not also decompose the air and take in oxygen. But the process does not get as far as a chemical existence. If it did, organic life would be destroyed. In the transformation of air into water, it is useless to look for a chemical explanation of the passage of nitrogen into hydrogen, for these substances are immutable from that standpoint. The transformation is brought about by oxygen, which is the negative self. However, the process does not stop here, it returns into carbon, the solid element, and conversely, the plant equally resolves this punctiform element by the opposite path into air and water. The plant maintains the moisture in the atmosphere and equally absorbs water from it. Everything negative is equally positive. But in the plant itself, this process is its formation, which contains three moments. The plant becomes a solid self, a woody substance, a water-filled, neutral existence, an aeriform, purely ideal process. Link gives the following account of this process of the plant with the air. I found that oxygen is indispensable to the life of the plant, but that the plant does not grow in it at all. On the other hand, carbon dioxide mixed in the ratio of I:12 with oxygen promotes an excellent growth of the plant in the light. Carbon dioxide is decomposed and oxygen is liberated. In the dark, carbon dioxide is harmful. According to Saussure's experiments, plants absorb oxygen, convert it into carbon dioxide, and, after decomposing it, breathe out oxygen. Parts which are not green do not absorb oxygen, they convert it straightway into carbon dioxide. The extract of fertile soil serves as nourishment for plants. Oxygen takes the carbon from it to form carbon dioxide. Soil taken from far below the surface is no good for feeding plants, but it becomes so after long exposure to dry air. A shower of rain then puts everything right. Saussure observed that bare root 9, which withered when they were exposed to respirable gases, and their tips were dipped in water, lived on in oxygen. This they converted into carbon dioxide, but, if the stalk were still attached, they absorbed carbon dioxide and developed oxygen from the leaves. The process with the air, therefore, must certainly not be represented as an appropriation by the plant of something already formed which it increases only mechanically. Such a mechanical representation is altogether to be rejected. What occurs is a complete transformation, an operation accomplished by the majesty of the Irving organism, for organic life is just this power over the inorganic to transform it. 1 Link, Nachtrage, Volume I, pages 62-3, Grundlehren, pages 284-5. 339. Besides, where else is the potash supposed to come from which is so often found particularly in unripe plants? In grapes, for example. 1 The organs of this process of the plant with the air are described by W.I. Udenau as follows. The apertures are seen on the cuticle of plants. They are extraordinarily delicate, oblong fissures which open and shut. As a rule they are opened during the morning and closed in the heat of the midday sun. They are found in every part of the plant which is exposed to the air and has a green color, and are more abundant on the underside of leaves than on the upper side. They are lacking on the leaves of aquatic plants below the surface of the water, and on the surface of leaves which float on the water. They are missing in water algae, mosses, lichens, fungi and cognate plants. But there is no canal running inwards from this pore, and therefore no tubes to be found connected with it. The pore culminates, without any further mechanism, in the closed cell. 3. Next to the air process, the water process is of cardinal importance, for it is moisture which first makes the plant fertile. There is in the plant no independent impulse to germinate, and without water the seed remains inanimate. There lies the grain of seed perhaps for countless years without any vital impulse, inert and locked up within itself. Its awakening is for it a lucky chance, without which it would remain still longer in its indifference or finally perish. To liberate this growth from earthy influences, and to grow from the food which it has itself grown, this is the urge of the sprouting stem. To liberate the growth from the plant's own food resources, from the accident of what is already a growth, and to achieve its own measure, the circumscribed form over against the abundance of earthy influences, this is the life of the leaf. 2 Most plants do not require soil for their nourishment, they can be planted in powdered glass or in pebbles which remain unaffected by them, i.e. the plants cannot draw any nourishment from them. The plant gets on just as well with water, although, if possible, it should contain an oily substance. Helmont was the first to find that a tree in a pot filled with earth increased its weight by much more than the loss in weight of the earth, and he concluded from this that water is the proper food of plants. Duhamel grew an oak tree in water alone, and it continued to grow for 8 years. Schrader, in particular, has carried out accurate experiments on the growth of plants in flowers of sulfur sprinkled with pure water, but the plants do not bear ripe seeds. It is no wonder that plants raised, not in their proper soil, but either in water alone, or sand, or sulfur, do not come to perfection. A plant from chalky soil never thrives in sand, and conversely, sand plants put into rich soil as a rule do not bear ripe seeds. It may well be that salts really act as manure and not merely as stimulants to growth, but in larger amounts they are harmful. The insoluble basis of the soil is not a matter of indifference as regards plant growth, nor is its action to be measured merely by its capacity to hold water or let it pass through. Sulfur accelerates the germination of seeds in the air, so too does lead monoxide, and without any trace of deoxidation. When moisture begins to fail, plants often feed on themselves, as is shown by bulbs laid out to dry, which grow leaves and flowers, but, in doing so, use up the entire bulb. 12 The process outwards is introduced, on the one hand, through the root, and on the other, through the leaf. It is the digestive life of the plant drawn outwards, and indeed, in Caledomium and other plants, the circulation extends from the root to the leaf. The product of this process is the formation of nodes in the plant itself. This development and movement outwards of the plant, which results in this product, can be expressed as a ripening of the plant internally. But in doing so, the plant also arrests this movement outwards, and this is precise like plant's reproduction of itself in buds. Whereas the first impulse is the purely formal increase of what is already in existence, a mere continued sprouting, the flower bud is at once an arrest and retraction of the movement outwards, of growth as such, and that, too, as soon as inflorescence takes place. With us, every shrub or tree makes 2 growths annually. 1. The main growth occurs in spring. It is formed by the quantity of sap which the root has absorbed during the winter. With us, it is not until about St. Sebastian's Day, January 20th, that we find sap in trees when they are tapped. If mild days follow, the sap does not flow, but only when there is another spell of cold weather. From late autumn to the middle of January the sap does not flow at all. Nor will it flow again later when the leaves have come out, therefore it flows only once when the root begins to be active in January, and then for as long as the leaves are still active in feeding the bark. The second impulse is not so strong, and occurs near the longest day, i.e. St. John's Day. That is why it is also called St. John's sap. It is produced by the moisture absorbed in spring. In warm latitudes, both growths are equally strong, with the consequence that plants there grow more luxuriantly. 3 In those latitudes, therefore, there are 2 different impulses, but in subtropical plants, growth and suspended growth occur at the same time, whereas with us when one impulse is present the other is not. Since the reproduction of the living organism is exhibited as the repetition of the whole, the formation of fresh buds is also accompanied by the formation of a fresh annual ring, or a fresh diremption within the plant, for as next year's buds form about St. John's Day, so too docks the new wood, as we have already seen above. Now as the fruitfulness of trees is increased generally by arresting the growth outwards, so it is also increased particularly, by grafting, simply because the foreign branch remains more apart from the life of the entire plant, which just consists in the growth outwards. The tree therefore bears more fruit because, as independent, it is relieved from simply sprouting, and in its own peculiar life can devote itself more to fruit-bearing, also cultivated fruit of finer quality because, as Schelver says, the root of the wild stock which serves the cultivated plant is always presupposed, and the organ which is grafted is also already presupposed by the cultivated plant. Wringing the bark of olive trees also arrests growth and makes the tree fruitful. Root growth is also promoted by wringing. In general, however, the character of this process is not an endless growth outwards, but rather the plant takes hold of itself, returns into itself. The blossom itself is just this moment of return, of being for self, although the plant can never really develop into a self. The flower is this node, not the bud which merely grows, but as this nodulation which arrests growth, it is the assemblage of leaves which are more delicately developed. From the punctiform basis of the cellular tissue or from the first seed, through the linear form of the woody fiber and the surface of the leaf, the plant has achieved in the sower and fruit the fully rounded shape. The plurality of leaves is concentrated again into one point. As the shape which has been raised into light, into the self, it is the flower above all which possesses color, already in the calyx and still more in the flower. The merely neutral green takes on color. Also the flower does not smell only when it is bruised, like the leaves of trees, but it gives out a scent. Finally, in the blossom, there occurs the differentiation into organs which have been compared to the genitals of the animal, and these are an image of the self generated in the plant itself, which brings itself into relationship with the self. The flower is the plant life which has clothed itself, which forms a garland round the seed as an inner product, whereas previously its activity was directed only outwards. The plant also brings forth its light as its own self in the blossom, in which the neutral color green is then further specified. The genus process, the relation of the individual self to the self, as a return into itself, arrests the growth of the plant as an unrestrained. 343. Sprouting from bud to bud. But the plant does not attain to a relationship between individuals as such but only to a difference, whose sides are not at the same time in themselves whole individuals, do not determine the whole individuality, therefore the difference, too, does not go beyond a beginning and an adumbration of the genus process. The germ is to be regarded here as one and the same individual, whose life runs through this process, and through return into itself has not only advanced to the maturity of a seed, but equally has preserved itself. But this process is, on the whole, superfluous since the process of formation and assimilation is itself already reproduction as production of fresh individuals. Zusatz. The final act of the plant is the opening of the blossom whereby the plant makes itself objective, assimilates light, and produces this external element as its own. That is why Oken says that the flower is the brain of the plant. Others, however, from the same school opine that the plant has its brain, the root, in the ground, but its sexual organs turn towards the sky. The flower is the plant's highest subjectivity, the contraction of the whole as in the individual, its opposition within itself and to itself but at the same time to itself as an externality, for this development of inflorescence is itself in turn a succession, stem flowers earlier than the branches, the main branch earlier than the side branches, and so on. On one and the same branch, flowering is earlier on the lower part than on the upper part. But furthermore, since the plant, in producing other individuals, at the same time preserves itself, the significance of this fruitfulness is not merely that the plant, by its constant budding, transcends itself, but rather that the cessation of growth, the arrest of this sprouting, is the condition for that fruitfulness. Now if this negation of the plant's coming out of itself is to attain existence in the plant, this means nothing more than that the self-subsistent individuality of the plant, the substantial form which constitutes its notion and exists for itself throughout the whole plant, the idea matrix of the plant, becomes isolated as a separate existence. True, the outcome of this isolation is only the production of a fresh individual, but this, just because it arrests reproduction, is only a differentiation within itself, and that is what takes place in the plant if we consider the fate of the sexual parts. It is of no use here, as in the generative process generally, to investigate what is in the unfertilized seed and what is added to it by fertilization. The process eludes the crude methods of chemistry, which destroys the living organism and deals only with inanimate matter, not living substance. The fertilization of the plant consists solely in this, that the plant endows its moments with an abstract existence in which they exist separately, and posits them as a unity again through contact. This movement, as a movement between abstract, differentiated, activated, but existent moments, is the plant's actualization of these abstractions, a process which it displays within itself. Since Linnaeus, this display has been regarded generally as a sexual process, but it could be this only if the moments of the process were not merely parts of the plant by whole plants. It is therefore notoriously a moot point among botanists whether there is actually in plants, as in animals, first, sexual difference, and secondly, impregnation. The first question we must answer, the difference reached by the plant, which is a difference of one plant self from another plant self, each of which has the urge to identify itself with the other. This determination exists only as an analog of the sexual relationship. For the aids of the relation are not two individuals. There are only a few plants where the difference of sex occurs in such a manner that the separate sexes are distributed in two separate and distinct plants. These are the Dioidae, of which the most important are palms, hemp, hops, etc. The Dioida thus provide the chief proof of impregnation. In the Monoeciea, however, such as melons, pumpkins, hazels, firs, oaks, the male and female flowers are found on the same plant, i.e. such plants are hermaphrodites. To this class belong also the Polygamiae, plants which bear flowers, some of which are hermaphroditic and some not. 1 But these differences are often very changeable while plants are growing. In dioecious plants like hemp, Mercurialis, etc., a plant will show, for example, an early disposition to be female and yet subsequently become male, thus the difference is only a quite partial one. The different individuals cannot therefore be regarded as of different sexes because they have not been completely imbued with the principle of their opposition, because this does not completely pervade them, is not a viversal moment of the entire individual, but is a separated part of it, and the two enter into relation with each other only in respect of this part. The sexual relationship proper must have for its opposed moments entire individuals whose determinateness, completely reflected into itself, spreads through the whole individual. The entire habit of the individual must be bound up with its sex. Only when the inner, generative forces have reached complete penetration and saturation, does the individual possess the sexual impulse, only then is it awakened. That which in the animal is sexual right from the beginning, which merely develops itself, becomes a force, an impulse, but is not the formative principle of its organa. That in the plant is an external product. The plant therefore is asexual, even the Diocaryria, because the sexual parts form a closed, particular circle apart from their individuality. On the one side, we have filaments and anthers as male sexual parts, and on the other, seed bud and pistil as female sexual parts, which link the cribs as follows: 1. Have never found vessels in the anthers. These consist for the most part of large, round, and angular cells. These are longer and narrower only where nerves are to be seen. The pollen is found in the anther, mostly loose in tiny globules. Only rarely is it fixed to a fine thread. In some plants it is resinous, in others, of an animal substance, phosphate of lime and phosphate of magnesia. The anthers of moss have in their outer form, in the regular arrangement of leaves round them, a great similarity to stamens. The vascular fascicles never run from the peduncle, or the middle of the seed bud, straight into the pistil, but they meet in the pistil after coming from the outer coverings of the fruit or from the surrounding fruits. Accordingly, the base of the pistil sometimes seems to be hollow, and a strong slender strip of cellular tissue runs through the middle of the seminal passage. There is no other canal running from the stigma to the seeds to fertilize them. Often the vessels do not reach as far as the stigma, or else they go from the stigma past the seed into the fruit outside, and from there to the peduncle. To the first question, whether the plant has veritable sexual organs, is linked the second, whether copulation as such occurs. That actual fertilization does occur is proved by the following account, which is well known in Berlin, and the botanical garden there, is a female Chimerops humilis which for 30 years had borne bowers but never any ripe fruit. In 1749, Gleeditzk fertilized it with pollen from a male plant which was sent to him from the Borischen garden at Leipzig, and obtained ripe seeds. In the spring of 1767, Karl sent part of the pollen of Chimerops humilis, gathered in the Karlsruhe botanical garden, to Gleeditzk in Berlin, and the rest to Eckelben the head gardener in St. Petersburg. At both places the pollination of the female palm was successful. The palm in St. Petersburg was already 100 years old, and had always blossomed in vain. Now, though this compels us to admit the occurrence of an actual fertilization, there still remains the third question, whether it is necessary. Since buds are complete individuals, and plants propagate themselves by stolons, and leaves and branches need only come into contact with the earth in order to be themselves fertile as distinct individuals, it follows that the production of a new individual through the union of the two sexes generation is a play, a luxury, a superfluity for propagation, for the preservation of the plant is itself only a multiplication of itself. Fertilization by sexual union is not necessary, since the plant organism, because it is the whole individuality, is already fertilized on its own account even without being touched by another plant. Thus many plants have fertilizing organs but produce only sterile seeds. Some mosses can have stamens without needing them for propagation, for they can reproduce themselves sufficiently by buds. But ought it not to be possible even for unfertilized plants, at least over several generations, to bear germinating seeds, as they do plant lice? Spallanzani's experiments seem to prove that it is. 1. Now if we ask whether a plant can bear ripe seeds without the pistil receiving pollen from the filaments and anthers, the answer is that in some instances the plant does not bear ripe seeds, but in others it certainly does. The position generally is, therefore, that in most plants contact of the pistil with the pollen is a condition of fertilization, but that in many plants fertilization occurs without contact being necessary. And the reason for this is that, although the feeble life of the plant attempts to advance to the stage of sexual difference, but does not quite succeed, the nature of the plant being, on the whole, indifferent to this distinction, yet some plants do mature and develop even when the anthers and stigma are nipped off, and the life of the plant has in consequence been injured. They therefore achieve consummation on their own account, and in this way the seed is not superior to the bud. In hermaphrodites like melons and pumpkins, the two parts are not ripe at the same time, or else at such a distance and in such a position that contact between them is impossible. Thus in many flowers, especially the Asclepias, one cannot see how the pollen can get onto the pistil. 3. This must be effected in some instances by insects, the wind, etc. 2. Now where sexual difference and the genus process are present, the further question arises, how ought this process to be understood, since it is not necessary for the ripening of the seed, and also, whether it is to be taken as a complete analogue of the genus process in the animal. In plants the genus process is formale, it is only in the animal organism that the process has its true meaning. Whereas in the genus process of the animal the genus, as the negative power over the individual, is realized through the sacrifice of this individual which it replaces by another. In the plant, this positive side of the process already exists in the first two processes, since the relationship with the outer world is already a reproduction of the plant itself and therefore coincides with the genus process. It is for this reason that, strictly speaking, the sex relationship should be regarded as just as much, or as even more, a digestive process. Here digestion and generation are the same. Digestion produces the individual itself, but in the plant it is another individual that is produced, as in the immediate digestion of growth. This very growth is a process of bud formation. All that is necessary for the production and ripening of the buds is the arrest of luxuriant growth. Through this, the whole plant recapitulates itself in the bud and in the fruit, and falls asunder into many seeds which are capable of existing independently. The genus process therefore has no importance for the nature of the plant. It shows that the reproduction of the individual is mediated, is even a complete process, although, nevertheless, in the plant all this again is equally an immediate production of individuals, the difference of the sexes as well as the production of the seed. But where there is actual contact, what does happen? The anther bunts open, the pollen flies out and touches the stigma on the pistil. After this release of the pollen, the pistil withers and the seed bud, the seed and its case, swell up. But all that is necessary for the production of individuals is merely the negation of growth. Even the fate of the sexual parts is only an arrest, a negation, a falling into dust, a withering away. Arrest, negation, is also necessary in animal life. Each sex negates its being for self, posits itself as identical with the other. But it is not through this negation alone that this living unity is posited in the animal. The affirmative realization of the identity of both, the realization brought about by this negation, is also a necessary factor. This is the accomplished fertilization, the germ, the product. But the reason why only the negation is necessary in the plant, is that the affirmative identity of the individuality, the germ, the idea ematrix, is already everywhere present in principle in the plant itself, for the plant's identity is original, since each part is already an individual. In the animal, on the other hand, the negation of the independent existence of the individuals also becomes an affirmation as a sense of unity. Now this negative side, which is alone necessary in the plant, exists precisely in the turning to dust of the pollen which goes together with the withering of the pistil. Schelver has gone even further in regarding this negative side as a poisoning of the pistil. He says, if the anthers are removed from tulips, the latter produce neither capsules nor seeds but remain sterile. But from the fact that the anthers are necessary to the consummation of the fruit of the plant, and must not be snipped off, it still does not follow that they are the fertilizing sex. Even if they did not serve the purpose of fertilization, they still would not on that account be a superfluous part which can be removed or damaged without injuring the life of the plant. Also the removal of the petals and other parts can harm the development of the fruit, and yet we do not therefore say that in removing them the fertilizing sex of the fruit has been removed. Could not the pollen, too, be a necessary excretion prior to the ripeness of the germ? Anyone who considers the matter without prejudice will, on the contrary, probably find that in some climates there are also plants in which the removal of the stamens can be just as beneficial to fertilization, as in others, and generally, it is harmful. Often, too, sterile plants can be made fertile by pruning the roots and branches, by tapping the bark, drawing off sap, etc. But Spallanzani has broken off the male flowers in monoecious plants, e.g. the shield melon and watermelon, also without causing injury, and has obtained from the non-pollinated fruits ripe seeds which germinated again. To the same result was obtained in dioecious plants whose female flowers were enclosed in glass vessels. Such pruning of trees, roots, etc., in order to get more fruit, is a withdrawal of excess nourishment which can be regarded as an arboreal venesection. Now a number of experiments and counter-experiments were made, some successful and others not so. If the fruit is to ripen, then the plant must stop growing and sprouting, for, if the plant is continually making fresh efforts to grow from within outwards with new, youthful vigor, then necessarily there can be no arrest of growth, and maturation, the formation of the fruit, cannot come to completion. That is why, in general, young plants and all those rich in sap and richly nourished, seldom bear ripe fruit. It often happens that even the already partly formed fruit falls off or is changed into shoots, as in so-called perfoliate flowers and fruits. As such a lethal poison does the pollen act on the stigma, arresting growth. For the pistil always withers as soon as the gen begins to swell and to ripen. Now if this death does not occur as a result of the turning inwards of the plant process, then the germ will not ripen without help from outside. But this help is in the pollen, because this is itself the eruption and the manifestation of the climax of the growth impulse, the disruption of the process of growth. This power in the pollen which is fatal to growth is chiefly the oil in it. For the plant produces for itself a combustible being for self. In every part of the plant the oil, wax, resin, is the nine-hiney outer covering which bounds it. And after all, is not oil in itself the limit of vegetable matter, the highest, ultimate product which, striving almost to surpass the plant nature, is analogous to animal matter, to fat? With the passage into oil, the plant nature perishes, and that is why the oil contains the power to subdue the fresh sprouting of the germ. That pollen can fertilize other plants is shown by the so-called hybrids to fertilization, as the contact of the stigma with the oily substance, is thus only the negation which overcomes the separateness of the sexual parts, but not as a positive unity. In the new number of his periodical 3 Skelver deals with the superficial character of the experiments on this subject. 3. The result of this destructive process is the formation of the fruit, a bud which is not immediate, but is posited by the developed process, whereas the earlier bud is only the formal repetition of the whole. The fruit, however, is expressly the production of a seed, consequently in the fruit the plant achieves its consummation. The seed which is produced entire fruit is a superfluity. The 9 qua seed, is not superior to the bud, for what is to be produced is only something new. But the seed is the digested plant, and in the fruit the plant demonstrates that it has brought forth its own organic nature from itself and by itself, whereas in many plants which have no seeds, the preservation of the genus is not effected in this way, but the genus process has already coincided with the process of the individuality. The seed is the seed as such, and the pericarp is its covering husk or fruit or more woody case, a rounded shape into which the entire nature of the plant is finally concentrated. The leaf which, from the seed, from the simple notion of the individual, has reached out into line and surface, has concentrated itself into an aromatic wordages, powerful leaf in order to be the covering of the seed. In the seed and the fruit the plant has produced 2 organic beings which, however, are indifferent to each other and fall apart. The power which gives birth to the seed becomes the earth, it is not the fruit that is the womb. The ripening of the fruit is also its downfall, for injury to the fruit assists its ripening. True, it is said that, where insects have conveyed the pollen to the female parts, no fruits are formed. But Skelver has shown that in figs it is precisely the injury which causes the fruit to ripen. He quotes from Julius Pontedera on caprification, as with us the fruits of most plants soon ripen and fall off if they have suffered external injury. Apple and other fruit-bearing trees whose fruits fall off before ripening, have been helped by placing stones on them and fastening the roots. This method often prevents the loss of fruit. The peasants often obtain the same result in almond trees by driving in an oak wedge. In others, plugs are bored into the trees as far as the pith, or the bark is ringed. I believe that in this way a particular kind of fly is produced which breeds on the blossom of the barren palms. This insect penetrates to the embryos of the fertile trees, boring into them and attacking them with, as it were, a helpful bite so that all the fruit stays on the tree and ripens. Skelver continues, in the case of the fig tree which is supposed to be fertilized by Synops psenes, and which seems to have first made celebrated this art of insects, the transference of pollen is the Less to be suspected because this caprification is made necessary only by the climate. Caprification owes its name to the fact that this insect, which has to puncture the good fig tree so that it will bear ripe fruit, is found only on another species of wild fig tree which is therefore planted nearby. These insects, says Johann Bauerhin, which have bred from the rotting fruit of die wild fig tree, fly onto the fruit of the cultivated tree, and in biting these open draw off the superfluo as moisture, and in doing so promote and hasten ripening. Pliny says that a dry soil, on which the figs soon dry and burst open, produces the same effect on fertilization as that contributed by the insects, that in districts where a lot of dry dust from the roads gets onto the trees, and the superfluous sap is absorbed, caprification is unnecessary. In our regions where the male tree and the insect are missing, fig seeds do not come to maturity, because the figs do not ripen completely. But that in hot countries, figs which ripened without caprification were only a ripe container which did not contain any ripe seeds, that is a mere assertion. A lot therefore depends on the warmth of the climate and the nature of the soil. Caprification I9 an arrest in the nature of the fruit, and this heterogeneous, lethal influence fashions the reproduction of the plants themselves and completes it. The insect punctures the fruit, and brings it to maturity by doing so, not by conveying pollen from elsewhere, and generally, fruit which has been punctured drops off and ripens more quickly. The flower, the pollination, and the fruit, however, lie dormant so long as the lower life is in control. But when the flower opens, the mystery is everywhere unfolded to its fullest extent, growth and germination are suspended, and the coloring and scent of the flower are then often developed in every part. When pollination dominates, the flower which, in opening has achieved its consummation, dies away, all its parts then begin to wither, the leaves drop soon after, the outer bark dries and becomes loose, and the wood hardens. When finally the fruit dominates, the same vital spirit enters into every part, the root puts out runners, buds spring up in the bark, in the axils of the leaves new leaves begin to grow. Pollination is in its own self an end of vegetation, a moment of the entire plant life which passes through every part of the plant and finally, breaking through to an existence of its own, only attains to a separate manifestation in the anthers 1. 349. But what has been posited in the notion is that the process displays the return into itself of the individuality, and shows that the parts which in the first instance are individuals belong also to the mediation, and are transient moments in it, and consequently that the immediate singularity and externality of plant life are sublated. This moment of negative determination is the basis for the transition to the veritable organism, in which the outer formation accords with the notion, so that the parts are essentially members, and subjectivity exists as the one which pervades the whole. Zusatz. The plant is a subordinate organism whose destiny is to sacrifice itself to the higher organism and to be consumed by it. In the same way, that light in the plant's color is a being for other, and the plant in its airy form is an odor for other, so the fruit as etheric oil concentrates itself into the combustible salt of sugar and becomes a fermented liquid. The plant now reveals itself here as the notion which has materialized the light principle and has converted the watery nature into a fiery one. The plant is itself the movement of the fiery nature within itself, it proceeds to ferment, but the heat which it gives out from itself is not its blood, but its destruction. This animal process which is higher than that of the plant is its ruin. Now since the stage of flower life is only a relationship to an other, whereas life consists in being self-related in its self-distinguishing, this contact within the flower, whereby it becomes for itself, I9 its death, for it is no longer the principle of the plant. This contact is a positing of the individual, of the singular, as identical with the universal. But the singular is thereby degraded to being no longer immediately for itself, but only through negation of its immediacy, but thus it is raised into the genus, which now comes into existence in it. With this, however, we have reached the higher notion of the animal organism. The organic individuality exists as subjectivity in so far as the externality proper to shape is idealized into members, and the organism in its process outwards preserves inwardly the unity of the self. This is the animal nature which, in the actuality and externality of immediate singularity, is equally, on the other hand, the inwardly reflected self of singularity, inwardly present subjective universality. Zusatz. In the animal, light has found itself, for the animal arrest be its relationship to an other, it is the self which is for the self the existing unity of distinct moments which are pervaded by it. The goal of the plant's development is to become for itself, but it does not transcend the stage of two independently existing individuals, viz. the plant itself and the bud, which are not in the form of ideal moments. These two posited in a unity are the animal nature. The animal organism is therefore this duplication of subjectivity, which no longer, as in the plant, exists as duplicated, but only as the unity of this duplication. There Thursday 9 exists in the animal the veritable subjective unity, a unitary soul, the immanent infinitude of form which is set forth in the externality of the body, and this owl in turn stands in relationship with an inorganic nature, with an outer world. But the subjectivity of the animal consists in preserving itself in its bodily nature and in its contact with an outer world and, as the universal, resnenervt at home with itself. The life of the animal as this highest point of nature is thus the absolute idealism of possessing within itself the determinateness of its bodily nature in a perfectly fluid form, the incorporation of the immediate into the subject and its possession as incorporated. Here, therefore, heaviness is first truly overcome, the center has become a filled center, which has itself for fulcrum and first, as such, is a truly self-subsistent center. In the solar system we have the sun and other members which have an independent existence, and are related to each other, not according to their physical nature, but only according to the nature of space and time. Now if the animal organism, too, is a sun, then in it the stars are related to each other according to their physical nature, and are taken back into the sun, which holds them within itself in one individuality. The animal is the existent idea in so far as its members are purely and simply moments of the form, perpetually negating their independence and bringing themselves back into their unity, which is the reality of the notion and is for the notion. If a finger is cut off, it is no longer a finger, but a process of chemical decomposition sets in. In the animal, the fully achieved unity is for the implicit unity, and this latter is the soul seal, the notion, which is present in the body in so far as this is the process of idealization. The asundi mess of spatial existence has no truth for the soul, which is unitary, finer than a point. People have been at pains to find the soul, but this is a contractadisation. There are millions of points in which the soul is everywhere present, and yet it is not at any one point, simply because the asundi mess of space has no truth for it. This point of subjectivity is to be adhered to, the others are only predicates of life. But this subjectivity is not yet for itself as pure, universal subjectivity, it is not aware of itself in thought, but only in feeling and intuition. That is to say, it is only reflected into itself in the individual which, reduced to a simple determinateness, is posited as ideal, it is objective to itself only in a specific, particular state and is the negation of any such determinateness, but does not transcend it in the same way that sensual man can indulge every appetite, but not get beyond it in order to grasp himself in thought as universal. The animal has freedom of self-movement because its subjectivity is, like light, ideality freed from gravity, a free time which, as removed from real externality, spontaneously determines its place. Bound up with this is the animal's possession of a voice, for its subjectivity as real ideality, dominates the abstract ideality of time and space and displays its self-movement as a free vibration within itself. It has animal heat as a permanent process of the dissolution of cohesion and of the enduring self-subsistence of the parts in the permanent preservation of shape, further, an interrupted intussusception as a self-individualizing relationship to an individual, non-organic nature. But above all, as the individuality which indeterminateness is for itself, immediately universal, simply abiding with itself and preserving itself, it has feeling the existent ideality of being determined. Zusatz. Because in the animal the self is for the self, it at once follows that it possesses the wholly universal determination of subjectivity, that of sensation, which is the differentia specifica, the absolutely characteristic feature of the animal. The self is ideal, is not poured out and immersed in materiality but is only actively present therein, at the same time finding itself within itself. This ideality which constitutes sensation is, in nature, the supreme wealth of existence because in it everything is compressed. Joy, pain, etc., assume, it is true, a bodily form, but all this corporeal existence is still distinct from the simple independent existence as feeling into which they are taken back. In seeing and hearing, I am simply in communion with myself, and they are in me only a form of my pure transparency and clarity. This point, which yet is infinitely determinable, which remains thus unclouded in its simplicity, this point, because it has itself for its object, is the subject as self equals self, as self-feeling. The animal, in its possession of sensation, has a theoretical relationship to its other, whereas the plant bears itself either indifferently or practically towards the outer world, and in the latter case does not leave it in existence, but assimilates it to itself. True, the animal, like the plant, also comports itself towards the outer world as to something ideal, but, at the same time, the other is left free, remains in existence, and withal is still in relation with the subject, without remaining indifferent to it. This is a disinterested relationship. The animal as sentient is inwardly satisfied when it is modified by an other, and it is precisely this inner satisfaction which is the basis of the theoretical relationship. That which enters into a practical relationship is not inwardly satisfied, since an other is posited in it. On the contrary, it must react to this modification posited in it, must sublate it and identify it with itself, for it was a disturbance. But the animal in its relationship to the other is still inwardly satisfied, and this is because at the same time it posits as ideal the externally caused modification, and can therefore tolerate it. The other determinations are merely the consequences of sensation. S24W75N. The animal as sensuous is heavy, remains tied to the center, but the particular place it occupies is not determined by gravity. Gravity is the universal determination of matter, but it also determines the particular place. The mechanical relationship of gravity consists precisely in this, that something, in being determined in space, has its determination therein only in something outside it. But the animal, as self-related singularity, does not occupy this particular place as the result of an external determination, because, as a singularity which is turned back into self, it is indifferent to non-organic nature, and in free movement is merely related to it by space and time generally. The particularization of place lies therefore in the animal's own power, and is not posited by an other. It is the animal itself which gives itself this place. In any other thing, this particularization is fixed, because the thing is not a self which is for itself. True, the animal does not escape from the general determination of being in a particular place, but this place is posited by the animal itself. And it is for this very reason that the subjectivity of the animal is not simply distinguished from external nature, but the animal distinguishes itself from it, and this is an extremely important distinction, this positing of itself as the pure negativity of this place, and so on. The whole of physics is the form which develops in contradistinction to gravity, but in physics the form doia not yet attained to this freedom in face of the torpor of gravity, and it is in the subjectivity of the animal that this being for self over against gravity is first posited. The physical individuality, too, does not escape from gravity since even its process contains determinations of place and gravity. Voice is a high privilege of the animal which can appear wonderful. It is the utterance of sensation, of self-feeling. The animal makes manifest that it is inwardly for itself, and this manifestation is voice. But it is only the sentient creature that can show outwardly that it is sentient. Birds of the air and other creatures emit cries when they feel pain, need, hunger, repletio, pleasure, joyfulness, or are in heat, the horse neighs when it goes to battle, insects hum, cats purr when pleased. But the voice of the bird when it launches forth in song is of a higher kind, and this must be reckoned as a special manifestation in birds over and above that of voice generally in animals. For while fish are dumb in their element of water, birds soar freely in theirs, the air. Separated from the objective heaviness of the earth, they fill the air with themselves, and utter their self-feeling in their own particular element. Metals have sound, but this still is not voice. Voice is the spiritualized mechanism which thus utters itself. The inorganic does not show its specific quality until it is stimulated from outside, gets struck, but the animal sounds of its own accord. What is subjective announces its psychic nature in vibrating inwardly and in merely causing the air to vibrate. This independent subjectivity is, quite abstractly, the pure process of time, which in the concrete body, is self-realizing time, vibration, and sound. Sound belongs to the animal in such a manner that it is the animal's own activity. That makes the bodily organism vibrate. But nothing is outwardly altered thereby. There is only movement, and the movement produced is only abstract, pure vibration, and this produces only an alteration of place, but an alteration which is equally cancelled again, a negation of specific gravity and cohesion which, however, are equally reinstated. The voice is the closest to thought, for here pure subjectivity becomes objective, not as a particular actuality, as a state or a sensation, but in the abstract element of space and time. With voice there is linked animal heat. The chemical process also yields heat which can rise to the intensity of fire, but it is transitory. The animal, on the other hand, as the lasting process of self-movement, of consuming and producing itself, perpetually negates and reproduces what is material and must therefore perpetually generate heat. This is especially true of warm-blooded animals in which the opposition between sensibility and irritability has reached a more highly developed stage, and irritability is established in its own independent character in the blood, which can be called a fluid magnet. Because the animal is a true, self-subsistent self which has attained to individuality, it excludes and separates itself from the universal substance of the earth which is for it an outer existence. This external world which has not come under the domination of the self, is, for the animal, a negative of itself, an indifferent existence. An immediate consequence of this is that the animal's non-organic nature has become individualized in relation to it, for it is at no distance from the element. And it is this relationship to non-organic nature which is the general notion of the animal. It is an individual subjective that enters into relationships with individual objects as such, not like the plant, merely with the elements, or with another subject, except in the genus process. The animal also has the plant nature, a relationship to light, air, and water, but in addition it has sensation, to which is also added in man, thought. Aristotle thus speaks of three souls, the vegetable, animal, and human, as the three determinations of the development of the notion. As a unity of different individualities reflected into self, the animal exists as an end which spontaneously produces itself is a movement which returns into this individual. The process of the individuality moves in a closed circle which, in organic being in general is the sphere of being for self, and because this is its notion, its essence, its non-organic nature is individualized for it. But because as a self-subsistent self it is equally in relationship with itself, it posits its being for self as distinct from non-organic nature, in relationship with it. It interrupts this relationship with the outside world because it is satisfied, because it is sated, because it has sensation, is a self for itself. In sleep, the animal submerges itself in its identity with universal nature. In the waking state it forms relationships with individual organisms but also breaks off this relationship, and the life of the animal is the alternating fluctuation between these two determinations. The animal organism as living universality is the notion which passes through its three determinations as syllogisms, each of which is in itself the same totality of the substantial unity, and, at the same time, in keeping with the determination of the form, transition into the others, so that the totality as existent results from this process. It is only as this self-reproductive being, not as a mere being, that the living creature is and preserves itself. It only is, in making itself what it is, and is the antecedent end which is itself only result. The organism is therefore, like the plant, to be considered as individual idea which in its process is only self-related, and inwardly coalesces with self-shape, as idea which enters into relationship with its other, it non-organic nature, and posits this inwardly as ideal assimilation, idea as entering into relationship with an other which is itself a living individual, so that in the other it is in relationship with itself. The genus Prose 9. Zusatz. The animal organism is the microcosm, the center of nature which has achieved an existence for itself in which the whole of inorganic nature is recapitulated and idealized. This will be worked out in the detailed exposition to follow. Since the animal organism is the process of subjectivity, of SDF relation in an outer world, the rest of nature is therefore here present for the first time as outward, since the animal preserves itself in this relation with the outer world. Now the plant is drawn towards the outer world but without truly preserving itself in connection with what is other, and consequently the rest of nature is still not present for it as outer. As its own product, as self-end, animal life is end and means at the same time. End is an ideal determination which is already existent beforehand, so that, in the process of realization which must fit in with that exists determinately beforehand, nothing new is developed. The realization is equally a rudimentu self. The accomplished end has the same content as that which is already present, i.e. the agent, the living creature, therefore, with all its activities does not add anything to it. As the organization is its own end, so too it is its own means, it is nothing merely there. The viscera, the organs generally, are perpetually posited as ideal, for they are active against each other, and just as each, as center, produces itself at the expense of all the others, so it exists only through the process. In other words, that which, as sublated, is reduced to means is itself end, is itself product. That which develops the notion, the animal organism is the idea manifesting only the differences of the notion, and thus each moment of the animal organism. 357. Notion contains the others, is itself system and totality. These totalities, as determinate, produce in their transition the whole which each system is in itself, as a one, as subject. The first process is that of the self-related, self-embodying organism which contains the other within itself, while the second, that which is directed against non-organic nature, i.e. against its in itself in the form of an other, is the judgment of the living creature, its active notion. The third process is the higher one, that, namely, of singularity and universality, of the individual against itself as genus with which it is implicitly identical. In the perfect animal, in the human organism, these processes are developed in the fullest and clearest way. This highest organism therefore presents us in general with a universal type, and it is only in and from this type that we can ascertain and explain the meaning of the undeveloped organism. I functions of the organism shape is the animal subject as a whole which 19 related only to itself. It exhibits the developed determinations of the notion, as existent within it. Although these, as existent within the subject, are inwardly concrete, they are here present only as its simple elements. The animal subject is consequently, its simple, universal being bright in self in its externality, whereby the real determinateness is immediately taken up as a particularity into the universal, and this latter in it is an undivided identity of the subject with its self-sensibility, particularity as a capacity for being stimulated from outside and the subject's own reaction outwards to the stimulation irritability, the unity of these moments, the negative return to itself from its relation with the outside world, and, through this, the production and positing of itself as a singular reproduction, which is the reality and the basis of the first two moments. Zusatz. The plant lets its wood, its bark, die and sheds its leaves, but the animal is this negativity itself. The former can counter the becoming other of itself only by leaving this other lying there indifferently. The animal is the negativity of itself which transcends its shape. It does not let the arrest of its growth issue only in the digestive and sexual processes, but as the negativity of itself, in its own inner process it gives itself form in its viscera. In thus shaping itself as an individual, it is a unity of shape and individuality. The simple identity of the universal subjectivity of the notion with itself, the sentient creature which in the sphere of spirit is the egg, is sensibility. If an other is brought into contact with it, it transforms this directly into itself. The particularity, which in sensibility is at first only ideally posited, receives its due in irritability, where the activity of the subject consists in repelling the other with which it is in relation. Irritability is also sensation, subjectivity, but in the form of relation. But whereas sensibility is only this negative relationship to other, reproduction is this infinite negativity of transforming what is outside me into myself, and myself into externality. Only then is universality real and not abstract developed sensibility. Reproduction passes through sensibility and irritability and absorbs them. It is thus derived, posited universality which, however, as self-producing, is at the same time concrete singularity. It is reproduction which is first the whole, the immediate unity with self, in which the whole ha-nine at the same time entered into relationship with itself. The animal organism is reproductive, this it is essentially, or this is its actuality. The higher forms of life are those in which the abstract moments of sensibility and irritability have separate existences of their own, whereas the lower forms of life remain at the stage of reproduction. The higher forms of life possess within themselves the profounder differences, and preserve themselves in this more intense diremption. Thus there are animals which are nothing more than a reproductive process in a morphous jelly, an active slime which is reflected into self and in which sensibility and irritability are not yet separated. These are the general animal moments, but they are not to be regarded as properties, as if each acted, as it were, in its own special way, as color acts specially on sight, taste on the tongue, and so on. Nature does, it is true, give the moments an indifferent, separate existence, but only and solely in the shape, i.e. in the dead being, of the organism. The animal is intrinsically the most lucid existence in nature, but it is the hardest to comprehend since its nature is the speculative notion. For, although this nature is a sensuous existence, it must nevertheless be grasped in the notion. Although in sensation the animal is utterly simple, in contrast to the separation of qualities characteristic of inorganic nature, yet the animal is also the most concrete, for it allows the moments of the notion, real in a single subject, to have determinate existence. The inorganic, on the other hand, is abstract. In the solar system, sensibility corresponds to the sun, the moments of difference are comet and moon, and reproduction is the planet. But whereas there each member is a separate existence, here they are held in a single subject. This idealism which recognizes the idea throughout the whole of nature is at the same time realism, for the notion of the organism is the idea as reality, even though in other respects the individuals correspond only to one moment of the notion. What philosophy recognizes in the real, the sensuous world, is simply the notion. One must start from the notion, and even if, perhaps, the notion cannot yet give an adequate account of the abundant variety of nature so called, we must nevertheless have faith in the notion though many details are as yet unexplained. The demand that everything be explained is altogether vague, that it has not been fulfilled is no reflection on the notion, whereas in the case of the theories of the empirical physicists the position is quite the reverse. These must explain everything, for their validity rests only on particular cases. The notion, however, is valid in its own right, the particulars then will soon find their explanation. These three moments of the notion are not merely concrete elements in principle, but have their reality in three systems, namely, the nervous system, the circulatory system, and the digestive system, each of which, as totality, is inwardly differentiated according to the relevant determinations of the notion. 1. The system of sensibility is differentiated into ACL. The extreme of abstract self-reference, which I9 a transition into immediacy, into non-organic being, and an absence of sensation, but a transition which remains incomplete. The osseous system, a covering for what is inner, and a firm support for the inner against the outer, SSSS. The moment of irritability, the cerebral system and its further ramifications in the nerves, which similarly have an inward and an outward reference, the sensory and motor nerves respectively, YY. The system pertaining to reproduction, the sympathetic nerves and the ganglia, the sphere of dull, indeterminate self-feeling, devoid of will. 2. Irritability is just as much a capacity for being stimulated by an other and the reaction of self-maintenance against it, as it is also, conversely, an active maintenance of self, in which it 19 at the mercy of an other. Its system is a abstract sensible, irritability, the simple conversion of receptivity into reactivity muscle in general. This gains an outer hold on the skeleton and is differentiated first into extensors and flexors, and then, further, into the special systems of the extremities. SSSS. Irritability as independent of, and opposed to, an other, and as concretely self-related and self-contained, is inward activity, pulsation, living self-movement, the material of which can be only a fluid, the living blood, and which itself can only be circulation. This, in keeping with the particularity of its origin, is in its own self immediately specified into the duality of the pulmonary and the portal systems, in which the circulation at the same time has an outward reference. In the former system the blood takes fire within itself, and in the latter it kindles itself against its other. YY. Pulsation, as irritable, self-coalescing totality, is the circulation which, from its center, the heart, returns in the dual system of arteries and veins into itself, and is equally an immanent process, in which the blood generally is delivered up for the reproduction of the other members which take their nourishment from it. 3. The digestive system, as a system of glands with skin and cellular tissue, is immediate, vegetative reproduction, but in the system proper of the intestines, it is mediating reproduction. Zusatz. Since sensibility also has an existence of its own in the nervous system, irritability in the system of the blood, and reproduction in the digestive system, the bodies of all animals can be analyzed into 3 different constituents of which all the organs are composed, into cellular tissue, muscle fiber, and nerve pulp parts. Sensibility, as self-identity of sensation, if reduced to abstract identity, is insensibility, the inert, dead side of the organism, the deadening of itself which, however, still falls within the sphere of vitality, and this is the production of bone, whereby the organism presupposes its own basis. Thus the osseous system itself still participates in the life of the organism. In old age the bones get smaller, the skull bones, the cylindrical bones get thinner, their medullary cavity seems as it were to get larger at the expense of the bony substance. The entire, dry bony skeleton of an old person becomes relatively lighter, accordingly old people get shorter, even without taking account of their bent backs. Bones, simply on account of the larger number of their blood vessels, in general possess more vitality, and this is evidenced by their susceptibility to inflammation and pathological changes, by their reproduction, also by the absorptive power of their pointed extremities and their readier arousal of sensation, and finally even by their composite structure. F-bone, i.e. the sensibility belonging to shape as such, is, like the wood of the plant, the simple and therefore dead force which is not yet a process, but abstract reflection into self. At the same time, however, it is the dead force reflected into self, or it is the vegetative burgeoning which produces itself in such wise that the product is an other. Its shape is, in the first instance, a bony nucleus, for that is how all bones begin. The bony nuclei multiply and grow lengthwise like the plant node which becomes a woody fiber. The bony nuclei are found at the extremities of the limbs, they contain the marrow which is not yet expressly developed into their nerves. Bone marrow is fat, and that is why there is little marrow or liquid marrow in thin people, and plenty of marrow in fat people. The periosteum is the life proper of the bone, a production directed entirely outwards, which consequently dissects away in itself and lives only on the surface of the bone. The dull force within the bone itself, the osseous system, together with the system F. Autenrieth, Handbuch der Physiologie, Partit, 767, $rm. 361. Of the skin, thus falls under reproduction. The bone, in developing towards totality from nucleus and line, breaks open, and in place of the marrow there appears the nerve, which is a nucleus carry, shooting out lengthwise from its center. But, with this totality, the bone ceases to belong to the shape as such, its marrow becomes living sensibility, a point which expands in lines and from which, as from the totality, the dimensions proceed. As nucleus, the bone is the immediately sensible moment of shape, but, as bony skeleton, its first and more precise function is to be, in relation to the outer world, the stable, merely firm, hard element of the body, to give itself its own firmness, to attain mechanical objectivity and thus win a fulcrum against the earth which is the absolutely firm, fixed body. The prolongation of the bone is the middle term, the transition in which the shape sinks to the level of an outer whose inner is an other. In the limbs, the bone is the inner moment, what is immediately firm and solid, but for the rest, it ceases to be inner. Just as wood is the plant's inner being and the bark its exterior, so bone becomes the outer covering for the viscera, a covering which no longer has its own center, but is at first still discontinuous and held together by its own line, still has its own articulation. Finally, however, it again becomes a pure surface without intimality of it, a reversion to point or line, from which lines radiate and become flattened out into what is merely an enclosing surface. This is the totality which has not yet rounded itself off into a whole, but which is still turned outwards. Thus the second determination of the bone is to be controlled by an other, to have an other as subject within it, and to terminate outwardly in firm points d'appui like horns, claws, nails, etc. It is the indestructible element in the organism since, after everything else in a corpse has turned to dust, kin is often still visible on some parts. At the same time, since in the vertebra the bony center is pierced, the bone, now returning into itself, is, thirdly, the hollow cranium. The form of the spinal column is the basis of the skull bone and the one can be explained from the other. But the os sphenoidum is directed towards completely overcoming the center, and reducing the cranium to a surface without center of its own. But at the same time this complete overcoming of nuclearity passes over into the reinstatement of the nuclei. The teeth are this return of nuclei into themselves, which pass through the moments of the process, i.e. they are negative, active, affective, and therefore cease to be a merely passive separated organ Absonderung. It is immediate sensibility which has become irritability. In the teeth, the periosteum is no longer an outer, but only an inner membrane. The bones, like the periosteum, are without sensation, but they acquire sensation in the lymphatic diseases. The basic organism of the bone is the spinal vertebra, and all else is merely a metamorphosis of it, a tube directed to the interior of the body, and continuations of the tube directed outwards. It was Goethe in particular who, with his organic feeling for nature, saw this to be the fundamental form of bone structure and followed out the transitions in full detail in a treatise written as early as 1785 which he published in his Morphology. Oken, to whom Goethe had communicated the treatise, paraded its ideas as his own in a program he wrote on the subject, and so gained the credit for them. Goethe showed that the cranial bones are developed solely out of this form, the os spherundum, the os zygomaticum up to the os bregmatis, the frontal bone which is the hip bone in the head. But here, as in the plant, the identity of form is insufficient to explain such a transformation of the bones, how it is that, instead of being an inner center, they now become an enclosing structure, and are determined as external fulcras for the extremities, arms, legs, etc., combining with each other and being at the same time movable. This other side of metamorphosis, The introjection of the spinal vertebra into the separate bones was not developed by Goethe, although it was by Oken. The spinal vertebra is the center of the osseous system, a center which splits into the extremes of the cranium and the extremities, and which at the same time joins these together. In the former we have a hollowing out which, by uniting surfaces, excludes the outer world, while the latter is a development in length which takes up a middle position and is fastened, essentially by cohesion, along the length of the muscles. The moment of difference in sensibility is the nervous system, which is directed outwards and is involved in external relationships, sensation as determinate either as immediately posited from outside or as self-determination. The motor nerves mostly start from the spinal cord, and the sensory nerves from the brain. The former are the nervous system in its practical function, the latter are that system as receptive of determinations, and to this the sense organs belong. But in general the nerves are concentrated in the brain, from which they ramify into every part of the body. The nerve is the condition for sensation where the body is touched, it is also a condition of the will, and generally of any self-determining end. Apart from this, we still know very little about the organization of the brain. Experience teaches that there is a partial or total cessation of the function of the motor organs which carry out voluntary actions and the capacity of these organs for sensation, when the nerves coming from them, or the spinal cord, the cerebellum or cerebrum connected with those nerves, is damaged or destroyed. The individual nerve fibers with their sheaths are joined together in bundles by cellular tissue, and these bundles are more or less tightly combined into a larger, palpable cord. Even the individual medullary fibers of the nerves are everywhere closely interconnected by small lateral canals filled with medullary substance which, at their points of contact, seem to form very fine tiny knots, and in this respect a nerve bundle resembles a very expanded net pulled lengthwise like a piece of knitting, the threads of which are now almost parallel. We must not represent the communication between the brain and another part of the body as if, when the nerves in that part have been affected, the impression is propagated by these particular nerve fibers on their own, or as if an impression was made by the brain on a particular nerve fiber according to the external association of the nerves. On the contrary, communication occurs through the common nerve trunk and yet achieves determination through the universal presence of the will and consciousness. The nerve fiber is connected with many others, and when it is affected these, too, are affected, although this does not produce a plurality of sensations, nor conversely does the general nerve trunk from the brain set in motion all the associated nerves. The sensibility which has withdrawn into itself, the innermost point of the sentient creature in virtue of which it no longer is abstract, the system of ganglia generally, and especially of the so-called sympathetic nerves, a system not yet separated out, not developed into specific sensory forms. This system forms ganglia which can be regarded as little brains in the abdomen. They are, however, not absolutely independent and for themselves, i.e. are not without connection with the nerves directly connected with the brain and those of the spinal cord, but have at the same time their own place in the nervous system, and are distinct from the nerves of the cerebrospinal system both in function and structure. 1. This division into the brain of the head and the brain of the abdomen is the reason why headaches originate in the abdomen. It is remarkable that in the stomach, one could almost say at its upper opening, the development of the eighth nerve descending directly from the brain stops, its place being taken by the sympathetic nerve, so that there is here, as it were, the boundary of a more distinct feeling. This upper opening plays a marked and significant role in many diseases. Autopsies show that inflammation is found more often near this opening than in any other part of the stomach. Nature leaves us a free choice in the matter of selecting food, mastication, deglutition, and finally, in the evacuation of the useless, major part, but the business of digestion proper is withdrawn from our control. In the somnambulistic state, where the outer senses are cataleptically rigid, and self-consciousness is turned inwards, this internal vitality passes into the ganglia and into the brain of this dark, independent self-consciousness. Rishrand 3 therefore says, through the sympathetic nerves, the internal organs are withdrawn from the dominance of the will. 1 The system of these ganglia is irregular. 4 F. Autenrieth, Handbuch der Physiologie, Part 3, 824, 866, 868. Bichat once says, The system of the ganglia can be divided into the ganglia of the head, throat, thorax, abdomen, and pelvis. They are found therefore throughout the body, though principally in the parts belonging to the internal structure, especially in the abdomen. A series of these ganglia lies on either side in the openings between the vertebrae, where they are formed by the posterior roots of the nerves of the spinal cord. Through their interconnections they form the so-called sympathetic nerves, then the plexus semilunaris, solaris, splanchnicus, and finally the communication of the semilunar ganglion, through its ramifications, with the thoracic ganglia. In many subjects the so-called sympathetic nerve is found to be interrupted, that is, the part in the thorax is separated from that in the abdomen by an interstice. Often, after having provided a number of threads to the neck, the nerve is thicker than before. The nerve threads of this system are very different from those of the cerebrospinal system. The latter are thicker, not so numerous, whiter, denser in tissue, and exhibit little variety in structure. The distinguishing marks of the ganglia, on the other hand, are extreme tenuity, very large numbers of threads, especially near the plexus, grayish color, considerable softness of tissue, and extraordinary variety in different subjects. There is controversy as to whether these ganglia are independent, or whether they originate in the brain and spinal cord. This expression originate * is a dominant conception in the relation of nerves to brain and spinal cord, but it is without definite meaning. It counts as an undoubted truth that the nerves originate in the brain. But if here they are in identity with the brain, they are also separate from it, although not in the sense that the brain is antecedent to the nerves, these coming later any more than the fingers originate in the palm of the hand, or the nerves originate in the heart. Individual nerves can be severed, and the brain still lives, just as parts of the brain can be removed without destroying the nerves. The sensibility of the outer organism having passed over into irritability, into difference, its unitary nature now overcome, passes over into the opposition of the muscular system. The burgeoning of the bone has been taken back into the simple difference of the muscle, whose activity is the real, material relationship with inorganic nature, the process of mechanism with the outer world. Organic elasticity is the softness which, when stimulated, withdraws into self, equally negates this yielding and reinstates itself, pushing against itself in a linear movement. The muscle is the unity of this dual activity, and both moments also exist as kinds of movement. Treviranus 1*3 puts forward the proposition that contraction is accompanied by an actual increase in cohesion. This is demonstrated particularly by the following experiment. Ehrman took a glass cylinder open at both ends, closed the bottom end with a cork through which passed a platinum wire, and filled the cylinder with water. He introduced into the water a part of the tail of a live eel, and then closed the top of the cylinder likewise with a cork through which passed a platinum wire and, in addition, a narrow glass tube open at both ends. When the latter cork was pressed, water entered the glass tube, its level being accurately marked. Now Ehrman observed that, whenever he connected the spinal cord with one wire and the muscles with the other, and brought both wires into contact with the poles of a voltaic pile, the water in the tube fell in jerks to the extent of 4 or 5 lines each time. Also, the muscles are spontaneously irritable, e.g. those of the heart, even when the cardiac nerves are not stimulated. Similarly in the galvanic circuit, the muscles are set in motion without the nerves being touched. 3 Treviranus also maintains that his hypothesis that the transmission of voluntary stimuli to the muscles, and the conveyance of external impressions to the brain, are the action of different nerve constituents, the former being performed by the nerve sheaths, the latter by the nerve pulp, has not yet been refuted. Muscular movement is the elastic irritability which, a moment of the whole, posits a peculiar, self-dividing movement which arrests the circulatory flow and, as a self-contained movement, posits and generates from within itself a fire process which overcomes this inert persistence. This dissolution of this persistence is the pulmonary system, the true, ideal process with the outer world of inorganic nature, with the element of air, it is the organism's own self-movement which, as elasticity, draws in air and expels it. The blood is the result, the organism which through its own interior process returns into itself, the living individuality which makes members into viscera. The blood as axially rotating, self-pursuing movement, this absolute interior vibration, is the individual life of the whole in which there is no distinction animal time. This axially rotating movement then splits up into the cometary or atmospheric process and the volcanic process. The lung is the animal leaf which enters into relationship with the atmosphere and forms the self-suspending and self-restoring process of outbreaking and inbreathing. The liver, on the other hand, is the return from the cometary process into being for self, into the lunar process. It is the being for self which seeks its center, the heat of being for self, the rage against otherness and the consuming of it. The processes of lung and liver are most intimately connected. The transient, eccentric lung process tempers the heat of the liver, and the latter vivifies the former. The lung is in danger of passing over into liver, of becoming nodulated in order then to consume itself when it receives into itself the heat of being for self. The blood divides itself into these two processes. Its real process, therefore, is to be this threefold circulation. One is its own proper circulation, the second is the pulmonary circulation, and the third is that of the liver. Each is a separate circulation on its own, for what appears as an artery in the pulmonary circulation appears as a vein in the portal system, and conversely, the veins entering the portal system appear as arteries. This system of living movement is the opposite of that of the outer organism. It is the power of digestion, the power of overcoming the outer organism. This inorganic nature is here necessarily threefold: the outer, universal lung, the specified lung, the universal reduced to an organic moment, the lymph, and the entire organism in its immediate aspect, the individualized lung. The blood elaborates itself from the air, the lymph, and the digestion, and is the transformation of these three moments. From the air it takes pure dissolution, the light of the air, oxygen; from the lymph, the neutral fluid; from digestion, the moment of singularity, the substantial moment. And as thus the whole individuality, the blood opposes itself to itself afresh and generates shape. The blood in the pulmonary circulation, having its own movement, is this purely negative immaterial life for which nature is air and which has here the sheer victory over it. The infant's first breath is its own individual life. Up till then the infant floated in the lymph and absorbed nutriment in vegetative fashion. Emerging from the ovum or the womb, the creature breathes, it enters into relationship with nature which for it has become air, and it is not this continuous flow but its interruption, the simple organic irritability and activity through which the blood demonstrates itself to be pure fire and becomes such. It is the blood which sublates the neutrality, the floating in the lymph. It overcomes this, stimulating and exciting the whole outer organism and impelling it to return into itself. This movement, too, is a digestive system, a cycle of distinct moments. Everywhere the lymphatic vessels construct for themselves ganglia T stomachs, in which the lymph is digested and finally conducted into the ductus T caroticus. It is in this process that the blood acquires its fluid nature. As such, it cannot be rigid. From its watery neutrality, the lymph changes into fat and does not therefore become more animalized but becomes a vegetable oil and serves as nutriment. Consequently, hibernating animals grow very fat in summer, and in winter live on their own resources so that in spring they are quite thin. Lastly, blood is the digestive process proper of the individual, and this is the peristaltic movement generally. As this process of singularity, blood splits up into the following three moments: the dull, interior being for self, the state of becoming hypochondriacal and melancholic, its slumber, the venous blood in general, which becomes this nocturnal force in the spleen. In this, blood is said to be carbonized. This carbonization is precisely the process in which it becomes earth, i.e. absolute subject. From here, its center is the portal system where its subjectivity is movement and becomes an active process, a consuming volcano. As thus active in the liver, it operates on the chyme prepared in the stomach. Digestion begins in the stomach after the food has been masticated and steeped in the salivary lymph. The gastric and pancreatic juices are, as it were, the solvent acids which induce fermentation in the food. This action of the lymph and the generation of heat constitute the chemico-organic moment. It is in the duodenum that the proper, complete mastery over the food is achieved by fire, by the bile, which is produced by the venous blood of the portal vein. The outward turned process which is still active in the lymph develops into being for self and is now transformed into an animal self. The chyle, this product of the blood, returns into blood, the latter has produced itself. This is the great, interior circulation of the individuality whose center is the blood itself, for it is the individual life itself. Blood in general, as the universal substance of every part, is the irritable concentration of everything into the interior unity. It is heat, this transformation of cohesion and specific gravity, but not merely the dissolution produced by heat but the real, aimal dissolution of everything. Just as all food is converted into blood, so, too, blood is dispensed as the source from which everything takes its nutriment. That is what pulsation is in its complete reality. It has been said that the juices, because they are secreted das Ausgeschieden, are inorganic and that life belongs solely to the solid parts. But in the first place, such distinctions are in themselves meaningless, and secondly, blood is not life, but the living subject as such, in opposition, to the genus, the universal. Those feeble flowery folk the Hindus do not eat animals but let them live in complete freedom. The Hebrew lawgiver forbade only TB eating of the blood of animals, the reason given being that the life of TB animal is in its blood. The blood is this endless, unbroken unrest of welling forth, whereas the nerve is at rest and remains where it is. The endless process of division and the suppression of division which leads to another division, all this is the immediate expression of the notion which is, so to speak, here visible to the eye. In the description of it given by Professor Schultz it presents itself as a visible phenomenon. Blood has a tendency to form globules but does not actually do so. If blood flows into water it forms globules, but blood itself in its living state does not do so. Thus blood globules only appear when blood is dead, when it is exposed to the atmosphere. Their existence is therefore an invention, like that of atoms, and is based on misleading phenomena, those which occur when blood is forcibly withdrawn from the organism. This pulsation remains blood's chief characteristic. This circulation is the vital point where none of the mechanical explanations of the understanding are of any use. It eludes the finest anatomical and microscopic investigations. TB inward ignition of the blood through its contact with air is explained as an inhalation of the atmosphere and an exhalation of nitrogen and carbon. But these chemical conceptions explain nothing. It is no chemical process, but life, which is perpetually interrupting such a process. The concentration of this internal differentiation into a single system is the heart, the vital muscular principle, a system which 19 everywhere connected with reproduction. No nerves are found in the heart, but what pulsates is the pure vitality of irritability present as muscle in the center. As absolute motion, the natural living self, process itself, the blood is not moved but is motion. Physiologists search for all kinds of forces to explain its movement. The cardiac muscle first drives the blood outwards, and is helped in this by the walls of the arteries and veins and the pressure of the solid parts which impel the blood onwards. Admittedly, the cardiac impulse is no longer operative in the veins, so that the effect must be produced solely by the pressure of the walls of the veins. But all these mechanical explanations of the physiologists are inadequate. For whence comes this elastic pressure of the walls and the heart? From the irritation of the blood, they reply. According to this, therefore, the heart moves the blood, and the movement of the blood is, in turn, what moves the heart. But this is a circle, a perpetuum mobile, which would necessarily at once come to a standstill because the forces are in equilibrium. But, on the contrary, this is precisely why the blood must be regarded as itself the principle of the movement. It is the leaping point asterisk, in virtue of which the contraction of the arteries coincides with the relaxation of the ventricles of the heart. There is nothing incomprehensible or unknowable about this self-movement unless we mean by comprehension * that something else, the cause, is assigned by which the movement is effected. This, however, is only outer necessity, i.e. no necessity at all. The cause is itself again a thing, the cause of which has in turn to be asked for, and so on to another cause, ad infinitum, the spurious infinity which is the incapacity to think and conceive the universal, the ground, the simple, which is the unity of opposites and consequently the immovable which yet moves. This is the blood, the subject, which no less than the will initiates a movement. As the whole movement, the blood is the ground and the movement itself. But also, it steps to one side as one moment, for it is to be distinguishing of itself from itself. The movement is precisely the stepping aside of itself whereby it is subject, a thing, and the supersession of its standing aside, so that it overlaps itself and its opposite. But it appears as a part and a result just because the opposite intrinsically sublates itself and it is from its side that the return takes place. Thus does the living and vivifying power of blood develop from shape, and its interior movement also demands real, mechanical, external movement. It moves, embraces the parts in their negative, qualitative difference, but requires the simple negativity of external movement. An invalid who has remained immobile for a long while, e.g. after an amputation, develops ankylosis, the 37 degrees synovial fluid diminishes, the cartilages become ossified, and the muscles flag as a result of this bodily inactivity. The course of the flow itself is, in one regard, the general circulation through which each part participates in this circular movement, but it is no less completely elastic within itself and is not merely this circular movement. Even in different parts of the body the circulation varies somewhat. In the portal system and inside the cranium, it is slower than in the other parts. In the lungs, on the other hand, the flow is more accelerated. In a whitlow the artery has 100 pulse beats to the minute, while the artery on the healthy side has only 70, synchronizing with the heartbeats. Further, the passage of the arteries and veins into each other is made by the finest canals, some of which are so fine that they do not contain any red blood corpuscles but only yellowish serum. It seems, says Sommering, that in the eye the arteries are continued into finer branches which no longer contain red blood. These at first join onto a similar vein but finally onto a venule carrying red blood. Here, therefore, there is no passage of the thing that is properly called blood, but there is a movement in which it vanishes and reappears, or an elastic vibration which is not an advance. The passage * then, is not directly perceptible, or only rarely so. In addition, there are abundant anastomoses of the veins and more particularly of the arteries. Some of these form larger branches, others form entire large plexuses where, therefore, circulation, strictly speaking, is inconceivable. In the anastomost branch, the blood flows in from both sides. There is an equilibrium which is not a flow in one direction but only an internal oscillation. It might perhaps be thought that here in one branch, one direction had a preponderance, but with several whole festoons, plexuses, of anastomost blood vessels, one direction cancels out the other and converts the movement into a general interior pulsation. When an artery is opened, the blood spurts much further at the moment that the heart contracts than when it is distended. In the arteries, the period of contraction lasts a little longer than the period of distension. In the heart the converse is true. But we must not conceive the live arterial system as if the blood moved on in a succession of rounded waves, or as if an artery, laid bare along its whole length, rather resembled a string running through a garland of roses. On the contrary, the arterial system throughout its entire length and in all its branches appear always cylindrical, oscillating delicately with every heartbeat and expanding uniformly laterally, yet so slightly as to be hardly perceptible and that only in the larger branches, while during the contraction of the heart a shortening, as it were, takes place. Circulation, then, does indeed occur but it is an oscillatory circulation. The distinction between arterial and venous blood takes on reality in the lungs and liver, it is the same opposition as that of the extensor, and ptoius in the text is presumably a misprint for wake \. Asterisk. Flexor muscles. The arterial blood is the outgoing, solvent activity, the venous blood is the inward-going activity, the lungs and liver are, as a system, their peculiar life. According to chemistry, the difference is that the arterial blood contains more oxygen, which makes it bright red. Venous blood contains more carbon and when shaken in oxygen also becomes bright red, a difference which expresses only the fact, not the nature of the arterial and venous blood and their relation in the whole system. The general process is this return of self to self after running its cometary, lunar, and terrestrial course, from its viscera back to unity. This return is, then, its general digestion, and thus returned, its existence is quiescence, i.e. it returns to mere shape, which is its result. This process of nutrition, which supersedes shape and which only splits itself up into the viscera, but in so doing shapes it 9-elf, is the alimentary process whose product is likewise shape. Now this alimentation does not consist in the arterial blood throwing off its oxygenated fibrin. On the contrary, the arterial exhalations are rather a finely elaborated exudation. A wholly universal aliment from which each individual part of the body takes what it needs and converts it into whatever part it is in the whole. This lymph, bomb from the blood, is the vivifying aliment, or rather it is the general vivification, the being for self of each organ, which enables it to transform into itself its non-organic nature, the universal organism. The blood does not conduct material to each organ but vivifies the latter, the form of the organ being the main thing, and this is done not only by the artery but by the blood in its twofold nature as venous and arterial. Thus the heart is everywhere, and each part of the organism is only the specialized force of the heart itself. Reproduction or the system of digestion is not present, strictly speaking, as a developed, articulated whole. For whereas the systems of sensibility and irritability are developed into distinct organs, reproduction does not create any structure, nor is it the total structure except merely formally, and consequently it does not reach the stage of a differentiation into characteristic forms. The system of reproduction can here only be called abstract since its function is assimilation. Reproduction in its crass, immediate form is the cellular tissue and the glandular organs, the skin, a simple animal gelatine together with tubes. In animals which are no more than this there is an absence of developed differences. The organic activity of shape or structure operates through the skin, connected with this is the lymph, the contact of which with the outer world is the entire process of nutrition. The immediate return of the exterior organism into itself is the skin, in which it becomes actively related to itself. It is, at first, still only the notion of the interior organism and is therefore the exterior aspect of shape or structure. The skin can be and become everything, nerves, blood vessels, etc., as absorbent. It is the universal digestive organ of the vegetative organism. But the skin, which in claws, bones, and muscles has acquired SI relation involving real difference, now interrupts the process of absorption and enters into individual relationship with air and water. The organism relates itself to the external world not only as to a universal element but to this element as a separate, detached existence, even though it is only a draught of water. The skin thus turns back on itself towards the organism's interior. In addition to being a general orifice, it is now a single orifice, the mouth, and non-organic nature is seized and ingested as an individual thing. The individual organism seizes it, crunches and destroys it as a purely external structure and transforms it into itself, not by immediate infection but in virtue of a mediating activity which makes it pass through the different moments, reproduction in opposition. Immediate, simple digestion becomes explicit in the higher species of animals in a system of viscera, the bile, the liver, the pancreas or gastric gland, the pancreatic juice. Animal heat derives, in general, from the fact that the structures it overcomes are individual structures. This heat is the absolutely mediating activity of the organism reflected into itself, the organism which possesses the elements within itself and through these goes into action, bringing them all into action to attack the individual. It infects it with organic lymph, the saliva, it works on it with the neutrality of the alkaline and acid principles, with the animal gastric and pancreatic juices. Lastly, it attacks it with the bile, the onslaught of the fiery element on the ingested food. The inward turned or visceral reproduction is the stomach and intestinal canal. Immediately, the stomach is this digestive heat as such, and the intestinal canal is the separation of what is digested, into entirely inorganic matter which is to be excreted, and into completely animalized matter which is both the unity of the enduring structure and of the heat of dissolution, the blood. The simplest animals are merely an intestinal canal. The total structure. But for the structure we have, on the one hand, the differences of the elements and their systems uniting to produce a general, concrete interpenetration of one another so that each part of the structure contains these systems linked together in it, and on the other hand, structure divides itself into the centers of the three systems of the head, thorax, and abdomen, with the addition of the extremities for mechanical movement and prehension, these latter constituting the moment of singularity, positing itself as distinct from the outer world. Structure differentiates itself in accordance with abstract difference into the two directions of inward and outward. Each structure shares in the inward and outward aspects of each system. The outward aspect, as in its own self different, exhibits this difference through the symmetrical duality of its organs and limbs. 1. The whole, as structure completely developed into a self-subsistent individual, is, in this self-related universality, at the same time particularized into the seriatushan, into a relation outwards with another individual. Structure, being self-enclosed, points within itself to its two directions outward. Zusatz. Sensibility, irritability, and reproduction, brought together into the concrete unity of total structure, form the outer configuration of the organism, the crystal of vitality. These determinations are, first of all, merely forms, as in insects where they are cut up into separate parts. Each moment is a total system as a given determinateness, or under one given form. Thus the head is the center of sensibility, the thorax of irritability, and the abdomen of reproduction, and these contain the precious viscera, the interior side of the organism, while the extremities, hands, feet, wings, fins, etc., represent the behavior of the organism in relation to the outer world. Secondly, these centers are also developed totalities, so that the other determinations have the character, not of mere forms, but are displayed and contained in each of these totalities. Each abstract system permeates, and is connected with, them all. Each displays the entire structure. Therefore the systems of nerves, veins, blood, bones, muscles, skin, glands, etc., are each an entire skeleton, and this gives interconnection to the organism, for each system is dominated by the others with which it is interlaced and at the same time maintains within itself the total connection. The head, the brain, has viscera of sensibility, bones, nerves, but there also belong to it all the parts of the other systems. 1 Bichat, Recherches physiologiques sur la vie et la mort, p. 7. Les fonctions de l'animal ferment deux classes tr and distincts. Les uns se composent d'une succession habituelle d'assimilation et d'excrétion. Tu nevit tu en lui, par cette classe de fonctions, par l'autre, il existe hors de lui. Tu sent et apercaridoit ce qui one entoure, rdf ushed ces sensations, se mood volontairement d'après leur influence, etle plus souvent put communiquer par la voix ses sur ses craintes, ses players ouc pains. J'appelle vie organique l'ensemble de fonctions de la première classe, parce que tous les points traces organises, v g tos ou animaux, and jouer sent. Les fonctions relunées de la seconde classe ferment la vie animale, in z nom carat e parce quel est one attribut exclusif du rngne animal. To have brought to notice this distinction in the organism, which Bichat with his great insight into nature has done, reveals a penetrating glance. Blood, veins, glands, and skin. Similarly, the thorax has nerves, glands, skin, etc. In addition to these two distinct forms of these totalities, there is the third form of the totality which belongs to sensation as such, where therefore the psychic character of the organism constitutes the main feature. These higher unities which gather round themselves organs of all the totalities and have their unifying point in the feeling subject, still present great difficulty. There are connections of particular parts of one system with particular parts of the same or another system or systems which, in respect of their functions, are linked together, seeing that on the one hand they form a concrete center, and that on the other hand, the essential nature of their unities, their profounder determination, is to be found in the sentient creature they are, so to speak, psychic ganglia. The soul, as self-determining, is as such present in the body. It does not merely conform to the specific pattern of physical relationships in the body. Thus, example, the mouth belongs to a particular system, that of sensibility, for it contains the tongue, the organ of taste, as a moment of the theoretical process. Further, the mouth has teeth which appertain to the extremities, for their function is to seize outside things and to crunch them. In addition, the mouth is the organ of the voice, of speech. Other cognate sensations, e.g. that of thirst, also have their seat there. Laughing, and kissing too, are also done with the mouth, and thus the expressions of many sensations are unipounded in it. Another example is the eye, the organ of sight, which also sheds tears, as animals also do. Sight and weeping, which are functions of a single organ, may seem remote from one another, but both have the inner ground of their connection in the sentient nature, and have therefore a higher link which cannot be said to lie in the process of the living organism. There are also connections of another kind where phenomena are manifested in the organism in widely separated parts, phenomena connected not physically but only in principle, so that it is said there is a sympathy between such parts, a sympathy which was supposed to be explained by the nerves. But this connection is possessed by every part of the organism, so that such an explanation is inadequate. The connection is grounded in the specific nature of the sensation, and in man, in his spiritual nature. Such a connection is found in the development of the voice and of puberty, a connection which is rooted in the interior aspect of sentient nature, similarly with the tumescence of the breasts in pregnancy. As the non-ancient creature produces relationships here which are not physical, so too it isolates again parts which are physically related to each other. One wills, example, to be active in some part of the body, and this activity is brought about by means of the nerves, but these are themselves branches of nerves connected with many others with which they unite to form a single stem which is connected with the brain. The sentient creature is here, of course, active in all this, but sensation isolates this point of activity, so that the activity results from or by means of these nerves without the rest of the bodily system being involved. Autenrieth cites the following example of this: it is harder to explain crying by internal causes, for the nerves connected with the lacrimal glands belong to the fifth pair which also serve so many other parts in which feelings of sadness fail to produce changes as they do in the lacrimal glands. But the soul has the capacity to act in certain directions from within outwards, even though the direction is not determined by the anatomical connection of the nerves. Thus we can move particular parts of the body in a certain direction by particular muscles connected with many other muscles by common nerve stems, without all these other muscles taking part in the action. And yet it is abundantly clear that the will, in such a case, acts solely through the nerve stem common to them all, the separate fibers of which are interlaced in so complex a fashion that if the nerve is cut or ligatured, the soul no longer possesses any influence on the muscles served by it, even when all the other kinds of connections of these muscles with the rest of the body, e.g. by vessels, cellular tissue, etc., remain undamaged. The factor therefore which stands supreme over the organic interconnection and efficacy of TB systems is the essential nature of the sentient creature, which forms relationships which have no physical reality, or, conversely, intercepts or interrupts relationships which have such reality. There is also symmetry in this structure, but only in its outward turned aspect, one for in the relation to another, self-identity manifests itself only as exact likeness. The distinct moments of structure which go inwards are not only not symmetrically duplicated, but anatomists come across many other diversities in form, size, position, and direction of the internal organs, of the spleen, liver, stomach, kidneys, salivary glands, and the lymphatic vessels in particular, since the number and volume of these are seldom the same in two subjects. 4 In the system of sensibility, observes Bichat quite correctly, the sensory and motor nerves are symmetrical, for they have two similar pairs on each side. Similarly with the sense organs we have two eyes, two ears, and the nose too, is double, and so on. The osseous system also is extremely symmetrical. In the system of irritability the muscles, the female breasts, etc., are symmetrical. Similarly the members of the extremities which subserve locomotion, voice, and mechanical prehension are a pair of similars, such as arms, hands, and legs. The frequent asymmetry of the larynx is described by Bichat as an exception. Most physiologists, Haller in particular, have stated that the cause of a lack of harmony in the voice is the disparity between the two symmetrical sides of the larynx, the inequality of strength in the muscles and nerves, etc. On the other hand, the brain, heart, lungs, ganglia, the internal venous system of reproduction, the abdominal muscles, the liver, and the stomach lack symmetry. The ganglia in particular are signalized by their quite irregular arrangement, i.e. they are not separated into two sides. The sympathetic nerve, says Bichat, whose sole function is to serve the interior life, shows an irregular distribution in most of its branches. The plexus solens, ms lyricus, hypogastricus, splenicus, stomachicus, etc., are examples of this. These symmetrical pairs are not, however, perfectly symmetrical. In human beings particularly, this evenness of configuration is again made asymmetrical by occupation, habit, activity, and intelligence in general. As an intelligent being, man concentrates his efforts mainly on a single point, comes to a point, as it were, but not merely to a mouth for animal nourishment. On the contrary, man alters his shape, turning his individuality outwards and so individualizing his bodily strength at one point of his body and concentrating it on one side for a particular purpose, e.g. riding rather than holding it in equilibrium. Thus human beings are more dexterous with the right arm than with the left, and with the right hand likewise. This naturally has its basis in the position of the right arm in relation to the whole, since the heart is on the left side and is always held back and defended by the right. Similarly, people seldom hear equally well with both ears. The eyes, too, often have different visual acuity, and in human beings the cheeks are seldom quite similar in shape. In animals the symmetry is more marked. Thus there is similarity in limbs and strength, but agility varies. But exercises in which intelligence plays a small part preserve symmetry in their movements. Animals leap with the greatest skill from crag to crag where the very slightest slip would hurl them into the abyss, and they walk with marvelous precision on surfaces which are hardly as wide as the extremities of their limbs. Even those animals which are very ungainly do not stumble as often as man. In them, equilibrium in the motor organs of both sides is even more rigidly maintained than it is in man, who voluntarily introduces inequality. When people acquire intellectual and special skills, e.g. writing a great deal, cultivating music, the fine arts, technical skills, fencing, etc., equilibrium is lost. F on the other hand, cruder, merely physical, exercises like drilling, gymnastics, running, climbing, walking on narrow surfaces, jumping and vaulting preserve this equilibrium, but they do not fit in with the other practices. Because they are thoughtless activities, they are in general obstacles to mental composure and collectedness. In this paragraph we considered structure, first as quiescent, and secondly, in its connection with an other outside it. The third moment is the connection of structure with an other, which at the same time belongs to the same genus, and in which the individual achieves self-feeling in the act of feeling itself in the other. Through the male and female natures, there emerges a determination of the entire structure, a different habitus which, in man, also extends to the spiritual sphere and becomes a distinct natural feature. 356-4. The structural process structure, as alive, is essentially process, and it is, as such, abstract process, the structural process within structure itself in which the organism converts its own members into a non-organic nature, into means lives on itself and produces its own self, i.e. the same totality of articulated members, so that each member is reciprocally end and means, maintains itself through the other members and in opposition to them. It is the process which has for result the simple, immediate feeling of self. Zusatz. The structural process is, as the first process, the notion of the process, formation as an unrest but only as a general activity, as a general animal process. It is true that, as this abstract process, it resembles the process of vegetable life with the external world, in so far as the living creature's power is the immediate transformation into animality of what is external to it. But since the organism, as a developed being, expresses itself in a special articulation, not containing independent parts, but only moments in a living subjectivity, these moments are sublated, negated, and posited by the organism's vitality. This contradiction, that they are and are not, that they have come forth from subjectivity and yet are contained in it, manifests itself as a perpetual process. The organism is the unity of internal and external, so that as internal, it is the structural process, in which the structure is a sublated moment which remains enclosed within the organism's self, the external, the other, the product, has, in other words, returned to that which brought it forth. The organic unity brings itself forth without becoming another individual like the plant, it is a circle which returns into self, the otherness of the organism or the organism as external, is free, quiescent structure, the quiescence or repose which is opposed to the process. The organism itself is the higher repose as a unity of both the restless notion which is self-identical. Now the general structural process consists in this, that the blood in its exhalation lets itself be reduced to lymph, but that the sluggish, indeterminate fluidity of the lymph strengthens and organizes itself. On the one hand, it becomes split in the opposition inherent in muscle, an opposition which is a movement immanent in its structure, and on the other hand, withdraws into the immobility of bone. Fat, bone marrow, is this vegetable substance which goes on to become oil and excludes the neutral from itself, not as water but as an earthy neutrality, as lime, in the same way that the plant goes on to produce silica. Bone is this dead neutrality set between lymph and bone marrow. The individual, however, does not merely convert itself into an object, but equally idealizes this reality. Each part is hostile to the others, maintains itself at their expense, but delivers itself up to them. Nothing in the organism endures, but everything is reproduced, not excepting the bones. Rishrand therefore says of bone formation, if the inner periosteum is destroyed with a stylet, the outer periosteum separates itself from the bone which it covered, appropriates the phosphate of lime brought by the vessels spread through its tissues and forms a new bone round the other. Each organ is so determined as to serve only the general end, the development of the whole living creature. Each member draws on the others for its own needs, for each secretes animal lymph which, discharged into the blood vessels, is brought back into the blood, from this secretion each takes its nourishment. The structural process is thus conditioned by the consumption of the products. When the organism is restricted to this process, as e.g. in disease, where its interaction with the outer world is interrupted, the human being consumes himself, converts himself into aliment. This is the cause of emaciation in disease, for the organism no longer has the power to assimilate its non-organic world but can only digest its own self. Thus in Blumauer's Aeneid, the companions of Aeneas consume their stomachs, and in starving dogs the stomach has been found actually eaten and partly absorbed by the lymphatic vessels. The process in which the organism expends itself and inwardly collects itself goes on without ceasing. It is said that after 5, 10, or 20 years the organism no longer contains its former substance, everything material has been consumed, and only the substantial form persists. The higher unity is, in general, that in which the activity of one system is conditioned by that of another. Many experiments have, example, been conducted to determine to what extent digestion, circulation of the blood, etc., are independent of nervous activity, or respiration is independent of the brain, etc., and the other way round, and whether, therefore, life can still persist if one or the other is stopped, also what kind of influence respiration has on the circulation of the blood, etc. In this connection Treviranus cites the case of a child bomb without heart and lungs, but which had arteries and veins. In the womb it could, of course, have lived in that condition, but not outside it. Now from this example it was concluded that Haller's assertion, that the heart is the sole mainspring of the circulation of the blood was false. This was indeed a fundamental question. But it is questionable whether the blood does still circulate after the heart has been extirpated. Treviranus has carried out a large number of experiments especially on frogs' hearts, but they have yielded nothing except details of the way in which he tortured these animals. Contrary to Haller's opinion that the beating of the heart produces the circulation of the blood, Treviranus asserted that the blood has a motive power of its own dependent on the nervous system, whose continuance requires the uninterrupted influence of the system, especially of the spinal cord star. For if the nerve trunk and spinal cord of a limb are severed, the blood ceases to circulate in this part, from which, therefore, it follows that each part of the spinal cord and each nerve trunk from it sustains the circulation of the blood in those organs which it provides with nerve branches. Legal Lois, who does not seem to have dreamed of the possibility of any other theory than Haller's regarding the circulation of the blood, opposes to Treviranus the hypothesis that the circulation of the blood depends solely on the contractions of the heart, and that partial destruction of the nervous system enfeebles or stops the circulation only through its influence on this organ. In general, he maintains that the heart draws its force from the whole of the spinal cord. 1 Now the experiments made by Legal Lois on rabbits and also on cold-blooded Phloemeu led him to the following conclusion: any part of the spinal cord, that, example in the neck, the chest, or the lumbar region, is certainly very closely connected with the circulation of the corresponding part of the body which receives its motor nerves from that part. But the destruction of such a part has a twofold effect on the circulation of the blood. It weakens the general circulation, since the heart is deprived of the contingent of forces received from the extirpated part of the spinal cord. It at once weakens the circulation in the corresponding part, and then forces the heart, though no longer having the force of the entire spinal cord, to do the same amount of work throughout the extent of the circulation. If, on the other hand, a ligature is applied to the arteries in the part, e.g. the lumbar region, where the spinal cord is destroyed, circulation is no longer necessary there, and since there is spinal cord in the rest of the body, the heart and circulation remain in equilibrium. Life indeed persists in this remaining part for an even longer period, and when Legal Lois destroyed the brain and the cervical spinal cord, circulation continued through the jugular arteries. Thus a rabbit survived more than 3/4 of an hour after decapitation and prevention of hemorrhage, since an equilibrium was produced. These experiments were made on rabbits aged 3, 10, up to 14 days at the most, death occurring earlier in older rabbits. 3 In these last, life has a more intensive unity, whereas in the younger animals life still is more like the life of polyps of opposition, of the particularized principle of air, and of the likewise realized neutrality of concrete water, and of the opposed moments of the dissolution of concrete neutrality smell and taste. The sense of ideality is likewise twofold, since the moment of particularization indispensable to the ideality as abstract self-reference, falls apart into two indifferent determinations: the sense of ideality as a manifestation of the outer for the outer, of light as such, and more precisely of light as being determined in the concrete outer world, i.e. color. And the sense of the manifestation of the organism's inwardness expressed as such in its utterance, the sense of sound, the two senses, then, of sight and hearing. Remark. Here we see how the threefold moments of the notion become fivefold. The more general reason for the transition we have here is that the animal organism is the reduction of inorganic nature, sundered into separate moments, into the infinite unity of subjectivity, in which, however, it is at the same time that nature's developed totality, the moments of which exist separately because the subjectivity is still a natural one. Zusatz, since the immediate unity of the being of the organism and its object is in the first place feeling, the non-objective unity with the object, in which, however, the latter also retains its own independence. This unity is therefore double, the nine ends of shape as shape, and the sense of heat. The differentiation here is only vague, since the other is only the other in general, lacking distinction within itself. The difference therefore the positive and the negative falls asunder as figure or shape, and heat. Feeling is Thursday 9 the sense of the earthy element, of matter, of what offers resistance, in accordance with which I exist immediately a 9 an individual, and the other in it 9 contact with me is also an individual, a material object existing independently, which I 9 how I, too, feel it. Matter yearns for a center, a yearning which is first satisfied in the animal, which has its center within itself. It is just this drivenness of matter, as lacking a self, towards an other, which I sense. Here, too, belong the particular ways of offering resistance, softness, hardness, elasticity, smoothness or roughness of surface, figure and shape, too, are simply nothing else than the way is which this resistance is spatially limited. In feeling, these determinations, treated by us in their various spheres, are bound together as in a bouquet, for as we have already seen, sentient nature has just this power of binding together several disparate spheres. Smell and taste have a close affinity, even in regard to their organs, for nose and mouth are intimately connected. Whereas feeling is the sense of the indifferent existence of things, smell and taste are the practical senses, whose object is the real being of things for an other by which they are consumed. In light a thing only manifests itself immediately as an immediate existence. But the manifestation of the organism's inwardness, namely, sound, is the explication, the bringing forth, the manifestation of the inwardness as inwardness. In sight, the physical 9 manifests itself spatially, and in hearing, temporally. In hearing, the object ceases to be a thing. We see the same thing with 2 eyes because they see the same thing, they make their 9 of the object into one 9 as many arrows hit only one point, it is precisely the unity of direction which cancels the diversity of 9 and 9ation. But it is just possible to see an object doubled if in the field of vision the eyes are fixed on something else. If I, for example, fix my eyes on a distant object and at the same time pay attention to my finger, I am aware of my finger without changing the slant of my eyes and see both objects at once. This awareness of the whole field of vision is unfocused vision. There is an interesting essay on this by Regius Professor Schultz in Schweiger's journal. The tetrad, NS the developed totality of the notion in nature, goes on to become a pentad in so far as its moment of difference appears not only doubled but even as tripled. We could also have begun with the sense of ideality, it manifests as a duality because, though abstract, it should also be the totality. If, therefore, we began in nature with the ideal asunder-ness of space and time, which are 2 because the notion is concrete, so we have now, on the one hand, the sense of physically determined space, and on the other hand, the sense of a physical time. Space is here determined in accordance with the physical abstraction of light and darkness, time as an inner vibration, the negativity of the organism's inwardness. The second member in the group totality of the senses, smell and taste, retains its place, and feeling is then the third. The arrangement is more or less immaterial, the main point is that the senses, a 9 rational, constitute a totality. Because, therefore, the sphere of the theoretical process is determined by the notion, there cannot be more senses, though some can be missing in the lower animals. The sense organs qua feeling constitute the general sense of the skin, taste is the muscle of the tongue, the neutrality which connects itself with the mouth, i.e. with the incipiently internalized skin, or with the retracted vegetative universality of the entire surface. The nose, qua organ of smell, is connected with the principle of air and with breathing. Whereas feeling is the sense of shape in general, taste is the sense of digestion, of the passage inwards of what is outer, smell belongs to the inner organism as the principle of air. Sight as a sense does not spring from an earlier function but is, like hearing, a sense of the brain. In eye and ear sense is related to its own self, but in the former case, the external object is an indifferent self, while in the latter, it is a self-sublating self. The voice, as active hearing, is the pure self positing itself as universal, expressing pain, desire, joy, contentment. Every animal suffering violent death has a voice, and thereby declares its own supersession. In voice, sense returns to inwardness and is negative self or desire, the feeling of its insubstantial nature as mere space, whereas the senses are saturated, filled space. The real process or practical relationship with non-organic nature begins with the diremption of the organism within itself, with the feeling of externality as negation of the subject, which is at the same time positive self-relation and the certainty thereof in face of this its negation, in other words, the feeling of lack and the urge to get rid of it. In this there is manifest a condition of an external stimulation and the negation of the subject posited in it in the form of an object against which the subject is braced. Remark. Only what is living feels a lack, for in nature it alone is the notion, the unity of itself and its specific opposite. Where there is a limitation, it is a negation only for a third, for an external parison. But it is a lack only in so far as the lack's overcoming is equally present in the same thing, and contradiction is, as such, immanent and explicitly present in that thing. A being which is capable of containing and enduring its own contradiction is a subject. This constitutes its infinitude. Even when reference is made to finite reason, reason demonstrates its infinitude in the very fact that it characterizes itself as finite, for negation is finitude, a lack only for that which is its accomplished sublation, infinite self-reference. Thoughtlessness stands still at the abstraction of the limitation, and in life, too, fails to grasp the notion. Though in life the notion enters into existence, it sticks to the determinations of ordinary thought such as impulse, instinct, need, etc., without inquiring what these determinations in themselves are. But the analysis of their concept will show that they are negations posited as contained in the affirmation of the subject itself. An important step towards a true conception of the organism is the substitution of the concept of stimulation by external potencies for that of the action of external causes. The former concept contains the seed of idealism, which asserts that nothing whatever can have a positive relation to the living being if this latter is not in its own self the possibility of this relation, i.e. if the relation is not determined by the notion and hence not directly immanent in the subject but of all the concoctions of external reflection in the sciences. None is more unphilosophical than the introduction of such formal and material relationships in the theory of stimulation as have long been regarded as philosophical, the introduction, for example, of the wholly abstract opposition of receptivity and active capacity, which are supposed to stand to each other as a 385 factors in inverse ratio of magnitude. 1 The result of this is to reduce all distinctions within the organism to the formalism of a merely quantitative difference, a matter of increase or decrease, of intensification or attenuation, depriving them, in other words, of every possible trace of the notion. A theory of medicine built on these arid determinations of the understanding is complete in a half-dozen propositions. It is no wonder that it spread rapidly and found many adherents. The cause of this aberration lay in the fundamental error of first defining the absolute as the absolute indifference of subject and object, and then treating all determinations as only quantitative differences. The truth is rather that the absolute form, i.e. the notion and principle of life, has for its soul only and solely the qualitative difference which sublates itself, the dialectic of absolute opposition. The failure to recognize this genuine negativity can lead to the belief that it is impossible to hold fast to the absolute identity of life without converting the moment of difference into a product of merely external reflection, as is the case with Spinoza's attributes and modes which present themselves in an external intelligence, with the result that life then altogether lacks the punctum saliens of selfhood, the principle of self-movement, of self-differentiation. Another crude and thoroughly unphilosophical procedure was that which simply substituted carbon and nitrogen, oxygen and hydrogen, for the determinations of the notion, and then further defined the difference hitherto characterized as intensive, as a more or less of one or the other substances, the active and positive relation of the external stimulus, however, being defined as an addition of a deficient substance. In an asthenia, e.g. a nervous fever, the nitrogen in the organism is supposed to have the upper hand because brain and nerve generally are supposed to be potentiated nitrogen, chemical analysis having shown this to be the principal ingredient of these organic structures. The ingestion of carbon is therefore supposed to be indicated in order to restore the balance of these substances, i.e. health. The remedies which empirical medicine has found effective in the treatment of nervous fever are, on these same grounds, regarded as belonging to the carbon side, and this kind of superficial collocation and mere opinion is put forward as philosophical construction and proof. The crudity of this procedure consists in taking the caput mortuum in its ultimate form, the dead substance, the life already destroyed, on which chemistry has inflicted a second death, for the essence of a living organ, and, indeed, for its notion. It is this ignorance and contempt for the notion which, in general, gives rise to the facile formalism that, in place of the determinations of the notion, makes use of sensuous materials such as chemical substances, as well as relationships belonging to the sphere of inorganic nature, such as the north and south poles of the magnet, or even the difference between magnetism itself and electricity, a formalism which, in its apprehension and exposition of the natural universe, attaches externally to its various spheres and differences a ready-made schema compounded of such material. For this purpose, a great variety of forms is possible, for it remains a matter of choice whether one employs for the schema determinations as they appear in the chemical sphere, e.g. oxygen, hydrogen, etc., transferring them to magnetism, mechanism, vegetable and animal life, etc., or whether one takes opposites from any one sphere, e.g. magnetism, electricity, male and female, contraction and expansion, and then applies them to the other spheres. Zusatz. The practical process, it is true, is an alteration and overcoming of the outer inorganic nature in its independent material existence, but it is nonetheless a process of unfreedom, because LQ animal appetite the organism directs itself outwards. People believe that it is in the will that they are free, but it is just in willing that they are in relationship with the reality outside them. It is only in the reasonable will, which is theoretical, as in the theoretical process of the senses, that man is free. What is primary, therefore, in animal appetite is the subject's feeling of dependence, that it is not for itself, but stands in need of an other which is its negative, and this not contingently but necessarily. This is the unpleasant feeling of need. The defect in a chair which has only 3 legs is in us, but in life, the defect is in life itself, and yet it is also sublated because life is aware of the limitation as defect. It is thus a privilege of higher natures to feel pain. The higher the nature, the more unhappiness it feels. The great man has a great need, and the urge to rid himself of it. Great deeds come only from profound mental suffering. Here may be found the solution to the problem of evil, etc. The animal is thus, in the negative, at the same time positively at home with itself, and this, too, is the privilege of higher natures, to exist as this contradiction. But equally, too, the animal restores its lost harmony and finds satisfaction within itself. Animal appetite is the idealism of objectivity, so that the latter is no longer something alien to the animal. The external manner of apprehension referred to in the paragraph plays a part even in Schelling's philosophy, in that he often carries his parallels too far. Oken, Troxler, and others lapse completely into an empty formalism, as when Oken, as we have already seen, calls the woody fibers of plants their nerves, or when the roots of the plant are called its brain. Similarly, the brain is supposed to be the human sun. In order to express the concept of an organ of vegetable or animal life, the name is taken, not from the sphere of thought, but from elsewhere. But one should not fall back again on sensuous forms for the purpose of determining other forms. It is from the notion that they must be derived. Need is something specific, and its determinateness is a moment of its universal notion, though particularized in an infinite variety of ways. An urge is the activity of getting rid of the defect of such determinateness, i.e. getting rid of its initially merely subjective form. In that the content of the determinateness is primary, and preserves itself in the activity through which it is only carried into effect, it is end or purpose, and the urge, as only in the living being, is instinct. This formal defect is the inner stimulus, whose determinateness, specified in accordance with the content, is at the same time a relation of the animal to the particular individualized forms of the various spheres of nature. Remark. The mystery thought to occasion the difficulty in understanding instinct is simply this, that an end can be grasped only as an inner notion, so that explanations and relationships stemming from mere understanding soon reveal their ineptness in regard to instinct. The basic determination of the living being seized on by Aristotle, that it must be conceived as acting purposively, has in modern times been almost forgotten till Kant, in his own way, revived this concept in his doctrine of inner teleology, in which the living being is to be treated as its own end Selbstzweck. The difficulty here comes mainly from representing the teleological relationship as external, and from the prevalent opinion that an end exists only in consciousness. Instinct is purposive activity acting unconsciously. Zusatz. Since an urge can be carried out only by quite specific actions, this appears as instinct, in that it seems to be a choice guided by a purpose. But because the urge is not a known end, the animal still does not know its ends as ends, and that which unconsciously acts in accordance with ends Aristotle calls jnkns. 389. In so far as a need is a connection with the universal mechanism and abstract powers of nature, instinct is only an inner, not even a sympathetic stimulus. But, as the animal's relation to its non-organic individualized nature, instinct as such is determinate, and in its further particularization is restricted to only a limited sphere of the universal non-organic nature. Instinct is a practical relationship to this, an inner stimulus associated with the show of an external stimulus, and its activity is partly a formal and partly a real assimilation of non-organic nature. Zusatz. Waking and sleep are not the result of an external stimulus but are an unmediated participation in the life of nature and its changes, a resting of the organism within itself and a separation of itself from the outer world. Similarly, the migrations of animals, e.g. of fishes to other seas, are a participation in the life of nature, a movement zug, within nature itself. Sleep is not preceded by a need, by a feeling of lack. One falls asleep without actively setting about doing so. It is rightly said that animals sleep out of instinct and also gather food for the winter. This, too, is the same kind of participation as waking. The lower tier organism, the more it participates in this life of nature. Primitive peoples are sensitive to the course of nature, but spirit turns night into day, and so, too, the moods of the seasons have less influence on higher organisms. Intestinal parasites, found at certain seasons of the year in the liver and brain of the hare or deer, are a weakness of the organism in which one part develops a separate life of its own. Because the animal lives sympathetically in the universal course of nature, it is not so absurd to speak of a connection of animal life with the moon and with terrestrial and sidereal life, and to see a presage in the flight of birds, e.g. at time of earthquakes. Thus certain creatures have a foreknowledge of the weather. Spiders and frogs, for example, are weather prophets. Man, too, feels a coming change in the weather in a weak spot, e.g. a scar. The change is already there and manifests itself in man, even though it has not yet come into existence as a change of weather. An urge in a particular animal is wholly determinate. Each animal has only a restricted sphere for its non-organic nature, which exists for that animal alone and which it must seek out by instinct from its complex environment. In the lion, it is not merely the sight of a deer that awakens the desire for it, nor the sight of a hare in the case of the eagle, nor calm, rice, grass, oats, etc., with other animals, nor is the desire a choice. The urge is rather so immanent in the animal that this specific determinateness of the grass, and moreover of this grass, this calm, etc., is in the animal itself, for which everything else simply does not exist. Man, as the universal thinking animal, has a much more extensive environment and makes all objects his non-organic nature and objects for his knowing. Undeveloped animals have only elemental nature, water, for their non-organic nature. Lilies, willows, fig trees have their own particular insects whose non-organic nature is entirely restricted to such plants. The animal can be stimulated only by its own non-organic nature, because for the animal, the opposite can be only its opposite. What is to be recognized is not the other as such, but each animal recognizes its own other, which is precisely an essential moment of the peculiar nature of each. 362 Instinct, in so far as it is directed to formal assimilation, impresses its specific nature on the details of its outer world and gives them, as material, an outer form appropriate to the end, leaving their objectivity untouched. But it is a real process in so far as it individualizes inorganic things or relates itself to those already individualized and assimilates them, consuming them and destroying their specific qualities. The process with air, with water, and with individualized earthy, i.e. particular formations of it. Life, the subject of these moments of the totality, develops inwardly a tension between itself as notion, and the moments of a reality external to itself, and is the perpetual conflict in which it overcomes this externality. In this relationship, the animal comports itself as an immediate singular, and because it can only overcome single determinations of the outer world in all their variety, its self-realization is not adequate to its notion, and the animal perpetually returns from its satisfaction to a state of need. Zusatz. The animal itself determines its place for resting, sleeping, and bearing its young. It not only changes its place but makes its own place. In doing so, the animal is practically related to the outer world, and this purposive determining is its inner urge put into action. The real process is at first a process with the elements, for the outer world itself is, in the first instance, universal. The plant stops at this process with the elements, but the animal goes on to the process of singularity. We could also include in these processes the relation to light, for this too, is an outer, elemental power. But for animal and man, light as such is not the same power as it is for the plant nature. On the contrary, because man and animal see, light, this self-manifestation of objective form, is external to them, but in the theoretical process their relation to it is ideal. It is only on the color of feathered creatures and on the color of animal pelts that light exerts an influence. The black hair of the Negro, too, is an effect of climate, of heat and light. The blood of animals and their colored fluids are also subject to this influence. On the color of plumage, Goethe has remarked that this is determined by the action of light as well as by internal organization. Speaking of the colors of organic structures in general, he says, white and black, yellow, orange, and brown, alternate in a variety of ways, yet their appearance is never one such as to remind us of the elementary colors. They are all rather a mixture of colors resulting from an organic concoction, and they indicate more or less the level of development of the creature to which they belong. Markings on the skin are connected with the internal parts which they cover. Mollusca and fish have more elementary colors. Warmer climates, which affect even the water, bring out the colors of fishes, beautify and intensify them. In Otaheite, Forster saw fish whose surface showed a beautiful play of color, especially at the moment of death. The fluid in mollusks has the peculiar property of appearing, when exposed to light and air, first yellowish, then greenish. It then turns to blue, and from blue to violet, but always assumes a deeper red, and finally, under the action of the sun, especially when spread on cambric, takes on a pure, deep red hue. The action of light on the plumage of birds and their colors is altogether remarkable. In certain parrots, for example, the breast feathers are really yellow, but the part which stands out like a scale and which catches the light is intensified from yellow into red. Thus the breast of such a bird looks deep red, but if one blows into the feathers, the yellow color appears. There is thus a very marked difference between the uncovered part of one Goethe's Farbenlayer reads never, which Hegel misquotes as not. Asterisk the Farbenlayer reads immer, which is misquoted as whiter. 39 asterisk organics the plumage and the part covered up and not in movement, so that, example in ravens it lb, in fact, only the uncovered part which has colored feathers, and, using this as a guide, it is possible to rearrange at once in their proper order the tail feathers, if they have been thrown into a heap while the process with light remains this ideal process. The process with air and water is a process with material substance. The skin process is the advancing vegetative process which erupts into hair and feathers. The human skin is less hirsute than that of the animal, but bird plumage especially is a taking up of vegetable life into animal life. The quills not only grow to a considerable size, but they are all covered with branches, and this makes them true feathers. Many of these branches and tufts are subdivided again, everywhere reminding us of the plant. The surface of the human being is smooth and clean, and in the finest specimens allows the beautiful form to be seen, except for a few places which are more decorated with, than covered by, hair. An excessive amount of hair on chest, arms, and legs is an indication of weakness rather than strength, for it is probably only the poets who, misled by the appearance of a nature in other respects intensely animal, have occasionally brought such hirsute heroes to honor among us. 1 The respiratory process is a spontaneously interrupted continuity. Exhalation and inhalation is a volatilization of the blood, the volatilizing irritability, the transition into air is started and retracted. The mudfish Cobotes fossilis breathes through the mouth and exhales through the anus. 3 The gills by which fishes decompose water are also a secondary, respiratory organ analogous to the lungs. The entire bodies of insects are pierced by air passages with openings on both sides of the stomach. Some which live under water collect a supply, keep it under their wing coverage or in the fine hair on the abdomen. 4 Now why is the blood connected with this ideal assimilation of the abstract element? The blood is this absolute thirst, its unrest within itself and against itself. The blood craves to be ignited, to be differentiated. More exactly, this assimilation is at the same time a mediated process with air, namely, a conversion of air into carbon dioxide and venous blood, and into arterial, oxygenated blood. The activity and animation of the arterial blood I attribute not so much to its material alteration as to its satiation, that is to 9 the blood, after the manner of the other digestive process, perpetually appeases its hunger or quenches its thirst and achieves being for self through negativity of its otherness. Air is in itself the fiery and negative element, the blood is the same thing, but as a developed unrest. The burning fire of the animal organism which not only consumes itself but also preserves itself as fluid and finds in air its pabulum vitae. Venous blood injected into arterial blood therefore paralyzes action. In corpses, in place of red blood, almost pure venous blood alone is found. In apoplexy, it is found in the brain. This is not caused by a trifle more or less of oxygen or carbon. 1 In scarlet fever, on the contrary, the venous blood too is scarlet red. But now the true life of the blood is the continuous conversion of arterial and venous blood into each other, in which process the small vessels develop the greatest activity. 1 In various organs, there occurs a more rapid transformation of arterial blood into venous blood, and often into venous blood whose characteristic properties are present in a higher degree than elsewhere, as, example in the spleen, without the walls of the vessels showing in a higher degree the normal influence of the oxygen of the arterial blood. On the contrary, they are softer, almost pulpy. The thyroid gland, taken as a whole, possesses greater arteries than any other part of the human body. This gland in its own small space converts large quantities of arterial blood into venous 3. Since the vessels of this gland do not get harder, as they should, what becomes of the oxygen of the arterial blood? It does not exercise any external chemical action. The process with water is the demand for the neutral element, on the one side, to counteract the abstract heat within itself, and on the other, to counteract the specific taste of which one wants to get rid, for that is why one drink's urge is only instinct when it relates its self to an individualized object. But whereas in such relationship the momentarily satisfied need always recurs, spirit finds its satisfaction in the cognition of universal truths, in a universal manner. 363 The process begins with the mechanical seizure of the external object. Assimilation itself is the conversion of the externality into the self-like unity. Since the animal is subject, unitary negativity, the nature of assimilation can be neither mechanical nor chemical, for in these processes both the material substances and the conditions and activity remain external to each other and lack living, absolute unity. Zusatz. The appetitive organism which knows itself as the unity of itself and the object confronting it, and so sees into the determinate being of the other, is structure turned outwards and provided with weapons. Whose bones and achin have made themselves into teeth and claws residential-pectively. The process with claws and teeth is still mechanical, but the saliva already makes the process organic. It ha long been the fashion to give a mechanical explanation of the process of assimilation, as also of the circulation of the blood, or to explain the action of the nerves as if they were taut strings which vibrated, but a nerve is quite slack. Another explanation is that the nerves are a series of globules which when pressed, push and displace one another, the last globule impinging on the soul. The soul, however, is omnipresent in the body and its ideality is such that the outer separated existence of bones, nerves, and veins has no significance for it. To assign finite relationships to life is therefore even more strikingly out of place than when, as we saw in the case of electricity, it is imagined that the processes in the upper atmosphere are similar to those carried out in a laboratory. Similarly, attempts have been made to reduce digestion to a matter of pressing, pumping, and so on, but in that case it would imply an external relationship of inner and outer, whereas the animal is the absolute self-identity of life, not a mere composition or aggregate. Recently, chemical relationships have been employed, but assimilation cannot be a chemical process either, because in a living being we have a subject which preserves itself and negates the specific quality of the other, whereas in the chemical process, each of the substances taking part, acid and alkali, loses its quality and is lost in the neutral product of the salt or returns to an abstract radical. There the activity is extinguished, but the animal, on the contrary, is a lasting unrest in its self-relation. Digestion can, indeed, be grasped as a neutralizing of acid and alkali. It is correct to say that such finite relationships begin in life, but life interrupts them and brings forth a product which is other than chemical. Thus there is moisture in the eye which refracts light. These finite relationships can therefore be pursued up to a certain point, but then there begins a quite different order of things. Again, chemical analysis can discover a good deal of nitrogen in the brain. Similarly, analysis of exhaled air reveals ingredients other than those contained in inhaled air. The chemical process can thus be followed up even to the point of decomposing the separate parts of the living being. Nonetheless, the processes themselves should not be regarded as chemical, for chemistry applies only to what is lifeless, and animal processes always sublate the nature of what is chemical. The mediations which occur in the living being, like those in the meteorological process, can be followed up for some distance and demonstrated, but this kind of mediation cannot be imitated. Because the living being is the universal power over its outer nature which is opposed to it, assimilation is, first, the immediate fusion of the ingested material with animality, an infection with the latter and simple transformation. Secondly, as mediation, assimilation is digestion opposition of the subject to the outer world, and, as further differentiated, the process of animal water and of animal fire, processes which are, all the same, particularized infections. But T9 involvement with the outer world, the stimulus, and the process itself, has likewise the determination of externality over against the universality and simple self-relation of the living being. This involvement itself therefore constitutes, properly speaking, the object and the negative over against the subjectivity of the organism, which the latter has to overcome and digest. This inversion of attitude is the principle of the organism's reflection into itself. The return into self is the negation of its outward directed activity. It has a double determination. On the one hand, the organism separates from itself the activity in which its conflict with the externality of the object is manifested, and on the other, as immediately identical with this activity, it has become for itself has in this means reproduced itself. The process outwards is thus transformed into the first, formal process of simple reproduction from its own self, into the uniting of itself with itself. Remark. The chief moment in digestion is the immediate action of life as the power over its non-organic object which it presupposes as its stimulus only in so far as it is in itself identical with it, but is, at the same time, its ideality and being for self. This action is infection and immediate transformation. To it corresponds the immediate seizure of the object pointed out in the exposition of purposive activity. This immediacy with which the living being as a universal, continues itself into its food without any further mediation, by its mere contact with it and by simply taking it into the heat of its own sphere, has also been empirically demonstrated and shown to accord with the notion by the experiments of Spallanzani I and others, and by recent physiology a refutation of the theory of a merely mechanical and fictitious sorting out and separating of parts already assimilable, and of the theory of a chemical process. But investigations of the intermediary processes have not revealed more specific moments of this transformation. It has, on the contrary, been shown, example, that a great deal of food passes straight from the stomach into the mass of gastric juices without having passed through the other intermediate stages, that the pancreatic juice is nothing more than saliva and the pancreas could quite well be dispensed with, etc. The final product, the chyle which is received into the thoracic duct and discharged into the blood, is the same lymph which, secreted by each intestine and each organ, is obtained from every part of the skin and the lymphatic system in the immediate process of transformation and is everywhere found already prepared. The lower forms of animal life which, moreover, are nothing more than lymph coagulated into a membranous point or tube, a simple intestinal canal, do not go beyond this immediate transformation. The mediated digestive process in more highly organized animals is, in respect of its characteristic product, just such a superfluity as, in the plant, the production of seeds through the so-called difference of sex. THT faces often show, especially in children, in whom moreover the increase of material is most prominent, the greater part of the food unchanged, mixed mainly with animal substances, bile, phosphorus, and the like, and the chief action of the organism to be to overcome, and get rid of, what has itself produced. The syllogism of the organism is, therefore, not the syllogism of external teleology, for it does not stop at directing its activity and form against the outer object, but makes this very process, which is on the point of lapsing into a mechanical and chemical one, into an object. This behavior was expounded as the second premise in the universal syllogism of purposive activity. The organism is a uniting of itself with itself in its outward process. From it takes and wins nothing but chyle, its general animalization referred to above, and as the self-existent living notion, it is thus no less a disjunctive activity which rids itself of this process, draws away from its anger towards the object, from this one-sided subjectivity, thereby becoming explicitly what it is implicitly, the subjective, not neutral, identity of its notion and its reality, and thus finds the end and product of its activity to be that which it already is at the beginning and originally. In this way, the satisfaction conforms to reason, the process outwards into external difference is converted into the process of the organism with itself, and the result is not the mere production of a means but of the end union of the organism with itself. Zusatz. Here the alimentary process is the main thing, the organism is in a state of tension with its non-organic nature, negates it and makes it identical with itself. In this immediate relation of the organic to the non-organic, the former is, as it were, the direct melting of the non-organic into organic fluidity. The ground of every reciprocal relation between these two is just this absolute unity of the substance through which the non-organic is thoroughly transparent, ideal, and non-objective for the organic. The alimentary process is merely this transformation of the non-organic nature into a corporeality belonging to the subject, but then it also manifests itself as a process passing through a number of phases, a process which is no longer direct transformation but seems to employ means. The animal nature is the universal over against particular natural existences which, in this animal nature, are in their truth and ideality, for the animal nature is actually what these forms are implicitly. Similarly, because all men are implicitly rational, they are subject to the power of that man who appeals to their instinct of reason, since what he reveals to them is something corresponding to this instinct, something which can harmonize with the reason he has explicated. Because the people directly accept what is imparted to them, reason manifests itself in them as a propagation and infection, and so the rind, the illusion, of a separation, which had previously obtained, vanishes. This power of animality is the substantial relation, the main thing in digestion. If, therefore, the animal organism is substance, then the non-organic is merely accident, whose peculiarity is only a form which it immediately surrenders. We know from experience that sugar, vegetable gums, and oils, nutritious substances, therefore, which contain little or no nitrogen, are none the less converted into animal substance which contains a large quantity of nitrogen. For there are whole races which live solely on a vegetable diet, just as others live entirely on meat. But the temperate nature of the former demonstrates that their body does not merely retain that small ingredient in their food resembling animal substance which is present in every plant, and excretes the remainder, but that it elaborates a large part of this vegetable food into nutriment appropriate to its organs. The animals and plants which the animal consumes, are, true, themselves organic structures, but for this animal they are relatively its non-organic nature. What is particular and externa has no enduring existence of its own, but is a nullity as soon as it comes into contact with a living being, and this, transformation is merely the revelation of this relationship. It is on this immediate transition and transformation that all chemical and mechanical explanations founder and in which they find their limit, for such explanations take into account only those data which are already externally similar. The truth is rather that the two sides exist in complete freedom from each other. Bread, example, has in its own self no connection with the body, or the chyle, the blood, is something wholly different. Neither chemistry nor mechanics can follow empirically the alteration of food to the point where it is changed into blood, no matter what methods they employ. True, chemistry extracts something of a similar nature from both of them, possibly albumin, perhaps iron, too, and the like, or oxygen, hydrogen, nitrogen, etc., or it extracts from the plant substances also found in water. But the two sides are at the same time simply different, and therefore wood, blood, flesh, are still not the same thing as these other substances, and blood which has been analyzed into these constituents is no longer living blood. The quest for what is similar and the continued pursuit of it is abruptly halted, for the reality of the substances completely vanishes. If I decompose a salt, I obtain again the two substances of which it was composed. The salt, therefore, is thereby explained, and the substances have not become something else in the salt but have remained the same. In the organism, however, this becoming something else on the part of non-organic substances is made explicit. Because the non-organic being is only a sublated moment in the organic self, it has to be taken into account, not as what it immediately is, but as what it is in its notion, but in its notion, it is the same as organic being. This is exhibited in organic assimilation. Food which is subjected to the influence of organic life is dipped in this fluid and itself becomes this dissolved fluid. Just as a thing becomes an odor, a dissolved matter, a simple atmosphere, so, in the organic sphere, it becomes a simple organic fluid in which nothing more is to be found of the thing or its constituents. This organic fluid which remains self-same is the fiery nature of the non-organic which therein directly returns into its notion. For eating and drinking convert non-organic things into what they are in themselves. It is an unconscious seizure of them, and the reason why they become such sublated moments is that they are such in themselves. This transition must also exhibit itself as a mediated process in which the terms of its opposition are developed. But the basis of it is that the organism directly draws the non-organic into its organic matter because it is the genus as a simple self and hence is the power over the non-organic. If the organism does bring the non-organic into an identity with itself gradually through separate stages, this complex arrangement of digestion through the intermediation of several organs is, for the non-organic, indeed superfluous, but it is not so for the organism which progresses through these moments within itself for its own sake in order to be movement and consequently actuality, just as the strength of the spirit is measured only by the extent of the opposition it has overcome. But the fundamental relation of the organism is the simple contact in which the other is transformed directly and at a stroke. The lower animals act still without any special organs like bile, gastric juice, for the special activities connected with the assimilation of food. Water is already absorbed through the skin in the process with air as is seen in many worms and zoophytes, thus water on which polyps, example feed is directly turned into lymph, jelly. The simplest mode of nutrition through a single mouth is found in Hydra, Brachiopoda, and Vorticella. The Hydra feeds on small aquatic animalcules which it seizes with its tentacles. The sac-shaped receptacle which comprises most of its body opens and receives the prey. This has hardly been swallowed before it is changed, it is transformed into a homogeneous mass and continually loses volume in the process. Anally the polyp opens its mouth again and evacuates part of the ingested food along the same way in which it entered the Hydra's stomach. This rapid decomposition of what has entered the stomach takes place even when, as not infrequently happens, the creatures swallowed are long worms only half of which can be contained by the stomach. The one half then often still tries to escape, the other half being already digested. In fact, the polyp is also able to digest with its outer surface. It can be turned inside out like a glove, and the inner surface of its stomach made the outside, and yet the phenomena referred to still take place as before. An intestine of this kind is merely a canal of so simple a structure that one cannot differentiate between esophagus, stomach, and intestines. But after the alimentary canal, there is no vital organ so common throughout the whole animal kingdom as the liver. It is found in every mammal, bird, amphibian, fish, and mollusk. Even in the class of worms, the Aphrodites seem to possess bile-secreting organs in the pockets confining a dark green bitter juice, which border both sides of their intestinal canal. There are similar pockets on the alimentary canal of the sea cucumber, and again an actual liver is found in the starfly and H. In insects, the vessels which can be regarded as biliary vessels seem to take the place of the liver. Others attribute another function to these vessels. Although with many zoophytes there is no visible excrement, there can be no doubt that in all of them an evacuation of gaseous matter connected with nutrition takes place through the achin and the respiratory organs. Nutrition and residential pyration are thus closely connected. Also higher up the scale of animal life we find this immediate assimilation. It is a familiar experience in the catching of thrushes and field fares that when they are quite thin, on a misty morning, they get quite fat in the space of a few hours. This is a direct transformation of this moisture into animal matter which takes place without any further elaboration or passage through the separate moments of the process of assimilation. Man, too, directly assimilates as is shown by the account of the English ship at sea, the crew of which, having used up all their water, and finding the rain-water laboriously collected in the sails inadequate, quenched their thirst by moistening their shirts and even dipping themselves in the sea. Their skin, therefore, had absorbed pure water from the sea without the salt. In animals provided with specific digestive organs there occurs partly this general assimilation as such and partly a special separate digestive process, In the latter, it is organic heat which initiates assimilation. But the stomach and intestinal canal are themselves nothing else but the outer skin, only reversed and developed and shaped into a peculiar form. The more detailed comparison of these various membranes is to be found in Treviranus. Ipecacuan ha, opium, rubbed in on the outside of the stomach has the same effect as when taken internally, but ipecacuan ha has also been rubbed in the shoulder and has been equally well assimilated. It has been observed that small bits of meat enclosed in small linen bags and placed in the abdominal cavity of a live cat, were dissolved, down to tiny bits of bone, into a pap in a similar way as if in the stomach. The same thing happened when such meat was conveyed subcutaneously onto bare muscles of live animals and left there for a time. This seems to resemble what happens in leg fractures where nature discharges a quantity of moisture round the fracture, softening and quite dissolving the sharp ends of the bones, and another instance is that congealed blood in contused parts of the body which have healed over, is gradually dissolved and liquefied, finally being reabsorbed. The gastric juice does not act therefore as a quite special kind of fluid different from any other kind of animal fluid, but only as a watery fluid plentifully supplied to the reservoir of the stomach by the exhalatory arteries. It is a secretion from the arterial blood which shortly before had been exposed in the lungs to the action of oxygen from the air. 1 Treviranus also remarks, bones, flesh, and other animal parts which P. Smith introduced into the abdominal cavity or under the skin of live animals, were there completely decomposed. This affords an explanation of a remarkable observation made by Cuvier on Salpa octophora. He found in the interior of many of these creatures, but outside of the stomach, parts of an anaphor all of which, down to the outer skin, had decomposed and vanished and which presumably had entered through the orifice through which the salpas take in water. These creatures have, indeed, a stomach. But perhaps they digest quite as well outside as inside it and form the transition to those organisms in which respiration, digestion, and several other functions take place through one and the same kind of organ. Spallanzani's experiments were aimed at finding an answer to the question whether digestion is effected by solvent juices or by trituration performed by the stomach muscles or by both. To decide this, he administered food to turkeys, ducks, chickens, etc., in latticed or perforated metal tubes or spheres so that the gastric juice could reach it. Since the grain was never digested but only became more bitter, he concluded that digestion results from the violent pressing and pushing of the walls of the stomach. Now since in these experiments the hardest bodies like metal tubes and glass balls, even pointed and cutting objects, were triturated by the stomachs of these creatures, it was believed that the many small stones, as many as 200 even, which are often found in the stomachs of such animals help to triturate the food. Now to refute this hypothesis, Spallanzani took young pigeons which could not yet have swallowed any stones from their parents' beaks, he also saw to it that their food contained none, and shut them up to prevent them from looking for any, and yet even without the stones the birds were able to digest food. I began to mix hard objects with their food, some iron tubes, glass balls, small bits of glass, and although not a single small stone had been found in the stomachs of these pigeons, yet the metal tubes were worn away, and the glass balls and bits of glass broken up and rubbed smooth without leaving the slightest trace of injury to the walls of the stomach. 2 Drinks in particular are digested in 2 different ways. Drink exudes through the walls of the stomach and the cellular tissue to the urinary vessels and is excreted through them. There is a fund of experience on this subject. Beer is a diuretic. Asparagus imparts a special odor to the urine only a few minutes after ingestion. This is the effect of immediate assimilation by the cellular tissue. Afterwards the smell passes off and 1 Autenrieth, LOCCIT, Part 2, 597 8** experiences sur la digestion de vicomité de différences x's d'aninoducs, par Vabi Spallanzani pages 127. Does not reappear until 8 to 12 hours later when digestion proper and the discharge of excrements is completed. Another instance of this immediate assimilation is that cited by Treviranus. Of 5 ounces of water injected into a dog, 2 were vomited, 1 was still left in the stomach, So that too must have found an exit, though the walls of the stomach * the greater the homogeneity of the food, example meat dishes, the easier is immediate assimilation. Animal lymph, as the universal element of animality, is that into which the non-organic is directly transformed. The animal digests the food from outside just as well as it digests its own viscera, muscles, nerves, etc., even absorbing bones, which are phosphate of lime, e.g. bone splinters in a fracture. It destroys the specific particularity of these products and turns them into the general lymph, into blood, and this it specifies again into particular products. The other form of digestion involves mediation, and this occurs only in more highly organized animate. Its proximate moments are also, of course, actions of the organism against the outer world, but it is no longer a general but a particular operation of particular animal products like the bile, pancreatic juice, etc. However, this mediatory activity is not merely a passing through the organism like, example the passage through the four stomachs in ruminants, nor does it consist of distinct operations and changes, of various stages of organic cooking which the food passes through as if it had been softened and seasoned / nor is it an alteration as the action of one specific substance on another. For in that case the relationship would only be chemical and the effect nothing more than a neutralization. The mote that chemical researches on gastric juice and bile have been able to demonstrate is that the chyme in the stomach is made slightly acid and that the acidity is removed by the bile. When the bile is mixed with chyme, a white precipitate like a thick slime is formed * which is no longer acid although milk curdles in the stomach. 1 But even this is not quite certain, nor is it the specific point, for if the precipitate were freed from acidity, it would be the same as before. The bile is thus opposed to the pancreatic juice which comes from the great gland, below the stomach, the pancreas, and which, in the higher animals, takes the place of the lymph in the glands without being essentially different from it. Now the whole process of digestion consists in this, that the organism in angrily opposing itself to the outer world is divided within itself. The final product of digestion is chyli, and this is the same as the animal lymph into which the animal organism, in its immediate operation, transforms what is offered to it, or what it offers to itself. Just as in the lower animals immediate assimilation prevails, so in animals with a developed organization, digestion consists in the organism relating itself. Treviranus, Biology, Volume 4, pages 467-9. The animal organism to the outer world, not through its immediate, but its specific, activity. Now the process is not very complicated. First, the food is mixed with saliva, with the general animality, in the stomach the pancreatic juice is added, and lastly, the bile, which plays the chief part and has a resinous, inflammable nature. Chemical analysis of the bile yields nothing more specific than that its tendency is to inflame. We know besides that in anger, bile flows into the stomach, and the connection between bile, stomach, and liver is therefore a familiar fact. A physiology which investigated such connections would be very interesting, e.g. why shame is accompanied by blushing of the face and bosom. Just as anger is the feeling of being for self which flares up in a person when he is insulted, so bile is the being for self which the animal organism turns against this potency placed in it from outside, for the pancreatic juice and the bile attack the chyme. This active destruction, this turning in on itself of the organism which the bile is, originates in the spleen, an organ which presents difficulties for physiologists. It is the sluggish organ belonging to the venous system and connected with the liver, whose sole function seems to be to bring the inertia of the venous system to a focus in opposition to the lungs. Now this sluggish being within self which has its seat in the spleen, when ignited is the bile. As soon as animals acquire a developed nature and do not merely have an immediate digestion or remain simply at the lymphatic stage, they have both liver and bile. The main point, however, is that the organism, although exercising a mediating, distinctive activity, nonetheless remains in its universality, while at the same time its outward turned action is chemical, just as crystals when fractured reveal their characteristic inner formation as a particular mode of their existence. The animal, because it behaves as actively different, in so doing becomes different within itself. In other words, because the animal is involved in a struggle with the outer world, its relation to the latter is untrue, since this outer world has already been transformed in principle by the power of the animal lymph. The animal therefore, in turning against this food, fails to recognize its own self. But the immediate result of this is simply that when the animal comes to itself and recognizes itself as this power, it is angry with itself for getting involved with external powers, and it now turns against itself and its false opinion, but in doing so it throws off its outward turned activity and returns into itself. The triumph over the non-organic potency is not a triumph over it qua non-organic potency, but a triumph over animal nature itself. The true externality of animal nature is not the external thing, but the fact that the animal itself turns in anger against what is external. The subject must rid itself of this lack of self-confidence which makes the struggle with the object appear as the subject's own action, and must repudiate this false attitude. Through its struggle with the outer thing, the organism is on the point of being at a disadvantage. It compromises its dignity in face of this non-organic being. What the organism has to conquer is, therefore, this its own process, this entanglement with the outer thing. Consequently, its activity is directed against the direction outwards, and is the means to which the organism lowers itself in order that, by repudiating and rejecting that means, it can return into itself. If the organism were actively hostile to the non-organic, it would not come into its own, for the organism is precisely the mediation which consists in involving itself with the non-organic and yet returning into itself. This negation of the outward turned activity has this double determination: first, of the repudiation by the organism of its hostile activity towards the non-organic, and the positing of itself as immediately self-identical, but secondly, of reproducing itself in this self-preservation. The notion of digestion, therefore, is that after its mediating process has merely explicated what already exists in principle, the triumph over the food which has entered the atmosphere of the living animal, the organism, returning into itself out of the opposition, now concludes by laying hold of itself. The phenomena corresponding to this notion have already been mentioned. Through this process of assimilation, therefore, the animal becomes in a real way for itself, for by particularizing itself into the main differences of animal lymph and bile in its behavior towards the individual thing itself, it has proved itself to be an animal individual, and by the negation of its other, it has posited itself as subjectivity, as real being for self. The animal having now become, in a real way, for itself, i.e. individual, this self-relation is immediately a diremption and deviation of itself, and the organism in constituting itself a subjectivity is immediately a repelling of itself from itself. Thus the differentiation does not take place only within the organism itself. On the contrary, the nature of the organism is to produce itself as something external to itself. Like the plant which, in its differentiation, breaks up into parts, the animal, too, differentiates itself, but with this difference, that the self-subsistent being from which the animal distinguishes itself is posited not merely as something external, but also as identical with the animal. This real production in which the animal, in repelling itself, duplicates itself, is the final stage of animality as such. This real process has in its turn three forms: the form of abstract, formal repulsion, the constructive instinct, and the propagation of the species. These three seemingly heterogeneous processes are essentially connected with one another in nature. In many animals, the organs of excretion and the genitals, the highest and lowest parts in the animal organization, acts intimately connected, just as speech and kissing, on the one hand, and eating, drinking and spitting, on the other, are all done with the mouth. The animal abstract repulsion of itself by which it makes itself external to itself is excretion, the conclusion of the process of assimilation. TCF. Phenomenology D. Geists, p. 254. The animal organism. Since it only makes itself into an external thing, this latter is something non-organic, an abstract other in which the animal is not identical with itself. The organism in thus separating itself from itself is disgusted with itself for not having more self-confidence. This is what it does when it abandons the struggle, rids itself of the bile which it has discharged. Excrement has, therefore, no other significance than this, that the organism recognizing its error, gets rid of its entanglement with outside things, and this is confirmed by the chemical composition of the excrement. Usually, the moment of excretion is regarded only as the rejection by the organism of useless and unusable material, but the animal did not need to ingest anything useless or superfluous. And even if indigestible material is contained in excrement, the latter consists mainly of digested matter or what the organism itself has added to the ingested material, namely, the bile, whose function it is to mingle itself with the food. The healthier the animal and the more digestible the food consumed, the smaller the amount of undecomposed food evacuated through the rectum and the more homogeneous is the excrement. Yet even in the healthiest animals the excrement always contains a fibrous residue of the ingested food. But the principal ingredients of the excrement are substances originating in the gastric juices, especially in the bile. Berzelius found in human excrement undecomposed bile, albumin, biliary gum galangTZ, and two peculiar substances, one of which looked like glue. The other substance is formed from the biliary gum and biliary albumin only in contact with the air. The human body evacuates through the rectum, albumin, two peculiar animal substances, biliary matter, sodium carbonate, sodium chloride and sodium phosphate, phosphate of magnesia, and phosphate of lime, and through the urinary organs, mucus, lactic acid, uric acid, benzoic acid, sodium chloride, ammonium chloride, phosphate of lime, and fluorinated lime, etc. These substances are not merely heterogeneous, inassimilable matter, they are the same ingredients of which the animal organs consist. The constituents of the urine are met with again mainly in the bones. Many of these substances also enter into the composition of the hair, others into that of the muscles and brain. A cursory examination of these facts seems to lead to the conclusion that in digestion, a larger quantity of matter is assimilated than the organs to be nourished by it are able to appropriate, and that it is this unchanged surplus which is evacuated by the excretory organs. Closer investigation, however, reveals disparities between the constituents of the food, the assimilated material, and the substances excreted, which render this assumption untenable. What follows certainly shows 6 disparities between the food and the assimilated material, but not so much between the assimilated material and the substances excreted. These disparities are particularly evident in phosphoric acid and lime. Fourcroy and Vauquelin found more calcium phosphate in horse dung and more calcium carbonate and calcium phosphate in bird excrement than could be extracted from the food. On the other hand, in birds a certain quantity of silica in the food disappears. The same perhaps might be found true of sulfur *, which is also found in the excrement. Sodium, however, is also found in the bodies of herbivorous animals whose food does not contain any significant quantity of this salt. On the other hand, the urine of lions and tigers contains in place of sodium a large quantity of potassium. So it is more than likely that generally in all living organisms decompositions and combinations occur which exceed the powers of chemical agents hitherto known. And so, in spite of all the evidence, these processes are supposed to be chemical and nothing more, but in truth, the activity of the organism is purposive, for it consists precisely in discarding the means after the end has been attained. Bile, pancreatic juice, etc., are therefore nothing else but the organism's own process which it gets rid of in material shape. The result of the process is satiation, the self-feeling which feels completeness in place of the previous lack. The understanding will always hold to the mediations as such, regarding them as external relationships mechanical and chemical in nature, but they are none the less subordinate in comparison with free vitality and self-feeling. The understanding pretends to know more than speculative philosophy and loftily looks down on it, but it remains confined within the sphere of finite mediation, and vitality as such is beyond its grasp. 406. 3. The constructive instinct. The constructive instinct is not to be understood here as it is by Blumenbach, who means by it principally reproduction. The artistic impulse as instinct is the third phase, the unity of the ideal theoretical process and the real process of digestion, but in the first instance it is only the relative totality, since the veritable, interior totality is the third phase in the whole, the generic process. Here, an external object, something belonging to the animal's non-organic nature, is assimilated, but in such a manner that at the same time it is also left to remain as an external object. Thus the constructive instinct, too, like excretion, is a self-externalization, but as a building of the form of the organism into the outside world. The object is shaped in a way in which it can satisfy the animal's subjective need, but here there is not a mere hostile relationship of appetite to the outside world, but a peaceful attitude to outer existence. Appetite is thus at the same time satisfied and restrained, and the organism objectifies itself only by disposing of inorganic matter for its own purposes. Here, then, the practical and theoretical relationships are united. The instinct can be satisfied by the form, without doing away with the object, but this is only one side of the constructive instinct. The other side is that the animal excretes products of its own activity, but not out of disgust, not to get rid of them. On the contrary, the externalized excrement is fashioned by the creature to satisfy its need. This artistic instinct appears as a purposive action, as wisdom of nature, and it is this category of purposiveness which makes instinct difficult to comprehend. It has always appeared a most remarkable phenomenon because it has been customary to grasp rationality only as external purposiveness and to contemplate vital phenomena in general merely from the standpoint of sense perception. The constructive instinct is in fact analogous to the understanding as a self-conscious entity, but one must not therefore, in thinking of purposive action in nature, think of self-conscious understanding. Not a step can be made in the contemplation of nature if what an end is has not been comprehended, for an end is precisely that which is predetermined, is active, enters into relationship with an other in which it preserves itself by assimilating it. The notion is the connection of these moments, a fashioning of the external object or of the secretions which have a connection with the creature's need. But as artistic impulse, this notion is only the inner io itself of the animal, only the unconscious overseer workmeister. It is only in thought, in the human artist, that the notion is for itself. Cuvier therefore says that the higher the forms of animal life, the less instinct they have, the insects have most. In accordance with this inner notion everything is a means, i.e. is connected with a unity, so that the unity would not exist without this means, which is at the same time only a moment in the whole, a sublated moment, not something independent, in and for itself, just as the sun even is a means for the earth, or each line in the crystal is a means for its immanent form. The living being has this higher nature, to be the activity which fashions the things outside of it, at the same time leaving them in their externality because, simply as purposive means, they have a connection with the notion. The first form of the artistic impulse which we have already touched on is the instinctive building of nests, lairs, shelters, in order to make the general totality of the animal's environment, even though only in respect of form, its own, and then the migration of birds and fishes as expressing their feeling of climate, the collection and storage of food for the winter, so that what the animal will eat later on already belongs to its habitat. Animals thus have relationships with the ground on which they lie, which they want to make more comfortable. In the satisfaction of this need to lie down, the thing, unlike food, is not used up but is merely fashioned and so preserved. True, food too is fashioned but it completely disappears. This theoretical side of the constructive instinct which entails a check on appetite is lacking in plants which, unlike animals, cannot restrain their impulses because they have no sensation, no theoretical relationships. The other side of the artistic impulse is that many animals have first to prepare their weapons, e.g. the spider its web, as a means of catching their food, just as other animals with their claws and feet, or the polyp with its tentacles, extend the range within which they feel and seize their prey. Such animals which arm themselves with weapons they have elaborated out of themselves, excrete these from themselves productions of the animals themselves which separate themselves from the animal and are also separated by the animals from themselves. In crabs and brachiopods, CNECZL appendages in the intestinal canal take the place of liver and pancreas and generally of the entire apparatus of glandular organs which, in the higher classes of animals, promote digestion and nutrition. In insects, not only does the same thing occur, but here there is no trace whatever even of glands. Such intestinal-like blind sacs provide in spiders the material for webs, and in caterpillars and leaf insects the substance for the cocoon for pupation. In the fork-tailed caterpillar they supply the juice which it squirts out when excited, and in the bee, the poison which comes from the sting of this insect. In addition, it is such sacs which in insects elaborate all the juices required for procreation. On both sides of the body in the male, there lies an organ consisting of a very long but also very delicate and narrow coiled-up canal, and it is this organ which corresponds to the epididymis in mammals. From it another tube goes to the penis. In the female there is a double ovary, etc. The complete absence of genitals is peculiar to all insects in their larval state and to some, worker bees for example, throughout their whole life. The building of cells and the excretion of honey by these asexual bees is the sole mode by which they produce themselves. They are, as it were, sterile flowers which do not attain to propagation of the species. With regard to this point there is a remarkable law: among insects, all asexual individuals have, instead of genitals, certain other organs which supply a substance for making artificial products. The converse of this law, however, is not true. Spiders, for example, construct their webs from a substance elaborated by their own organs, but they are not therefore asexual. Caterpillars merely eat and excrete and have no external genitals. The next stage, the spinning of the cocoon round the pupa, pertains to the constructive instinct, and copulation is the function of the butterfly. There are some insects which retain throughout their whole life the same shape with which they emerge from the egg. These insects comprise all the species of the family of spiders and several species from the classes of wood lice and mites. All other members of this class undergo a partial or total metamorphosis during their life. Where metamorphosis is only partial, the larva is distinguished from the pupa, and the latter from the developed insect. Mostly only by the smaller number or slighter development of their organs. On the other hand, where there is total metamorphosis, the perfect insect no longer bears any trace of what it was in its larval state. The innumerable muscles of the larva have disappeared and quite different ones have taken their place. Similarly head, heart, trachea, etc. have a completely different structure. One in the constructive instinct the creature has produced itself as an outer existence and yet remains the same immediate creature. Here, then, it first attains to self-enjoyment, to the specific feeling of self. Previously it had only an enjoyment of external things. The immediate sensation was only an abstract being within self in which the creature felt only in what way it was determined. The animal is satisfied when its hunger and thirst are appeased, but so far, it has not satisfied itself. It is only now that it does this. In adapting its environment to its own needs, it is present to itself externally and enjoys itself. To the artistic impulse also belongs the voice, by which the creature gives itself form in the air, in this ideal subjectivity, and perceives itself in the outer world. Birds, especially, achieve this blithe self-enjoyment. With them, voice is not a mere declaration of a need, no mere cry. On the contrary, birdsong is the disinterested utterance whose ultimate determination is the immediate enjoyment of self. 366 Through the process with external nature, the animal endows its self-certainty, its subjective notion, with truth and objectivity as a single individual. This production of itself is thus self-preservation or reproduction, but further, subjectivity has become in principle a product, and at the same time is sublated as immediate. The notion, thus united with its own self, is determined as concrete universal, genus, which enters into relationship and process with the singularity of subjectivity. Zusatz. The satisfied appetite does not have the significance here of the individual producing itself as the singular, but as a universal, as ground of the individuality, for which it is only a form. It is therefore the Universal which Hinein return to itself, in which individuality is immediately present. The theoretical return into self produces only a lack in general, but in the case of the individuality the lack is a positive being. The individual which feels a lack is filled with its own self, it is a dual individual. The animal is at first restricted to itself, secondly, it produces itself at the expense of its inorganic nature by assimilating it. The third relationship, the union of both, is the genus process in which the animal relates itself, to one of its own kind, it relates itself to a living being as in the first process and, at the same time, as in the second process, to a being already confronting it. The genus is in an implicit, simple unity with the singularity of the subject whose concrete substance it is. But the universal is disjunction or judgment, in order to issue from this its diremption as a unity for itself, give itself an existence as a subjective universality. This process of its closing with itself contains the negation of the merely inner universality of the genus, and also the negation of the merely immediate singularity in which the living being is still only a natural being. The negation of this singularity exhibited in the preceding process is only the first, immediate negation. In this process of the genus, the merely natural being only perishes, for, as such, it does not transcend the natural. But the moments of the process of the genus, since their basis is still not the subjective universal, still not a single subject, fall apart and exist as a plurality of particular processes which culminate, in one way or another, in the death of the creature. Zusatz. The individual which has established itself through its self-feeling, has acquired solidity and, so to say, breadth, its immediate singularity is sublated and the individual no longer needs to be in relationship with a non-organic nature. With the vanishing of its determination as an exclusive singularity, the notion acquires the further determination that the subject determines itself as a universal. This determination is again disjunctive tielend, again excludes what is other, but it has the determination of being identical for this other and existing for it as identical. Thus we have the genus, whose determination is to attain to an existence distinct from singularity, and this is the genus process as such. True, the genus still does not attain to a free existence in the individual, not to universality, but even though it is here, on the one hand, still only immediately identical with the individual, yet, on the other hand, it has already attained to a differentiation of individual subjectivity from the genus. This difference is a process, the outcome of which is that the genus as universal comes to itself, and immediate singularity is negated. THI9. Extinction is the death of the individual. With this, organic nature ends, for with the death of the individual the genus comes to its own self and thus becomes its own object. This is the procession of spirit. This extinction of the singularity in the genus we have still to consider. But because the genus is related to the individual in a variety of ways, we have also to distinguish the particular processes, which are the different ways, in which the living creature meets its death. Thus the genus process, in its turn, has three forms. The first is the sex relation. What the genus brings forth is the procreation of individuals through the death of other individuals of the same genus. The individual, after reproducing itself as another individual, perishes. Secondly, the genus particularizes itself, divides itself into its species, and these species, behaving as mutually opposed individuals, are, at the same time, non-organic nature as the genus against individuality, death by violence. The third form is the relation of the individual to itself as genus within a single subjectivity, either as a transitory disharmony in disease, or else ending with the preservation of the genus as such through the transition of the individual into existence as a universal. This is natural death. I. The sex relation 3 to the power of 8. This first diremption of the genus into species and the further determination of these to the point of immediate, exclusive being for self of singularity, is only a negative and hostile attitude towards others. But the genus is also an essentially affirmative relation of the singularity to itself in it, so that while the latter, as an individual, excludes another individual, it continues itself in this other and in this other feels its own self. This relationship is a process which begins with a need, for the individual as a singular does not accord with the genus immanent in it, and yet at the same time is the identical self-relation of the genus in one unity. It thus has the feeling of this defect. The genus is therefore present in the individual as a straining against the inadequacy of its single actuality, as the urge to obtain its self-feeling in the other of its genus, to integrate itself through union with it and through this mediation to close the genus with itself and bring it into existence. Copulation. Zusatz. The process of the animal with its non-organic nature has made the ideality of the latter explicit, and the animal has thereby demonstrated in its own self its self-feeling and its objectivity. It is not merely an implicit self-feeling, but a self-feeling which exists and is alive. The division of the sexes is such that the extremes are totalities of self-feeling. The animal's instinct is to produce itself as a self-feeling, as totality. Now in the constructive instinct, the organic became a dead product, freely released, it is true, from the organism, but only a superficial form imposed on an external material, and T9 did not therefore confront itself as a free, indifferent subject. Here, on the contrary, both sides are independent individuals as in the process of assimilation, but with this difference, that they are not related to each other as organic and non-organic beings. On the contrary, both are organisms and belong to the genus, so that they exist only as one species. Their union is the disappearance of the sexes into which the simple genus has developed. The animal has an object with which it feels itself immediately identical. This identity is the moment of the first process which is added to the determination of the second. This attitude of an individual to another of its kind is the substantial relation of the genus. The nature of each permeates both, and both exist within the sphere of this universality. The process consists in this, that they become in reality what they are in themselves, namely, one genus, the same subjective vitality. Here, the idea of nature is actual in the male and female couple, their identity, and their being for self, which up till now were only for us in our reflection, are now, in the infinite reflection into self of the two sexy nine, felt by themselves. This feeling of universality is the highest to which the animal can attain, but its concrete universality never becomes for it a theoretical object of intuition, else it would be thought, consciousness, in which alone the genus attains a free existence. The contradiction is, therefore, that the universality of the genus, the identity of individuals, is distinct from their particular individuality. The individual is only one of two, and does not exist as unity but only as a singular. The activity of the animal is to sublate this difference. The genus, as the foundation, is one extreme of the syllogism, for every process has the form of the syllogism. The genus is the impelling subjectivity into which is placed the vitality which wants to produce itself. The mediation, the middle term of the syllogism, is the tension between this essential nature of the individuals and the incongruity of their single actuality, and it is this which impels them to have their self-feeling only in the other. The genus, in giving itself actuality, which, because it has the form of immediate existence is, of course, only a single actuality, closes itself with the other extreme, that of singularity. The formation of the differentiated sexes must be different, their determinateness against each other must exist as posited by the notion, because, as differentiated moments, they are an Urgetrieb. But the two sides are not merely, as in the chemical sphere, implicitly neutral. On the contrary, on account of the original identity of formation, the same type underlies both the male and female whilst only that in one, the animal organism or the other, one or the other part predominates. In the female, it is necessarily the passive moment that are indifferent, in the male, the moment of duality das Entstuit, of opposition. This identity is most striking in the lower animals. In some grasshoppers the large testicles, composed of vessels rolled together in bundles, resemble the ovaries, which are equally large and composed of bundles of similarly rolled up oviducts. Also in the male horsefly, not only does the outline of the testicles present the same shape as the thicker grubbery, larger ovaries, but they, too, consist of almost oval, elliptical, delicate vesicles which, with their base, stand up on the substance of the testicles like ova on an ovary. The greatest difficulty has been experienced in discovering the female uterus in the male genitals. The scrotum has ineptly been mistaken for its Z simply because the testicles present a definite correspondence to the female ovary. But at 19 rather the prostate in the male, which corresponds to the female uterus. In the male, the uterus is reduced to a gland, to an indifferent generality. This has been very well demonstrated by Ackermann in his hermaphrodite, which has a uterus as well as other, male, organs, but this uterus not only occupies the place of the prostate, but the ejaculatory ducts also pass through its substance and open into the crista galli in the urethra. Also, the female labia puterui are shrunken scrota. Consequently, in Ackermann 8 hermaphrodite, the labia pudendae were filled with a kind of testicular secretion. Lastly, the medial line of the scrotum is split in the female and forms the vagina. In this way, a complete understanding is obtained of the conversion of one sex into the other. Just as in the male, the uterus is reduced to a mere gland, so, on the other hand, the male testicle remains enclosed in the ovary in the female, does not emerge into opposition, does not develop on its own account into active brain, and the clitoris is inactive feeling in general. In the male, on the other hand, we have instead active feeling, the swelling heart, the effusion of blood into the corpora cavernosa and the meshes of the spongy tissue of the urethra. To this male effusion of blood correspond the female menses. In this way, the reception emphangen, by the uterus, a simple retention, is, in the male, split into the productive brain and the external heart. Through this difference, therefore, the male is the active principle, and the female is the receptive, because she remains in her undeveloped unity. Procreation must not be reduced to the ovary and the male semen, as if the new product were merely a composition of the forms or parts of both sides. The truth is that the female contains the material element, but the male contains the subjectivity. Conception is the contraction of the whole individual into the simple, self-surrendering unity, into its representation. The seed is this simple representation itself simply a 1 Schubert, Anungen einer allgemeinen Geschichte Lebens, Part I, p. 185. Asteriskibid, p. 05-6. Single point, like the name and the entire self. Conception, therefore, is nothing else but this, that the opposite moments, these abstract representations, become one. 369 The product is the negative identity of the differentiated individuals and is, as realized genus, an asexual life. But on its natural side, this product is only in principle this genus, distinct from the individuals whose difference has perished in it and is itself an immediate singular, destined to develop into the same natural individuality, into the same difference and perishable existence. This process of propagation spends itself in the spurious infinite progress. The genus preserves itself only through the destruction of the individuals who, in the process of generation, fulfill their destiny and, in so far as they have no higher destiny, in this process meet their death. Zusatz. Thus the animal organism has run through its cycle and is now the asexual and fecund universal. It has become the absolute genus which, however, is the death of this individual. The lower animal organisms, e.g. butterflies, die, therefore, immediately after copulation, for they have sublated their singularity in the genus and their singularity is their life. Higher organisms survive the generative act since they possess a higher kind of independence, and their death is the culmination of the process in their structure, which we shall come across later as disease. The genus, which produces itself through negation of its differences, does not, however, exist in and for itself but only in a series of single living beings, and thus the sublation of the contradiction is always the beginning of a fresh one. In the genus process the separate individual creatures perish, for they are distinct only outside of this unity of the process, which is the true actuality. Love, on the other hand, is the feeling in which the self-seeking of the individual and its separated existence is negated, and the individual foxm therefore perishes and cannot preserve itself. For only that preserves itself which, as absolute, is self-identical, and that is the universal which is for the universal. But in the animal, the genus does not exist as such but only in principle, it is only in spirit that it exists in and for itself in its eternity. The transition to the existent genus takes place in principle, in the idea, in the notion, that is to say, in the eternal creation, but there the sphere of nature is closed. To genus and species the genus, in its implicit universality, particularizes itself at first simply into species. At the base of the different forms and classes of animals is the universal type of the animal, determined by the notion. Nature exhibits this type, partly in the various stages of its development from the simplest organization to the most perfect, in which it is the instrument of spirit, and partly in the various circumstances and conditions of elemental nature. An animal species, developed to the point of singularity, distinguishes itself from others in and through its own self, and through the negation of them is for itself. The natural fate of the individuals in this hostile relationship, in which others are reduced to an inorganic nature, is a violent death. Remark. Zoology, like the natural sciences generally, has concerned itself mainly with the search for sure and simple signs of classes, orders, etc., of animals for the purpose of a subjective recognition of them. Only since giving up this attempt to construct so-called artificial systems for classifying animals has the way been opened for a more comprehensive view directed to the objective nature of the organisms themselves. Of the empirical sciences, hardly one has in recent times expanded as much as zoology through its auxiliary science of comparative anatomy, an expansion not mainly in the sense of accumulated observations, for none of the sciences has lacked these, but in the sense of an arranging of its material to conform to the notion. Just as the ingenious approach to nature especially of the French naturalists has adopted the division of plants into monocotyledons and dicotyledons, so, too, it has adopted the fundamental distinction in the animal world made by the absence or presence of a backbone. In this way, the fundamental classification of animals has been reduced in its essentials to that which had already been perceived by Aristotle. In addition, the habit of individual animals, as a coherent whole determining the construction of every part, has been made the main point, so that Cuvier, the great founder of comparative anatomy, could boast that from a single bone, he could learn the essential nature of the whole animal. Also the general type of the animal has been traced in the most imperfect and disparate forms and recognized in the barest suggestions, and in the intermixture of organs and functions, too, their significance has been recognized, so that in this way the animal has been raised above and out of its particularity into its universality. A cardinal feature of this method of treatment is the recognition of how nature shapes and adapts this organism to the particular element in which it is placed, to climate, to a particular form of food, in general, to the environment into which it is born, an environment which can also be one particular species of plant or another species of animal. But for the special determination, a correct instinct has hit upon taking the distinguishing characteristics of the species also from the teeth, claws, and the like, i.e. from the animal's weapons, for it is through these that the animal itself establishes and preserves itself as an independent existence, that is, distinguishes itself from others. It is on account of the immediacy of the idea of life that the notion does not exist as nihuk in life, and its existence is therefore subjected to the manifold conditions and circumstances of external nature, and can appear in the most inadequate forms. The fecundity of the earth causes life to break forth everywhere and in every way. Almost less even than the other spheres of nature, can the animal world exhibit within itself an independent, rational system of organization, or hold fast to the forms prescribed by the notion, preserving them, in face of the imperfection and medley of conditions, from confusion, degeneration, and transitional forms. This impotence of the notion in nature generally, subjects not only the development of individuals to external contingencies. The developed animal can exhibit monstrosities, but even the genera are completely subject to the changes of the external, universal life of nature, the vicissitudes of which are shared by the life of the animal, whose life, consequently, is only an alternation of health and disease. The environment of external contingency contains factors which are almost wholly alien. It exercises a perpetual violence and threat of dangers on the animal's feeling, which is an insecure, anxious, and unhappy one. Zusatz. The animal, qua a natural life, is still essentially an immediate existence, and therefore is determinate, finite, and particular. Life, tied to the infinitely many particularizations of inorganic and vegetable nature, exists always as a limited species, and these limitations the living creature cannot overcome. The particular character does not have for its determination the universality of existence. On the contrary, the animal in its relationship to nature attains only to particularity. Life, which receives these powers of nature into itself, is capable of the most diverse modifications of its structure. It can adapt itself to every condition and still pulsate among them, although the universal powers of nature always retain their complete mastery. In studying the classification of animals, the method followed is to search for a common feature to which the concrete forms can be reduced, that is, to a simple, sensuous determinateness which, therefore, is also an external one. But there are no such simple determinations. For example, if we take the general concept fish as the common feature of what this name connotes in our concept, and ask, what is the simple determinateness in fish, their one objective property, the answer, swimming in water, is insufficient, since a number of land animals do this, too. Besides, swimming is not an organ or a structure, and in general, is not any specific part of the shape of any fish, but a mode of their activity. A universal of this kind, like fish, simply as a universal, is not linked to any particular mode of its external existence. Now the assumption that there must definitely exist such a common feature in a simple determinateness 8, fins, for example, which yet cannot be found, makes the work of classification difficult. This is based on the kind and manner of the individual genera and species, and laid down as a rule, but the variety and profusion of living forms does not admit of any general feature. Consequently, the infinity of forms of animal life is not to be rigidly conceived as if they conformed absolutely to a necessary principle of classification. On the contrary, therefore, it is the general determinations which must be made the rule and natural forms compared with it. If they do not tally with it but exhibit certain correspondences, if they agree with it in one respect but not in another, then it is not the rule, the characteristic of the genus or class, etc., which is to be altered, as if this had to conform to these existences, but, conversely, it is the latter which ought to conform to the rule, and so far as this actual existence does not do so, the defect belongs to it. Some amphibians, for example, are viviparous and breathe with lungs like mammals and birds, but, like fishes, they have no breasts and a heart with a single ventricle. If we admit that the works of man are sometimes defective, 624-8876p, then the works of nature must contain still more imperfections, for nature is the idea in the guise of externality. In man, the source of these imperfections lies in his whims, his caprice and negligence, e.g. when he brings painting into music, or paints with stones in mosaic, or when epic poetry is introduced into drama. In nature, it is external conditions which distort the forms of living creatures, but these conditions produce these effects because life is indeterminate and receives its particular determinations also from these externalities. The forms of nature, therefore, cannot be brought into an absolute system, and this implies that the species of animals are exposed to contingency. The other side to this is that the notion, of course, also exerts its influence, but only to a certain degree. There is only one animal type and all the varieties are merely modifications of it. The principal varieties have for basis the same determinations which we saw earlier in inorganic nature as the elements. These grades, then, are also grades of the development of the animal type as such, so that the grades of animal species can be recognized in those determinations. There are thus two distinct principles which determine the difference between the classes of animals. One principle of classification, and this is closer to the idea, is that the later grade is only a further development of the one type of animal, the other is that the scale of development of the organic type is essentially connected with the elements into which the forms of animal life are cast. Such a connection, however, exists only in the more highly developed forms of animal life. The lower forms have little relation to the elements and are indifferent to these great differences. Apart from these chief moments in the grouping of the classes of animals, there are distinctions connected with the climatic factor. We have already remarked that because in the northern hemisphere the continents are more compact, plant and animal life there are not so varied, whereas the further south one goes in Africa and America, where the continents divide, the greater is the variety of animal species. While climatic differences thus determine the animal, man lives everywhere, but here, too, Eskimos and other extreme types differ from the types in the temperate zone. But still more is the animal subject to such determinations and localities, to mountains, forests, plains, etc. One must not therefore seek notional determinations everywhere, although traces of them are everywhere present. In the scale of development formed by genera and species, one can begin with the undeveloped animals in which the differences do not as yet exist definitely in the three items of sensibility, irritability, and reproduction. Then man, as the most perfect living organism, is the highest stage of development. In recent zoology especially, this form of classification according to the grades of development, has held the field, for it is natural to progress from the undeveloped to the higher organism. But in order to understand the lower grades, one must know the developed organism, since it is the standard or archetype for the less developed animal, for in the developed animal, every function has attained to a developed existence, and it is therefore clear that it is only from this animal that undeveloped organisms can be understood. The infusoria cannot form the basis, for in this torpid life the rudiments of organic life are still so feeble that they can only be grasped by reference to more developed animal forms. But to say that the animal is more perfect than man, is inept. In one or other respects, the animal can, indeed, be better developed, but perfection consists precisely in the harmony of the organism. The universal type which forms the basis, cannot, of course, as such exist, but the universal, because it exists in a particular form. Similarly, perfect beauty in art must always be individualized. It is only in spirit that the universal, as ideal or idea, exists as universal. We have now to see how the organism is determined in these particular forms. The organism is alive and its viscera are determined by the notion, but then it also develops entirely in accordance with this particularity. This particular determination permeates every part of the structure and harmonizes the parts with one another. This harmony is present mainly in the limbs, for particularity is precisely the tendency outwards, towards a specific inorganic nature. But the higher and more developed the animal is, the more marked is the thoroughness of the particularization. Now Cuvier has developed this aid, to which he was led by his studies of fossil bones, for in order to find out to what animal they belonged, he had to study their formation. He was thus led to consider the appropriateness of the individual members in relation to one another. Pye says in his Discovers Prehomere to the richer Ches sur its ossements fossils de quadrupeds, every organized creature forms a whole, a unified and closed system, all the parts of which mutually correspond, and by reciprocal action on one another contribute to the same purposive activity. None of these parts can alter without the others altering too, and consequently each of them, taken on its own, suggests and gives all the others. If, therefore, the viscera of an animal are so organized that they can digest only raw meat, then the jawbones, too, must be adapted for swallowing the prey, the claws for seizing and tearing flesh, the teeth for biting it off and chewing it up. In addition, the whole system of the motor organs must be adapted for pursuing and securing the prey, and the eyes, too, for seeing it at a distance. Nature must even have implanted in the brain of the animal the necessary instinct to conceal itself and to ensnare its victims. These are the general conditions of the carnivora. Each carnivore must, without fail, combine these within itself. But particular conditions like the size, kind, and haunt of the prey, also result from particular circumstances within the general forms, so that not only the class, but also the order, the genus, and even the species, is expressed in the form of each part. In fact, in order that the jawbone can seize the prey, the condyle asterisk. The organ which moves the jawbone and to which die muscles are attached must have a particular shape. The temporal muscles must possess a certain bulk, and this requires a certain hollowing of the bone in which they are inserted and of the process of the cheekbone under which they pass. This latter must also have a certain strength in order to afford sufficient support to the masticatory muscle. The same principle applies throughout the entire organism. In order that the animal can carry away its prey, the muscles which lift the head must have a certain strength. This in turn affects the form of the dorsal vertebrae to which the muscles are attached, and the form of the occiput in which they are inserted. The teeth must be sharp in order that they can cut flesh and must have a solid base so that bones can be crushed. The claws must have a certain mobility, accordingly their muscles and bones must be developed, similarly with the feet, etc. This harmony, however, also leads on to correspondences which have an inner connection of a different kind, a connection which is not always so easy to recognize. We quite see, example, that the ungulata must be herbivorous since they have no claws for seizing prey. We also see that, because their forefeet can only be used to support their bodies, they do not require such large shoulder blades. Their herbivorous diet will demand teeth with a flat crown for grinding grain and herbage. Grinding requires that this crown shall make horizontal movements, therefore the condyle of the jawbone must not be such a tight hinge as in the carnivora. Treviranus says, in the lower jawbone of homed animals, there are usually 8 incisors. The upper jawbone, on the other hand, instead of incisors, has a cartilaginous pad. Most of them lack canines. In all of them the molars are grooved by serrated, transverse furrows, and their crowns do not lie horizontally but are notched obliquely, in such a way that in the molars of the upper jaw it is the outer side which is highest, but in those of the lower jaw it is the inner side, that which is turned towards the tongue. The following observations of Cuvier also present no difficulties. It is fitting that those species with less perfect teeth should have a more complex digestive system. Such are the ruminants, which require a more complex system mainly because herbivorous food is itself harder to digest. But I doubt whether anyone who had not learned by observation would have guessed that all ruminants have cloven hoofs, that therefore the dental system is more perfect in the ungulata which are not ruminants, than in cloven-hoofed animals, that is in ruminants. It is noticeable, too, that the development of the teeth is in thoroughgoing sympathy with the greater development in the osteology of the feet. According to Treviranus, most homed animals lack fibulas. Cuvier continues the passage quoted as follows: it is impossible to give the masons for these connections, but that they are not accidental is evident from the fact that whenever an animal with cloven hoofs shows an approach to the NNN minanta in the arrangement of its teeth, it also shows it in the arrangement of its feet. Camels, for example, which have eye teeth and even 2 or 4 incisors in the upper jawbone, have an extra bone in the tarsus in comparison with other animals with a less developed dental system. Similarly in children, teething, the ability to walk and also to talk, all develop simultaneously, namely, in the 2nd year. The particularity of the determination brings, therefore, a harmony into all the parts of the animal. The smallest facet of bone, the least apophysis, has a specific character in relation to the class, order, genus, and species, to which it belongs, so that if one has only a well-preserved splinter of bone, it is possible with the aid of analogy and comparison to determine everything else with the same certainty as if one possessed the entire animal *ex ungulationem, as the proverb says. I have tried out this method many times on parts of known animals before putting my whole trust in it for fossils, but I have always had such infallible success that I no longer have the slightest doubt of the certainty of the results it has yielded me. But although there is a universal type underlying the various species of animals, a type which nature works out in them in such a way that the result conforms to the particularity of the species, we must not think that everything found in the animal serves a purpose. In many animals, we find rudiments of organs which belong only to the universal type, not to the particularity of these animals, and which therefore have not been developed because the particularity of these animals does not need them. Consequently, too, it is only the higher organisms, not these lower ones, that can afford an explanation of such rudiments. For example, reptiles, snakes, fish, show rudimentary feet which have no meaning, and the whale has undeveloped teeth which serve no purpose, being merely rudimentary teeth concealed in the jaw bones. Conversely, in man, there are some organs which are only necessary in the lower animals. He has, example, a gland in his neck, the so-called thyroid gland, the function of which is not understood but which is really obliterated and past, but in the foetus in the womb, and still more in the lower species of animals, this organ is active. Now further consideration of the scale of development which provides the basis for the general classification of animals shows that, as the animal is both an unmediated production of itself and a production mediated by its inorganic nature, therefore the distinction between the forms of the animal world is that either these two essential sides are in equilibrium, or else that the animal exists more in accordance with one aid than with the other, so that while one side is more developed, the other plays a subordinate part. It is this one-sidedness which makes one animal stand lower in the scale than another, although in no animal can one side be completely lacking. In man, who is the fundamental type of organism, since he is the instrument of spirit, all sides attain their most perfect development. The ancient classification of animals belongs to Aristotle, who divides all animals into two main groups, into those with blood and those without it, and he enunciates as a general proposition based on observation, that all animals which have blood have an osseous or bony spine. This is the great, veritable difference. To be sure, it has been possible to raise many objections to it, e.g. that there are animals which by nature should be bloodless and yet have blood, like leeches and earthworms which have a red fluid soft. In general, the question posed is, what is blood? And in the end, the difference is one of color. The vagueness of this division caused it to be abandoned, and Linnaeus opposed to it his well-known 6 classes. But just as the French rejected the Linnaean system of plant classification, a mere rigid product of understanding, in favor of Jussieu's classification into monocotyledons and dicotyledons, so too, following Lamarck, a gifted Frenchman, they reverted to the Aristotelian division of animals, but in this form, that animals are classified, not according to blood, but into vertebrates and invertebrates. Cuvier united both principles of classification, for, in fact, the vertebrates have red blood, and the others white blood and no inner skeleton, or at least, only an inarticulate one, or else an articulated but external skeleton. It is in the lamprey that we first see a backbone which, however, is still only a tough leathery substance and in which the vertebrae are indicated merely by grooves. The vertebrates are mammals, birds, fish, and amphibians. The invertebrates comprise mollusks, crustacea, which have a carapace separated from the fleshy skin, insects, and worms. The general appearance of the animal world at once shows this huge difference which prevails between the two groups into which it is divided. This difference also corresponds to the previously mentioned classification based on the relation between the organization of the organism's viscera and the organic articulation connecting it with the external world, a relation which, in turn, is based on the fine distinction of the organique and the animal. In the invertebrates, therefore, says Lamarck, the basis for a proper skeleton is also lacking. Nor have they true lungs consisting of cells, consequently neither do they have a voice or vocal organ. Aristotle's classification according to blood is, on the whole, confirmed by this. The invertebrates, Lamarck continues, at the place quoted, do not possess true blood, which should be red and warm, it is more like lymph. Blood owes its color to the intensity of animalation *, which, therefore, is also lacking in these animals. Such animals, on the whole, also lack a genuine circulation of the blood, nor have they an iris in the eye, nor kidneys. Also they have no spinal cord, nor the great sympathetic nerve. The Aristotle's hist, animal. Vertebrates, therefore, have a greater development, an equilibrium of inner and outer. In the other group, on the contrary, the one is developed at the expense of the other. Accordingly, of the invertebrates, two classes in particular must be mentioned, worms and insects. The former have more developed viscera than the insects, but these have a more delicately fashioned exterior. To the invertebrates also belong polyps, infusoria, etc., which are completely undeveloped, consisting merely of skin and jelly. Polyps, like plants, are a collection of several individuals and e'en be cut up into pieces, even the garden snail grows a new head. But this reproductive strength is a weakness of the substantiality of the organism. In the invertebrates, one sees a gradual disappearance of heart, brain, gills, circulatory vessels, the organs of hearing, sight, and sex, and finally of sensation altogether, and indeed even of movement. Where the interior life predominates as an independent activity, there is development of the digestive and reproductive organs as the concrete universal in which, as yet, there is no difference. It is only where the animal kingdom has relationships with the outer world, with the emergence of sensibility and irritability, that a differentiation takes place. While therefore in the invertebrates, organic and animal life stand opposed to each other, in the vertebrates, where both moments are in a single unity, the other essential basis of determination must come into play, namely, the particular element for which the animal is destined, whether it is a land animal, an aquatic creature, or a creature of the air. The invertebrates, on the contrary, do not exhibit this connection of their development with the elements, because they are already subordinated to the other basis of classification. But naturally there are also animals which are intermediate forms. The reason for this lies in the impotence of nature to remain true to the notion and to adhere to thought determinations in their purity. A. In worms, mollusks, shellfish, etc., the organism is internally more developed but its exterior is formless, in spite of the outer difference which distinguishes mollusks from the higher animals *, says Treviranus, we find in their internal structure in some measure, the organization of the latter. We see a brain resting on the esophagus, a heart with arteries and veins, but no spleen and pancreas. The blood is white or bluish in color, and the fibrin is not formed in the crura, but its threads swim freely in the serum. In only a few are the male and female sexual organs found in separate individuals, and in these, the structure of the organs is so peculiar that often their function cannot even be guessed. They breathe through gills, says Lamarck, and have a nervous system, but the nerves are not nodulated, that is, they do not present a series of ganglia, and they have one or more hearts which, although possessing only one ventricle, are well developed. The system of external articulation in mollusks is, on the other hand, much more undeveloped than in insects. Here, says Treviranus, the difference of head, thorax, and abdomen, of which there are still traces in fish and amphibians, disappears completely. Mollusks do not have a nose, most of them have no external limbs at all, and they move either by alternately contracting and relaxing their stomach muscles or else are quite incapable of any forward movement. B. The organs of movement in insects are far superior to those in mollusks, which, in general, have only a few motor muscles, for insects have feet and wings, and the head, thorax, and abdomen are quite distinct in them, too. On the other hand, their interior structure is correspondingly less developed. The respiratory system permeates the whole body and coincides with the digestive system, as in some fishes. The blood system has only a few developed organs, and even these can hardly be distinguished from the digestive system, whereas the external articulation, e.g. the masticatory organs, etc., are correspondingly more developed. In insects and other lower classes of animals, says Autenrieth, a movement of the fluids seems to take place without circulation, and in the following way: fluids are received into the body only from the surface of the alimentary canal, and after being used for nourishing the various parts are gradually excreted as waste matter through the surface or in other ways. These are the principal classes of invertebrates. According to Lamarck there are 14 of them. C. As regards the further classification of animals, this is based more simply on the elements of their inorganic nature, earth, air, and water, that is, they are either land animals, birds, or fish. This is a convincing distinction, and one directly appealing to a naive apprehension of nature, whereas in the preceding classifications, the distinction became a matter of indifference. For many beetles, for example, have webbed feet but live as well on land and also have wings for flying. Now there are, of course, even in the higher animals, transitions from one class to another which nullify that distinction. Life, which exists in different elements, is united in a single organism just because it is unable to discover in the representation of the land animal the single determinateness which ought to contain the simple, essential character of the animal. Only thought, understanding, can make fixed distinctions, and only spirit, just because it is spirit, can produce works which conform to these rigid distinctions. Works of art or of science are so abstractly and entirely individualized that they remain faithful to their character and do not confuse essential differences. If these differences are mixed in art, as happens in poetic prose and prosaic poetry and in dramatized history, or if painting is introduced into music or poetry, or if painting is done in stone and, example shows curly hair in a statue, then the essential character of the art is violated. For genius can produce a genuine work of art only by expressing a specific individuality. It is the same when one man wants to be poet and painter and philosopher. In nature, this is not so. A creature can develop in two directions. But the fact that in the cetacea, the land animal falls back again into the water, that in the amphibians and reptiles the fish again climbs onto the land, where it presents a sorry picture, snakes, for example, possessing the rudiments of feet which serve no purpose, that the bird becomes an aquatic bird, and in the duck-billed platypus even crosses over to the class of land animals, and in the stork becomes a camel-like animal that is covered more with hair than with feathers, that the land animal and the fish attain to flight, the former in vampires and bats, and the latter in the flying fish. All this does not efface the fundamental difference, which is not a common, a shared difference, but a difference in and for itself. The great distinctions must be adhered to in face of these imperfect products of nature, which are only mixtures of such determinations, like a humid air or a moist earth, and the transitional forms must be interpolated as mixtures of the differences. The true land animals, the mammals, are the most perfect, then come birds, and the least perfect are fish. A. The natural element of fishes is water. As their whole structure shows, articulation is restricted by the element and accordingly is forced inwards. Their blood has little warmth, for its temperatures differ only slightly from that of the element in which they live. Fish have a heart with a single ventricle, or else with several, which then are directly interconnected. Lamarck, describing the four higher classes of animals, says of fish, they breathe through gills, have a smooth or scaly skin, fins, no trachea, no larynx, no tactile sense, and probably no sense of smell either. Fish, and other animals, simply abandon their young, and have no concern for them at all, right from the start. Such creatures, therefore, do not yet attain to a feeling of unity with their young. SS. Reptiles, or amphibians, are intermediate forms which belong partly to land and partly to water, and that is why there is something repulsive about them. They have only one cardiac ventricle, an imperfect pulmonary respiration, and a smooth, or else scaly, skin, frogs, before reaching maturity, do not have lungs but gills. Why? Beards, like animals, have feeling for their young. They provide them with their food in the egg. Their foetus, says Lamarck, is contained in an inorganic envelope, and soon ceases to have any connection with the mother but can develop inside the shell without drawing nourishment from her. Birds use their own warmth to keep their young warm, share their food with them and also feed their females, but they do not sacrifice their own lives for their young as insects do. By building nests, birds display the artistic and constructive instinct and thus attain to a positive self-feeling in that they make themselves into an inorganic nature for an other, and this other, their young, they put forth directly from themselves. Lamarck proposes the following classification of birds from this standpoint, if one bears in mind that aquatic birds like the palmipeds, for example, sandpipers, and gallinaceous birds, have the advantage over all other birds that their young, as soon as they emerge from the egg, can walk and feed themselves. It will be seen that they must form the first three orders, and that the columbidae, passers, birds of prey, and climbers must form the last four orders of this class, for their young, when they have emerged from the egg, can neither walk, nor feed themselves. But this very circumstance can be regarded as a reason for placing these latter in front of the others, not to mention that the palmipeds are mongrels. Birds are positively distinguished by the connection between their lungs and membraneous air pockets and big, marrow-less cavities in their bones. They have no breasts, for they do not suckle their young, and are bipeds, and the 2 arms or 4 feet are transformed into wings. Because this form of animal is cast into the air, and the abstract element thus lives in birds, the vegetative principle fluctuates and develops on their skin in the form of plumage. Also, since birds belong to the air, their thoracic system, too, is specially developed. Consequently, many birds not only have, like mammals, a voice but they also sing, the inner vibration developing in the air as in its element. Whereas the horse neighs and the ox bellows, the bird continues this cry as an ideal enjoyment of itself. On the other hand, the bird does no troll about on the ground, the expression of a crude self-feeling, it clings only to the air and in this element attains to self-feeling. 8 mammals have breasts, 4 articulated extremities, and all their organs are developed. Because they have breasts, they suckle and feed their young from themselves. These animals thus attain to the feeling of the unity of the one individual with the other, to the feeling of the genus, which achieves an existence in the progeny in which the 2 individuals are precisely the genus, even though, in nature, this unity of the individual with the genus falls back again into singularity. But the perfect animals still behave as genus to this existence, for in it they find their universal. These are the mammals, and those birds which hatch out their young. Of all animals, monkeys are the most docile and have most affection for their young. The satisfied sexual instinct persists for them in objective form, for they have passed over into another, and in caring for the needs of their young, they have the higher, disinterested intuition of this unity. Although in mammals the skin partakes of a vegetative nature, the vegetative life is far from being as powerful as it is in birds. In mammals, the skin continues its growth into wool, hair, bristles, pines, and even into scales and armor. Man, on the other hand, has a skin which is smooth, pure, and much more animalized and which also sheds anything of an osseous nature. Woman has a more luxuriant head of hair. In the male, an abundance of hair on the chest and elsewhere is regarded as a sign of strength. It is, however, a relative weakness of the cutaneous organization. Further essential classifications have been based on the behavior of animals as individuals, to other animals, that is, on their teeth, feet, claws, and beaks. It was a correct instinct which led to the choice of these parts, for it is by them that animals themselves distinguish themselves from other animals. If the difference is to be a true one, it must not be simply a sign which we have picked out, but a difference of the animal itself. By opposing itself as an individual to its non-organic nature through its weapons, the animal demonstrates that it is a subject for itself. On this basis, the classes of mammals are very accurately distinguished, act. Into animals whose feet are Hanel's number and the monkey SSSS into animals whose extremities are claws-logs, wild beasts like the lion, the king of beasts, YY. Into rodents in which the teeth are specially shaped, S8. Into Chiroptera, which have a membrane stretched between the toes, as occurs even in some rodents, C. Into sloths, in which some of the toes are missing altogether and have become claws, pound. Into animals with fin-like limbs, the cetacea, into hoofed animals, like swine, elephants, homed cattle, horses, etc. The strength of these animals resides in the upper part of the body, roost of them can be tamed to work, and the formation of the extremities 9 has a special relationship to the animal's non-organic nature. If the animals under SSSS, YY, 88, EE, are grouped together as animals toith claws, then WC have 4 classes, I. Animals with hands, A with claws, 3. With hooves, which work for man, 4. Toith fins. Lamarck, following this classification, grades the mammals in descending order as follows. The unguiculate mammals have 4 limbs, fiat, or pointed claws at the tips of their toes which latter do not envelop the claws. The limbs are, in general, fitted for seizing, or at least hanging onto, objects. THSA animals include those which are most highly organized. The hoofed mammals have 4 limbs, the toes of which are completely surrounded at their extremities by a rounded, horny substance called a hoof. Their feet can be used only for walking or running on the ground, they cannot be used for climbing trees, or for seizing an object or prey, or for attacking and rending other animals. They are completely herbivorous. The mammals without hooves have only 2 extremities, and these are very short and flat, and shaped like fins. Their toes, covered by skin, have neither claws nor hooves, they are the least highly organized of all the mammals. They have neither a pelvis, nor hind legs, they swallow their food without masticating it. Lastly, they usually live in water but come up to the surface to breathe air. As regards TB further subdivisions, these must be left to the spancy and contingency proper to nature, that is, to be determined by external factors. Climate, however, still constitutes the great determining factor. In southern latitudes, the animal kingdom is particularized more according to differences of climate and country than it is in northern latitudes, thus the Asiatic and African elephants are essentially distinct from each other. White in America there are none, lions and tigers, etc., are similarly distinguished. 3. The genus and the individual. 371a. The disease of the individual in the 2 preceding relationships, the self-mediation of the genus with itself is the process of its diremption into individuals and the sublation of its difference. But since the genus also assumes the shape of external universality, of an inorganic nature against the individual, it attains to existence in the latter in an abstract, negative manner. In this relationship of an external existence, the individual organism can just as well not conform to its genus as preserve itself in it through its return into self. It finds itself in a state of disease when one of its systems or organs, stimulated into conflict with the inorganic power, establishes itself in isolation and persists in its particular activity against the activity of the whole, the fluidity and all-pervading process of which I9 Thursday 9 obstructed. Zusatz. While the division of animal life is the animal type in itself *particularization, so now, in disease, the individual organism, too, is capable of one particularization which does not accord with its notion, i.e. with its total particularity. Here too, therefore, the deficiency of the individual subject in face of the genus is still not removed, but the individual is, both in its own self and in its opposition to itself, genus, it is itself alone the genus, and has it within itself. This is the disharmony to which the animal is now subjected and with which it comes to an end. Health is the due relation of the organic self to its real existence, that is, all its organs are fluid in the universal, It consists in the commensurate relationship of the organic to the non-organic, so that for the organism there is nothing non-organic which it cannot overcome. Disease does not consist in an irritation being too great or too small for the susceptibility of the organism, rather 13 its notion a disproportion of its being and itself, not a disproportion between factors which exist separately within the organism. For factors are abstract momenta, and cannot exist apart from each other. To talk of an increase of irritation and a decrease of susceptibility as if an increase in the one were accompanied by a corresponding decrease in the other, the latter falling as the former rises, this quantitative contrast is inevitably at once suspect. Nor is it a question of disposition, as if someone could be diseased in principle without being actually infected, without being ill, for it is the organism itself which makes this reflection, namely, that what is in itself is also actual. Disease arises when the organism, as simply immediate, is separated from its inner sides which are not factors, but whole, real sides. The cause of disease lies partly in the organism itself, like aging, dying, and congenital defects, partly also in the susceptibility of the organism, in its simply immediate being, to external influences, so that one side is increased beyond the power of the inner resources of the organism. The organism is then in the opposed forms of being and self, and the self is precisely that for which the negative of itself is. A stone cannot become diseased, because it is destroyed in the negative of itself, is chemically decomposed and its form does not endure, because it is not the negative of itself which overlaps its opposite, as in illness and in self-feeling. Appetite, too, the feeling of a lack, is to its own self the negative, relates itself to itself as a negative, is itself and is also in relation to itself as a being feeling a lack, but with this difference, that in appetite this lack is something external, that is, the self is not turned against its structure as such, whereas in disease the negative thing is the structure itself. Disease, therefore, is a disproportion between irritation and the capacity of the organism to respond. Because the organism is an individual, it can be held fast in one of its external sides, can exceed its measure in a particular respect. Heraclitus aia, excess of heat is fever, excess of cold, paralysis, excess of air, suffocation. 1 The reason why the organism can be irritated beyond its capacity is that, being equally the complete unity of possibility and actuality, it is wholly under each of the two forms. The opposition of sex separates efficacy and stimulus, distributing them between two organic individuals. But the organic individual is itself both, and this is the possibility of its death, a possibility immanent in it, namely, that the organic individual itself separates itself into these forms. In the sex relation, it has surrendered its essential determinateness outwards in so far as it is in the relation, but now, it has this determinateness in its own self, mating, as it were, with itself. The union is not consummated in the genus because life is tied to one singular, and in many animals copulation is even the terminal point of existence. But even though others survive, so that the animal overcomes its non-organic nature and its genus, yet all the same, the latter remains master over it. Into this reversal falls disease. Whereas in health, all the vital functions are held in this ideality, in disease the blood, example, is heated, inflamed, and then it is active on its own account. Similarly, the bile can become overactive and, for example, generate gallstones. When the stomach is overloaded, the digestive apparatus functions as an isolated, independent activity, makes itself the center, is no longer a moment of the whole but dominates it. This isolated functioning can go so far that animals are generated in the intestines. All animal, at certain times, have worms in the heart, lungs, and brain. In general, the animal is feebler than man, who is the strongest animal, but it is a false hypothesis that tapeworms in human beings are the result of swallowing the eggs of such creatures. The restoration of health can consist only in the overcoming of theoparticularization. A Dr. Good, in Isis, has attacked this doctrine in a rigmarole which purports to be profoundly philosophical, even saving the unity of the idea, the essence, the comprehension of life and disease in the essence. It is very pretentious to try to disprove a theory about mere appearance and externality with the loftiness and frankness appropriate to truth. Th's definition of disease has missed the point. Only the external appearance of fever, only its symptom, has been grasped. He continues, that which, in life, is blended into a unity and internally concealed, appears in the phenomenal world as a particularity, i.e. developing and exhibiting, in a peculiar way, the essence of the one organism and its idea. Thus life's inner essence appears externally as its character. Where all is, where all lives from one idea, from one essence, there all opposition is only a semblance and external, is only for appearance and reflection, not internally for life and idea. The truth is rather that the living being itself is reflection, diremption. These philosophers of nature mean only an external reflection, but life is just this, to appear. Life is beyond their comprehension because they do not get as far as its appearance, but stop short at dead gravity. Dr. Good seems, in particular, to fancy that the diseased organ does not come into conflict with the organism, but, at first, with its essence, the total activity of the whole is only a consequence and a reflex of the arrest of free movement in the individual. By this, he fancies he has said something really speculative. But then, what is essence? Just vitality. And what is actual vitality? Just the whole organism. To say, therefore, that the organ is in conflict with its essence, with itself, is to say that it is in conflict with the totality, which is in it as vitality in general, as the universal. But the reality of this universal is the organism itself. Fine philosophers these, who fancy that in essence they have the truth, and that if only they keep on ing sense asterisk, then this makes it the inner truth of the matter. I have not the slightest respect for their talk of essence, for it is nothing but an abstract reflection. To explicate essence, however, is to make it appear as a real existence. There are various ways in which subjectivity can be deranged through failure of the bodily activities to preserve their ideality. The principal grounds from which disease originates are, on the one hand, air and moisture, and on the other hand, the stomach and the skin process. More precisely, the types of disease can be reduced to the following. One type of disease is the injurious affection, which is, in the first instance, a general determinateness lying in the non-organic nature as such. Such injurious affection is a simple determinateness which, though it must be considered as coming from outside and as inflicted on the organism, can at the same time also appear as something placed in the organism itself, no less than in its natural environment. For diseases such as epigermes or plagues are not to be thought of as something particular, but as a whole of the determinate flowness of external nature, to which the organism itself also belongs. They can be called an infection of the organism. Various circumstances contribute to such afflictions which are of an elemental, climatic nature, and therefore also have their seat, namely, their origin in the elemental determinateness of the organism. They exist therefore, at first, obscurely in the general foundations of the organism which are not as yet a developed, formed system, that is chiefly in the skin, the lymph, and the bones. Such diseases are not only climatic but also historical, since they appear at certain periods of history, and then disappear. They can also come about through the transference of an organism accustomed to one climate, to another climate. Historical researches have not resulted in any well-founded conclusions, e.g. on syphilis or venereal disease. When this disease first appeared, there had been contact between European and American organisms, but it has not been proved that the disease was brought over here from America, and it is no more than a theory that it came from there. The French call it mal de Naples because it appeared when they captured Naples, although no one knew where it came from. Herodotus reports that a nation migrated from the Caspian Sea to Media and there caught a disease. It was the mere change of place which caused the disease. With us, too, cattle from the Ukraine were brought into South Germany, and although they were all healthy, the mere change of place gave rise to a murrain. Many nervous diseases were the result of Germans coming into contact with miasmas in Russia, and 1,000 healthy Russian prisoners were attacked by a terrible outbreak of typhus. Yellow fever is endemic in America and in a number of maritime. F. Spix and Martin's Travels, Part I, p. 114. Smallpox, which has been almost only sporadic during the last 10 years, does not run a very virulent course in the organisms of the inhabitants of Rio de Janeiro, because the hot climate and the flabbiness of the body are favorable to the development of the disease. However, there can be no doubt that this disease runs a much milder course in people of the Caucasian race than in Negroes and especially American Negroes. In the Indians, who are very susceptible to smallpox, the smallpox matter is assimilated only with the greatest difficulty and they very frequently succumb to the disease. This is attributed mainly to the thickness and hardness of their skin. The physician who compares some of the diseases in Brazil, such as smallpox and syphilis, with those in other parts of the world, is led to observe that just as each individual is subject to particular diseases in each phase of his development, so, too, whole nations, according to their state of culture and civilization, are more readily susceptible to, and develop, certain diseases. Districts, in Spain, for example, and does not spread from there, for the inhabitants protect themselves against it by going several miles inland. Such diseases are dispositions of elemental nature in which the human organism participates, although one cannot say that it is infected by the disease, since the dispositional change is in it, too, but, of course, infection does also occur. It is therefore idle to dispute whether disease originates spontaneously or is caused by infection. Both cases exist. If it does develop spontaneously, it also develops through infection after it has penetrated into the lymphatic system. Another general type of disease is that which is caused by particular, external harmful influences with which the organism comes into contact, and then it is one of the particular systems of the organism, e.g. the skin or the stomach, which is affected. This system is then particularly active and so acts only for itself, in isolation from the rest of the organism. Now here we must distinguish two forma of disease, the acute and the chronic, and it is the former which medicine knows best how to treat. 1. When one of the systems of the organism is diseased, cure mainly depends on the possibility of the entire organism becoming morbidly affected, because then the activity of the whole organism too, can be released, thus facilitating the cure of the disease, and this is acute disease. Here, the organism is shut off from the outer world, has no appetite or muscular movement, and in so far as it lives on its own resources. Now it is just because acute diseases are in this way seated in the organism as a whole, not apart from the whole in one of its systems, but in the so-called humors, that the organism can free itself from them. 2. If, however, the disease cannot become a disease of the whole organism, then I regard it as chronic, e.g. hardening of the liver or phthisis, etc. In such diseases, appetite and digestion remain quite unimpaired and the sexual instinct retains its strength. Here, because one system has made itself the independent center of activity, and the organism can no longer be raised above this particular activity, the disease remains in one organ, since the organism too can no longer, as an independent whole, come to itself. Cure is therefore difficult and the difficulty increases in proportion to the severity of the attack and the extent to which this organ or system is affected. A third form of disease is that which originates in the universal subject, especially in man. These are diseases of the soul, which are caused by terror, grief, etc., and which can even result in death. 372 The characteristic manifestation of disease is, therefore, that the identity of the entire organic process displays itself as the successive course of the vital movement through its distinct moments, sensibility, irritability, and reproduction, i.e. as fever, which, however, as process of the totality in opposition to the isolated activity, is just as much the effort towards, and the beginning of, cure. Zusatz. We have seen that the notion of disease is that the organism separates itself into its separate moments, Now we have to consider in more detail the course of disease. The first stage of disease is that it is virtually present, but without any actual morbidity. In the second stage, the disease becomes for the self, i.e. there is established in the self and in opposition to it as universal, a determinateness which makes its own self into a fixed self. In other words, the self of the organism becomes a fixed existence, a specific part of the whole. Up to this point, the systems of the organism had a selfless existence, but now, the actual beginning of disease consists in this, that the organism, being irritated beyond its capacity to respond, one particular part, a single system, gains a foothold in opposition to the self. The disease can begin in the organism as a whole, can be an indigestibility in general, or in a particular part which establishes itself, for example, in the process of the gall or the lungs. The simply affirmative determinateness is a single determinateness which, usurping the self, takes possession of the whole organism. In this immediate, isolated form, the disease is, as physicians say, in its first stages. This is, so far, nothing more than the first conflict, the running riot of the particular system. But so far as the determinateness has become the center, the 9-elf of the whole organism, so far as the organism is dominated, not by the free self, but by a determinate self, then we have disease proper. On the other hand, so long as the disease is peculiar to one particular system and is confined within that system, it is easier to cure because only one organ is irritated or depressed. The system has only to be extricated from its entanglement with its non-organic nature and kept within bounds, and so external remedies can also be of assistance here. Generally, in this case, the remedy can be restricted to the stimulation of the system concerned. Appropriate remedies in this second stage are emetics, purgatives, venesection, and the like. But the disease also spreads into the general life of the organism, for when one organ is affected, there is also an infection of the whole organism. The entire organism, therefore, is involved and its activity deranged because one will in it has made itself the center. But at the same time, the entire vitality of the organism is turned against it, so that the isolated activity shall not remain an excrescence but a moment of the whole. For if, example, digestion isolates itself, then the circulation of the blood, muscular energy, etc., are also affected, in jaundice the whole body secretes bile, is liver through, and so on. The third stage of the disease, then, is eoction, which consists in the affection of the one system becoming an affection of the whole organism. Here the disease is no longer in the particular system external to the whole, but the whole life is concentrated in it. Here, too, as we saw in connection with acute disease, cure is always easier than when, as in chronic diseases, for example of the lungs, the disease is no longer capable of becoming a disease of the whole organism. With the entire organism thus infected affected, with a particularity, a dual life begins to be manifested. In opposition to the stable universal self, the whole organism becomes a differentiating movement. The organism posits itself as a whole against the determinateness. Here the physician can do nothing, and, as a matter of fact, the whole of medicine does no more than assist the forces of nature. Indeed, since the particular morbid affection has become an affection of the whole, this disease of the whole organism is itself at the same time a cure, for it is the whole which is set in motion and, in the circle of necessity, breaks asunder. The true constitution of disease consists, therefore, in the organic process now taking its course in this fixed shape, in this persistence, i.e. the harmonious processes of the organism now form ruejasic, that is to say, the general systems, tom apart, are no longer immediately a one, but display this unity through the passage of one into the other. Health, which is at the same time in the organism, but arrested, cannot exist in any other way than by a succession of activities. The total process, health, is not in itself abnormal in relation to the kind or system, but only through the succession. This movement, now, is fever. This, then, is disease in its pure, proper form, or the diseased, individual organism liberating itself from its specific disease, as the healthy organism does from its specific processes. Fever being thus the pure life of the diseased organism, its appearance first makes possible the recognition of a specific disease. Not only is fever the succession of the functions, but it also makes them fluid, so that through this movement the disease is at the same time sublated, digested. It is an interior process directed against the organism's non-organic nature, a digestion of medicina. Therefore, even if fever is, on the one hand, a morbid state and a disease, yet on the other hand, it is the way in which the organism cures itself. This, however, is true only of a severe, violent fever which lays hold of the whole organism, but a creeping, consuming fever which does not develop into a true fever is, on the other hand, a dangerous sign in chronic diseases. Chronic diseases are, therefore, of a kind which fever cannot subdue. A creeping fever, in its course, does not gain the mastery, but all the separate processes of the assimilating organism function disconnectedly and each on its own account. Here, therefore, fever runs only a superficial course which does not overcome these separate parts. Teal. In burning, violent fevers it is chiefly the vascular system which is attacked, and in asthenic fevers, the nervous system. In a true fever, then, the entire organism subsides first into the nervous system, into the general organism, then into the interior organism, and finally into the structure. 1. Fever is, at first, shivering, heaviness of the head, headache, twinges in the spine, twitching of the skin, and shuddering. In this activity of the nervous system, the muscles are left free and consequently their own irritability functions as an uncontrolled trembling and powerlessness. Heaviness of the bones sets in, tiredness of the limbs, withdrawal of the blood from the skin, a sensation of cold. The simple subsistence of the enrpnimi wholly reflected into self, isolates itself and has the entire organism in its power. The organism dissolves all its parts within itself in the simplicity of the nerve, and feels itself withdrawing into the simple substance. 2. But secondly, as a dissolution of the whole, this very process is the negative power, though this notion, this organism which is concentrated in its nervous system passes over into the organism of overheated blood delirium. It is this very withdrawal which is the transformation into heat, negativity, where the blood is now the dominating factor. 3. Thirdly, this dissolution passes over finally into the process of shape formation, into product. The organism in the reproduction of itself reduces to lymph, this is sweat, the existence of the organism in fluid form. The significance of this product is, that in it, the isolation, the single system, the determinateness, ceases, for the organism has produced itself as a whole, in general, has digested itself. Sweat, to use an expression of the ancient physicians, is cooked morbid matter, an excellent notion. Sweat is the critical secretion. In it, the organism attains to an excretion of itself, through which it eliminates its abnormality and rids itself of its morbid activity. The crisis is the organism which has gained the mastery over itself, which reproduces itself, and exercises this power by sweating. Of course, what is secreted is not the morbid matter, as if the body would have been healthy if this matter had not been present in it or could have been emptied out with a spoon. On the contrary, the crisis, like digestion generally, is at the same time a secretion. But the product is double. Consequently, critical secretions are very different from secretions arising from exhaustion, which are not strictly secretions but a dissolution of the organism and therefore have the very opposite significance. The process of recovery implicit in fever consists in the totality of the organism becoming active. In so doing, the organism raises itself out of its submergence in a particularity, it is alive as a total organism. It subdues the particular activity and then also gets rid of it. Having thus recovered itself, the organism now exists as a universal and is no longer diseased. The determinateness is transformed at first into movement, necessity, into total process, and this in turn into total product, and accordingly also into total self, since the product is simple negativity. 8 Ms 876 Q2. 373b. Therapy. The medicine provokes the organism to put an end to the particular irritation in which the formal activity of the whole is fixed and to restore the fluidity of the particular organ or system within the whole. T9 is brought about by the medicine as an irritant, but one which is difficult to assimilate and overcome, so that the organism is confronted by something alien to it against which it is compelled to exert its strength. In acting against something external to it, the organism breaks out from the limitation with which it had become identified and in which it was entangled and against which it cannot react so long as the limitation is not an object for it. Remark. The main point of view from which medicine must be considered is that it is an indigestible substance. But indigestibility is a relative term, not, however, in the vague sense that only what is tolerable by weaker constitutions is to be called easily digestible. On the contrary, such substances are indigestible for the stronger individuality. The immanent relativity, that of the notion, which has its actuality in life, is of qualitative nature and consists, when expressed quantitatively, in the homogeneity being greater, the more the opposed terms are intrinsically self-subsistent. For the lower forms of animal life which have not attained to a difference within themselves, the digestible nutriment is the unindividualized neutral element of water, as is the case with plants. For children it is in part the completely homogeneous animal lymph, mother's milk, a food which is already digested or rather has been directly converted into animal substance as such and is not further differentiated within itself, and in part the least individualized of the more heterogeneous substances. Substances of this kind are, on the other hand, indigestible for mature and robust constitutions which more easily digest individualized animal substances or plant juices which sunlight has matured to a more powerful individuality and which are therefore called spirituous, than, for example, those vegetable products which are still only neutral in color and stand closer to the chemical process proper. Substances of the former kind, on account of their more intensive selfhood, form a correspondingly greater contrast, but for that very reason are more homogeneous irritants. Medicines are, so far, negative irritants, poisons. The organism, estranged from itself in disease, is given an irritant which is at the same time an indigestible substance alien and external to it, and to counter it the organism must gather up its strength and enter into process against it in order thereby to regain its self-feeling and its subjectivity. Brown reduced the classification of diseases to sthenia or asthenia, the latter being subdivided into direct and indirect asthenia, and the efficacy of remedies was restricted to their fortifying or debilitating action. Furthermore, to give these distinctions an air of natural philosophy, they were traced to the action of carbon and nitrogen, oxygen and hydrogen, or magnetic, electrical, and chemical factors and the like. Now this theory of Brown's, regarded as a complete system of medicine, was simply an empty formalism, but on the other hand it did also serve to direct attention beyond what was merely particular and specific both in diseases and remedies, to the universal in them as the essential element. Through its opposition to the more debilitating method on the whole practiced up till then, it was shown that the organism does not react to the most opposite kind of treatment in such an opposite way, but frequently, at least in the final results, reacts in a similar and hence general way, also that the simple identity of the organism with itself as the substantial and truly efficacious activity combating a particular disequilibrium of one of its systems, is demonstrated in specific irritants. The definitions and statements put forward in the paragraph and the remark are general and, in comparison with the very complex phenomena of disease, insufficient, but nonetheless it is only the firm foundation of the notion which can furnish a clue to the maze of particulars and also really clarify those phenomena of disease and its treatment which, to those who are steeped in the externalities of the particular, appear extravagant and bizarre. Zusatz. Our conception of healing must follow the lines of our treatment of digestion. The organism does not will to subdue something external to it, but it is healed by disentangling itself from something which is particular and which it must regard as beneath its dignity, and by coming to itself. This can happen in various ways. One way is that the determinateness which holds sway in the organism is given to the latter in the form of something inorganic and selfless to which the organism reacts, thus enmanifested as a determinateness opposed to health. It is for the organism mandirine. The instinct of the animal feels the determinateness placed in it, the instinct of self-preservation, which is Jewett the total, self-relating organism, has the definite feeling of its deficiency. It therefore proceeds to consume this determinateness, seeking it in the form of an edible, inorganic nature. The determinateness thus exists for the animal in a less powerful, in a simple, passive form. Homeopathy, in particular, prescribes remedies which are able to produce the same disease in the healthy body. The effect of introducing into the organism this poison, something 6 imply inimical to it, is that this particularity in which the organism is fixed becomes for it something external, whereas the particularity, as disease, is still a property of the organism itself. Since, therefore, the medicine is the same particularity, although with this difference, that it now brings the organism into conflict with its determinateness as with something external, the effect now is to stimulate the healthy energy of the body into an outward activity and to force it to rouse itself, to come out of its self-absorption and not merely to concentrate itself inwardly but to digest the external substance administered to it. For every disease is a hypochondria of the organism, in which the latter disdains the outer world which sickens it, because, restricted to itself, it possesses within its own self the negative of itself. But now the medicine excites the organism to digest it, and the organism is thus drawn back again into the general activity of assimilation, a result which is obtained precisely by administering to the organism a substance much more indigestible than its disease, to overcome which the organism must pull itself together. This results in the organism being divided against itself, for since what was initially an immanent involvement is now an external one, the organism has been made dual within itself, namely, as vital force and diseased organism. TB's action of medicine can be called magical, like that of animal magnetism in which the organism is brought under the power of another person, for through the medicine the organism as a whole is subjected to this specific determination and it succumbs, therefore, to the power of a magician. But if the organism, in virtue of its diseased state, is in the power of something other than itself, yet at the same time, as in animal magnetism, it also has a world beyond, free from its diseased state, through which the vital force can restore itself. That is, the organism can sleep within itself, for in sleep, the organism is alone with itself. Now while the organism is thus internally at variance with itself, its vital force endows it with an existence of its own, and possessing such an independent existence, it has saved its general vitality as such and got rid of its entanglement in this particularity. Since this no longer has any power to affect the organism's inner life, the latter is, in consequence, restored, just as in magnetism, the inner life retains its vitality in face of the controlling influence. It is just this extrication from the entanglement, therefore, which permits and brings about the return of the organism into itself by way of assimilation, and recovery simply means that in this accomplished withdrawal into itself, the organism digests itself. Now to say which are the right remedies is a difficult matter. Emilaria Medico has not yet uttered a single rational word on this connection between a disease and its remedy. Experience alone is supposed to decide this. And so experience with chicken dung has as much value as that with medicinal plants, for in order that medicine should be nauseating, human urine, chicken dung, and peacock dung were formerly used. Thus there is not a specific remedy for each particular disease. If there were, it would mean finding the connection between the two, i.e. the form in which a determinateness is present in the organism and the form in which it occurs in vegetable nature, or simply as a dead, externally applied irritant. Thus cinchona, leaves, green plants, seem to have a cooling action on the blood. Soluble salt, saltpetre, must be administered, it seems, to counteract excessive irritability. As the organism in disease is still alive and merely obstructed, easily digested foods can suffice to maintain its vitality and often, therefore, even to effect a cure. When the disease is not located in a particular system but in the digestive system generally, vomiting can occur spontaneously and especially in children who vomit very easily. The reaction to an inorganic remedy like mercury, for example, can be an inordinate intensification of a partial activity. The action is, on the one hand, specific, but there is also a general stimulation of the organism. In general, the relationship of disease to medicine is magical. The irritant, the poison administered, can be called, as Brown calls it, a positive irritant. The remedy can, however, be more in the nature of a negative irritant, like, example hydrochloric acid. Its purpose, then, is to depress the activity of the organism so that in eliminating from it all activity, that of the diseased system, too, is eliminated. Thus, on the one hand, the organism has to exert its activity since it must direct itself outwards, on the other hand, the activity of the conflict is weakened, example by venesection, or ice in cases of inflammation, or by paralysing the digestion by salts. In this way, the ground is cleared for the functioning of the inner vitality, for there is no longer any external object. Thus fasting as a debilitating treatment has come into fashion, and in so far as homeopathy is concerned mainly with diet, that, too, falls into this class. The simplest kind of food, like that received by the infant in the womb, is intended to make the organism live on its own resources and so overcome the abnormality. In general, remedies have tended to become more general in character. In many cases, a general shock to the organism is all that is necessary, and physicians themselves have admitted that one remedy is as efficacious as its opposite. Both methods, therefore, the debilitating and the fortifying, although opposed, have in this way demonstrated their efficacy, and ailments which, since Brown, have been treated with opium, naphtha, and brandy, were formerly treated with emetics and laxatives. A third way of healing, corresponding to the third type of disease, is that which acts on the universal aspect of the organism. It is here that magnetism has its place. The organism, as immanently universal, is to be raised above itself and brought back, to itself, and this can be brought about externally. Since, therefore, the self, as simple, falls outside the diseased organism, it is the fingertips of the magnetizer which conduct this magnetism throughout the whole organism and which, in this way, fluidify it. Only sick persons can be magnetized, can be put to sleep in this external manner. Sleep is just this gathering itself together of the organism into its simplicity, whereby it is brought to the feeling of its inner universality. But instead of this magnetically induced sleep, a healthy sleep, too, can produce this turning point in an illness, i.e. the organism can then spontaneously gather itself together into its substantiality. In disease, the animal is entangled WTHIA non-organic power and held F in one of its particular systems or organs in opposition to the unity of its vitality. Its organism, as a determinate existence, has a certain quantitative strength and is, indeed, capable of overcoming its dividedness, but the organism can as well succumb to it and find in it the manner of its death. The animal, in overcoming and ridding itself of particular inadequacies, does not put an end to general inadequacy which is inherent in namely, that its idea is only the immediate idea, that, as animal, it stands within nature, and subjectivity is only implicitly the notion but is not for its own self the notion. The inner universality therefore remains opposed to the natural singularity of the living being as the negative power from which the animal suffers violence and perishes, because natural existence as such does not itself contain his universality and is not therefore the reality which corresponds to Zusatz. The organism which is abandoned by self brings about its own death. But disease, strictly speaking, in so far as it is not a fatal process, is. The outer, existent course of this movement from the singular to the universal. In the organic sphere, the necessity of death, as of all else, does not consist in particular causes, for it lies in the nature of the organism itself that the cause be something external. There is always a remedy for a particular disease, for the latter as such is weak and cannot be the ground of death. The ground is the necessity of the transition of the individuality into universality, for the living being, a nine alive, is the onsidedness of existence as a self, but the genua is the movement of just sublating the individual, merely immediate self, and then relapsing into this eight oblation, a process in which the merely immediate singular perishes. Death, simply from old age, is an impotence, a general, simple state of decline. The outer signs of this are an increasing ossification and the slackening of muscles and tendons, bad digestion, feeble sensation, a retreat from the individual to the merely vegetative life. The soundness of the heart in old age to a certain extent increases, its irritability diminutishes and finally ceases altogether. There is also noticeable a shrinking in size in extreme old age. Point to this merely quantitative behavior, but as qualitative, as a specific process, was strictly speaking the disease, not weakness or excessive strength, which is a completely superficial explanation. 375. See the self-induced destruction of the individual, the universality which makes the animal, as a singular, a finite existence, reveals self I and I as the abstract power which terminates I, the internal process active within I, the animal, a process which is itself abstract. The disparity between its finitude and universalities I, its original disease and het inborn germ of deaths, and the removal of this disparity is itself the accomplishment of this destiny. The individual removes this disparity in giving its singularity the form of universality, but in so far as this universality is abstract and immediate, the individual achieves only an abstract objectivity in which I activity has become deadened and ossified, and the process of life has become the inertia of habit. It is in his way that the animal brings about its own destruction. Zusatz. The organism can recover from disease, but disease is in its very nature, and herein lies the necessity of death, i.e. of this dissolution in which the series of processes becomes the empty process which does not. 1 Autenrieth, Handbuch der Physiologie, Part I, 157. Ibid, Part 2, 767. Return into itself. In the opposition of sex, it is only the separated sexual organs, parts of the plant, which die in an immediate manner. Here, they die through their one-sidedness, not as a totality. As a totality, they die through the opposition of the male and female principles which each has within it. Just as in the plant, the stamens swell up into passive receptacle, and the passive side of the pistil swells up into the generative principle, so now, each individual is itself the unity of both sexes. But this is its death, for it is only an individuality, and this is its essential determinateness. Only the genus is the unity of complete wholes in a single unity. Just as at first, we had the opposition of male and female unoblated in the organism, so now we have the opposition in a more determinate form, that of the abstract forms of the whole which occur in fever and are filled with the whole. The individuality cannot divide itself in such a manner because it is not a universal. In this general innate quasi lies the separability of soul and body, whereas spirit is eternal, immortal, for because spirit, as truth, is itself its object, it is inseparable from its reality. It is die universal which is objective to itself as the universal. In nature, on the other hand, universality is manifested only negatively, in that subjectivity is sublated in it. The form in which this separation is accomplished is, precisely, the consummation of the singular, which converts itself into the universal but cannot endure this universality. In life, the animal maintains itself, it is true, against its non-organic nature and its genus, but its genus, as the universal, in the end retains the upper hand. The living being, as a singular, dies from the habit of life, in that it lives itself into its body, into its reality. Vitality makes itself, for itself, into the universal, in that the activities become universal, and it is in this universality that the vitality itself dies, for since vitality is a process, opposition is necessary to it, and now the other which it should have had to overcome is for it no longer an other. Just as in the spiritual sphere, old people dwell more and more within themselves and their kind, and their general ideas and conceptions tend to occupy their interest to the exclusion of what is particular, with the result that tension, interest falls away and they are contented in this processless habit, so, too, it is in the physical sphere. The absence of opposition to which the organism progresses is the repose of the dead, and this repose of death overcomes the inadequacy of disease, this inadequacy being therefore the primary cause of death. 376 But this achieve identity I universal is the sublation of the form al opposition between the immediate singularity of the individuality and I universality, and this is only one side, and that the abstract side, namely, the death of the natural being. But in the idea of life, subjectivity is the notion, and it is thus in itself the absolute being within self of actuality and concrete universality. Through the sublation of the immediacy of its reality just demonstrate, subjectivity has coalesced wthi itself, the last self externally of nature has been sublated and the notion, which in nature is present only in principle, has become for itself. Wthi this, nature has passed over into its truth, into the subjectivity of the notion whose objectivity is itself the sublated immediacy of singularity, is concrete universality, so that the notions I posited as having for its determinate being the reality which corresponds to it, namely, the notion and this is spirit. Zusatz. Above this death of nature, from this dead husk, proceeds a more beautiful nature, spirit. The living being ends with this division and this abstract coalescence within itself. But the one moment contradicts the other, that which has coalesced is for that reason identical notion or genus and reality, or subject and object, are no longer divided, and that which has repelled and divided itself is for that very reason not abstractly identical. The truth is their unity as distinct moments, therefore in this coalescence and in this division, what is sublated is only formal opposition because of the intrinsic identity of the moments, and similarly, what is negated is only formal identity, because of their division. That is to say, in more concrete terms, the notion of life, the genus, life in its universality, repels from itself its reality which has become a totality within it, but it is in itself identical with this reality, is idea, is absolutely preserved, is the divine, the eternal, and therefore abides in this reality, and what has been sublated is only the form, the inadequacy of natural existence, the still only abstract externality of time and space. The living being is, it is true, the supreme mode of the notion's existence in nature, but here, too, the notion is present only in principle, because the idea exists in nature only as a singular. Certainly, in locomotion the animal is completely liberated from gravity, in sensation it feels itself, in voice it hears itself, in the genus process the genus exists, but still only as a singular. Now since this existence is still inadequate to the universality of the idea must break out of this circle and by shattering this inadequate form make room for itself. Therefore, instead of the third moment in the genus process sinking back again into singularity, the other side, death, is the sublating of the singular and therewith the emergence of the genus, the procession of spirit, for the negation of natural being, i.e. of immediate singularity, is this, that the universal, the genus, is posited and that, too, in the form of genus. In the individuality, this movement of the two sides is the process which sublates itself and whose result is consciousness, unity, the unity in and for itself of both, as self, not merely as genus in the inner notion of the singular. Herewith, the idea exists in the self-subsistent subject, for which, as organ of the notion, everything is ideal and fluid, that is, the subject thinks, everything in space and time its own and in this way has universality, i.e. its own self, present within it. Since in this way the universal is now for the universal, Therefore the notion is for itself / this is first manifested in spirit, in which the notion makes itself objective to itself, but in doing so, the existence of the notion, as notion, is posited. Thought, as this universal which exists for itself, is immortal being. Mortal being is that in which the idea, the universal, exists in an inadequate form. This is the transition from nature to spirit. In the living being, nature finds its consummation and has made its peace, in that it is transformed into a higher existence. Spirit has thus proceeded from nature. The goal of nature is to destroy itself and to break through its husk of immediate, sensuous existence, to consume itself like the phoenix in order to come forth from this externality rejuvenated as spirit. Nature has become an other to itself in order to recognize itself again as idea and to reconcile itself with itself. But it is one-sided to regard spirit in this way as having only become an actual existence after being merely a potentiality. True, nature is immediate, but even so, as the other of spirit, its existence is a relativity, and as the negative, its being is only posited, derivative. It is the power of free spirit which sublates this negativity. Spirit is no less before than after nature, it is not merely the metaphysical idea of it. Spirit, just because it is the goal of nature, i.e. prior to it, nature has proceeded from spirit, not empirically, however, but in such a manner that spirit is already from the very first implicitly present in nature, which is spirit's own presupposition. But spirit in its infinite freedom gives nature a free existence and the idea active in nature as an inner necessity, just as a free man of the world is sure that his action is the world's activity. Spirit, therefore, itself proceeding, in the first instance, from the immediate, but then abstractly apprehending itself, will to achieve its own liberation by fashioning nature out of itself, this action of spirit philosophy. With this, we have brought our treatment of nature to its boundary. Spirit, which has apprehended itself, also wills to know itself in nature, to make good again the loss of itself. This reconciliation of spirit with nature and with actuality is alone its genuine liberation, in which it shed its merely personal habits of thought and ways of looking at things. This liberation from nature and nature's necessity is the notion of the philosophy of nature. The forms which nature wears are only forms of the notion, although in the element of externality, it is true that these forms, as grades of nature, are grounded in the notion, but even where the notion gathers itself together in sensation, it is still not yet present to itself as notion. The difficulty of the philosophy of nature lies just in this: first, because the material element is so refractory towards the unity of the notion, and, secondly, because spirit has to deal with an ever-increasing wealth of detail. Nonetheless, reason must have confidence in itself, confidence that in nature the notion speaks to the notion and that the veritable form of the notion which lies concealed beneath nature's scattered and infinitely many shapes, will reveal itself to reason. Let us briefly survey the field we have covered. First, the idea was, in gravity, freely disbanded into a body whose members are the free heavenly bodies. Then this externality fashioned itself inwardly into properties and qualities which, belonging to an individual unity, had in the chemical process an immanent and physical movement. Finally, in the living being, gravity is disbanded into members in which the subjective unity abides. The aim of these lectures has been to give a picture of nature in order to subdue this proteus, to find in this externality only the mirror of ourselves, to see in nature a free reflex of spirit, to know God, not in the contemplation of him as spirit, but in this his immediate existence. 445.